If you
That's
had a
the whole
floaty
point of the
object.
test. I was just trying to eliminate all of the, refraction, all of the laser being perfectly straight, all of those issues.
If
That was the whole point behind this, and I feel like this was the simplest way I could break it down.
No, if you
Yeah,
have a floating
definitely
object
hinges on
and
that.
it's a straight object, and it's like it can float and it's actually perfectly rigid in itself, the object will raise up off the water so to where it hangs over the edge and over the edge of the other water. So your water will be like a little curve of water holding your straight bar, and your straight bar should be above all the other water and go just raise away a couple inches at each end, like 4 inches at one end, 4 inches at the other when it just sits there. Just sitting your level thing on a curved portion of water, it automatically, when you look to the right and look to the left, there should be in a mile, there should be 4 inches to the right and 4 inches to the left deviation. Now, in less than a mile, it would be different. But just a straight object sat on the water should be sitting on a sphere.
Yeah, but that's the problem, is getting something that is straight enough, that's long enough. That's why I figured doing it in the water in a neutrally buoyant medium as the material we're using would be the only way to truly do that.
No.
If you
You're
can pull
missing
it
the
off.
point. You're
No,
microscopic.
I hear your
My,
point.
my,
Matt. I
no,
just
no, no.
think
My feet are only so big, and then I'm so microscopic on this big, giant curve that any little straight thing I sit in front of me on water should be popping off the edges of the water. Doesn't matter what size. It doesn't matter because any inkling, just a dash, a dot and a dash away from me to the right is down. A dot and a dash. A
Yeah, but
dot.
you have to have
even
something
if you're right, the Globers
straight.
can agree with that.
Yeah, you'd have to have something perfectly straight. In theory, if that existed, then yeah, you could just pop that like a level, just pop a level right on the water, a straight material, something that's completely straight. Because yeah, the water should deviate from that. But that's the challenge, is getting something that's that long, that's perfectly straight. It's very challenging.
Well, you don't have to have it that long. That's my point. Any size that you sit on any sphere of water that's a straight line is going to do that. Just more each time, more big.
DMOC, you think that would be definitive, though, from the globe side, even if you could show that? If it's something that's short?
Yeah,
You know what I mean?
definitive in physics on a beach ball.
The whole point of my test is to make sure it's definitive on both sides. But
I just do them both next to each other. I'd say this floaty line that we have 1 mile of, or 1 inch of, or 10 feet of, or 30 foot of, it sticks itself off the water to the right there, and to the left. You see it?
Yeah, but that's what I'm saying. It has to be long enough to do that, and it has to be straight enough. You'd have to have several miles straight. What do you call it? A stencil? The Earth stencil?
Right, but do you understand what a sphere is? I mean, like, if you get a ball right now and you put a toothpick on there and break it down into pieces, that toothpick is still going to levitate on the left and right of that sphere. It doesn't matter the size. I don't get what you guys are saying.
Yeah,
the scale, DMOC, the scale, bro. That
the size of the
no sphere, bro, is a sphere. Bro. A sphere is a sphere. What do you mean the scale?
If you look at a small enough segment of a sphere, DMOC, it's going to look straight, bro.
Well, you use the toothpick on a basketball, and you're right. If you put a toothpick on a basketball, there's going to be a little gap because it's straight, obviously. Right. So what I was just saying is that if you were to try to do that on the Earth, since it's, let's say, 8 inches in a mile, so just to get a little 4 inches, you'd have to, let's just use a mile. You'd have to have a 1 mile long, perfectly straight material that could give you a 4 inch gap.
You guys are going by the wrong math. Listen. Any gap is all you're looking for. Do you understand? If I get any sphere, a cue ball, any size sphere, goddammit, and put that little stick on it, I can break a piece off that the toothpick, just a piece off the end, put it on the cue ball. It's going to do the same thing. So no matter what size of the ball, I can get a 10-foot piece of tube, a straight piece, and I should set it on the water. If it floats, it should stick off the water a piece. It doesn't matter how many. You're not looking for a certain amount. You're looking for any.
How do you know that little tiny piece of toothpick you're talking about? How do you know that the piece that you broke off is to scale as to what you're describing on this?
To scale of what? There's a sphere and a straight line. I'm putting a straight line on a sphere. What do you mean?
Because if you look at a small enough segment, if you look at a small enough segment of a beach ball, it's going to look perfectly straight, bro. That's my point.
No, it's not. Okay. No, it's not, bro.
Okay.
You're never going to put a toothpick on any beach ball to where it lines up with it perfectly. Show me that.
Literally everybody disagrees with you in this room. Everybody.
No, I disagree with everybody else then. Prove your point then. Everybody in the room can't prove their point, right?
All right.
Can I take a shot at my
first
I want to
No, hold on, man. I want anybody in this room to get a straight line and put it against a sphere and show me it match. Get the bigger sphere. Get a big sphere if you need to, and get a ruler and show me it match. Show me what size scale you fucking think that makes sense on. None. Never. It doesn't work.
You're right. I'm about to see if I can take a shot at what you're saying.
Coach said I'm fucking right, not you guys.
Yeah, you are right, man. But regardless, I'm gonna try in a second to. Anyway, regardless of that, I just wanted to say, because I was listening, I couldn't say anything because I was in the shower. But by the way, I was cleaning my ears and my Q-tips had blood on them. That's not a good thing, right? But regardless,
stop cleaning your ears. Stop cleaning them.
Regardless, I was surprised because I've heard about this force the line thing since I first got into this community, and even the buoyant, neutrally buoyant thing. But I guess I never really gave it too much thought because I always thought of them as being the same, like neutrally buoyant under the water or force the line above the water. But the neutrally buoyant thing is actually more. It's more brilliant than you guys think because all of the issues that you guys brought up actually aren't issues when it's if you had an ideal
if it floats right off the
top material, it doesn't matter how long, you can make it half a mile. And if you had a canal where you could be sure that there's no turbulence in the water, not too much of it, then it
would deviate left and right.
The ability to pull the string taut is actually not there's I can't think of a reason why it would be any bit difficult at all. There wouldn't be anything making it difficult to pull that string, to make that string straight. Like there's no gravity.
You're correct. You're correct, because that's what we do when we fish. When we fish the fish and we pull the fishing line, the string, the chain, anything that you like, just slowly with the little like ting, 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 it does that. And then eventually, if you have too much, like he's saying, I agree with pulling a line, but I'm just saying that that's a big version of it. But in my mind, literally, and in the physical attributes of what I do in front, and I'm right here in a room, and with real little straight lines, I can never get any straight line to match that curve. If I get a millimeter.
The thing is, Coach, is that to get the curved water result, the line has to be pulled taut.
Yeah.
So, yeah.
But yeah, I agree with that.
3 mile line underwater pulling it taut.
No, that's what I'm saying is,
if it's neutrally buoyant, it won't matter. It won't take that much to pull it taut.
Yeah, exactly. That
but if it's not perfectly taut, it's gonna still be floating near the top of the water, and you're not going to get the curved water result if it was curved.
If it's neutrally buoyant, it would be perfectly straight.
It wouldn't be floating near the top of the water if it was buoyant, man. You could make it to where it sunk a little bit. You could make it where it floated a little bit. You could make it to where
we have styrofoam tubies. Those styrofoam things kids play with.
Yeah, those float though. That's the thing. If you had something that floats, that would create a problem. If you had something that was too heavy to float, then that would create a problem. But if you had something that was the same density as the water, then there'd be no resistance to it being taut.
Oh, you're talking about a floaty, like filled with liquid, filled some with liquid, and some with air, and you put it across the water. Is that what you're talking about, Coach? You have a little bit of liquid in the actual material,
line, like you said.
Oh, just a fishing line. Okay.
The line itself, though, is like the density of a submarine that's neither ascending or descending. It's like just neutrally buoyant in the water. It's not heavy in the water or lighter than.
Right.
Yes, that's the whole point, and that's the crux of it. If we can't do that, then it's not going to work. But if we can, and we can show with controls on the side that this fishing line is staying where it is suspended for the duration of the test, then there is no reason this shouldn't work, man.
I know we got telephone poles and shit too that they can make perfectly. I mean, they make them motherfuckers straight, Jack, out of this machine. And if you just let it float on the water, the right end of the telephone pole and the left end of the telephone pole should be sticking off the water. I don't care if it's fucking half of a piece of an inch. It should be sticking off the water, the right part and the left part of a telephone pole, man. You ain't. The longer you go, the more. That's all it is. The longer you go, the more of a space.
But we can't see the horizon.
The line would be longer than 5 miles, really, would you?
You wouldn't even need one longer than a mile to do. I got to think about this test more, and the same way I was enamored with White's World, and I talked to them about it in Gems, and it's a good place. Gems is a great place to test an idea like this.
Why don't you do this? Run some water on a beach ball just a little bit to where it has a smooth layer, right? And then take your toothpick and sit it on there.
Another variation, Kosho, on White's Word. We talked about doing it over like frozen water. So if you had a very large frozen lake, for a frozen canal, whatever it may be, and then you would have to shovel the snow and everything to have it be as clear as possible, and then put a line over that and then pull it taut, where you're trying to have so the line is right on the surface of the ice. Of course, if it's curved, the ice should be curving along with your globe. So if you then put the line on the ice and then pull it taut, you don't have it up off the ice at all. It's literally on the same level, the same elevation as the ice itself, and then you pull it taut, and then have very sensitive scales all along the ice under the line, and then as you pull it, if it's curving, there should be significant tension all the way along that curve as it's pressing into it. But of course, a planar, frozen ice is not going to give any additional pressure. As you pull it taut, it's just going to stay neutral.
Hey, Kosho, real quick. Kosho. No.
If you
hold on, real quick. Let me just say something.
Pull it tight on the globe, it would be more pressure at the center of the line, right?
All along it, but yeah. But
no, not all. No, it'd be more pressure at the center, right? Or it wouldn't.
The center is going to touch the water.
Be all along it, but I think Regis was trying to say something. Go ahead.
Yeah, let me just say one thing real quick. Kosho, I agree that it would work over 1 mile. The idea that we were talking about with the fishing line. The reason why I chose 3 was because over the distance you get exponential drop, so it would be a much bigger leeway as far as being able to tell for sure. Like if it's hovering right near 3 inches, for sure it's flat. If it's closer to 3, then it's a globe. Whereas if you do it over 1 mile, that margin is going to shrink. You know
what else you could do? You could literally just make your sand thing
all along it. It would.
You could make your sand thing like Gio said, because the sand you can actually trough flat. And if you make 1 mile of liquid that's like static, straight, whatever like not like moving around a lot or nothing crazy, because you put it in like a canal you made. When you fill that canal, that's 1 mile. The middle of that canal's water should bubble up 8 inches. If you make a straight line canal of 1 mile and you fill it with fucking liquid, the center or somewhere on that line, the water should be 8 inches above the fucking line you're standing on looking at the water. That's how this is supposed to work. The water is supposed to bubble above the fucking land, not in a mud puddle. Now, we've had mud puddles everywhere. So if we make it 8 inches down, right? So you pour the water to an 8-inch mark you have down, 8 inches down, and you fill that line to the water. The center of that water should touch the fucking actual top level you got 8 inches away from the fucking like a mean line. You got a mean line for the water, and you got 8 inches more up for the fucking edge of your pool. So you have an 8-inch down marker for a mile-long pool. It's a straight line against the wall, just like a fucking pool has, like a regular pool has on the markings, like how many feet you're going down. But it's just 8 inches all the way down. So you have a mile-long 8-inch fucking gap from the top to where you fill it. And when you pour the water in, there should be an 8-inch fucking bulge in the center touching that top line, man. That's it. It should show itself. It should present itself.
I agree with what everyone's saying. I just I'm I'm trying to think about this whole.
Listen to the one I just said too.
Yeah, I did. Here's the thing I was going to say before Democ about the. You're right what you said about the like any sort of straight line you have, you put it over to.
Yeah, you just drop it on the fucking ground on a hill, and you'll see that the stick goes over on one side of the hill and doesn't touch, and then on the left side doesn't touch ever. Little hills in my backyard, so big hills, like if it's on a fucking hill and the stick is bigger than the hill piece, you know what I mean? If it's bigger than the piece, then it's going to do it. If the hill curves down and away and doesn't follow the stick, you're going to see it. I mean, it doesn't matter how much.
Right.
You're looking for any.
Yeah, but no, but the problem is that with the curvature of the earth and the size of it, anything like let's say you had any material that was straight, whether it was a steel rod or a wooden shaft or
where can you demonstrate the claim you're going to make? Hold on. You're getting ready to make a weird claim about how a sphere is going to react to a straight thing.
No.
Can you? You're not.
No,
you're
not about. It's not about yeah.
And say to scale, and you're not going to say, well, it matters because your globe's going to look straight to our scale because we're little bitty. That's not what you're telling me?
Not quite. What I'm saying is, if you had a long enough pole, let's say it's just a big metal pole.
Doesn't have to be long enough, Kosho.
Well, okay. So here's the two problems. If it's too short, then it's not going to if you set it on the surface, it's not going to be lifted up off of the ground. Not enough to measure is what I'm saying. Is that going to be enough?
You can demonstrate that on a sphere.
Well, I can tell you the value.
No. I don't want to hear your story of what leprechauns look like. That the value of a leprechaun doesn't matter. I want to see your claim in action in physics, because everybody keeps telling me I'm wrong, but I want them to demonstrate how I'm wrong, and they can't, which is weird. And all you need is a ball and any straight object to do so. Any ball you choose, you can get a ball bigger than your house and then use the toothpick. I don't care. Demonstrate your claim be true compared to what I just said. Hold on, stop, please. If you have a ball the big as your house, the toothpick is still going to stick off the edge of that, the right and the left. If you have a toothpick the size of the Epcot Center, and I set the toothpick right there, it's still going to deviate right and left. It does not matter the scale. I don't know why.
I'll try to prove you right. Okay, so in order to prove this correct, we're going to need to calculate what we should expect. So
no, you get a sphere. You get a sphere, and that sphere stands for 24,901. Okay, I have to tell you guys how to do physics. Then you get a toothpick, which would stand for when you put the toothpick against there. You measure it up, how long it is. That's going to stand for that portion of 24,901. Correct? You take a little piece of the toothpick, break it off. That's going to stand for, you have little increments of measurement on your toothpick now. You break it off. That's going to stand for your little guy. That would be like a mile to him or whatever. You pop it on there. Show me where it's going to follow the fucking curve perfectly. It'll never do that. It'll always deviate left and right, no matter what size the straight line is and no matter what size the sphere is. I've never seen anything but, and no one's going to show me any different. I'll wait to see it. I mean, I'm making a claim that is backed by everything I've demonstrated to myself, and I can't even imagine anything being different than that.
That's fair. However, so let's say we do your test with the toothpick.
Doesn't match my actual physical material stuff. Isn't your material supposed to match my sphere and stick? I mean, your numbers? Aren't your numbers supposed to match the physics of a sphere you claim? If they don't, then what
let Kosho respond. You've interrupted him every time he started to speak.
That's it. Well, let's go ahead and try it the way that you're suggesting with a toothpick, okay? Because I just by rough numbers, if a toothpick's 3 inches long, then you could technically get 500 million toothpicks to go all the way around the Earth in this country. And if you were able to do that with 500 million toothpicks, then that means that with any one toothpick, the amount of curvature you would expect to be beneath either end of it, while like the center sitting on the curve and then the two ends are above it, the amount of space in between the toothpick and the surface is going to be something that there's no device capable of measuring. There's no way to measure that gap.
You know that thing where it's like hotter, colder, like you're getting hotter or colder? I think we're getting way colder in terms of finding a definitive test. Because the thing is, Democ, I mean, I hear what you're saying with this. In theory, yes, of course, like a straight line doesn't fit on a sphere. The challenge is getting a material that would be straight. A toothpick, if that's what you're saying. Like a toothpick on a basketball, like what's the radius of a basketball? Like, you know, whatever, however many inches it is. And then the toothpick, it's like 3 inches. So the ratio of like a toothpick's only probably 1.5 inches. So like 1.5 inch toothpick with whatever the inches of the radius of a basketball, that ratio is such that when you put that toothpick on it, yeah, you could measure the gap, the difference between the curve and the straight toothpick. But if you're then talking about the Earth, the radius they claim the Earth is of a globe, and then to have something like a toothpick, like a straight material, that's the challenge, is the practicality of getting something straight like that that would be kept straight, let's say at least over a mile, and it would be so straight that you would be able to measure a 4-inch deviation on each side. Or
a hump of water. A sphere of water would present that for you. If you're standing on a sphere of water and the sphere of water has a hump and every part of that sphere is higher than every other part that you touch, then yes, in theory and in reality, this will work. A little noodle a little floaty noodle you sit on the water, because of the buoyancy of the noodle, the most of it is going to be supported by the hump of the water, and then the little edges are going to pop out. They have to. This is physics. They would have to on spherical water. On flat water, is the only problem you have is being flat water. That's why we have a problem, because it's flat water. If it was round water, you wouldn't have any problem doing this anywhere.
But what would stop the two ends of this let's say a giant toothpick? Just whatever.
It's not. I'm talking about floating.
What stop the two ends from bowing down and making the whole toothpick bow down by the weight of it?
Because you use a styrofoam floaty, the toothpick was just to show you that you can't line up any straight line with a ball. The floaty is what you're going to use on the water, and the whole middle of the floaty, except for the little piece that's going to be popped off the water at the end, the right end and the left end, the little edges are going to be popped off the water. Every other part,
you'd have to have something that's perfectly straight. So a floaty now is where you're at to get something that's perfectly straight. That is not going to work.
No, that's definitely going to work. It's a styrofoam floaty. Yeah.
Gio, I posted a flat Earth test in the text here, but I think it would work. It would probably cost definitely some thousands of dollars, but you could go to the Brazilian salt flats and just get like a truck winch. You'd need like a mile of cable, but put like 20 or 30 scales in between. Somebody else said this. It's not like my idea, but put like 20 or 30 scales in between the winch and like a stake in the ground, and attach the cable like 1.5 inches or 2 inches off the ground. And then when you reel the winch cable tight, it'll be pressing down on the scales more and more if the earth curve slack is being taken out.
Somebody already did measure the salt flats and found like 1 inch of slope, but just from higher elevated land, and that was it. But
this is like White's World. Yeah, this is White's World.
If you put scales, if the cable was resting on scales and you reeled it in, the scales would increase their weight, because like the 6 inches of curve would be like trying to come out of the cable. So you could definitely do that. It would probably cost like $10,000 at least, I would think, by the time, you went through all the headache, and I'm sure there'd be unforeseen, costs and everything like that. But I think it's a pretty realistic, pretty infallible test.
A good one. What do you think, Coach? I was mentioning this the other day. What do you think of this, right? So I was listening to Neil Armstrong talk about going to the moon, right? And he said that he had the video camera cable, right? It was like a hardwire cable. It's not wireless like we have these days, right? And he said it was 100 foot or 100 yard. No, 100. I think it was like 100-yard cable or something like that, right? He says, I'm on the moon, and I'm going to go take the camera over there. And lo and behold, we only got 60 feet away from the thing, away from the capsule, right? And he said we were really all confused for a second. And then we realized it was the curvature of the moon shortened from 100 feet in a straight line to 60 feet or 60 yards, whatever it was, over a curved surface. You think that would be a result everywhere on Earth as well, or is that interesting?
I have to ask you about that again, because I got to think about that one. Sounds kind of sounds interesting, and it's a bit too extreme. But I'd have to look at exactly what that claim is. But because there's actually a couple things that were said just now, like because what you're talking about, Seven Saxton is a lot like White's World Test, except for I now have come up with a way that actually it could work because it still has the same problem where if you pull it, it's going to pull on the scale, and so you might get a false positive. But I think I'd have a way to
wait. No, it would pull up the scale laterally, dude.
No, you're right. You pull laterally, but I'm saying
but you would be able to calculate based on how much slack is caused by the curve and how long the line is. You'd be able to calculate exactly how much tension would increase on the scale based on how much you reeled it in.
I think if you had multiple scales, like you said, and you also pulled at the same,
you'd probably need in excess of probably even like 50 scales, man. I don't know. I mean, it would be like quite the undertaking, but if you had enough money, I mean, you could probably do it for like 30, 40 grand, I would think, like realistically, at least. But like, you could do it, you know? The only other thing I've thought that you could just infallibly test the curve is if you had a ring laser gyro in an aircraft over long distance. That's another one, because then they can't cross session and gimbal friction.
Yeah, because the one like Bob Nodell used, they have instruct. I mean, those are made for planes too. But and then but I still like the thing is, Regis's test with the neutrally buoyant. It's a lot like the one you just described, but it's I can see that being done for less than a couple $100 because if you have the right location and the right material. I think most. Yeah, because you don't have to worry about the weight.
That line, because they already have neutrally buoyant line for divers and stuff, don't they?
I'm not sure. I don't know much about that.
Yo, guys,
I'm pretty sure they.
What about vision?
Guys, what stops us from actually doing this test? Because I think most of us in this VC agree it's pretty viable. Like, why can't we come together and actually do this? Like, what do we need? How much would equipment cost? And what kind of terrain would we need to perform this on?
I think like Bob Nodal of FE Core would be like the people that realistically could get it done. Like,
oh, but we can do it as well. What stops us, bro? We just as smart as them. We're just as capable.
I don't think we're just as smart and capable as them.
Why not?
Because I think they're more smart and capable than us.
Why? What degree does Bob Nodal have that allows him to perform these kind of measurements better than you?
I'm just saying, if I had to
have more than a meniscus,
I had to guess. You know,
I don't know. I think this is something we. Well, I mean, if you don't want to do it, it's cool. The 7th, but I think there are people in here that are pretty interested in doing this.
At all, I'm not saying I won't contribute. It is fun. I'm just saying, like, to me, realistically, the best way to really get something like that done is to talk to, like, you know, Bob Nodal of FE Core, because they're like the group that's like dedicated to doing stuff like that. You know.
I personally wouldn't take Bob Nodale's word for it.
Yeah, then what? We got to wait 3 years, and I try to catch him on a live show and squeeze the information out of him. Like, what?
Why is it so?
I'm serious, man.
Listen to this real quick, guys. Why is it so easy to tell that water dips down on the fucking floor when your floor dips down, and you got a room and your floor dips down 8 inches in a little bitty room? How do you know that the water is dipping down 8 inches to match the floor? Why is it doing that so easily?
That's a very good
and we have no problem with that, right?
An even better
but it's so hard to see. Hold on a minute, I'm not done. But it's so hard to tell whether 8 inches of a hump is in that same room, but we can tell 8 inches of a fall. Kind of weird to me, man.
Weird as hell. But really, man, you know, like, aren't you guys tired of the talking? Let's go out there and actually do something, all of us.
Right,
you know?
some optics.
It doesn't need to be all of us at the same time, but we could split up into small groups and get things done, you know? Jeremy and I are up northeast.
Okay, so
whoever's out west.
All right. So step number 1 is we got to get like a mile of neutral density line. How much is that stuff? Here, I'll Google.
Get a picture.
Let's look into it, man. How did that?
I'll get a picture. For me,
please.
Like
I said,
how long would the line be though?
Like I said, Rumpus had a way to measure it at the. If you do get a neutral density line, the way to tell if it's neutrally buoyant or not is by measuring it in the first few hundred feet. You know, at intervals. That way you can tell if it's being if it's.
They sell it.
Jeremy's
already,
talking. Come on, man. Jeremy's talking, bro.
Okay, now, come on, man.
Calm down, man. Jeremy, go ahead.
I'm just saying, there's a way to tell if it is actually neutrally buoyant or not.
Which is
profound.
I didn't hear it. I'm sorry, man.
Measure it. Me and Rumpus came up with this one day because we were talking about this, and you measure it at the beginning of the, within the first couple hundred feet or whatever.
Okay, that's pretty standard. That's what everyone would do. But yeah, I mean, I think this is feasible, guys. This is something we could actually do, and I think as a server, it would really be a good thing to do, man.
I'd be careful, Jeremy. It sounds like Nature's trying to find an excuse to be alone with you and probably try to fuck you.
Yeah.
Trying to touch tips.
Sounds like tips.
Fuck you till you love me. No, I'm playing me.
He's really adamant about this, man.
Yeah, because I really do think it's about time we stop with the talking and actually go out there and start doing stuff, guys.
Yeah, do some pictures too. Actually get like a totem pole type thing, like I told you.
You too, Demark. You too. Like we should all be.
No, I do visuals on a ball. I get a little ball and I do visuals on it. No.
Yeah, but not visuals.
Stop
Let's
for a minute.
go out and do
You're not listening.
Experiments.
Yeah, you can go out and see if reality matches my ball. When it doesn't anywhere, then I did mine. So if you can go out and match reality to my ball and go up in the air and not see the top of an object that's a couple miles away around the curve, then you would match my ball. Then you would match real ball on real physical reality. That the only ball I fucking ever seen in my life, 360-degree sphere.
Someone's
basketball. Yeah, somebody is snoring. They've been snoring for about 30 minutes.
Fuck.
I might have.
Who is it?
Hold
on.
Don't worry. It's not anybody in here.
Nobody in here.
Trust me. Me and somebody else in here knows who it is. It's all that matters.
Jeremy, who is it?
I don't know.
Anyways, the point is, the point. There's a couple other things. Oh yeah, right. You wouldn't even need to do more than a mile for Regis's. I mean, I'm probably gonna fuck around and try to do it. I think the most difficult part about what Regis was saying is being able to find a still enough, calm enough area to do this. Like you would need like a very narrow canal, one that was almost private, that nobody else goes in.
I crunched the numbers. It's going to be about $2,700 in line. They just sell neutral density line. That's what I was trying to tell the guy that was rambling on about how to test it. I was trying to. They just sell it already like that, but it's like 27.
They sell it uninterrupted spool.
I did
1,000 feet for $140.
They sell it in 1,200-foot sections, and it's like 500 and something. I don't know. I crunched numbers. It's like $2,700 for a mile and a quarter.
Get some used.
It's not.
Get some off.
You're talking about I was the guy rambling on about how to test it?
Yeah, you
yeah, I wasn't trying to cut you off. I was just trying to say they already sell it like that. You don't really have to test it. But it would be like $2,700.
I told someone earlier you could put it in salt water or you could put it in fresh water.
Yeah.
Do you even know?
Put it in fresh
talking
water.
About?
But who wants to pony up $2,700?
You know what you're talking about? Is it neutrally buoyant in salt water or fresh water?
Talk about whether or not we can get the money to buy it.
Yeah, we like
try to buy it before we test it. So where's the $2,700?
Listen,
neutrally buoyant in salt water or fresh water?
Fresh water. And listen, they sell some neutrally buoyant high test line on a spool of 15,000 feet for $140 some places. Now the line that you've found for 2,700, I would look at it. If it's claiming to be 100% neutrally buoyant, then maybe it is worth trying to raise the funds for that if we're doing one definitive test. But
how thick is the line for referencing?
How what?
How thick is the line? What's its tensile strength? It's got to have a lot of tensile strength, man, because it's going to be really long.
80 test.
Okay, it's gonna have to be stronger than that, man.
Dude, not in neutrally buoyant medium.
Yeah. I mean, I don't know. I think the stuff I was looking at was stronger, but regardless, dude, my point is to the guy that was asking the question before. Okay, why don't we just do it? Well, it's gonna take thousands of dollars, and I mean, just travel, all that, So that's the problem. That's why we just don't do it.
But
it's not going to cost that much, dude. We have the GoPros among the community. It's really
just cost that much to send a high altitude balloon up and a drone. Just send them straight up from where you're at, and just look out and see which buildings you can't see the top of, but you can see the front door. Just look where you can see the front door and the bottom of the building, and not the very top of it. Anywhere at any altitude, then we're on a ball. If not, we're not on a ball. Go optically.
Right.
But
yeah, also,
but isn't it worth it?
Who actually did that? I would contribute. If they spend their time and money, I contribute.
Right, but this drone thing is cheaper. So if you guys do that, and the drone thing costs 50 cents for somebody who already has a drone, why not do them both?
Yeah, we can.
Well, I don't know. I feel like the drone thing's already been done. I feel like the drone.
It has. Well, then we're on a flat plane then.
Yeah,
or a round plane, right?
Yeah, I agree.
Can I just get a word in? We can do as many tests as possible. We can do long distance observations, the long string buoyancy thing, or drones. Whatever it takes. But is there really a price on wanting to know what the truth or the nature of our planet is? Like are we gonna cry because it costs too much to figure out what the truth is?
If you're talking existentially, no, there's not a price. But if you're talking realistically, to do these experiments, yes, there is a price. To get the neutral,
what I'm saying is there a price? Is there a price?
What's the range in a helicopter of view?
Yo, DeMarc, yeah. I'm talking. We are more than 10 grown men in here with jobs. I'm sure we can put together 2,700, right?
Yeah, I think we can, but can we? You know what I mean? I agree that it's possible, but can we actually do it though?
What's stopping us?
I guess it's just a matter of one guy being okay, here's my my info, send me all your money, and everybody actually
you guys are thinking about it wrong, man. There's 100 million fishermen. Some of them are flat earthers, and some of them probably have a spool of string already sitting to the side that they'll donate you.
Yo, who's snoring? When they turn their mic on, they got someone sleeping heavy in the background.
It's DeMarc. It's definitely DeMarc. Because it happens when DeMarc talks.
If the line is actually neutrally buoyant, then when you pull it tight, should be just like a plumb line under the water. So
no, it's not plumb line.
If it's neutrally buoyant, it would be essentially it would be a plumb if it's perfectly neutrally buoyant. Yes.
No.
It would be a plumb line. There would be a force. We would pull a force on the line, just like the force of gravity on a plumb line.
Oh, you're saying
it would just go straight in the direction of the force.
Yeah, you're saying it's like a horizontal plumb line is what you're saying. Yeah, okay, I agree with you. You're saying something stupid. Anyways, check this out.
Let's let this guy ramble on about how we can't get 2,700.
Check this out,
yeah,
dude.
So even if let's say we could do it for $1,500 just in line, then we got to get the winch. The winch is going to be $400 or $500. Then somebody even if let's say I was the one that had this stuff and you guys gave it to me, even though I don't want that, then I'd have to still go do it. So I just have to spend I don't know. I mean, how long this would take? How much of a headache? There's always unforeseen things that are headaches. So somebody will work for free.
You don't need a winch.
How much of a pain in the dick this is? It's what's their time worth? You know what I mean?
You don't need a winch, man. It's not going to be that hard to pull it taut in neutrally buoyant situation.
Okay, all right. Well, all I'm saying is basically prove me wrong. Then you're saying it's so easy to do. Then just go do it. Why haven't you done it already?
Pretty sure 2 fishing poles could do it. If 2 fishing poles had one string connected to both of them, and then you just pull take one that way with you and give it to the other guy, and then they just pull the fucking reel in.
I do think the line would have to be at least 1.25 miles, though. I mean, it'd have to be really long.
Right, but we have whale fishing poles, so if actually that's all you'd probably need. Take one end of the string, hook it to the pole right here, and then hook the other string to the pole, hook it through the eyes, and then you got them connected. And you just take that one with you, and one guy stays right here with the other one. You take one down.
I mean, yeah, you're essentially measuring the sagita in this, right? You're keeping it a foot beneath the water on each side, and then you pull it tight. Is that what's going on?
Yeah, basically.
So you're just measuring the sagita. So you're just measuring the sagita then. So you'd have to have it decently long, yeah.
This is what you could do. All you need is a boat, and then you'd need you could just tie the neutrally buoyant line to like
to underneath it.
Pier, the piling of a pier, and then you could just drive the boat away from the pier. Unravel.
Right, underneath the foot,
idea. No, it's a fucking terrible idea.
Why is that a terrible idea?
A boat?
Yeah.
With an iron rod 1 foot low, and then you have 1 foot below the pier water, and you have them tied, and you just keep pulling it taut.
You tie one end of the neutrally buoyant line on the pier piling a foot below the water, and then you drive the boat away with the winch unraveling it, and then you have the neutrally buoyant line put a foot below the water on the boat, and then you see another guy test in the middle.
You don't want to be stirring the water up with a propeller, though.
Right.
This needs to be done in still water, first of all.
It's only a mile. You can use a rowboat.
You'd have to be careful.
You hear two people talking
on the rotating propeller and cut your line too, or just like jump out in the water and get eaten by sharks.
Spaz up in here. So you're definitely not going to do this in the ocean.
No.
You could do it anywhere. That's the point.
No, the problem.
You can't do it in the ocean.
We're trying to address is that
it's still calm water.
In life, you could do it.
Yeah, the water's got to be completely
water.
still.
You're definitely not doing it in the ocean.
You need no turbulence whatsoever. Otherwise,
so who has a boat and a lake?
Let's not be dumb about this. You're not going to be using a boat for this. You can't use a boat for this.
The water's got to be as still as possible, without the least amount of turbulence as you.
How did you can't go on the ocean and do this? Just become you can't do this in a boat at all, and everything you just explained is wrong.
No, you could do it in the ocean.
Boat. You're not going to be doing this in the ocean or using a boat.
I didn't say you do it in the ocean ever. Ever did I say the word ocean?
Here.
Yeah, the whole point though is that you don't want to have any sort of chance of turbulence.
Yeah, it has to be calm down. You ever been outside and been on the water, dude?
Yes.
Have you ever seen
a calm down? I hope a turtle comes by and bites your line and breaks your line from a turtle or a fish or something.
But what if there's waves? What if there's turbulence? So you just go another day.
Well, at the ocean, you don't have that luxury, though. There's not really calm ocean time. And then the boat is going to create the wave that you'd be avoiding.
You guys are telling me how this is so easy to do these experiments and how I'm just so negative, and it's like, well, then you do them, and then it's like there's 1,000 problems with no solutions.
Yeah, this is a logistical nightmare. Yeah, we've talked about this to death. This isn't our first day talking about this. Like some people in here, we've been talking about this to death. So
2 years.
Look at the picture I'm going to put back in the back. I'm going to put a picture in the chat.
We have 3 ways to do it. The bottom line is it takes a lot of money and time.
Money it would probably take a few grand. Might take a little bit of time to do it. The setup is what's the most important part of it, though. You got to make sure your setup's right.
Yeah, and then it's like you're doing it for just ungrateful idiots on the internet who like are just laymen who think they're way smarter than they are, and then they just like don't contribute financially at all. Like I know how most of you people are.
Fuck, man.
And they'll deny it anyway, so it won't matter.
Yeah, no matter what result you come back,
you don't need finance.
They'll just say the line was either buoyant or sagging or whatever, either side, whichever way it goes.
You don't need crazy financing, like you just said. That's idiocracy. You need visuals. If you can't do it on a thing,
we've already done visuals ad nauseum, dude.
You did what? Which ones did you do?
Visuals have already been done ad nauseum.
Show me the blind test you did. Show me where you saw a box of cereal drop after 8 inches after the mile you pushed it away.
Okay.
Show me the visuals.
Tell
how
them
you
about
see
the
a
fishing
picture
pole.
in itself.
Maybe tell them about the
With
fishing
a picture.
pole.
A picture. Show me how you did a visual with a picture of grandma tilted down where you can't see it. You push it away and then she pops up and you can see her. I'll wait.
Yeah, I agree though. There's no optical shit that's gonna be an end to this. It needs to be something tangible, definitive.
Check this out, Playboy. I have found this shit right here. Okay, it's called 500 meters of nylon Japanese monofilament rock sea fishing line, and the monofilament that's neutrally buoyant, and this is only $12.
Just so we're clear, all the bodies of water, they're all the same. They all have the same density. All lakes and rivers and canals and shit.
Dipshit.
I'm just wondering, is that how water works?
That's a good question, man. I'll get back to you.
Is this the same? Does the fucking neutral density line actually work, guy?
Are all bodies of water the same density? I'm just curious.
Dude, shut the fuck up.
That's not a reasonable question?
Jeremy, this dude. He's out of control. Snap.
Yeah.
I know. He was calling me a retard 2 days ago. I know.
I hope I didn't make a bad. I mean, wasn't a bad example.
You know
I was just messing around with you, dude.
He left.
I was just saying. Yeah, I was telling you.
Somebody probably gave him a warning or something. Are all bodies of water the same density? Like, if I go to a lake near my house, is it the same density as Lake Okeechobee or a canal somewhere or something?
Your brain is definitely more dense than all bodies of water.
I know.
No, but yeah, you're right, my man. Something I didn't think about, and I certainly, like I said, I was a bad example because I think he thinks I was being serious, and so he followed suit, unfortunately. But regardless, yeah, you're right, but at the same time, that's not a hard problem to solve. You just kind of determine, is this a freshwater or saltwater one, and then test it at where you're going to be at. And what you said, what you and Rumpus said about going out there and, however you would test it, you wouldn't need to do any of that. You would just need to take it and put it in the water and see if that is neutrally buoyant. It doesn't matter.
What about when you start stretching it? I know you could cut a piece off, throw it in the water, place it wherever you want, time it, moving. But what about when you stretch it out?
Here's what you would never do. Stretch it out.
We're going to stretch it out when we pull the line to see if it measures the same height above the water. No, you're not going to stretch it out.
You don't want to stretch it out. You want to pull it taut, however it's said. And by doing that in a neutrally buoyant material and environment, but in principle, you should never need to pull it, stretch it out.
So we're going to pull it, you're saying just tight enough to where it doesn't stretch?
Like I said, but in principle, you should be able to pull it without it needing to stretch it out, yes. Although I bet you that's not exactly possible the way you would think, ideally.
It doesn't even sound possible, yeah.
I mean, it might be possible. Like I said, there's going to be issues like with the fact that it was rolled up, and so it's like you want to make sure it's straight and not. So there's going to be tension, or not tension. There's going to be like a force that you're going to have to overcome by the fact that it was rolled up, right? So
this is the one thing Rumpus was right on. You got to check the line once you pull it tight to make sure it's not going up or down in the first few 100 feet, because then you'll know.
Yeah.
I don't know why you said it's not. You don't need to do that.
Well, because I wasn't thinking about, like I said, because you know how it's like it keeps its shape, like curved around, so you want to like straighten that part out, and then to do that, you're gonna want to pull it a little bit more. So.
Yeah, no, that's still a viable one to do, the underwater line, definitely.
That's the best one I've heard. I don't know how. Other than the one I came up with, of course.
GPS thing?
Yeah, it's by far the greatest.
Yeah, but your GPS thing has refraction in it, so we're definitely not going to be using that.
You're lucky there's a lady present right now, dude. Cause I would fucking wipe the. I would just. I don't want to say. You know, you pissed me off when you said that, dude.
Bro, it's not. I didn't come up with that. That's you can Google is there refraction in GPS, and they tell you yes, there is.
How much?
It doesn't matter. We're not doing anything that has refraction involved with it because now we're just talking about how much, which way's the light bending. Who knows?
This is how crazy I am, dude. I was literally just thinking, I'm not about to pretend like I've never had this conversation with this guy and respond to him about this. But then I realized I have to, because I don't get, dude. Why would you say that, dude? Why would you say that when you know it's not an issue whatsoever? Well, I told you when you use differential GPS, you correct for any errors that you would have been given, including refraction. So if refraction was an issue before you did differential GPS, by doing differential GPS and using a base station, you would have corrected for whatever refractive effects you were experiencing. I've said this to you 1,000 times.
Okay, here we go. You ready? Though both refraction and diffraction, the atmosphere, the apparent speed, and to a lesser extent, their claim, the direction of the signal. Google GPS refraction, and you'll get a whole slew of shit. How GPS is affected by refraction. We're not doing nothing with refraction, dude, because now it's just an argument of which way is the light bending, and
Okay, thank God, Blaze.
You might as well do another laser test.
I mean, Jeremy, anything optical or light-based is going to be affected by refraction.
Yeah,
try telling Kosho that.
Listen, dude, I don't care how much Nate wants you, and so he's going to try to fucking side with you so you can get in your pants. Guess what, bro? It doesn't matter. Listen, dude. Let me tell you this. Let me just try to reason with Nate, and then maybe Nate can explain it in a way that makes sense to you. Okay, Nate. This is clear. When you do GPS, it's true. Refraction can be a problem. So can 1,000 other things, whatever they are. Okay, the atmosphere can be a problem. The ionosphere is a problem. Anyways. So it doesn't give you the exact location. It's sometimes 30 feet off, closer sometimes. Regardless, differential GPS specifically takes the reading of a nearby base station, which is a location that is already referenced in the model that the GPS is using to find your location. So the base station is a known location that's also getting GPS readings at the exact same time. And since it knows where it is, and it's also getting readings from the GPS, it can easily tell what the errors are that it's receiving. So if it says it's like fucking 5 feet from where it is, you can draw a vector that points to its correct position, and then you can take that same exact vector and attach it to your reading that you're getting, as long as you're close enough to that base station, like within 20 miles, 10 miles or so. If you take that same vector that you corrected for at that base station and apply it to your measurement, you can get within a centimeter of accurate measurement. This is why they use this method to make things like LIGO and shit. It's because it's very very accurate. So
yeah,
GPS,
I
GPS
agree with that 100%. Yeah.
So
yeah, exactly. That works.
Yeah. The thing is, you have to.
And refraction would be accounted for in that situation because you know the actual location of these base stations, right?
The same refraction that would have been fucking up the base station's measurements, you're already applying that same correction vector to yours. So the refraction is accounted for in that correction.
Yeah. But why does Jeremy still have an issue with that?
That's why I want to blow my brains out, because I don't know.
You drove him to suicide, Jeremy.
Did you guys hear the citation I just read?
Yeah.
Yeah, but in your citation, did you hear what Kosho said? In Kosho's setup, refraction is being accounted for, Jeremy, because we know the actual locations of these base stations. So we know if there's an error, if it's off, we can account for it.
We just call it Ron Hatch to fix it if it's incorrect.
Yeah, call Ron.
No, we account for it.
Ron Howard. Yeah.
I don't know. Let me try to think of a more simplified example, Jeremy. If your house, right, is at the end of the block, and I know your house is at the end of the block, my house is at the top, and your house is 10 houses from mine at the end of the block. And then I try and use some sort of optical device to figure out how many houses away your house is from mine, Jeremy. And due to refraction, I get a measurement of 11 houses. I know that refraction has affected my measurement, and I can account for it because I know the actual location of your house, Jeremy. I know it's 10 houses away. So if I get 11, then I need to account for that refraction. Does that make sense?
To everybody but Jeremy.
Dude, we're trying to make a straight line here. We're trying to make a straight line. This GPS thing has refraction involved. We all agree. There's a refraction correction they make. Okay? They're guessing which way the refraction's bending, by how much. Now we're in the same position we are with a black swan or any other optical thing where there's refraction involved. And now we're debating on refraction, which way is the light bending.
But Jeremy, we can... Sorry, go ahead, Coach.
This is evidence that you don't listen to anything I say, dude. I almost half think that Nate wasn't even listening to me, but it doesn't matter. The point is, you were not listening to me, dude. Because you keep saying that same shit over and over again. No, I mean,
how was I half listening?
Physical that even a blind man could find out that it's measuring curvature or lack of curvature. Just like I said, just like Neil Armstrong did with that cable on the moon, where he said he had a 100-foot cable, laid it out, and says the curvature of the moon only allowed him to extend it 60 feet.
How sure are you that you remember those numbers correctly? Because if you remember those numbers correctly, that's cool. But if not, then I want to look it up because I want to see exactly what the claim is.
Yeah. While you're looking that up, can you explain how I was half listening?
I just think your analogy was very bad.
No. I was trying to make it as simple as possible.
I appreciate the effort.
No, the houses analogy. It was 12. But yeah, the numbers, it was 160, whether it was meters or feet or yards, I'm not sure. And it was post moon landing and upon his recent return. So it's not like an old man. It's him very recently interviewing afterwards. There was the 100 number and the 60, whether it was meters, yards, or feet, I'm not sure.
Okay, Nate, I'm gonna show a picture right now, just to make sure that because I want to make sure that what I said to you also wasn't it was clear. Because I think that's the problem. Is sometimes when I explain things, it makes sense to me. Maybe it didn't come.
I feel like I understood you, but yeah, go for it.
Oh, this is what I did. I made this picture for Jeremy. I'm glad I found it because I was like, I hate it when I make a picture. I take a waste of time doing it and I make it again. But anyways, yeah. So, in this picture, you have the what do I have here? Hold on. Right. Okay. So you have the base station, I guess. Yeah. I guess.
Yeah. GPS base station.
Right. So you have the base station. Let me look at this for a second before I start explaining this.
Oh my God, Kosha. Isn't it you using that first line to the top in the top left quadrant, right? Right. It says GPS base station, that checkered line. You're using that as your basis to correct for all your other measurements. Right. Where you have position 2, 3. Yeah. So I mean that's I don't know how that doesn't work with the example I gave with Jeremy. If the GPS blue dot is the house at the bottom of the block, base red dot is the house at the top of the block.
Well, no.
And we know there's 10 houses in between. No.
Wait, I mean, unless I misheard you. Yeah, the base state. The red dot is the base station where it actually is fixed in reality and in reference to the coordinate system. And the GPS next to it, right, is the GPS reading for the base station, which I think you said. Because then you said that vector is the vector representing the correction needing to be made to get the correct position. And so, you just apply that to the GPS. So on the right side, is your location that you're getting. Okay, I think you would say, right. I just maybe wasn't listening correctly.
I think you don't listen to me, Coach.
Yeah, it could be it, to be honest.
Are you guys building a test using the ISS and satellites to prove curvature? That's not going to work for anybody.
I agree. Yeah, the ISS would be very difficult to do, to use for GPS. But regardless, the GPS satellites are a little bit more useful for that regard. But I think that you do understand what I'm saying.
Yeah, I do. I just don't get why Jeremy doesn't agree with it.
Whatever you use, I'd imagine would have to be seen, right? Like, so if you're using a satellite, then it needs to be as big as a football field, fly up on a balloon. We have to see it, not a satellite.
Here's the
weather
beauty
balloon or something.
Yeah, the beauty of GPS is, for this regard, using GPS to do this, it's actually irrelevant where the signal's coming from and how the signal is telling you where you are. All that matters is how sure you are that it's giving you a consistent and correct position. And this can be verified beforehand, before you actually go through the actual test. You can verify to make sure it's given. Like, let's say, like when I'm testing it for me, I'll test devices in the exact same location over and over again, just to be sure that it's giving me the same location over and over again, right? So stuff like that. But if you can be sure about that, it doesn't matter that that's coming from a satellite or whatever, because all you're using it for is the fact that it's giving you exact positions, which you can use to develop a straight line.
Yeah, I say keep it. I mean, I appreciate you guys' thought. I'd say keep it simple. You just you just build a cube, put a little truss in between it, square it up, put it in a lake, a 1 mile long lake, submerge it from the center, and let's see what happens. If it's evenly submerged, then there's no curve.
The problem with anything that has weight or buoyancy, something that's not neutrally buoyant, anything at all, is that any bit of something that's long enough to be able to measure this curve that we'd be looking for would also be long enough such that the weight of it.
Yeah, but you get like little buoys or something. I mean, there'll be different lengths, right, to the bottom of the lake, right? So, but you have them suspend every 4 feet throughout the structure. All that takes is air in a container, a buoy on a string or a stick to hold it at that depth. And if it doesn't pop out on either end out of the water once it's submerged 8 inches under, then there's no curve.
So if it doesn't pop out, but that's what I'm saying is if it's long enough, the weight
on either end of the structure, it should pop out of the water 4 inches on each side.
This is what Democ was saying, but that's what I'm saying is the weight alone would compel it downward and would almost mask the fact that it was on a curved surface, because it would seem like it's
so what you're saying, Coach, is the each end would go under the water 4 inches, but the center wouldn't. We could look for that too, right?
No. So if you had a long enough pole and you put the center on the surface of the water.
So hold on. So the center's not going to match the edges, right? It's going to bow at the ends from the center. So we're looking for 4 inches of deviation under the water or above the water, right?
No, but that's what I'm saying is the bowing would make it. The bowing it's only going to bow until it's perfectly level, right? Because then
So you're saying the bowing pole is the earth curve stencil we've all been waiting for.
Yes, but it's not going to be able to measure the curvature because it's going to match the curvature.
So a earth curve stencil made by the earth's curve, bowing the material, is not going to match the earth curve, but it is the earth curve making the earth curve.
No,
How much sense do you make?
The earth curve, but you won't be able to use it to to identify.
How much sense does that make? This here little Jimmy matches this outline tracing matches a smiley face, little Jimmy, but you're not going to be able to use this to trace a smiley face. How does that make sense?
Well, so you once it matches the curve, how are you going to test that it's curved or not? Where are you going to take it out of the water?
Well,
I mean, it would have to be a mile long, right?
You take little buoys, like little rods, right? Like 4 feet, 5 feet, 10 feet, whatever, until it hits the bottom of the lake, and you know that they are changing up because you have it bolted. You have whatever you built, you have it bolted to that buoy, and then another. Then you have the string of a buoy with air on it, holding it and suspending it. Above the structure. You got the stick below it and the little air buoy above it.
Yeah, Lake Pontchartrain Bridge is
life raft. Sorry.
I mean, there's structures built this way, so why not use structures?
So what you're telling me, Coach, shows like no one in the world knows how to make a stencil of something.
No, they do. But let's say that you want to make a stencil of the curve,
like a railing to a curved stairway, or a railing to a little bridge over a brook, a babbling brook, right? Of a global eye. We're walking over the babbling brook of the global eye, and we have a little curve on this on the arc of this little bridge. Who made that, and how'd they do it? If they can't make another.
No, but that's my point. If you take Lake Pontchartrain Bridge and we pretend the Earth is curving, and we know that the bridge is matching the water, so it's doing whatever the water is doing, whether it's curved or flat. This would be a stencil, as you suggest. The question is, now that we have this stencil, we have this bridge that is perfectly matching the water. How do we then take that bridge and identify it as flat or curved?
You get a big roll of paper that's straight, because you get it from the store, manufacturing paper, and they make it that way. Construction, you get a roll of it and you roll it out like a rolling paper that you roll with. Those are straight, but it's big. Like, our size, like felt paper, like a thing of 4-foot felt paper. Those are straight. So then you roll it out, right? And then you trace your stencil along that paper, right? You start from the bottom corner and you trace it.
How long? How long of a line are you making?
However long you want. You can make 2 foot, 3 foot, whatever section, whatever you want to trace. You trace one. If you trace an inch, that's an inch of the earth curve. If you trace 10 foot, that's 10 foot of it. If you keep going and trace the whole bridge on the row of paper, then that's the whole, however long that is. You can do how much ever you need, and then you could take sections of that little curve you got on the paper, make it into a material. Make a hard material, match it, line it up on the paper, make it match it. Then you go put it to water. I mean, why haven't we done this? I mean, you're claiming to have stencils of the earth curve, but nobody can have one in their hand. That's just weird to me. But we're so technologically advanced.
If we had something straight, Coach, all right, if we had something perfectly straight and we laid it upon the surface of the earth, is it going to conform to the curvature of the earth, or is it going to remain straight?
It's going to conform to the surface of the earth. That depends on two things. One of them is the length of it. It would need to be long enough for there to be a discernible distance between the other end of it and the surface. And then it would also need to be rigid at all costs. And unfortunately, it's that second part that creates the biggest problem, because the longer you make it, the heavier.
Yeah, but it doesn't need to sit on its own. You can suspend it like a bridge with pillars, right? Like our 1 mile wooden cube structure that we built. We can, like a bridge, put pillars to the bottom of the lake at different lengths. Suspend every 4 feet, holding up that structure. It would still bend.
Yeah, but how would you determine? With
a cubed structure? Yeah, with a cube, it's a cube structure. So imagine you take 2x4s of wood, right? And you build a cube, right? And that way, everywhere along the measurement that it's squared. There's triangles in between everything, keeping it all perfectly straight. It's a cube.
I used to say something a lot, but I would say this and it would make people very angry on your side, especially this guy called Hans. I remember I told him one time he got very angry. But if the Earth were completely smooth, like the size that it is, but a perfectly smooth ball with no features on it, the size that it is though, or the size we think it is, I could build a railroad that went all the way around the equator at let's say in segments of 20 feet, 10 feet, 20 feet segments. It doesn't matter. Well, it does matter, but let's say 20 feet segments. And I would never need to account for the curvature, meaning I could build a railroad going all the way around the Earth, piece by piece, connect them together, and not need to know that the Earth was curved.
Where you would have to
that doesn't
account
make
for
any
it,
sense.
you would fall. Yeah, where you'd have to account for it is in the material. That if you had enough material and you measured it in like feet and inches in a factory, right, 20 feet, whatever it is, you said 20 feet, that you would fall short. You would be, I don't know how short you'd be, but you'd be maybe 5 miles short once you got to the other end of the railroad of material. You wouldn't have enough supply.
Well, if I need a circumference, sorry, go ahead, Skyline.
Just like Neil Armstrong said previously that he had a 100-foot cable or 100-yard, whatever it was, cable on the surface of the moon. It only extended 60 feet because of the curvature of the moon.
You just take off laying your tracks, and when you get to the end, you fill the gap. I mean, that's not an issue.
Well, you'd be short.
The Earth is only 4 times bigger. The Earth is only 4 times bigger than the moon, bro. So if they used 100 foot, we only need 400 foot.
What are you saying?
Guaranteed.
Yeah, so that's, I mean, when you said you wouldn't have to take it into consideration, you would, I mean, you're saying, well, then you would just go buy material. Well, you'd consider buying more material because then you'd have to consider it and take it into consideration.
We don't know how long it is. We're just going to lay tracks till we close the loop.
Right. Well, yeah, sure.
Loop. There ain't a loop on a sphere.
Money's all free and all materials are infinite and nothing matters, then yeah, I don't have to take it into consideration. I hear that argument. That's a good one.
Well, if Neil Armstrong did it on the moon, and the moon is 1/4 the size, and we have all that math, and it's all been worked out and calculated already, and we all agree on it, then all we need is a 400-foot rope, right?
Well, I mean, Kosho's point is that, I mean, why would you have to accommodate the curvature in laying tracks, 20, 30-foot sections? Why would you have to accommodate it?
In which way? You mean as far as
keeping
it horizontal level?
The curvature of it. It's a perfectly smooth ball where there's no terrain, no hills, no topography. You just take off laying tracks. Why would you have to consider the curvature?
Show us that on a ball. We don't know what you're talking about. I've never seen that before. You guys are making claims and nobody agree on that shit. You'd have to demonstrate that hold on a second. You got to demonstrate a railroad track, little pieces, get some Legos and get your size of a ball. I done challenged you. Get a ball, get little Legos. We know they're little straight, flat squares, and put them around there and let us not see the deviation underneath each one. We'll wait.
Well, I didn't mean to steal Kosho's point, but
no, guys, actually don't do some math.
Kosho didn't have a point. You guys can't demonstrate it on a real ball. We need to see the physics match your imagination. You guys keep imagining that something straight is going to conform to a ball. I'd like to see it. You keep saying just because of a ball,
the answer would have
big.
to be in the give in between the 20-foot lengths. If it doesn't give at all, like up and down wise when they connect, then you would not be able to do what you're saying.
Exactly.
But so it does give.
There should be enough margin of error in there for it to be possible, though. I agree with that.
Yeah. Yeah. How rigid the object is, and then you would fall, and then again you would fall short on material. Yeah, those two things to be considered.
Even if they didn't give over 300 feet or 100 yards, the curvature, according to the model, is less than a millimeter. It's like 0.7 millimeters over 300 yards or 300 feet.
Where on what actual physical object?
So
On what
in
object?
20 feet, it's like in the thousandths
Where?
of an inch. You wouldn't even be. I mean, you could
Where?
probably
What are you
measure it.
talking about? That's your
God damn
imaginary
it!
numbers land. You understand that,
Okay.
right? Yeah. Uh huh. You understand that's in your number zone. That doesn't exist anywhere in reality. So where do we have that in reality?
And as you raise from the surface of this perfect sphere, right, then you would get even further apart. So, I mean, do this test, 10 miles high, you'll be even further apart and shorter on material. If I were to raise that
Anytime.
in the air.
Anytime
does
I
the
put
circumference
toothpicks on a
not?
ball, I have little triangles every time. I make little triangles every time I put straight things together on a sphere. Each connecting little straight thing, there's a little triangle underneath it. There's a little gap every time, every single time. Now, I don't know what sphere you guys think the Earth is or what the fuck you're claiming, but how are you demonstrating your numbers with the physical reality of what we're standing on? The water or the dirt? When have you guys actually demonstrated anybody's backyard or anybody's lake or anything doing any dip or curve or bending?
Well, DMAC, you do agree that you might not be using small enough pieces to fit the actual scale of the Earth, right?
What scale? It's an imaginated thing, right? Where are you demonstrating it? You haven't
Okay,
pulled out the little ball
if it
that's
is a globe,
scaled. You haven't got the listen. You don't have a little model in your hand called a ball showing me. You guys are allergic to doing this. So when you keep saying your numbers and your calculated scale, it doesn't exist anywhere but in your mind, unless you can bring it to physicality. Demonstrate what you're talking about so everybody can stop imagining. Why is that so hard for a glober? I don't get it.
You forget he's not a glober, dude.
Well, I don't care. Well, listen, why is it so hard to get a sphere and show yourself what you're talking about?
I'm about to actually break it down. So hold on, give me a second.
You're going to turn your camera on and get a sphere? Please don't tell us you're going to tell us a story and show dumb math, right?
Hey, man, don't ruin
Oh my God, I'm psychic. I'm psychic now. Kosho, why is it so hard for you guys to get a sphere and show us all this straight shit conform?
Give me 1 second.
Because in physics, man, I've only got one physics that I can demonstrate or do. I don't have any other ones that I know of, literally. So if I lay little straight things on any sphere, between these two straight lines, there's a fucking gap from the sphere. Between those two parts that meet, making the angle, which makes a triangle. Any two lines that meet make a triangle off a sphere's dirt. The round part's not going to be a triangle underneath, correct? It'll be off. But the top two parts will be. So it'll be 2 points meeting like a witch's hat, not necessarily a triangle. So anytime I've ever put two objects straight and tried to line them up and go around any size, it doesn't matter. God damn it. Does not matter. You're always going to have that you're always going to have a gap. And you are microscopic to this big. The numbers they keep telling you for this earth, right? And everything you can't notice because how microscopic you are. That means you're so small. You should be able to see that gap so big to you. That gap should be big to us because we're so small. It shouldn't be the other way. You don't notice it because no, motherfucker. If you're little to something that's huge, you notice it huge. You don't notice it none. You are the none. We are the microscopic thing on this dot that's supposed to be so huge compared to whatever we do with our fingers and hands and outside of our body and make big buildings and shit. We are the little dot. We are the thing that tells and that judges. I mean, what is that little thing in your hand that in school they call a ruler? You got a 1/4 of an inch, 1/8 of an inch, 1/16 of an inch, a millionth of an inch. What are those things to us? What are we to the globe? Now, if we are that to the globe, then we should clearly see these big tilts and big drops. These fucking huge, never-ending falls and shit. Like, no, we should notice big time.
Okay, so I got some hard numbers now. Actually, let me break it down even more. Hold on.
Kosho, my little brother can do math in his sleep. What the
Really?
fuck does that got to do with physics? What's that got to do with tangible stuff? Can your math bend this fucking lamppost? No. Can your math show me an 8-inch drop on a physical thing? No, your math is just 5291 over tangent RC squared cosine, whatever the fuck on paper, dude. How does that show us outside is doing what you claim?
But D-Mock, you're claiming that no matter how small you make the things that you put on your globe, you're claiming that no matter how small you do it, there is always a gap on the other side.
Yep. 2 little straight lines on any sphere. Yes, sir. When the parts that touch should be a little gap on a sphere.
Okay, I finally got the answer.
Listen, how the fuck would 2 straight lines not make a little gap off of a sphere?
I got the.
I can't even imagine that. That's like some leprechaun shit. Saying that, saying you believe that straight little objects are gonna wrap around a sphere and not be straight still is leprechaun shit to me, unless you can demonstrate it. Yes, my name's Democ. Do you have a demonstration to prove me wrong?
Yes, Kosho's trying to give us one here.
Yeah, I was going to say, I did the railroad
thing showing me I'm wrong.
I did the railroad calculation, and it has to do with what you said too, Democ. But if you had the railroads and if they were each 5 inches tall,
we got Legos.
Right. Let's say Legos. You have the Legos that you want to wrap around.
And you can go get a beach ball and demonstrate your claim.
If the Legos were 10 feet long and 5 inches high, okay, 10 feet long, 5 inches high. So, and you wanted to wrap it around this ideal Earth where there's no surface, it's just smooth and it's perfectly round. You could connect each Lego end by end, and the bottom crevice and the top crevice of the Lego, the different. So there should be a gap in the top part, right? Because it's curved and you're fitting on a curve. Yeah. But the gap, from my calculations, and I might have to do this again, but the gap that I'm calculating, it would only be 87 nanometers apart. So that's not detectable. And if you were to do this around the entire Earth, and you only got enough Lego to make the circumference, like
where did you get what physical attribute of physics of a physical thing did you get your numbers from? What physical little ball did you get that was smooth? What did you get your numbers from other than a piece of paper, Kosho? We need to see where you have a ball and where you took the ball in your lab and you said this ball represents the numbers of the Earth, the radius and the circumference, accordingly to the globe model. GPS and everything can fit it into the situation of the circumference of the globe model I have here in my lab. Now I'm going to take my little Legos that are so big compared to the bigness that I want them to be, accordingly to the 24,901 mile circumference and the 3959 radius of the globe, right?
Yeah,
and we take these numbers, and we take your Lego and you put it on there visually, and we can all see how your numbers really match.
Yeah, the thing is, if you had two Legos, so you had one Legos for the tracks, but then you wanted to connect them, so you have to attach a Lego on top, and then you line this up around the entire Earth, and they were each 10 feet long and 5 inches tall, it would be the exact same. It would be the exact same problem. If you made this straight, it would be if you made this straight, the curve of the Earth that would need to this Lego would need to rest on, it would make it so that in between each Lego there would be a 90 nanometer gap that would not be discernible, and it would be able to curve around the entire Earth without you even noticing that it's doing that.
It would, and if would do some stuff that's iffy. What are you talking about? Demonstrate it. We have Legos. I know you can go get a smooth ball somewhere or a smooth granite ball. We have these, right? They pour water on them. They make fountains out of them. I know you can go make a trip there and put your little Legos on there and show me where I'm wrong. Show me where they conform to that motherfucking granite sphere, buddy, or a steel sphere. Okay, we're talking smooth, and you keep talking all this smooth shit like the globe is smooth. I'm going to go with you on that. I'm going to steel man your steel ball because we have smooth things, right? And they have smooth granite and they have smooth steel, polished smooth steel like a mirror. You can take your Legos and go strap them on there. Show us your railroad.
Well, the thing is, if you had 10-foot long
segments, no ifs. Go do it. What do you mean? What do you wait? What, we don't need an if. We need to see it.
Yeah,
Why do you keep
getting close,
dude?
buddy.
What the fuck are the ifs for?
You're getting
so
close.
You're saying if who the fuck wants to hear?
Okay, go ahead, Coach.
I'm just saying, for your example, if you want to do this with some smooth ball that you have around the house, like a pool ball or basketball, something like that, to equate it to the Earth, these 10-foot segments, there would be about 13 million of them. So if you wanted to scale it down to a basketball, you would need to find some length of toothpick or Lego or something such that you could fit 13 million of them at a circumference around this ball. Which would be exceedingly, so if you scaled it down, those lines would be exceedingly small, and you would have the same amount of allowance of gap in between these tracks.
Why do you act like you guys are retarded? You get a floor that's a smooth part. You only need the top section. You don't need a little bitty retard ball that doesn't make any fucking sense for your ifs. You would get as big as ball as you can, like a big granite one. The little bitty people go visit. It's a big fountain, a big granite ball already sitting there for you. It's a big sphere. So no, you wouldn't need to go do some retarded shit that you said. That's ignorant. That's dumb as hell. So what you would do is get a half or a piece of a section, because all you need is a section of a big sphere. So your big section of your sphere only would need to be 1 foot off your real ground. You could pop it right on your floor. Like if you cut the top off of an orange, right? You can make it fucking huge. 20 foot, a 20-foot top section of the sphere. Then you could get your little Legos, a real Lego, and put it on there. And you're looking for your claim that they're going to match there like they're fucking stuck like glue, and they're going to arc and start conforming to it. I'm waiting to see this, to what size ball you can get for a real Lego, for the real Lego to conform to the spheres for us in front of us live, because that would be what your ball would be. Whatever sphere you picked, that's smooth and solid, a solid, smooth material.
Hey, D-Mike, okay, man, we understand.
So you understand?
You want to
so
see
you're going to do it. So you're going to drive your truck to a sphere,
I just wondered
and you're going to
if
take some
anyone else
Legos and put them out
had
and get
any
them on
input.
cam and take you about 3 seconds. Say, hey, look, Democ, I pulled up to a sphere. I drive all around in my truck. I'd be the one to be able to do this easy as hell and laugh my ass off when Democ is dumb and wrong. Right? Right, Left Lane? You're going to prove your globe, right? With some Legos on a big granite ball that we already have everywhere. They exist. So you guys going to prove your ifs or what?
What's the if that needs to be proven, DeMarc?
He said if every little smooth sphere matches every straight thing. If. I don't even know what the fuck if means. I want to see it. Can you show me where we have the big granite balls that are like 10 foot tall, 10 foot wide, right? They're big, huge granite fucking balls. And there's even ones bigger than that. I'm sure there's 30-foot ones too. And you get a Lego from the store. Go take you a little box of Legos. I'll pay you back for them if you do it. Then take them over there and sit them on it and show me where they conform to that sphere. You go get your size of whatever you think globe you need to conform under that Lego to where it matches it. Because I haven't seen it. I haven't seen the sphere that does that, the smooth, solid sphere. Not a dirt ball, a smooth, solid one. We're claiming smooth.
I could build a smooth, solid sphere out of Legos and do what with it?
That's not what I said. Clean your fucking ears out. I said go to a granite ball, buy a bucket of Legos, put your flat, straight, perfect Legos on there, and see how they conform to it. They won't.
DeMont, they're not the scale, DeMont. That's the problem.
What scale? Show us. You have the Lego. It's a straight thing. Everyone agrees. We all agree they're straight underneath and flat and perfectly horizontally straight.
To do the equivalent on the thing the size of a basketball, You would need a damn
Who said
microscope to see the
basketball? I
fucking
said go
Legos.
get your ball you need. Why do you keep saying stupid shit? You go get the
Even on a
ball that
10-foot
you
ball, they
need
would
to
still be
make the Lego
microscopic.
conform. Can you
They might
hear?
not be. I don't know.
You might not be able to fucking comprehend sentences or hear
I think they
anybody.
would be. I
Stop
think they would be
saying basketball,
microscopic.
Kosho. Kosho number 2. Nobody said basketball. Big granite, big granite. 20-foot by 20-foot granite fucking sphere. Are you okay? Lego at the store, little bitty in your hand, 1 inch, half inch, little pieces. You got the 1 inch piece, you got the 2 piece, you got the big piece, the 6 piece, the 4 piece.
So
The Legos. Put them on there. Let's watch them conform.
On a
What am I
25-foot
listening
diameter
to?
ball.
Cool, iffy. What ball?
Fucking
Where?
hell, man.
The
You're
ball
being
you're not going to
ridiculous,
show
Demont.
us.
I'm fixing to
So
just
another
fucking mute
if
your
that you're
ass,
not
man.
going to demonstrate, truck driver.
Just mute him, Howard. Come on.
Yeah, he's done.
Yeah.
He don't want to have a
What you were
conversation.
saying, Howard?
I'm sorry.
You was trying to say something. Demar kept over talking you.
I was just saying if you had a current equal 1,000 miles. I mean, it's ridiculous. He just doesn't understand the scale of the situation.
So if there is 20-foot lengths of track, right? The give that you would need for it to be able to go around a smooth, flat world would be you would only need 0.0001057 of an inch on both sides give for that to happen. There's definitely going to be that much give. I mean, you'd have to turn it into angular, an angular type situation.
No,
but from drop perspective,
no, they wouldn't.
all that you would need.
No, you wouldn't. You wouldn't have to do anything.
Yeah,
You could butt
I mean,
the
it's
squares up, and
so.
it would be difficult to measure the gap at the top.
Yeah, so if you try to scale that down to like a tiny globe, which I just tried to do it, it's actually a little harder than I thought it would be to kind of make that happen mathematically. But it would be such a small thing, and Legos don't have give, right? So you would have to.
Yeah.
I don't know. The whole issue is scale, and it's. I'm not. There's no way I'd be arguing this from flat Earth side.
I think the point that Kosho was making is that laying railroad tracks is not necessarily indicative of either model, so it's not a good argument for either side.
Why? Is it because they laid in sections or what?
Yeah. If you laid them in
sections of railroad, you only need a tiny
20-foot sections all the way around the equator, you wouldn't be able to measure the gap.
Yeah, not true that. True that. Yeah, I mean, I think putting anything on the floor or long distance observations on the ground using water or lasers or trying to put a line on the floor, I don't think any of that is going to give you any sort of strong indication as to what the shape of the Earth is. You either got to go real high up, or you got to use things in the sky as reference points, or what else? Maybe if you could build a structure, something like Lego, and use that as a comparison
with
other stuff. Yeah, but I mean that's not something like any ordinary person can do. I think as an ordinary individual at home, it's nigh on impossible unless you do some sort of, you do a calculation where you place trust in data you've collected from other people. I don't think there's any direct measurement or observation you could perform as a lone individual. Oh, I haven't heard of one. Yo, but why did it get so quiet in here, man? What's happening?
I ran across an interesting situation last night that I came out of it troubled. Someone said something about the government was going to impose these restrictions to where people couldn't travel more than 15 minutes from their home over in Europe. And it turned out that wasn't actually the case. But Witsit was talking about, going against and Globies. And I said to Witsit, I said, Witsit, if it come down to the government against us, wouldn't it be better to put our differences aside on the shape of the earth and combat that situation together? And he said, hell no, hell no, blah, blah, we don't want you or whatever, I mean, does everyone feel that way?
I think so, yeah. They do feel that way. They even perplexes them when they meet diehard biblical Globers, Like I think for a lot of people on that side of the argument, especially those as serious about it as Witsit, you gotta draw your position in the sand clearly. If you're a flat earther, you gotta be biblical or spiritual in some other type of nature. It's certain things you need to rock with and abide by.
My
And
concern is that we couldn't put our difference. I could put my differences aside if we all needed to come together as a force against, say, the government. Just a scenario.
you are
Yeah,
part
I
of the
would.
government in their eyes, Howard, because
I
you believe Earth is a
guess.
globe.
Yeah.
Yeah, you got to tick all of their boxes. If you're a glober that believes in God and reads the Bible, you're sus. You can't be trusted because you're a glober. You see what I'm saying? If you're a glober that
Yeah.
believes the moon landing is fake and NASA can't be trusted, you're still sus. We can't trust you. If you're a glober that's anti-vax and fuck the government, you can't be trusted. You still believe Earth is a sphere. That's why they don't even fully rock with Grimm. Like you got to tick all the boxes. It's like all or nothing with these people. Some of them.
Yeah.
Yeah.
I'm just surprised that that it's allowed to inhibit the humanity aspect of us as a people, that something like the shape of the earth would come between potential
Mm,
victory in a situation versus being a staunch flat earther that hates all globers, and I'm not going to fight next to you. I'm going to fight against you, kind of thing. When it comes down to life and death, kind of thing.
yeah. But I understand where Wits is coming from. I don't think most flat earthers would agree with that. I think a lot of flat earthers, if the government turned on us, they would team up with us. But I do understand where Wits coming from. He gets a lot of shit from Globus. I understand why he wouldn't want anything to do with Globus because people do go hard at him. I've heard some people say some really nasty things to him, and I kind of feel Howard. He maybe just said that, as like a reaction. It's maybe not what he really meant. If it really
Yeah,
came down
maybe
to it, he would band with us against the government. But I think he was just saying that out of spite.
maybe so.
Yeah, I think. But hey, I could be wrong. Maybe he did mean. I don't know. Was this in the other server or was that over
Yeah,
here?
yeah, it
Oh,
was over there.
okay. Are you distrusting of the government in any way, Howard?
Oh yeah.
Yeah. All right.
Yes, sir. Yeah. Yes, sir,
Are they
buddy.
conspiracies you entertain?
It's not so much the conspiracies as that the corruption and that the a true politician should be representing the people that they represent, but it's turned into a self gain situation. What can this position do for me? And that is by definition corruption. And I think it's just like a disease that's infected the entire wall to wall, front door to back door part of the capitals. And yeah.
Okay.
Yeah.
Oh, that's fair.
I mean, whether any of these other conspiracies are true or not, the government's going to have to, do some things different to win my trust back.
Oh. Interesting.
I mean, what's it's all about that though? Like, you guys don't think just because he's flat Earth that, like, you don't think he's like a bad guy, right? Like, you see that he's standing up
Well,
for what he thinks is right?
I mean, I made an attempt to reach out to him when they were talking about that we should put the shape of the earth argument aside to band together in that situation. And he was like a damn bee. I mean, he just fired right back. Hell no. You're my enemy, basically.
You're very contentious against him when he's talking. Like, was it right after you were saying against him? Like, I could see him reacting and just being like, no. Like, you know what I mean? Like, he might have just
he's always on guard. Yeah, he's always on guard, and he knows me. I know him, and it might have just been something directed at me, but it's sort of. I mean, even still, like I got people in here that I would call friends and interact with, and if they needed me, I would help them if I could, kind of thing, and prior to this, I would have even though me and Witsit get into it, if he needed something and I could help him, I would help him. I don't know if I would now or not.
Well, I think he's the same way. Like, I've witnessed him do some pretty cool stuff as far as helping people, and my bad. Can you still hear me? I think he'd be able to overcome, his flat Earth position in order to rise up and join people in a bigger cause. Like, we're all about that. Like, the government, we just don't trust. We just go a little bit further and include NASA in that. I think that's the only difference from that standpoint. Obviously, there's much bigger differences if you look at it from a micro aspect, but macro, I think he'd be right on board. Might have just been a reactionary thing he said.
Maybe so.
But yeah, man, world's getting crazy. Governments are looking a little shady with certain things, man. We might have to, because this is a cool community where we kind of get to know each other, and I think a lot of people in here, at the very least, respect each other. Maybe not always, but I think we'd definitely be able to band together if push came to shove. Now, am I alone in that? We all hate each other, guys.
No. I'm we. I don't. I would think it wouldn't even be a question in my mind that if you could stand this 2 against 1, why the hell wouldn't you? I mean, but maybe I'm wrong. Maybe I don't. Maybe I'm a little naive. How about that?
Well, I think this is the topics we get into here, I think, are significant for sure. But if you're comparing that against, you know, tyrannical overtaking and, you know, limiting our freedoms as people, I think that would surely take precedent immediately, you know?
I would think so. That's what I think. You know, it's probably a scenario that wouldn't really ever play out, but in that scenario, I would like to think that we could band together for each other's benefit, you know.
Yeah, man, I'm with you. For sure. I think it's always funny when we kind of come together for topics every now and again, where we're kind of, most of us anyway, are on the same side. Like right now, just talking about government and whatnot. And then it's always funny when someone new comes in and like throws up a topic about the Earth, and then we're at each other's throats again.
Yeah,
just happens so quick sometimes, you know.
Yeah,
but I don't think
yeah,
that means anything as far as, you know, something bigger happening where, you know, we all really need to buckle down and realize that we got to make a move of some sort, you know, if something were to happen in that vein of, you know, government tyranny or whatever. It's also quite cool that we can get to know each other. Like I'll hear someone's voice, know immediately who it is, and I'll have impressions that I've already made of the person, not like stereotypical, just based on what they've said. But it always comes to memory quick. It's funny how much we can know each other without ever meeting, without ever even seeing each other, you know?
Yep.
Pretty neat. All right, guys. Good talk this morning. I'm going to take off for a little bit. Have a good day, everyone.
Y'all too, man. Be careful.
You there, Left Lane?
Yeah, see, how you doing?
Good, yourself?
Doing good. Fixing to get on the scale, check in, and get my load for next week.
Good luck. Good on you, buddy. I was going to ask you a question. I'm curious. You go over to that other server, right?
Yeah, I've been in there.
Let me ask you, because I got a certain beef. Do they ever talk about children's protection, the woke movement, anything like that? Is that still off the table, or?
Well, I tell you, it's just being honest. It's an increasingly uncomfortable place for me over there. especially over the last week. Conversations really got off on some topics that I'm not comfortable being around, and maybe what you're talking about pops up now and again. And I made a comment last night that it kind of smells like the 24/7 2.0 platform, where they delete comments whether they're, you know, edgy or not. You know, they I don't want to say abusive, but maybe openly biased kind of thing. But
right, that's what they did with me. Yeah.
Yeah. What did they do for you?
Well, you know, I always talk about the woke movement and protecting children. It's one of my things.
Yeah.
And well, I just posted a video about in Vancouver. They were doing a woke movement, transvestites, half naked, to children 3 to 10, and I posted that. They were protesting outside, and the owner took it down and told me we don't talk about stuff like that here. I said, "You're kidding me, right?" I posted this everywhere.
I think there might be a significant member of it that is transvestite.
Yeah, like the owner.
I'm not sure about that. Yeah,
The
maybe
owner.
so.
The owner, I hear. That's what I heard.
All right, I got to run in and give him my number. I'll be back in a minute.
Okay, good luck, bro.
Thanks.
Come on, guys. I left for 5 minutes. This shit cleared out already. Seriously, man. Where the fuck is everyone at? Is everyone over there in Tartaria arguing with Zanuck and shit, even though they sat here and complained about Zanuck for the past year? Is that what's going on? Are they dealing with all the globe trolls? They yelled at us constantly and asked, why do we engage these people? Why do we let these people in here? Now they're over there dealing with them. Is everyone just off having lunch? Like, what's good? Hello? Gem's got damn near 50 people in it. They love the fucking shit show. Just Brian Mabbott over there screaming at him. Rhetoric. What up? What up? How we doing?
What's up, Jeremy?
Dylan.
Happy New Year's, well, Gregorian New Year's.
Yeah. Happy holidays and all that. Got everything I wanted for Christmas.
Nice.
What's new? Anything new?
What's going on, Jeremy?
Nothing. I'm trying to figure out who knows how to do celestial navigation. We get right down to it.
Maybe eggshells. That's about it.
No, that Kool-Aid guy knows. The boat boy.
I see. What's the contention you have with the navigation stuff?
I don't I don't know what's going on. I know the Globers are using the Haversine formula. I'm definitely not going to have a Glober show me how to do it.
No, definitely. Let me answer him about my contention. It's simple, bro. They claim that celestial navigation, the sextant, proves the flat Earth. And my contention is, well, there's many, but the main one is that when they use celestial navigation to prove the flat Earth, they use the nautical mile. They also use the nautical almanac. And the nautical mile is based on a globe Earth. They cut the Earth in half. They use either half. They make 360 degrees and they assign 1 degree for 60 nautical miles. So I was trying to tell them, you're using a globe model to prove flat Earth. That's basically my contention.
All right. So when was the nautical almanac made? Or I mean, since when did they be using celestial navigation? First of all, right? They used it since like 4,000 years ago, right?
Yeah, exactly. Yeah, more or less around that time, maybe even earlier. So yeah, right. Celestial navigation were used by the Polynesians, the Chinese, the Greeks, the Arabs. Yeah.
When was the nautical mile established?
I'm not exactly sure. It was around, I think, the 1700s.
Actually,
I'm not exactly sure.
I googled it the other day. It says that the nautical mile, that was used now, was established in 1929. There has been many. Let me see if I get my phone. I have the history of it. Many different types. Spaniards used one. The Romans used another. But the nautical mile was established in 1929.
The one we use now, huh? Really?
Yeah,
okay. Yeah.
And there's still two different versions of it, because we in the U.S. we use one, and then there's another country that uses another. I mean,
have you ever seen it done?
Ones? Really?
Has anyone ever seen this actually done? What the steps are?
Yes, I've seen it on YouTube.
Yeah, but let's see it from a flat earther's perspective before we start jumping any conclusions. The Globers are using Haversine formulas and shit, so we're definitely not going to use that, right? Is that what it is?
Well, they assume a globe, bro.
Well, you know what the Haversine formula is. You can't use that and say Earth's flat.
Exactly. Well, they measure it. They measure a flat whatever, and then they just slap on the curve. Yeah.
I just want to see a flat earther do it. That way, I can know the steps that we're doing here.
Nobody knows this stuff, bro. You gotta understand. Nobody knows this shit.
Somebody knows, bro.
Nobody knows. I'm telling you, including myself. I mean, I never done it.
Well, somebody's got to know.
I'll tell you one thing, right? Just YouTube it and see the procedures and tell me if you think that you can do that. No freaking way. Not me. No way.
I think Geo knows, but I don't. Geo doesn't say it proves a flat Earth or a globe either way, which I would be more likely to incline to think that it doesn't prove it either way. But I don't know. I got to see what the steps are.
You're saying Geo knows how to navigate? Really?
I think he knows about celestial navigation. Yeah.
Cool.
I don't know. I'm not sure though. I never asked him. I want to have one of the FED. I want to have because I didn't ask him because I want to have one of the guys who's saying it proves flat Earth. Like I want to see the steps they're doing. Like I don't know about that horizontal baseline shit. Like, dude, the land. Does that mean the land has to be flat underneath it? Like I don't understand. I don't even understand that part of it. Yeah. And I've heard that part like 100 fucking times.
That's their claim, bro. Yeah. For them, their main claim is, in order for you to use the angle that you take, right, for celestial navigation, you need a flat plane. You need a flat surface. That's their argument.
Yeah, that doesn't make. I don't know. I don't
ridiculous, bro. You can stand on a beach ball and take a freaking angle, right?
I know.
No. I mean, if you get an angle, you actually do need a triangle.
Yes.
Yeah. So
where did they get the triangle from?
you need a flat surface for that. In other words.
But bro, before you do that, right? Where do you get your triangle from? You start off with a single angle, right? And we all know you can do F all with one angle. At least I know that.
I'm just saying the fact you need a horizontal baseline to do this. I don't know why they think the Earth's like this works on the side of mountains and on the top of hills and shit. So like,
yeah.
I don't think the Earth has to be like flat underneath you for this to work.
Yeah, I mean, if it's curved, you can't get 90 degrees.
Bro, you don't think that you can stand on a hill and take an angle?
If it's curved, you cannot get 90 degrees.
Why?
Yeah, but you can get an angle from anywhere, bro.
I can get a 90 degree anywhere. Yeah. You could be on the top of a hill and get you get a horizontal on top of a hill, right?
I mean, with that's okay. This is the thing, though. But on their model, the Earth is curving, so that is just the horizon, which is a curve. From your perspective, it still is a curve there, which you're saying that's 90, but it will be a flat from here to the horizon.
Yeah, but no one's matching up the horizontal to the horizon. That's not even like. I don't think that's what they do. I mean, I don't know because I've never seen it done, but I don't think that's what's going on. Aren't they using like a dip correction or something? I don't know. I'd have to see the steps done to know.
This is what you do. Brian has made a video that explains it. Watch that video. You'll get an idea of how they do it.
Send it to me in a DM, will you?
I'll have to find it, bro. I don't know if I can do it now, but yeah, I'll do it
whenever you can. Yeah, I just want to see one of them guys, explaining it, so I can see exactly how it proves a flat Earth or something. I don't know. I can't imagine that it could because the Globers are saying it proves a globe. How could it prove both things? That doesn't even seem possible.
Exactly what I told them. I told them, leave this shit alone. Stick with the Black Swan. It's solid. Why the hell are you going to lights in the sky for? We've been railing all these years, lights in the sky. Stupid, dumb. And what do? You come up with a proof with lights in the sky. It's ridiculous.
I don't know. I'm not going to jump to any conclusions till I actually see how it's done.
Bro, all you have to say is this, okay? Navigators have been navigating for 4,000, like Elbow said, 4,000 or more years. Do you think they thought that the Earth was a globe? I mean, seriously.
No, I know. Whether we would have found globes, they would have like chiseled it in rock and shit.
Yeah.
They made giant spheres. There's giant spheres all over South America or Mexico or something, Central America maybe. Like there's giant spheres. They would have carved a fucking map into it.
Literally,
oh, look, here we are.
spheres.
Let's chisel our little area in this sphere, since we know it's a sphere.
Yeah, not one.
Since 1492, since the early late 1400s, which just so happens to coincide with Columbus. Anyways, yeah, if they had known for thousands of years, like with Eratosthenes and shit, dude, there would have been fuck globes all over the place.
All right, so check this out. The measurement was officially set at exactly 1.852 kilometers in 1929, but what is known as the International Hydrographic Organization. The U.S. and the United Kingdom both used slightly different measurements after that time, but the U.S. adopted the International Nautical Mile in 1954 and the U.K. in 1970.
Nice. I like that people are checking this out and researching it. Nice. Well done.
And I'm going to drop in the history of the nautical mile.
Sorry, was that the almanac? One of the almanacs they use for it?
Oh, no, this is just on the nautical mile itself.
Oh.
Did you see the part where it says how they got it? They split the Earth in half at the equator.
Right, because here's the. I mean, I was actually reading the whole. It's weird because I mean, if you read this, it's they everybody had a different way of measuring the nautical mile in a way. But I mean, I understand what it means is this because the nautical mile is the what degree is like an arc, 1 arc of a degree.
Yep. They literally chopped the fantasy Earth in half at the equator. Literally, that's what they say, and they make a circle, right? And each degree is 60 nautical miles.
What's that guy's YouTube channel, Brian? I need to see this.
And what's his last
name?
name?
The name of his channel or
Mabbitt, Brian Mabbitt.
Oh God, Mabbitt. Are you sure that's the right Brian?
No, it's not Mabbitt. No, hold on.
I was gonna say, I don't know. That doesn't even sound right.
Oh, I just woke up. It'll come to me.
I can't remember his name either, and I know who the fuck he is. Come on, Elbow. You know who he is. Who's the Brian guy on FED? The Irish guy or Scottish or something?
Irish.
I must have said his name at least fucking 50 times. I'm not even joking, dude. And everyone knows who this guy is. We can't think of it. This is fucking embarrassing. Anyways, if anyone thinks of it or finds that video or somebody showing us how to do celestial navigation, I can't learn it from a glober. Like the glober is using a Haversine formula. That I don't know if you guys know what that is, but that does not work at all. Flat Earth.
Yeah, this is talked about the measurements that the Portuguese had, the Roman had, Italians.
The Polynesians are one of my favorites. Yeah, Brian's logic. Thanks, Askin. Brian's logic. That's why I couldn't remember the name. It had logic next to it.
I mean, if all that I remember, an angle always has to be a triangle, and that's the issue.
Right angle, a right angle,
right
triangle.
angle triangle, right?
Not just anyone. Yeah,
right. I mean, you still have a regular angle as well. Yeah, because I mean, a triangle always has.
They got to be making a triangle on definitely if it's flat, because you got your straight line from you to the GP, then you got a straight line from the GP to the star or whatever, and then you got a straight line from the star to you. So yeah, it'd have to be a triangle. The Globers claim it's not a triangle. They say they're not making a triangle.
Yep.
Yeah, so how can they get an angle if they're not making the triangle?
You don't need a triangle to get the angle. You can just get an angle and not have a triangle, right? I mean, there could be one there, but I don't have to use it. Like if I just want to figure out your elevation angle from me and you're standing off in the distance, I don't have to like make a triangle or nothing. I could just see like, all right, here's my horizontal, you're X amount of degrees above or below it. All right. I don't know. I'm not even trying to argue this because I don't even know how it's fucking done. So.
I mean, can you cite this?
Cite what?
I mean that you can have an angle without a triangle.
Yeah, bro, you're out. It's me and you in a field.
No. I'm not talking about we're still assuming. I mean, even you're saying no, we don't need one. We're assuming. Well, this is yada yada yada. But how are you saying? Okay, yeah, I can see this, and that's an arc. I mean, that's a triangle right here. But I mean, that's an angle. But can you actually do this in quote unquote, math and trig without a triangle?
Yeah, bro, it can be done in reality. I can give you an example of it. I mean, I don't have a citation or anything, but I can give you an example of how you would get an angle without having the triangle. If it's just me and you in a field and I want to see if you're higher or lower elevation than me, I make a horizontal. I get that angle from the horizontal to you, wherever it may be, and boom, that's it. Is there a triangle there?
Here you go, Jeremy. You want to learn how they do it? This is it. And look off the crack. He has a box there, right off the crack.
Hold on. Did you DM it to me?
No, it's in live chat.
Oh man, will you DM it to me, please? I can't mess with my phone right now.
I don't even think I have you. Are we? Let me check. I think I do. Hold on.
Bro, I've DM'd you like 1,000 times, bro. Yes, you're in my list.
Yeah, we are. Okay, hold on.
Is that right elbow or what?
And I mean, regardless,
where's the triangle in what I just described? Where's the triangle? All we have is an angle. That's just one of the many things you can do with just an angle. Trying to trigger SE.
I don't care. That's not my thing. Honestly, that's not my thing. My thing is the book and the nautical mile. Plus the angle. It's true. I mean, with one angle, what are you going to do with it?
With one angle, I can find out if me and you are in a field and I get an angle, I can find out if you're higher or lower than me. With just an angle. Well, I mean, it's something. It's something.
Yeah, but for celestial navigation, bro, for celestial navigation, you can't do fuck all with it. Nothing, zero.
Yeah, you need 3 angles and a book and all kinds of stuff. We know.
And clocks and this and that. Yeah.
This is the point, though. In to create a angle, for the trig, you have to have a triangle. In other words, the surface has to be flat to be able to get a 90 and an actual angle. Because your
trig though.
Then your degree towards the top of whatever you think the angle is off.
If it listen, and I have another thing where if they know how to do the celestial navigation thing, you can do it to the sun, and if you are making a triangle, then they now have evidence for the distance to the sun. They got their triangle.
What do you say to that, Elbow?
Say that one more time. Say that one more time. Sorry, I was looking up for something.
Elbow does a lot of research. Good shit, Elbow. You're good. That's why I'm not trying to like argue with you and shit, but like FED asked, one of the housekeeping questions is there any evidence for the distance to the sun? If they know how the celestial navigation thing works, you can do it with the sun, I believe. Not sure, but I believe, and then you have your triangle. Like you would have the distance. I don't know if they're getting distances between the GP person making the observation.
They're getting distances between the GP. Yes.
Are you sure? I don't know because I've never heard one of these guys explain it.
Well, after you watch this, bro, all your questions will be answered.
I bet.
And you will be laughing to high hell.
Hey, I was lurking, listening on YouTube, and Bacon kind of laid it out for me in 2 hours. Do you want me to try, or you want to just watch that?
No, do it, please, man. Tell us.
So if Polaris is at 90 degrees at your zenith at the North Pole, right? When you move to make it at 45 degrees, when you double that distance to make it at 45 degrees, it becomes it goes to it goes to 0 degrees from your zenith, like a full 90 degrees. So if you did that on a flat plane, if you double the distance when Polaris is at 45 degrees, Polaris ends up at 23 degrees from the horizon, or like 67 degrees from your zenith. So on a ball, you incorporate 1 degree every 60 miles. That's how Polaris ends up on the horizon rather than at 23 degrees. I know that I'm fucking terrible at this right now. Sorry.
You want to laugh? Brian also made a video that water level is a gravimeter. How do you like that?
So, isn't that true?
So, Jeremy, when you were saying about the angle, right? When they say you can establish an angle to determine if I was taller than you, right?
If you were a higher elevation, and if me and you are standing in a field, I want to see if your elevation or you're from a horizontal, I want to see if you're higher or lower than me.
Yeah, but that's the thing. You're establishing a horizontal, but if you don't know if the what you're standing on is horizontal, how are you going to tell whether I'm taller than you or not?
I think that's not taller. I just want to see if you're high. I just want to see if, according to a horizontal line, if you're higher or lower than me.
But see, that there goes the part where you're assuming a flat surface.
No, not right. So
we have to. If you're saying establishing a horizontal, from the horizontal, establishing whether that person's higher than you. But if you know what you're standing on is a curved surface, you would never be able to get that because then you have to account for the curve.
Okay, look, we're skydiving out of a plane, me and you. I just happen to have an auto level in my back pocket. I pull that shit out. I want to see you. Yeah, you're like 100 yards away from me or something. I don't know, 100 meters away from me, and I want to see if I'm close. Higher or lower than a horizontal compared to me. I pull it out. It doesn't matter what the ground is underneath us. All right. Just compare it. Not that's why I stopped using elevation. Forget elevation. Just compare to the horizontal.
That's correct. But celestial objects are, they change position due to your GP. No, they don't. I'm fucking it up. Sorry, I gotta think harder.
Yo, and if they're getting distances, that could open up a whole nother can of worms because there's things you can do with distances. I don't know if heads really know this or not, but if you have enough distances, you can tell surface that you're doing this on is curving or not, or planar.
Wow, dude.
Heads were actually fighting me on that when I first proposed that. Like I was talking about this like months and months ago, and heads were like, "That's fucking stupid. You can't tell. You can't tell if it's flat or curved by distance." I'm like, dude, you can.
Was
because
it heads
shit won't work.
Heads or tails?
What's up? We're not flipping coins. What are you talking about? Listen,
keep saying heads wouldn't take it or heads wouldn't. Anyways, dude, I was the one who was doing the distance thing, dude, and you know that. So go ahead and pretend like you were the one doing it. But I was
don't stop trying to copy my stuff all the time.
Coach
Dude, I have the model
credit, man. Coach is always trying to take credit.
I know he's always trying to. What's it called when somebody says they're in the army and not in the army?
Stolen valor.
Yeah, Coach was always trying to stolen valor me.
My God, dude, I have the fucking model that I made when I asked all those people.
I know
distances. Yeah, of course. Yeah, exactly. So you admit that you stole my shit.
It's been my idea for a long time, just like the 2-on-2s.
That's oh my God. Anyways, check out this. I'll show you the model that I made, dude. Because
bro, actually, fuck your model. Yo, this guy Kosho showed me a model last night. It was a blue circle with 2 curving lines in it, and it said flat on the side. And it said flat on the side of it.
You're a doofus, dude. That's the ellipsoid model. Like that. If you ask anyone for the ellipsoid model, that's what it is.
So he showed me a picture. It said flat on the side of it. It was just a fucking blue circle with some red and yellow lines in it.
It's a goddamn ellipsoid model, dude.
I know.
It's a guy from Navigation YouTube channel.
Yeah, this guy really outlines it good. You want to find out? That's the dude.
That's where I learned a lot of my celestial navigation from. Yeah.
Same.
He used to have hair though.
That's why I asked that question a few days ago, Kosho. On can we get 4 stars? Like how big of a square could we make if you had 4 people at 4 GPs and everyone can see all the other people's stars? Like how big of a square could you make?
4 people?
Where? Yeah, 4 people at 4 GPs. How big of a square can we make? To where they can all see each other's stars. In other words, the one person needs to see all 3 other stars. Obviously, well, that should have went unsaid, but
yeah, but so you'd have to.
I was gonna say here's one of the errors they gotta correct for. They gotta tweak. It's very complicated shit, man. Anybody tells you that this is easy peasy, you take a 90 and you subtract it from there. Yeah, right. I'll bet anything. Any one of these guys can navigate.
Yeah, but this is if you're using a sextant to determine elevation, right?
The sextant period, the stuff that you got to do to the sextant. You said you watched this. He explains it all.
Yeah, but like if you used a bubble level, why not just use a bubble level? Because I feel like there's techniques in navigation which are difficult, but for purposes of like what we're basically discussing or the subject of our conversation is more to do with the outcome of getting the right angles. So you're assuming that you're going to do whatever it takes to get the right angle to these stars. So even if you have to look at where they are online and then verify them with a bubble level, whatever. But yeah, the difficulties of trying to find the horizon and stuff like that, that doesn't really help determine if it's flat or a globe. You know what I mean? It's just one of those details that makes.
This is one of the questions I asked Nathan. Then he muted me because he knew he was screwed. I asked him.
Dude, you guys fucked. My bad.
No, go on.
You guys fucked up. You should let me know you're going on there.
Well, now you'll go in more prepared. You'll learn from You know.
On Zanuck 3 years ago, I'm like, dude, stop going on Oakley's babbling, rambling like a lunatic. I'm like, have something ready to go. You can't just go on there not prepared.
Yeah, one of the first times I hung out with Zanuck or talked to Zanuck, I was on Nathan's and he was on Nathan's, and Nathan was trying to fuck with Zanuck because I think I might have corrected Zanuck, or we disagreed about something. I might have actually been wrong. Regardless, Nathan was like, "Oh, is Coach your teacher? Coach is your teacher. Listen to your teacher." And then Zanuck got so offended by that. He's like, "He's not my teacher. If anything, I'm his teacher." I was like, "What?"
I think I heard that one.
Yeah, but that was the show that got everybody talking about reference frames and fucking Coriolis for like 3 months, because I think it's because of something I've said about leaving reference frames.
You're not relevant, Coach.
Well, I said the wrong thing. That was back when I had said you could leave a reference frame.
You still don't know about reference frames, so nothing's changed. Listen, what's that? Dude, the way you describe reference frames, even Rumpus told you it's worthless the way you describe reference frames. Everything's in every reference frame. Reference frames are now worthless after that.
I wouldn't just express it as that, dude. That's a response.
We hear that every time we talk about reference frames. You got everything's in every reference frame.
No, that's because people are like people are claiming that objects, like, which reference frame is the object in? Is it this reference frame or this reference frame? Like if you're saying shit like that, then the response to that is, everything can be in any reference frame. That's just the truth. Observers can change reference frames, but if you're talking about an event or an object, you can view it from any reference frame. That's neither here nor there. What are you saying though,
SC, Brian's logic is saying that you can get distances with celestial navigation.
I think so, yeah.
All right.
What do you mean by that?
I don't know. You do celestial navigation that proves flat Earth. You get distances. We're about to find out real fucking quick if that shit is actually planar or not, because you can make a square. You can make any. It doesn't have to be a square. It can be just 4 points. You put 4 points down. You make an X in between them, so you don't even have to make an X. You have 4 points. You know all the distances in between them, including the diagonal ones.
Yeah.
And then you'll know if it's planar or not.
Yeah.
Because that won't work on a curve. If the surface is curved or flat, it won't work.
Of course.
Like if you were to try to replicate that on a flat surface, scale it down and replicate it on a flat surface, and it was actually on a curved surface, your distances wouldn't work.
We used this against you last year.
What?
Yeah, dude. You don't remember the whole thing? We did this. What are you talking about, dude? Remember we did this like with the 4 corners of the U.S., like Florida, Washington, New York, California.
Oh yeah, I remember that.
Yeah.
When you guys were trying to say you knew the distances down to the centimeter or millimeter or some shit.
That's why we started arguing that. It was because you were claiming the distances aren't known. But the point of us bringing that up in the first place was to do that X, like you said.
Yeah, and then I'm sitting here wondering, how'd you verify those distances? RC said it's because of plane flights.
Right.
But then in the middle of RC discussing it with me, I said, "How did you know you flew this distance?" And he said, "Because there's wind cones on the ground and we flew over them." So I'm like, "Well, why don't you just tell me how they knew how far the wind cones were apart? Why are we even talking about planes? Let's get down to these wind cones."
I'll take that bet.
Then RC told me go ahead.
No, go ahead.
No, it's all good. Go ahead. What do you
I was gonna go back to SC on the navigation stuff.
I'm glad you mentioned me. Read what I just posted, bro. Here, I'll do it. What is the formula for nautical miles? A nautical mile is based on the circumference of the planet Earth. If you were to cut the Earth in half at the equator, you could pick up one of the halves and look at the equator as a circle. Then you divide the circle into 360 degrees and a degree into 60 minutes. A minute of arc on a planet Earth is 1 nautical mile. That one thing right here kills the FED argument. Dead in the water. My opinion.
What's their argument exactly?
That celestial navigation proves flat Earth.
Oh yeah, right. Oh, so you guys okay? So you agree with us that, that's a silly claim, yeah.
Oh, I agree with the truth. It doesn't have to do with whatever side it is.
Okay, I'm just saying we agree with each other on this one, okay?
Yeah, I mean, it's obvious. I mean,
I think that this is the most boring and because you have to really look into this to actually understand what they're saying, right? But you have to like go into like mad details. If it was something that was actually pretty apparent, it will make sense. But this could be convoluted to both sides in one way or the other.
That's what I'm thinking, because it's like there's both sides are claiming it proves their opposing positions. So
yeah, that's exactly my argument. Either side, I'll fight either side. If the globe guys say that celestial navigation proves a globe, I'll tell them no, you're wrong, and I'll say the same thing to the other side. There's no proof of either.
I think it is true. One of the things.
Oh, show how big of a square can I make, bro? Sorry to interrupt you.
Listen, dickhead. I'm sorry. I didn't get a lot of sleep last night or anything.
No, you had Chinese food. I know.
Listen though,
how big of a square can we make with the stars, the GPS?
The question you're asking is, I don't know why you're asking me, dude, and why you can't think, because it requires the same amount of thought, whether I do it or you do it. Okay, but you understand that what you're really asking is how far away are the stars? So all you have to do is think about one position.
That's not what I'm asking at all.
So
no,
think about a single position, and think about what are the farthest 4 stars. The furthest GPS could be from him that he could see their stars. Right?
You're misunderstanding Jeremy's question, bro.
No. I'm understanding. He's talking about 4 different positions and them all being able to see all 4 of the stars. I understand that, but what I'm saying is you don't have to think about all 4 of the positions to answer that question. You just got to think about one position and think about how far away are all 4 of the stars he could see. Because if he can see all 4 of those stars, you just have to put the other 3 people inside of that same perimeter, that same surface area. So you just got to think about what are the 4 farthest away GPs that a person could see. That's probably. Do they have to be measured using like a sextant? Like they have to be within 30 and 80 degrees or something?
Bro, you got to be able to do a celestial navigation measurement. The one person at one GP everyone has to be able to do celestial navigation on all of this stuff.
Let's just do between 40 and 80 then. Okay, hold on.
We're going to get right down to the bottom of this.
Wait till you see that video. You'll understand and yeah. Like, look, this is a lost art, man. Here, Rakia's here right now, right? I've asked Rakia. Rakia's a captain. And I've asked him, and he's been at a table with 3 captains, and he's asked them, hey, guys, anybody here know celestial navigation? None of them knew it. 0. So it's not a thing that people use now. This is a lost art. You understand? It's just
100%.
It's just like, it's just like Indian tracking or something like that. It's like people aren't tracking the way they used to because they have devices and stuff now. So it makes sense.
Yeah, it's a lost art.
I mean, you don't use the counter from the back of a turtle's thing anymore because
yeah. So you're gonna tell me now the Polynesians navigated using the nautical almanac that wasn't invented 300 years, 400 years later? Come on.
I was trying to solve McToon's thing and like to see if I could do it. And actually there is a way that if you I was telling Brian about this, but if you know your latitude, for example, if you know what your latitude is, which is probably easier for the Polynesians, like they probably stayed within the same latitudes. Like, so they probably just traveled east and west. And when they traveled north and south, it probably was like they knew where they were, or they knew where they were along that same route. But regardless, if you know what latitude you're on, then you really only need 1 star. You could find your location. Because you could just, it's a whole thing, but you could use a flat map and draw an ellipse instead of a circle from that GP of that 1 star. If you know that what latitude you're on, you could pinpoint your exact location. I don't know if that's allowed in McToon's thing.
So you actually think that book gives the actual GP of the star? That's what you're thinking, right?
I mean, I know it does because I've used
Doesn't, bro. It's
to
just
do
a
that.
system that was developed. That's all. There's no way you're gonna. Have you ever looked up directly at a star and said, "Oh, this star is directly above me"? Have you ever done that? Ever?
No, probably not. I did see the ISS when it was directly above me once, but a specific star, no, I can't say that I've at least confirmed that it was directly above me. Yeah.
Yeah, it's just a system devised, just like every other system, just like the Polynesians had a system, the Greeks, the Chinese, the Arabs, the Egyptians, they all had a system how to navigate, and none of them had to do anything with celestial navigation as we know it today. None of them.
I mean,
Zero.
they must be able to tell when you're directly under a star because that's how they measured plumb lines not being plumb.
Yeah. Just because there's a system and you can navigate with it doesn't mean that you know the shape underneath that. It's ridiculous.
Well, I mean, I don't think that detail alone, but the details involved in it definitely do indicate, like the 60 nautical miles per degree thing. I mean, that's indicator right there.
Yeah,
Kosho, how big of a
and the
square?
FPD boys will tell you, yeah, we need a flat baseline. So how do you? What's next
Why do you need a flat baseline?
for the triangle?
You don't need a triangle.
Talk to them about that.
Oh, you're
Wouldn't
talking
you
about the FED people.
make your case, bro? Make blaze the trails for Jeremy.
Said to Jeremy for
No, don't blaze the trails for shit for me because they're gonna go in there. After dealing with your nutty ass, they're gonna fucking be mad hostile towards me.
Hey, he's gonna think that I'm you're me, or whatever. All right, check this out, dude. Because this is actually the angles involved in plotting a star, just GP. There's no triangles involved. The blue one would be the GP, where that line is intersecting the Earth, and the red line is where you're taking the observation from. You see, there's a horizontal from there, and there's a vertical from there, and there's the angle to that same star. But there's no triangles involved. You can add lines and make a triangle, but you know.
Listen to me. What is the biggest square we can make where all the GPs could do celestial navigation on all the other stars involved in this? Yo, that brings up something else. If I were to make a horizontal, let's just say Earth's curving. I make a horizontal line from that horizontal line. I go to the substellar point, and another person goes to another substellar point. We're on this horizontal line. If I'm 1,000 miles away from that person, I mean the stars are 1,000 miles away from each other.
What?
I make a horizontal line. Okay. I go to a GP of a star. Another person on that horizontal line goes to the GP of another star. Say we're 1,000 miles apart.
I got news for you, dude. If you made a horizontal line, there's not going to be any other person anywhere on that same line.
I mean, I can't get any. I couldn't get on a horizontal line and get a GP of another star. You can only get GPs on the curved Earth. You're telling me?
No, I'm saying the way you're describing it. If you were on a curved Earth, then the horizontal line would be a tangent from where you are. So if you by horizontal line, if you mean like a great circle.
Nope. We make a tangent line. Fine. We're on a globe. We make a tangent line. I'm at a GP. Somebody else on the tangent line is at a GP.
Some other tangent line though, right?
Nope. There's one tangent line.
Okay.
I'm on it. There's two people on a tangent line.
Okay.
Right?
So they're at the same spot. Okay.
Two people are on a tangent line. I am, I don't know, let's say 50 miles away from the other person.
Okay, that doesn't make sense.
I'm at a GP. What's up?
A tangent line is only going to be tangent at a single point.
Dude, there's a straight line. Straight line.
Okay. So a great circle then.
I know how tangents work. Yes, it touches the circle at a point. Yes, we know. Why are you even talking about this?
Because you're confusing me, dude. You're saying it's not a great circle, but it's a tangent line, which is tangent at one point, but there's two people on it and they're 50 miles apart. Doesn't make sense to me.
Yeah, one of them's in Death Valley, another one's on the top of a mountain or something. So there's a tangent line in between them. Can we do that or no?
I guess so. So it's not tangent from where they are, but it's a tangent line. Okay, between them. Okay.
There's a straight line. Two people are on it. They're both at the GPs of stars. All right, you with me?
Sure.
Say they're 100 miles apart.
They're 100 miles apart.
Is that, yeah. So we now have a square, no? Would the stars not have to be 50 miles apart from each other? Like, I don't understand. If I'm 50 miles away from the other guy and we both got 90 degrees to the stars.
Yeah.
Does that not mean the stars are 50 miles apart from each other?
No.
Why? Where are the stars then?
The celestial sphere is a sphere that surrounds the Earth, and it's used as if it's infinitely far away. But you could pretend like it's whatever distance. But really, it has to be a distance that's far away enough to where what's it called? The perspective doesn't come into play.
You're not hearing me.
But here's the point, though, dude. If you're 50 miles away from them on the surface of the Earth, then depending on how high that celestial sphere is, that circle, that distance is going to be much bigger because it's a bigger sphere.
I see what you're saying. They could be farther apart, but one could be closer and farther. All right, never mind.
Yeah.
All right.
But yeah, I have an answer for your other question too.
Yeah, how big is the square, bro? Come on, stop playing games.
I'm playing games, dude. Hold on, actually.
Yo, what the hell am I looking at, Kosho?
Oh, with this.
Did he show you the globe Earth model with the blue circle?
I was looking at the blue line with the yeah. This looks freaking weird as shit.
That's somebody measuring or trying to find the GP of a star, and so the blue line is representing the GP. So that where that blue line intersects the Earth, that's the GP, the spot right beneath the star. So let's pretend it's Polaris, for example. That's the North Pole. Then that blue line intersects. That's the North Pole. It's pointing right to Polaris, and this person is somewhere else, and they're trying to find their distance to the North Pole. So they are measuring the angle to Polaris, basically, from their position. That's all this is showing. So where the red position is the person measuring the angle to the star that they're trying to find the GP to.
And that blue line.
Why is your horizon up to the skies though?
No, the horizon is the one that is pointed to the down left. That's their horizontal, basically.
The horizontal is pointed to the sky. Is it supposed to meet the ground?
Yeah, this is okay. This is a crude drawing. So in this drawing, the person is really small, and the horizon in front of them is going to be, extremely close. This is just showing where that horizontal extends to if you draw it infinitely out, right?
Yo, the globers can make
it start. Does it start maybe in the center of this sphere, by any chance?
What's that?
Those lines, the red line and the blue line, do they start at the center of this sphere by any chance?
Yeah, of course, yeah.
Of course, okay.
Yeah, right. So you see the difference, SE, between how easy it is to get assuming a flat Earth, right? Let's say assuming a flat Earth, how easy it is to get an actual angle with a triangle on a flat Earth compared to what the hell they have to do to try to make an angle on a globe Earth.
No, I see how you're thinking of it. Yeah, I understand that. But just understand, you can take an angle from anywhere. You could be on a rock. You could be standing on a triangle. You could be standing on a square. You could be on the side of a hill. It doesn't matter, bro. You can still take an angle. You don't need a flat.
I don't even get the whole. I don't even get the whole first part of the argument.
Because if it's not flat, the surface is not flat. Your degree to the star or wherever the star is supposed to be, it's off.
Yeah, it's off. Yeah, you're assuming shape.
So you're saying this can't work?
No, but you understand that, right? I mean, that's the whole point of a having the angle, making a. Even if you're saying you don't need a triangle, but you do because there's the degree corresponds to a triangle.
I'm agreeing with you. I'm agreeing with you wholeheartedly. Right? But how do you get the triangle? You just have an angle. How do you get that triangle? This is the whole thing.
You're assuming the triangle.
When they do it on the flat Earth, they got.
Go ahead, Jeremy.
No, when you do it on the flat Earth, they got multiple angles. You got the angle to the star, and you got the angle from the GP, 90 degrees. The question is, does this not work on a hill, the side of a hill? Like, I don't get that whole first part of the argument. You need a horizontal baseline. Like, you can make a horizontal on the side of a mountain or a hill or the ocean.
So let's say you do, then you have to do a dip correction of how high you are to the base.
Yeah, I was just going to say that. When they take it on the boat, right, they do a dip correction, right? So if you take it on the side of a hill, can't you do a dip correction as well?
Yeah, you do a dip correction to the
there
base.
You go.
In other words, you do a hill correct. You do a correction to the base. In other words, to the flat horizon. You still make a.
But you're still taking an angle. You can still take that angle on the hill, right? That's my whole point.
As long as you correct, yes, you're right, 100%. But you have to correct for the base.
Okay, I'll give you all that, right? You have your angle now. You correct. What do you do next? How do you form your triangle? What do you do after that? Where do you get the info?
And this is where this is right. So this is where I understand this part of the conversation now. The whole almanac, getting the degree, and where's the GP, and this is where I feel like it's a lot of mumbo jumbo because you have to get the the degree to the star, getting whatever is supposed to be at a certain time, and therefore so on and so forth. So, but this is where I kind of just it becomes uninteresting to me.
Well, this is where the gravy is, bro, because they're using a globe system to prove flat Earth. It's like nonsensical, bro.
It's not a globe system because again, this was established way before the globe system. Now that they transposed it to a globe system, is different.
No, the nautical mile is a globe system. There's no way around that,
right? Because it got transposed.
Is based on. There's no way around. Look what I posted. I mean, read it for yourself, bro.
Right, I understand that. I understand that the nautical mile, but remember, nautical mile wasn't fully established until 1929, which again was the transpose of whatever mileage they were. Even though the other people was actually measuring. Remember, I don't know if you saw the history. They were assuming whatever, but the globe as well from the Romans but
no. The Romans didn't assume a globe. As far as I'm aware,
it has to be cleared up that whatever methods were used in the past, I would almost completely disregard them. And when like I wouldn't imagine that the technique that's used in the celestial navigation as we know it now was the same techniques they used back then at any time in the past. So I would use this as a unique. Like this was like a fresh start technique because in order to do this technique, it requires things that didn't exist before, like clocks that worked on ships, and also like an almanac, which also wouldn't have been available.
Right. Well, they had something. Exactly. They had the astro navigation, right?
No, he's right. This technique is a modern technique which uses a nautical almanac, uses a chronometer. And all that stuff, yeah,
right.
Absolutely.
Like I said, this was all transposed from whatever it was before to whatever it is now. In other words, it's just even though I mean, it's just if I go to a piano, back in the days, piano you can't transpose a key, but now you can, right? Doesn't mean that because we have a new modern way to actually do stuff doesn't mean that we have to, throw out the old way, which is.
I'm sure the old way still works. I'm sure the old Polynesian way you can navigate, the Egyptian, all that stuff. I'm sure it could be done, but it has nothing to do with the nautical almanac. Is my point. Nothing, zero.
Right. I mean, I think the whole argument that the FE is saying is that you need a flat baseline. That's
the whole argument. Exactly that. Yes. You need a flat adjacent. That's their whole argument. Yes.
Also, when the image I showed, it's very, like I said, simple, but at the same time, it does show you the person who's at the red point. He's trying to find the GP to the, blue GP star, whatever. And from his point, he can create a vertical, and or create a horizontal and then find his vertical, or find his vertical and then get his horizontal. Whichever one he does, he measures his angle to that star, and he can pick either one of those two angles. He really needs the small angle, but you can find the small angle by getting the big angle first. But regardless, you don't need the surface of the Earth to get either of those angles. You just need to know what your vertical and horizontal is.
You know what's funny? When I went on the first time, it was a little bit more cordial, and I told him this is one of the faults that ballers are going to come up with, and Jeremy thought of it. Because if you have a triangle, right, then you can figure out the distance to the sun. That was one of the things, one of the holes I told him that I found in it, besides the book, right?
That's if they're getting distances.
Yeah.
You need the two angles and the one distance, and then you could figure out the rest of the triangle, right?
Yep.
Wouldn't they have to be straight lines too?
Yeah.
Yes, sir.
Yeah,
good luck with that.
That would be the method on the flat plane, though. Yeah.
Is that right, Kosho? If I have a 90-degree triangle, what's up?
Oh, so the answer is yes, yeah.
And I have the two angles and the one distance, I can figure out the whole rest of it?
Yeah, if you had a 90-degree triangle, you only need one angle at that point because you already have the 90. But yeah. So if you have a 90-degree, if you were on a flat plane, for example, so that's the difference between these two methods about the two models is on a globe, obviously you find this angle, and in my picture it would be that small angle, and you multiply it by 60 nautical miles, and that will give you the distance from there to the GP. On a flat model or a flat plane, you'd have to get the information you're saying. You would find out where the GP is. You would know that's a 90-degree angle. You would then measure your angle from to that same star of that GP, so it'll be the second angle. And I guess you'd either have to know the height of the sun to determine your distance to the GP, or you could use your distance to that GP to determine the height of the sun. Yeah.
Well, just to
there
what
you
Rocky
go, Jeremy.
said. Just to what Rocky has said, real quick. If I'm at sea level and you're at sea level, I don't have to actually make that straight line on flat Earth. That would just be it'd just be a straight line, right? Like that line wouldn't have to actually be made. You know what I'm saying? If it's flat.
Even if you weren't at sea level.
First of all, isn't their surface curved?
Same elevation.
Isn't their surface curved? How are you going to make a straight line?
They're not making a straight. They could get a triangle out of their celestial navigation stuff and the information we know about their model. You can make a triangle. Or you make a chord from the GP observer to the observer. Now you got one straight line, two angles, and a distance. You can make a triangle with their shit too. They don't do it to do celestial navigation, but it's there with that in their model. So, I mean, have you ever done this, Kosho, to actually get a distance to the star?
You can't do that.
You can. I just told you have a chord. You can make a chord, right?
Yeah. Okay. So if you took
act
the
like
image,
we're in this 2D world where we can only live on the surface of the sphere and can't do anything.
no, but that's just okay. For the same reason that you can't get that perspective doesn't change the angles to stars. The same reasons because they're distance. If you were to draw a chord on the image I drew, those two lines pointing to the star are parallel, or they're as close enough to being parallel that they're certainly, you know, used as they're parallel. There's not a.
So you can do some calculations and come up with the distance, no?
Yeah, if you have a measuring device that can measure something extremely small difference between the angles there.
I mean, they measured plumb lines not being plumb. Oh, they must be able to do it pretty precise, no?
You know how they do it, Jeremy? They assume that all those stars are the same distance, if I'm not mistaken.
Yeah, I know what they assume, but they can make a triangle out of their stuff.
Yeah.
They have enough information between their
They take perspective out of it too, and you mean to tell me that you take the North Star and get to its zenith and then fly 1,000 miles an hour away from it in any direction? It's not gonna get lower in your vision. You have to use perspective with the stars.
No, it gets lower in your vision, but and the principle behind the way that we use it, at least on the globe, especially to use it for celestial navigation and stuff like that, is by using the principle that the light's coming in parallel. So the light from Polaris is coming in at the same angle, or whether you're on two ends of the Earth, or two sides of the equator, or something like that. And then so every place on the northern hemisphere is getting light from Polaris that's coming in as if it were parallel. Even though there's a slight angle difference between it in reality, that angle is so slight that it's not worth mentioning. Yeah.
I'm not so sure about that. Hold on, what Kia said is true because they have corrections for that. I don't know if you're aware of that.
For the moon and for the sun, but not for the stars.
Well, they don't show parallel. I'm sorry, Jeremy. Go ahead.
They only use perspective with the stars for the stars when it doesn't match, with their model.
Yeah, and I think the corrections are for parallax, not for perspective. You would always have perspective. You can see an object and you can go away from it or get closer to it. That object is going to appear higher or lower in your vision.
Not perspective, refraction. If I said perspective, I was mistaken. It's refraction that they have correction for.
I got you, and I don't understand because even at closer, like relative distances, like really close, you have refraction. Why wouldn't you have refraction? Something that's light years away. If you're going to say they're light years away.
No, there's definitely refraction because they have. There's definitely refraction because GPS suffers from refraction in the ionosphere they're playing. So I mean, even in their own model, there's refraction.
That's absolutely true, and they do have a correction for it. Yep. Amongst plethora of corrections, by the way, a plethora, whatever it's called, many.
We have plethora of pinatas. Don't oh my God me, Kosha. What's the biggest square we can make, dude? You still haven't answered that.
Listen, never mind. I'm not gonna say it. Yeah, I know. Never mind. Hold on. Just give me half a second. What's the square root of 2 again? It's like 1 point. Give me a second.
It's 1.9.
I need to know how big that square. What's up, SB?
I was gonna say we're supposed to believe that the Chinese navigated thinking that the Earth was a globe.
The square root of 2 is the same as a lot of other things. It's 1 point something, like 1.414, 1.415, or 1.5, or 1. 5-1 or
He's
something.
just saying every number. You just said every number.
No, that's a lot of numbers, dude. When you add a decimal in 2 or 3 places, that's a lot of numbers. But
You're
it's
bound to
somewhere
get
close
one right.
there. I think it's 1.414 something. Yeah.
Isn't it like phi or the golden ratio or something like that? Like some weird thing.
5 plus 1 divided by 2.
That phi stuff is freaking crazy, man. Really crazy. Proportions and nature and that? Man, oh man.
Ratio.
Yeah.
Ratio is a killer.
Osho, what is the biggest fucking square, dude? I've been asking you for like 3 hours now. I need to know this. If we get distances from celestial navigation, I'm gonna need to know this square thing.
Can you see live text, Rakia?
Yeah, I was just eating lunch.
Check that out.
It's time for you to start pulling your weight around here, Coach. There's no more free rides. Yeah, I'm gonna watch that Brian's logic video later so I can see if he gets distances or not. Just watch that whole Google Earth, flat Earth thing Oakley and QE presented a while back. Thought they were saying the good distances were good, but they never said, they specifically said no, not the distances, just that there's no drop.
And so then but it's crazy is that even though square root of 2 is that number, if you multiply that times itself, it's not 2.
I thought the square root was when you multiply a number by itself, you come up with that number.
Yeah.
Like say you were trying to get the square root of 25, I would say 5, and then I would check it. I'd be like, all right, 5 times 5 is 25. That checks out. You're saying that don't check out with 2?
Nope.
You know, how the fuck is it the square root? Kosho, what's the square root mean? Maybe I got it wrong. I don't know.
You're always wrong.
Forget it. Just focus on the square, bro. How big this fucking square can be. I'm gonna need like 100 miles at least. The bigger, the better.
It's a lot. You have a lot more room than that, dude.
Do I got like 1,000 miles?
More
make
than
like 1,000 miles sided, each side square.
Yeah. Okay. So I'll just tell you the. Oh fuck! Give me a second.
Come on, bro. Would you have some bad idea?
So God must have been a mathematician, huh?
The best.
I think this is a simulation. There's way too much math and shit involved in this.
But the math is fucked up, man. It can't even get the square root of 2 right.
What's the square after this square thing, Kosho? We want to get down to the bottom of the square root of 2.
Yeah. Okay. That's great. Listen, the perimeter. I mean, you have a big surface area. I can tell you the surface area, or I can tell you what do you want to hear? The edges of the square.
I want to hear how long the distances on each side of the square can be.
About more than 2,000 miles, 2,000 nautical miles.
So each side of the square is going to be 2,000 miles long.
2,000 nautical miles.
Don't get all nautical on me.
Hold on.
2,000 miles. Are you sure?
Absolutely. Yeah.
Okay, when I watch Brian's video, we're gonna revisit this. Now let's get down to the bottom of the square root of 2 thing. What is the square root of a number? That's when you can multiply it by itself and come up with that number, right?
Yes, of course.
So why
it checks out. It checks out.
Elbow said it didn't check out.
Yeah, it does. I think it's got
1.4 times 1.4 equals 2. That checks out.
There's more to it. It's an irrational number, so it's not just 1.414.
I got it to 1.9999999 repeating.
Yeah, I've got it to 1, 2, 3, 4, 5, 6, 7, 8, 9. I've got it to a billionth.
They actually say 0.9 repeating.
Yeah.
This is another interesting fact. Hold on, this is another
10 to the ninth. 1 times 10 to the negative 9.
Whatever number you put in, like my calculator on my computer has my, I don't know, like 20 digits after the decimal. It doesn't have an infinite amount of digits, so
it's always 1.9 repeating.
Well, no, it's just you're not actually using the square root of 2. Whatever your
square root. What's the square root of 2?
It's an irrational number. That means that it has digits that go on forever.
No one has the square root of 2.
No one has a square root of 2. It goes way too far for them to actually.
I think it repeats itself though. Like it's a repeating.
What's 1 times 1, Jeremy? What's 1 times 1?
I mean, I thought it was 1.
Yeah, this is God telling people, don't think you're so smart. This is my territory. I think that's God with the pie in that.
Well, this is an interesting thing we went over in Gems. 0.9 repeating is actually equals 1.
It's equivalent to 1. Yes.
Yeah, equals.
Only in somebody's fantasy brain. Only in somebody's brain.
Don't try to rephrase my shit like you're smart, please. Equivalent equals. Come on, dude. Anyways, they say it repeat. Well, they give good reasons for it though, because there's no number you could put in between it. I don't like it at all, just for the record. But they say it's basically the same thing because there's no number. But then they have infinity 9s. I mean, come on, dude. Once you start using infinity and shit, you've lost the plot.
Who's CB, Kosho?
Creation Bear.
No.
Well, I think he's referring to a person in Discord.
Yeah, it says here, Kosho, did CB just leave Gems? I don't know who CB is.
That's Captain Bullshit.
That's what I thought. That's what I thought it was. Who'd you say it was, Elbow?
Creation Bear?
I don't know. I don't know. They've been having a little rift.
Yeah, he's one of the mods over there, and him and Jim kind of go at it every once in a while.
Oh,
There's been a huge rift. There's been a huge rift over at Gems with Queen of the Trolls and the whole Pink Panthers or whatever they call themselves.
Yeah, they're gone. They're out. The Queen is
wasn't
gone.
Captain Bullshit with them people though, or
not sure if it was a Pinkerton. Not sure.
Oh, Pinkerton. Yeah, that's what it is.
The Pinkertons are out.
Yeah, but Captain Bullshit roll with them dudes though, so. So we can't get the square root of 2 ever?
No. You can't. Think about it. 1 times 1 is?
1.
That's God telling everybody, you think you know the Fibonacci sequence? You think you know pi? You think you know phi? No. That's my territory. I do that.
The Fibonacci sequence is dope. That's why there's no 4-leaf clovers. 4 is not a Fibonacci number.
Just look at all the veins, all the plants, the bees, everything, man. Everything is like, it's like it was mathematically designed, man. I mean, there's no way around that. Whoever the creator is, he's a mathematician.
That's seriously though. That's why I think 4-leaf clovers are rare, because shit's not supposed to grow like that. Because 4 is not a Fibonacci number. Yeah.
Yeah, but there's a lot of tools in nature. 2 eyes, 2 nostrils, 2 ears, 2 hands, 2 feet. I'm telling you, God said, nah. Stay away from this. This is mine. You build a tower, I will strike you down. That's my territory.
I go watch Brian's Logic video. Are you guys going to just all leave, or what's up? Do I got to keep you guys entertained?
We don't need you. Go, you can go away. What do you think?
I think every time I leave the room, the shit dies. 10 minutes. I left for 10 minutes earlier to go take a shower. The whole room died out.
Don't worry, we'll be here.
Coach, I don't go anywhere because after this, we're going to have to work on that square.
Space Poop says that they're still there, but I heard, and I even heard the Queen Badmouth gem many times.
Space Poop.
Space Poop.
Yeah,
Yeah,
she came back. I don't know, 2 or 3 days ago. Yeah.
Okay, I stand corrected then.
I think she's on the ban list. She was on there a couple days. It was a few days ago. I don't know if she's still right now. Still.
Yeah, she came back and stirred up a bunch of trouble, and then Jim got pissed off and muted her. And so I don't know. It's back and forth.
How can you tolerate that thing? Like, seriously, man. How could anybody tolerate her? Left Lane, I remember when I was in Gems and would go back and forth with her because she would badmouth people. And after I had an exchange with her, I would get DMs. Way to go, SC. We hate her guts. Keep it up. No, everyone's afraid of her. From ballers now.
Yeah. Yeah, she rubs people the wrong way with her aggression.
Yeah, there's some people that that's their game. Like Space Poop is one of them, Just hatred, just whatever you say, just to go against for the sake of going against. No argument whatsoever. We witnessed that yesterday with what's his name? We're having a great convo with new energy there. Well, not new, it's old. And then he comes in and ruins the whole thing. No way, you. I said that's what we would do to him. That's what he deserves, is what I said. That's what I felt like doing to him at that moment. I didn't say I did it.
Was that the guy you were going to piss on?
Yeah, that's the guy. I told him that if you were around.
I came in at that moment. I was like, what in the hell's going on? Why is people getting pissed off?
Yeah, it's pretty funny.
That guy is like just useless, so yeah. That's the guy that in one of the meetups, he ran by, who was it, Nathan? And he slapped the hat off his head and he just kept running.
Oh, okay.
You know who I'm talking about?
He tried running up on Whitman too. He tried running up on Whitman in Texas.
Now imagine going to a meetup so you could just run up to somebody, slap the hat off his head, and run away. Like, what is that?
Literally never heard any kind of productive, good, interesting, fruitful, put whatever adjective you want in the front of this. Never heard a conversation like that from him. Ever.
Ever, never. Not one time. Not one time. Years now he's been around the same old stick.
Dude, I was calling. I had him turned all the way down in Gems locally, and I would just call him Mumbles because it sounded like he was mumbling.
Yeah.
Have you ever heard the guy named Mumbles? Ed Bassmaster?
Bassmaster, yeah, that guy's dope.
Yeah, dude.
He's dope. He's been around for a long fucking time, dude. Over a decade now. Probably damn near 20 years.
If you're jealous, Wei Hugh, you can line up. No problem. Take a number. Or open your mic and tell us what's on your mind. Like, if you can support a person like that, I don't think you have much on your mind. Yeah, there's certain people like Space Poop, Paid NASA Shill, that guy. What's his name again?
M Stone.
M Stone. Yeah, he's one of the worst. Yeah, people like that are just absolutely useless in a conversation. I mean, you can get a better conversation with Brenda than with these guys. They're nothing but insults and that's it. Hatred. Like this dude, Space Poop, follows me around like a little dog. Everywhere I go, he'll come in and he'll make comments like that. That's all he does. Nothing, never any substance.
Let's not call names, though. It was kind of funny at first, but.
Yeah.
Where are you at, Babs?
Come in there, Babs. You yellow belly.
In,
tell us what you got. Tell us what you know. Come on. We all know you ain't got nothing. All you got is vitriol. Come in and say something scientific, like challenge me on anything. Come on. I dare you. I dare you. You're a baller now? Come on, let's talk. We all know you're yellow. You too, Wei Hugh. Come on in. The floor is yours. Tell us about this mythical sphere of yours. And tell us how we don't understand your model. Yeah, Jeremy.
Yo, what are you guys talking?
We were talking navigation, celestial navigation. Proves flat Earth.
You, man. I hate those topics.
What topics?
Celestial navigation. It's one of my least favorites.
I know. I've never gotten into it. I'm about to start getting into it, though.
Yeah. Bacon loves that shit. That's all he ever wants to talk about. I don't understand the flat Earth argument against celestial navigation working on a globe.
You need a horizontal baseline. You need a horizontal baseline. That's all I know.
Yeah, okay. But, I mean, having a horizontal baseline don't say nothing.
You have to.
The
Earth has to be flat because of that somehow.
No, having a horizontal baseline doesn't mean Earth has to be flat. If that's the argument, that must be the weakest flat Earth argument I've ever heard.
Dude, I'm just getting into this, so don't maybe go at somebody else with it because I'm not prepared. I've never gotten into this celestial thing.
Okay. Who's the flat earther that talks about it the most? Is there a flat earth champion? Celestial navigation?
You're kidding, right?
I don't think I'm the champion of anything, but I like to think I understand it.
Okay. Are you the champion, SC? Well,
No,
what do you mean by
FED is the champion. FED, a fellow by the name of 10th Man, which he never ever explained how it works, like from beginning to end, as far as I know. He's the one
But
you
he's
need
a
to
flat
talk
earther,
to.
right?
Sorry?
Yep.
Is he a flat earther?
Yeah, absolutely, yeah.
Is he in the server?
No, are you kidding me? No, he's over at Nathan's. These guys don't come out of their cage.
Oh, okay. Ew, I ain't going to Nathan Oakley.
Yeah, let's go over to Oakley's. I'll go with you.
Will you talk? I'm not going to talk.
I got to watch this video before I talk, but yeah.
All right, yeah, we can do it, but you got to send me an invite. I'm not in that, sir.
Maybe tomorrow. No, I'm not bringing no one with me, bro. That's just what I need. Want to bring a crazy Glober in with me. I'm going in all by myself.
Like I said, I won't talk, bro. I'll just be there, you know.
I'll send you the clip on YouTube.
Nah, come on, bro.
I'll send you the clip, dude. You say you won't talk. You be blurring shit out in the middle of my thing. No, absolutely not.
No, I won't. I swear to God, dude. Word
I don't
is
need
bond,
no
bro.
one.
I don't say nothing.
If we get a distance from this, that's all I need to know. And then I'm gonna do the math, crunch the numbers, and we'll see if it's planar or not. Easy peasy.
You're gonna crunch the numbers? That's what's up.
Well, not me personally, but I'll have Kosho do it and then have someone check Kosho's work.
What's up with you and delegating, bro? Like you'll never do nothing yourself.
Because listen,
the lazy fuck. That's why.
You can't. I can't do everything myself, guys. I need a flat Earth secretary as it is.
Got the
right? I can't do everything. Dude, I can't do everything myself. You think Elon Musk runs around doing everything himself at Tesla and SpaceX? No, you can't. You got to delegate.
So you Elon Musk.
I'm just saying, bro, when you're when you got a lot of stuff going on, you can't do everything. You got to delegate shit out.
Word. Damn, bro. All right. I hear you. Yeah, but no, just let me know what time you're going. But oh shit, what's the time for you right now?
Bro, I'm definitely not letting you know. I'm not telling no one. I don't want no one to fuck this up. Okay, you ever heard the phrase, if you want something done right, you got to do it yourself?
Yeah, definitely.
This is one of those cases.
Know, Jeremy.
No, I'm not letting you guys can all watch it on YouTube after.
Bro, you playing the whole game out, Jeremy.
I'm not playing games or not. I just don't want it to get fucked up. People are maniacs.
No, you just need support, man. You need support.
It's going to be hard enough as it is. I don't need support. I'm fine.
No,
it's hard enough as it is.
Actually, will be there to prep you, bro. Warm you up.
I don't need no prep, dude. This is all This is not a boxing match. This is all geometry.
We in your corner, bro. Don't worry, man.
No corners.
I'm gonna be your waterman.
We got the George over here. I think he knows the system from FCD best. Maybe you can talk with him.
Is George here?
Yep.
Yeah, you need a horizontal baseline for that. Yeah.
That's
feeling
correct.
better, George?
Elevation angle, yeah.
You feeling better?
Yeah, slightly better. He's not going to go
George,
just like
have
that.
you ever heard 10th Man or anyone on the FED panel describe how celestial navigation is done?
Yeah.
Okay, step 1, we take an angle to a star, or I don't want to like straw man it. What is the first step we do?
Celestial navigation. You try to find your fix, correct?
You what?
You're trying to find your position, your fix.
Whatever this entails, yes.
Yeah.
Your ground position?
Yeah, you're trying to find your position. Yeah, your ground position. Yeah.
Yeah. That's the whole point of it. But what's the first step?
First step, Well, the first step is to identify at least 3 celestial bodies in the sky. That's the first step. You need to be able to identify what is what. If you're using the sun and the moon, should be obvious, isn't it? So once you identify the object,
I was about to ask
dude, this is why you ain't coming on Oakley's with me, bro.
What do you mean?
Once that you identify the light in the sky that you're observing, you'll need to refer to your almanac.
Yeah.
Your almanac will tell you the GP of the light that you are observing. So the position over the ground.
Oh, wait. Does it tell you
position over the ground?
Yeah, but does it tell you the position over the ground at a specific time?
This is why
Jeremy, they already stepping all over your.
This is why I ain't telling no one when I go on FED. Exactly for this reason.
Come
Right
on,
now,
Jeremy, man. We asking the questions for you, bro. This is delegation, right?
No, this is not. This is the part I did not want delegated.
All right, but George, so you use the almanac to find the GP at a specific point in time, right?
Correct.
Okay.
Hold on. Jeremy wants to understand it, so can you let Jeremy just go at it, man, with him?
All right.
So you can get all steps.
My bad.
We got 3 stars. 3 stars. We see 3 stars in the sky. All right. Then what?
Well, you need to know which position those lights in the sky are straight overhead, which is a GP of them. So that position is being mapped out on the ground position, where it's going to be located. The almanac will give you the line of longitude and latitude for that light at a specific time.
Okay.
And you'll have
I look at the stars.
Yeah, you're looking at the star, you know the GP of the star. You're looking at the star, you measure an angle to the star. Elevation angle.
From where?
You aiming at the surface level, which is the horizon. So the sextant has 2 mirrors. One is the horizon mirror, which is the surface level one, the one that you're looking at the horizon. Second one is the celestial mirror, which is you have a mirror pointing at the celestial body, and you need to bring that mirror down. So basically, you have the celestial body coming all the way down to the horizon mirror, just touching the horizon. So once that you have that angle, you'll need to deduct that angle reading from the 90-degree angle. That's where the 90-degree of the almanac is very important. For you to have a distance to that point, you need to deduct your angle reading from 90 degrees and then multiply it by 60 nautical miles to give you a distance to the GP. Now, once you find 3 different distances to the GPs and you draw those circles, you'll find your fix, because those circles are going to intersect in one single point, which is your location.
Hold on, I don't want to interrupt you. Can we just rewind it real quick?
Yeah,
I got my angle to the star, and then I can use that to figure out how far I am from the GP, the distance between me and the GP.
That's correct.
Yeah, there's some math involved in that.
Is that how? Yeah. Well, I was just wondering if we can get a distance, and that's what FED claims. Are you sure?
What do you mean FED? Celestial navigation.
I know, but the people on Flat Earth debate, is that how they claim this happens?
Yeah, it's celestial navigation. Exactly the verbatim of celestial navigation. Well, we are talking about what the almanacs say regarding these elevation angles and how it's done.
So all I need to do is get the angle to a star, and then I can get the distance between me and the GP of that star. And we know where the GP is.
Yeah.
The 10th man tell you this? Who told you that?
The difference in the angle will give you a distance.
Yeah, but who told you that, though?
What do you mean who told you? This is what we talk about all the time. This is what the research has led to.
What about the math? George, what about the math? You go to the almanac, but you have to do some math to actually get the GP.
I already told you. You deduct your angle reading from 9 degrees to give you a distance.
No, it's a pretty complicated formula to actually
angle
get
is
the GP.
40 degrees. Yeah, if your angle is 40 degrees, you need to deduct 40 from 90. Yeah, that will give you 50 degrees. So now this 50 you need to times 60 nautical miles, which is the distance.
So you got that, but where do you put the GP at?
So it's easy as that to get a distance.
The GP you get it from the almanac. The almanac will tell you that this line to the sky at this time of the day will be where X marks the spot. Longitude,
so it's that
lines.
So it's that easy to get. Hold on a second. So it's that easy to get the distance from me to the GP. As I take the angle of the star, I subtract it from 90, and then I'll multiply it times 60 nautical miles, and I'll have the distance from me to the GP. It's that easy.
That is correct.
All right, perfect.
Now, that is a radius value between the G and the G is a radius. Now, you need to draw a circle around that radius because you know the distance between you and it, but you don't know where from which angle you are facing the light in the sky. That's why the circle. So you are somewhere on that circle to that light in the sky. That's why you need to have at least the radius from 2 other circles, and the line going to intersect is on the ground.
My main concern with all this was the distances. So I mean, we're good if that's all you need to do to get a distance. Perfect.
Well, the distance on the circle, isn't it? That's a circle of equal altitude.
The distance from me to the GP. The distance from me to the GP of the star.
The distance from you to the GP of the star is it's a radius line to draw a circle. Once that you have that radius line, a straight line to the GP, now you can grab your compass and you draw a circle around that point. The circle has 360 degrees. Every degree on that circle is because that's the distance to the center. 60 nautical miles times the degrees gives you the distance. But you don't want to travel there. You just want to know how far away from.
Yeah, I'm just trying to get distance. I'm just trying to get distances. That's all I'm trying to do with this.
If you're done, I'd like to ask George a question, Jeremy.
Yeah, no, I'm done. That's good. Perfect.
So, George, I don't know if you heard my argument against celestial navigation proving flat Earth. My argument is the nautical mile that you guys use, which is based on a sphere cut in half at the equator, and used one of those circles as 360 degrees, and each degree is assigned 60 nautical miles. What do you think about that, George?
Well, I just addressed a part of that. I think it's a misconception that you still have. You need to have a bit more grasp about it. Let's go one step at a time. What's your first beef with it?
Well, my first beef with it is that it's based on a nautical mile, right?
Well, it's a distance between you and the GP of something. Yeah.
Right. Now that distance, the nautical mile, is based on a spherical globe.
That's not correct. No, it's based on a circle. 360 degrees, every degree is 60, like a clock. You know?
Where do you think they got that from?
Yeah, but it's a circle. It's not a sphere. It's a circle.
Yeah, it's a circle. So they cut the sphere in half, George.
No, that's the celestial sphere. That's something else. And
if it's flat, why would you use a circle?
We're talking about the circle. If you want to know the distance between you and the star, you need to know the position of the star overhead, which is the 90-degree position. At some point, that light in the sky is going to be overhead on a point on the ground or the sea, yeah, on the grid system. So if you look right overhead at a certain point, you're going to see this star right over you. So you'll know that at that time of that day, because the sky is a cycle, repeats itself, there is a table that will tell you that the sun or the moon will be on this specific position GP at this time.
I
So
understand, George.
if you are capable to visualize at that time where the angle to the light, then you deduct that the angle reading from the 90 degrees and will give you the co-altitude. That co-altitude angle times 60, which is 1 degree. 60 is a degree on the circle, 360 degrees. So that will give you the distance to the GP. The radius
You're not
value.
listening to what I said, George. I just posted something 19 after the hour. Can you please read it quick?
All right.
Or if you like, I'll read it out loud. A nautical mile corresponds to 1 minute of longitude along the equator.
Please.
There are a total of 21,600 minutes of longitude in the circumference of all spheres, right? 360 degrees times 60 per degree equals 21,600 minutes. As a result, the circumference of the Earth in feet divided by 2160 defines a nautical mile, bro.
Yeah, but they are doing a circumference of a circle. That is a circle they're describing right there. I understand that the ballers would look at that and will say, oh, sphere. But no, it's 360 degrees per minute, like a clock.
George, I agree with you. I'm telling you the pitfalls of a baller.
It's a circle.
What I just told you. It's based on a globe, bro.
Yeah, listen. Yeah, but the line of longitude and latitude is on a grid system over a flat plane. Yeah, it's the distance between the extreme ends of the clock and the center of the clock is what we're talking about. But that is a horizontal plane.
George, I understand that. You're not understanding me. The nautical mile you use is based on a globe. It even gives you the circumference.
No.
Everything. Yes,
No,
George.
it's based on the circle. It's based on the circle. Listen, the circle is with Polaris at the 90 degree and the what do we call the equator line at the 0 degree, which is the celestial horizon, I believe is what they call
the equator line. Did you just hear what you just said, George?
Yeah,
you just said the equator line.
Yeah.
What's the equator line, George?
Yeah,
isn't it around a sphere? Isn't it around a sphere?
No,
the equator line, George?
No, it's the sun's path overhead.
Right.
The sun's path gives us the equator.
Yeah, I don't know, George. I'm trying to make
you have a straight line.
It.
You have a straight line. If you have a protractor in your hand, and you have the equator on 0, and the north celestial body at the 90 degree, you have a straight line. I know they do it from the center of a sphere, but that's not how it's done. It requires a horizontal plane to do that.
Yeah, but even your explanation, you use the word equator, George. You're not seeing it,
that
bro.
Line, equator. What do you mean?
What's the equator, George?
The equator is the sun's path. The sun's path overhead.
I don't know. I don't know how else I can tell you.
The sun's path overhead is the 0 line of the equator. The globe is based on that. It's a straight line from Polaris GP to the equator. Straight line, because you need to have a 90-degree angle. So that straight line will give you an equatorial plane all around 360 degrees. And the the diameter of the supposed globe. And if you turn that around, you'll have again another equatorial plane, the same, with south in the center and angles to the south. It's exactly the same. That's the celestial sphere model, which is a flattered model.
You can look at it that way, George, but when you use nautical miles, when you use the term equator, I mean, these are ball terms. These are sphere terms. There's no way getting around it, bro. You can say, I get what you're saying. It's a circle on a flat surface. I understand that, but
He's right.
Sphere terms is hemisphere and atmosphere. Those are sphere terms. Equator is not a term for that. It's been turned into it. No.
Just like nautical mile.
Before being a ball, it used to be flat and was based on the flat measurements that they driven the ball from. Yeah, they driven the ball from the celestial sphere, which you'll have a straight line from the northern star in the center of the celestial sphere all the way to the equatorial plane.
You know that when you use the nautical mile, George, you're affirming to a shape and a size, right? You do realize that, right?
Yeah,
a circle
right.
around Polaris. A circle around Polaris.
The equator, George. The equator is just the midpoint between the two celestial poles. And a flat circle
there is no celestial pole.
wouldn't have poles.
There's only
There's
only one pole.
And the celestial equators. The celestial equator is the
there's only
midpoint.
one celestial pole, the north.
Yeah, cool. But all I'm saying is the celestial equator is defined as a midpoint between the celestial poles. And that's why Odysee is right in saying these are all sphere terms, these are all globe terms.
Yeah, you turn the protractor upside down. It's not Bowler terms, This was driven from a flat plane.
Show me an equator on a flat 2D circle.
What makes it being the equator?
The equator is for a sphere.
The equator is the line.
It's the midpoint between two celestial poles.
No, it's not. The equator is the sunspot overhead.
But it's also the midpoint between two celestial
poles. Not also.
Yes.
The equator is the sunspot overhead. Doesn't matter if it's the land or the sea. The
look it up. Look it up, because you just kind of deciding what is and what isn't.
No, it's the sunspot overhead, man. It's the equator line.
But it's also the midpoint.
You're begging the question of a
sphere. You
can
say it's a sphere or a circle, whatever you can say it's a sphere or a circle, whatever you want. But in reality, it's just the path of the sun on an equinox.
That's correct.
I mean, that's what they're using is at dictionarium fallacy, which is if I could tell the definition is that. Let me give you an example of that. It's like, let's say the coffee is made with definition. Let's say the definition for coffee is made beans from a coffee tree or whatever, and yada yada yada, right? But somebody changes the definition to mean something else, and then change all the definitions of our dictionary to mean something else, then that definition now is not coffee. Coffee is not made just with beans of coffee.
I'll give you the example. Fishless fish burger. If it's fishless fish burger, I mean, fish is not a burger. But if it's fishless, why would you call it fish?
Because if you go to the origin, it's equare, which makes equal, and then in medieval Latin, it was to circle equalizing day and night, and then now to equator, which is an imaginary line drawn around the Earth equal distance from both poles. So it
on a sphere. Make sure you mention that.
Yes. I mean, that's what his definition is now, but it wasn't the definition before. You understand that, right?
No, it's always been that definition.
It's always been. Go back to the Latin. It wasn't.
The celestial sphere mentions the what is it called? The equatorial plane.
Yeah. So if you go back to Latin, the origin of it, which was equare, it was to make equal.
Yeah, it's to make equal because it's the midpoint. It's equidistant from both celestial poles.
No, it's not.
Right in between the celestial
It's
poles.
not.
That's the definition
Guys,
now.
It's not.
There was, Elbow stopped talking, and I took that chance to
You're
jump
right.
in.
Okay, yeah, my bad.
So, yeah, it's called the middle because it cuts the celestial sphere in half. It's the midpoint
it's wrong.
between the celestial poles. And the
Listen.
path of the sun is only on the celestial equator during the equinox, like what Jeremy
That's what
said.
they call it. The
Aside from
equinox.
yeah.
You should be able to see Polaris beyond the equator line, and you can. So it's not halfway. Nothing on celestial navigation, none of the lights in the sky in celestial navigation will reach zero on your reading because it doesn't exist zero.
But no one
lights,
that's not what it
lights in the
means
sky
when
can
we say it's
below the
halfway.
horizon. The lights in
But
the
that's
sky,
not
they don't go below the horizon. They will fade away. That's why you shouldn't use the reading below 15 degrees because it's not decreasing in the angle of elevation anymore. It's moving away from you. So it will stay longer in that same angle in the sky from your point of view. That's why it's not recommended to do the reading that low. But
yeah,
you
you
will
might
never
be
have,
wrong, you might be
you will
right.
never
I'm not
have,
sure. But that
you
is
will,
nothing to
if you have Polaris at 90 degrees, you will never have the equatorial line at zero. It's higher than zero.
George, that has nothing to do with the point being made. The reason it's called the equatorial equator is because it's at the center point of the celestial sphere. It cuts the celestial sphere in half. It is
You don't know
There is
that.
no
equidistant
sphere.
from
There is
either
no sphere, man.
celestial
It's a
pole.
plane, equatorial plane.
George.
Hold on,
It
though. Let him
cuts
finish.
it cuts the celestial sphere in half, and it's equidistant from either equatorial pole. Right?
Yeah, but in reality, you don't know
It's
if
a
that's
plane,
true or
though.
not.
And
In reality,
It's an
though, you don't know
equatorial
if that's
plane. Why don't you call it for what it is?
in reality,
Equatorial
though, you
plane,
don't.
equidistant from the center, which is Polaris, yeah, and you have a circle around you, which is the sun's path. So you have an angle to it, but that angle will, the sun's path will never be zero. It's zero on the
So,
chart, but not on the reading.
what's the place in the southern half that actually denotes the other half?
Well, you just turn the gears around, isn't it? The celestial plane that you have for the north is not the same for the south. You need to turn the gears around. So now the south is on the top. So now you can gear up everything again.
Oh.
You can put all of your dials for the sun and the moon.
Jeremy was trying to say something.
Like I said, you can say whatever you want about what the equate.
Different position, one for the south and one for
Oh,
the north.
George, you wildin', bro. Jeremy?
I don't know, man. I don't know if it's worth it.
Try. George is quiet.
Well, you guys just need to do the research, man, like other people are doing.
Oh, we've done it. I've done it. You know, I'm not saying I understand this topic to the level you do, but these are basics. You know, all I'm saying is these are the reasons we call these things the things we call them. You know, the numbers and stuff you were throwing out, I can't really argue against that because I don't fully understand what it is you are trying to say. But all I'm saying is the reason we call it the equatorial or the celestial equator is because it cuts the celestial sphere in half and it's equidistant from the two celestial poles. And the
Yeah, you
sun's
can say
path
that.
is only along the it's only along the celestial equator on the equinox, as Jeremy alluded to.
You can
Sorry, go ahead,
keep
Joe.
saying it. You can keep saying it cuts a sphere in half, but that hasn't shown to be the case yet. All we know is that the equator is definitely the path of the sun on an equinox. That's it.
That's correct.
What?
Well, what is
George
the
can keep
southern
saying
That's
it's
point?
a
what it is,
circle.
man.
George can keep saying it's a circle all he wants. You can keep saying it's a celestial sphere all. But in reality, all this equator is the path of the subsolar point of the path of the sun on an equinox.
So what is the point in the southern half that gives you the measurement of the bottom half? What is equal on top and equal on bottom? We got the North Star on the top. What's the equal point on the bottom?
I don't know. What is it?
South
Oh, what
Celestial
is
Pole.
it, man? It's your model.
South Celestial Pole.
It's your model. Pole. What's a pole?
Okay.
Someone born in Poland.
It's the pole. Come on, don't be dumb, George.
Yeah, places the stars rotate around. Yeah.
What makes it the pole?
Because it's the axis of rotation of the stars in the sky. That's the central point.
So now
that's
the
the
stars
point
in the
the
sky.
stars need to rotate around.
So the stars have a pole and the stars are rotating, correct?
The stars seem, from our perspective, to rotate.
So
about
now
a
they
fixed
don't
point.
rotate; they seem to rotate. You
I'm asking you a
corrected
question,
that.
George. You wilding out,
Why
bro.
did you correct your statement? The stars were spinning, and now they're not. Now they are seeming to spin.
Putting clarity. I'm putting clarity. I'm trying to give you as good an answer as possible. So,
Go ahead.
the celestial pole is just the axis of rotation from our position as to what the stars seem to be rotating about.
So the stars are rotating. All right.
Yeah. About a fixed point in the sky.
About the fixed point in the sky. Yeah. This celestial, the northern.
Is it me or did George get very quiet?
You got quiet.
No, the northern star.
George, it's very hard to hear you.
Yeah, it rotates around the northern star. I'm receiving a call, that's why.
Oh, okay.
All the stars apart from Polaris, all the lights in the sky rotate from east to west. All of them around Polaris. It's the only center point in the sky. There is no other.
Yeah, and we call that the North Celestial Pole.
Yeah, indeed. But we don't have two. We only have one.
But but there's also a South Celestial Pole.
Yeah.
No, there is no pole in the south.
Yeah, George, you could look. You could look south. Yeah, you could look south. You could do a time lapse from your location. You can't see the point because you're above the equator, but you can see that the stars are rotating in the southern hemisphere.
And
yeah, that tells you there's also a axis of rotation at the south.
In the sky. That's good.
In the sky. When Australians and South Africans,
so not the ground,
South Americans,
it's the sky.
Look,
I just want to make sure it's the sky that is spinning and
it's
not the
the
ground.
sky the same way in the northern hemisphere. It's the sky, George.
Yeah, and we can pinpoint these lights that are rotating in the sky. We can pinpoint where they are just above overhead, which is the ground position of these lights in the sky.
Yeah,
that's how we
can do that
celestial
in the southern
navigation.
Hemisphere.
Yeah.
Okay.
No, not hemisphere. It's a hemiplane. Because you have again another plane from the equator to the center, whatever you call it, to be a pole, which is not.
Hemiplane. Yeah, I hear you, George. I hear you. I'm not trying to, fight with you about celestial navigation. You know way more about it than most of us.
Oh, well, it's just celestial navigation, something that mariners use up until today, and they don't seem to get that lost at sea. They can find their position. So this knowledge, it's a fact, regardless if we understand it fully or not. Professionals do use this method, and it works out. It's elevation angles. It requires a horizontal plane, which we use the sea level. That's what we use as a horizontal plane. And that's how it's done. It could never be in the sphere, ever.
Okay. So now my question is now, what is the argument for celestial navigation not working on a globe?
Well, where should I start? For you to start even thinking about pinpointing these things overhead, you need to have a Cartesian system, which is you need to map the ground, basically. And we do it with lines of longitude and latitude. How do we achieve that? Well, it's elevation angles to Polaris and to the sunspot overhead, which we call the equator. So elevation angles to these 2 points will give us the lines of longitude and latitude on the grid system. Now
But
that we
George,
have that,
George,
now
can I
that we
ask you
have the
another
grid
question
system,
quick,
yeah, but now that you
please?
have the grid system, the chessboard on the ground, you can pinpoint when the lights in the sky will be right overhead on that chessboard. So when the light is on this square and when it's on that square and at what time and so on. So now that you know which square the light is, you can draw a distance from that light outwards and draw a circle, and you will be somewhere in the proximity of that light within that circle. If you do 3 other circles on that same chessboard, you can pinpoint your position on the chessboard. That's how it's done.
Okay. That didn't answer my question though, but I have another question. Is the sun's path not only, isn't it that it's only on the celestial equator during the equinoxes? Like during the solstice, it wouldn't be there, right?
Well, again, it's not always the same because it varies every day. You need to refer to the almanac. It's not going to be every day
I
at
agree,
12
but
noon on
I
the
just
same
want clarity.
position.
I just want clarity. Is the sun's path in the sky always along the celestial equator, or is it only at certain times in the year?
It is on the celestial equator because the celestial equator is ginormous. Don't
Yeah,
forget
but
the celestial equator
I'm
of the
asking you,
north. The celestial equator of the north will emerge with the celestial equator of the south.
I totally agree, but that's not answering my question. My question
It's just
is the
turn the
sun's
chessboard
path in
around.
the is the sun's path in the sky always moving along the celestial equator, or is it only during the equinox?
Not only during the equinox. There's an oxygen.
Is George breaking up?
Because it's not always the same. In the same or any other light in the sky that matter. I mean, it's repeatable, but it doesn't mean that it's repeatable to the same second tomorrow morning. It doesn't happen like that.
I agree. That's why I'm asking. Is the sun always traveling along the celestial equator, or is it only during the equinox?
The sun is always on the equator, always on the equator, and always
it's
going
always
from
traveling
east to
along
west. Yeah,
along
always
the
from east to
celestial
west.
equator.
Yeah.
Interesting. I thought it was only during the equinox that it moves or it comes across the celestial equator.
The equator is the zero line,
the
isn't it?
during the solstice, would the sun be traveling along the
equator still?
Celestial equator?
Obviously.
Okay.
It's oscillating on that equator line, up and down and up and down and up. That equator line is the zero line on the maps.
But if the sun is moving position, is that equator line moving with it? Or what do you mean moving up and down and up? I mean, maybe I don't understand that.
Well, according with the globe model, it's a massive distance, isn't it? It's when
one
George, solstice to the other is a long distance.
Are you able to look at text chat?
Yeah.
I just tagged you with an image.
Really?
The writing is not pretty clear, but you see the sun, the middle sun, right in the middle along the
Why?
equatorial.
Can I ask a question?
Yeah.
Why you have that ball around? That ball doesn't exist there.
I didn't make the
blue
picture.
line.
I did
understand.
not make the picture. Yeah, I didn't make the picture. Yeah.
I understand. That is a mind trick that they're using on us. Yeah. That is not part of the celestial sphere. The rings, yes. Those rings, every ring is a different celestial body. Yeah. And those rings, the declination from vertical, is the latitude angle from the person in the center of that plane, because that's a plane in the center with rings going around it. That's the celestial sphere. Now the rest
All
is
right.
just imaginarium. It doesn't exist.
Okay. Now those rings, right? Those rings are the sun's path at different key points in the year: the summer, winter solstice, and the two
That's correct.
equinoxes. Now, my question is, when the sun is traveling, let's say it's the summer solstice, the ring to the left, right? Is that ring
You
moving
need to
along?
adjust it. You need to adjust for the
Yeah.
time
Yeah.
and
Now my question
the
is
time
that
and
ring?
month.
Yeah. Let me get to the question. Is that ring moving along the celestial equator?
No, man. That ring, let's say you get your sextant, yeah, and you get your elevation angle to the sun, for example, yeah. So you know that the latitude of the sun is the reading, yeah, at 12 noon. So you go to the celestial sphere and you put the arch representing the sun at latitude equivalent to the reading that you did. So you know that the arch that the sun is going to draw in the sky from one horizon to the other, that arch is the latitude line that you are observing from the ground. So once that you have more reference points in terms of latitude lines and the highest peak of them, you can pinpoint your position on the ground. But that would be slightly more difficult to pinpoint. Yeah. The celestial sphere is simply a dial system. So you have different rings for different stars, and you are in the center of it. So you're going to put the sun for whatever month, whatever week, and whatever day, and will give you the declination depending on the time of the year.
Okay.
You know, it's
I
within the
understand.
mechanism itself.
Yeah, that I understand. What I'm trying to understand is, George, is what you mean when you say the sun is always traveling along the celestial equator. Maybe you could use that diagram I posted to explain that to me.
The equator is the sunspot. I didn't say that. The equator is the sunspot, which is pretty much what you say, but I didn't say that. The sunspot overhead is what it gives the equatorial line. It gives the tropics, isn't it? What we call the tropics as well. The tropical areas, the warmer places, which the sun is right overhead. So those areas in the maps, it's called the equator. Yeah, zero. It's the zero line. If you have a straight line or a circle line, it doesn't matter. It's the zero line. So if you are on this
And
side of the line, you are
that
on
is at the
zero plus.
equinox, right?
If you are on this side of the line, you are on zero plus. If you
Yeah.
are on the other side of the line, you are from zero minus. Yeah.
Okay.
But
I get what you
it's
mean.
sunspot overhead.
I get what you mean. So when the sun is at the solstices, that's when it's moving along the lines of Capricorn and Cancer. And then during the equinox, it's moving along the line of the equator. Right? Well, maybe I just don't understand the stuff, George. I'm
I
sorry.
don't see any problem with that because somehow part of this language is, like you guys pointed out, is global language because we have lack of a different language for it to describe it, isn't it? But obviously, the sunspot overhead it's cyclical, and you know always comes from east to west, and that is the reference that we use apart from Polaris, obviously. Polaris in the center, east, west. There you go. You have north, south, east, and west. You have already your coordinates. But south will be always outwards.
Okay. So now going back to the main question, what is the argument for this not working on a sphere?
It requires a horizontal plane.
Yeah, but a horizontal plane is just something you draw out. You just use your horizon to plot that. It doesn't tell you that the ground you are on Is a sphere, a triangle, a pyramid,
No, it
whatever?
does. It does. We're using surface level, sea level, to do these elevations from sea level.
Yeah,
This is
but you know,
measured at sea level, from sea level to sea level.
yeah, but level doesn't mean flat, George.
So what does it mean level then in English? Because any other language would mean no part higher than the other, unless you have a different description in English.
I think
Please
that's
go
what
ahead.
flat is. I think that's what flat is. Level depends on the context.
No, that's not what flat is. That's what level is. Level is very precise. Level is not just in one vector, it's in every single vector around a point.
How about a wall, George? Can a wall be level?
Well, walls are flat. They are built.
I mean,
on a
sorry,
different...
can a wall be flat? Was the question. My bad. Can a wall be
Can a
flat?
wall be... Yeah, a wall is flat, but it's...
Is it level?
Is it? No, not level. Flat.
Yeah.
Listen.
So you understand that flat is not an orientation, right?
It is an orientation.
Flat is an orientation?
Yes. You have flat bricks and you build them on the vertical by saying it's a wall. But the bricks themselves are flat and they give the flatness that requires to your wall. But
not talking about the bricks.
Just because
I'm looking at a wall
just
now,
because,
sheetrock wall.
Yeah, but you can have a wall in different in different vectors, in different angles. It's still a
Orientation
flat
is the
wall.
word you use
Yeah,
it for,
yeah,
right?
but it's still flat though.
Yeah.
It's still flat.
That's
Yeah,
the
but
point.
Odysee
You can
had a
have
very
flat,
specific question.
Because
you can have a flat.
Yeah,
George,
but when you
can I
say
get a sentence
wall,
out?
is on the vertical, isn't it?
That's what I'm telling you. You can have a flat vertical surface, right?
A flat vertical surface, yes.
Like a wall.
That is still level though.
Yes. Not level, not if it's on the vertical.
No, it's not.
Yeah, you can. Yeah.
No, if it's on the vertical, it's not level.
You can use a level on a
You can use level to establish the vertical.
I would use a plumb bob.
So you
I would
can.
use a plumb bob.
But
I don't know about you guys.
the vertical, we're talking about different things. The vertical that you're insinuating with a level, yeah, it's referred the vertical from horizontal. That's why the level. But if you have the vertical on its own, you don't have it.
No, I need a plumb bob. I don't need horizontal. I could use a plumb bob.
When you level a vertical, even if let's say you don't have a plumb bob, but you have a leveler, right? Which gives you a horizontal level and a vertical level one, which actually is the level also is horizontal when you try to vertically align that. Isn't it?
The point here is flat.
Let me simplify the question. Let me simplify the question. Are mirrors flat? Should be an easy answer. Right. Can mirrors be horizontal?
Huh? Can they be vertical?
Can mirrors be leveled? Can mirrors be leveled?
Yes.
Can they be plumbed?
Plumbed?
Yeah.
What do you mean plumbed?
Can they be placed on the vertical?
That's my whole point, George.
Right. Are they still flat?
Yes.
So flat is the orientation of the mirror after all, like the wall.
Yeah, but George, it could be in any orientation.
You can build a wall on the ground. Yeah,
George, stop
we
talking
call it a walkway.
George. Please try to not to interrupt me one time when I talk. Please. Thank you. Let me just get one sentence out. Flat, George, can be any orientation. Yes or no?
No, that's wrong. Flat, there's only one orientation for flat. Flat is horizontal.
Yes, SE, that's correct.
This is where you're getting it wrong. Flat is not an orientation. Because you can have a flat vertical wall.
You raise it.
Like your mirror,
raise it
George.
on the vertical, man. You raise it on the vertical, yeah? But it's still
George,
flat.
your mirror, can you slant it in any direction, like you said?
That's my point.
In any orientation, your flat mirror?
And it's still flat, regardless of which
Yeah, but is
vector
it
you're going to put it.
horizontal? In all the orientation, is it level and
No,
horizontal in all orientation?
Horizontal is different. Now, if you're talking about the different vectors, horizontal is a different vector. Yeah, the mirror
Are you saying
remains
horizontal
flat.
and level are not the same, George?
Huh?
Are you saying horizontal and level are not the same?
Of course, they are the same, and flat is the same.
No, it's not the same. That's what I'm trying to tell you. Flat is not the same.
Yes, it is, man. Come on.
No, it's not, man. I just proved
All
it to
right.
you. You can have a
Unless in
vertical,
English,
flat wall,
means
George.
something else, man. Unless in English means something else. And if you give me a definition for it, I might give it in. Yeah. But in my own language and Spanish language and Italian language, flat is an orientation. It has a specific vector. Yeah. Because everything we build it flat.
Can have any vector. Can have any
You're going
vector.
against what you said. Yeah, Leslie. You're going against what you said. You said with the mirror example. You said you can place it in any orientation. You're going against your own words, George. Flat is not an orientation. It's not. Sorry, man. You can have a flat surface like your mirror and any orientation you like. Just put your hand straight out and turn it. Put it level and just turn your hand, man. Any way you want. Or take your mirror and just turn it any way you want. There's no way around that, bro. I'm sorry, man, but it's just not an orientation.
Made him leave, SC.
I had a question back on the sextant thing about the GP. So you've taken your
I
angle.
was muted. Sorry, guys.
Oh, well, so you've taken your angle to the star. You've got your time written down, your date and time, and you go to the almanac. Does that almanac have a table that tells me the latitude and longitude of that GP, or do I have to do math to figure that out?
Now it tells you the longitude and latitude of the star that you are observing. Even if you're not observing, the star will tell you where it's going to be at that time of that day, regardless if you can see it or not.
So you just take your angle and your time, and the almanac spits you out of that long. You don't have to do any math?
No, the almanac doesn't spit anything else. The almanac just tells you that at this time of the day, this light in the sky will be over this position on the ground.
I think there's a problem with that, George.
So if the light is at that time of the day over that position on the ground, and you can see it, you can have an angle to it. Because overhead on the ground, that means a 90-degree angle, elevation angle.
All that. I was just talking about how you get your GP. There's a big problem for flat Earth and how you obtain your GP.
Well, your GP, you mean the fix?
No, the GP of the celestial body.
No, no difficulty. It's on the almanac.
You've got to do math to figure it out, though. It
No,
doesn't
no,
just
it
doesn't just give you. It doesn't just give you a latitude, longitude. You have to figure it out.
No,
you have to use a
You need
formula
to
to
figure out
it out.
your GP, not the GP of the stars. The GP of the stars is already on the almanac. The time of the day and location.
Okay. You'll have to prove that to me.
Prove? I don't have to do anything, man. It's celestial navigation.
Yeah, it is, and you have to use a formula called the Haversine to get the GP of the celestial body.
No, that's not correct.
I think so.
No, that's not correct. That would be converting something flat into a sphere. Why would you do that? If it's a sphere, you shouldn't be able to convert into a sphere. It just be observable, measurable, repeatable. You wouldn't have to use a formula to convert into a sphere, would you?
What's the point of the Haversine formula?
To convert to square a circle, basically. That's what they're trying to do.
You still have to use it to get the GP.
No, that is a circle of equal altitude, which is 60 nautical miles per degree, which is the distance between you and the GP of the celestial body. Yeah, 360 degrees of the circle. Sorry about that. 360 degrees on the circle, 60 nautical miles per degree. That will give you the distance to the GP. Oh, so wonderful to be a flat earther nowadays.
So if you didn't use the Haversine formula to get the GP, how do you get the GP?
Again, I already told you, the GP of the celestial bodies comes on the almanac. You don't need to use any formula.
Your GP. How do
Your
you
own
find
GP, GP, you find the distance to the GPs of these lights first, and then you draw the circles that's going to give you your fix, your position on the ground. X marks the spot.
I don't think anyone's satisfied with that answer, George.
I can't imagine just a printed table that would list all of this information just in a table where you could just go look at a number and cross-reference it to another number that would give you the GP. How many pages would that be? That would encompass every spot on the Earth.
It's a lot of pages. I mean, these almanacs are big, George. And
well, for the sun and the moon and a couple of more stars, 50 odd stars that they have on. No, not that many pages. Cyclical, remember?
Yeah, but don't they need to have that for every single point on Earth on your grid chessboard, right?
Yeah, every path, yeah. Yeah,
so you need
it's repeatable.
all
Yeah,
50.
it goes around. So they say it goes around. It comes back next morning, like the sun and the moon, isn't it? So if it goes around a circle 360 degrees for every degree that it moves away or from you, if you want to find the distance between you and it, it's calculated in 60 nautical miles. I don't see what the problem with that.
George, how far out can these books predict the GPs of these bodies? 1 year, 2 year, 3 years, 10 years?
Like I said, it's cyclical. I don't know, but every X amount of time it repeats again. It repeats again. I don't know how many years apart it is, but it tells you on the book.
Yeah, but from what I remember, they have to update these books after a period of time. Like after 5 years, for example, you can't use the book anymore. They need to find new.
No,
I don't
you're
know.
wrong, man.
Apparently,
You're wrong,
there's
man.
a limit.
They need to map it out for a year because the following year is going to repeat the same cycle again. Not quite. There's discrepancies
So
on the
I
calendar.
can use.
The calendar
Can
that
I
they use
use the
today, there are
Celestial
discrepancies
Almanac
on it.
Okay, can I use the Celestial Almanac from 1920 today to find the GP of Star?
Yeah, I believe so. Why not?
I don't know about that, George.
Wasn't
What
it
I
stand at 12 noon on Christmas Day on the same position all the time?
Lost at sea. Lost at sea.
No, you need to update it. There's certain
Yeah.
things that remain true, but I know for a fact it needs to be updated. That's a
how
fact.
how often do they update it, SC? Every 10
I think
years,
it's
5
yearly. I think it's yearly. I'm not sure though. Don't quote me on that. But I know for sure it needs to be updated.
years?
Because the sky changes.
Because the sky changes. All right. At least the sky is changing.
If we're gonna get anywhere as a group, we gotta say things the way they are, no matter what side they fall on.
That's correct. Mic check, mic check.
Yeah, it's good.
Nah, I had to change devices. It was running out of juice.
So I propose neither side can use the lights in the sky to determine the shape that they're on. That's what I say.
Sorry, see, can you say it again?
Yeah, I say neither side can determine the shape that they think they're standing on by looking at the lights in the sky.
Well, I disagree with that.
Yeah,
Celestial
disagree.
navigation give us flat measurements. And to work, it requires to be flat. Sea level? So to say we don't have the measurements, it's not true, is it? We do have the measurements. We just decided to ignore it for this long because it doesn't fit on the ball. Of course, it doesn't. That's why it's been overthrown by them, been ignored by many. But it's still used today, celestial navigation. It measures the Earth to be flat and stationary.
Yeah, but I mean, Earth is a sphere, George. Come on. Like, I know you know.
Well, mathematically, you can turn anything into whatever you want, even in a pyramid if you want to. Mathematically, that is. To describe something, yeah, you can describe any way you want.
Oh,
Sorry, I was getting a phone call.
that's cool, man.
Very busy boy nowadays.
What are you busy with?
Work?
What kind of work?
Well, it depends what people need, and I'll provide.
What kind of work do you do though? What do you provide to people?
What is it that you need, and how much you are willing to pay for? If it's appealing, I might be able to provide whatever that is.
What do I need?
I don't know, whatever your money can buy.
I need a lot, George.
Well, for the moment, I only need 2 kilos of $100 notes.
To do what with?
For tonight, no?
For the night?
You think 2 kilos would be enough for the night?
I don't know. 2 kilos of what again?
A night out.
$100.
$100 notes, yeah.
2 kilos of $100 notes.
There you go. You understand now what I said.
Yeah, that's a lot of money, George.
Would be enough for tonight, no?
Yeah, no way. Ain't you too young to be going out?
Oh, well, money doesn't have an age.
Yeah, true. So what got you into flat Earth, George? Like, were you already a conspiracy theorist? Or?
Well, working with levels and plums and knowing how to do the requirements for those jobs led me to the realization that level doesn't go with spheres. And level is the orientation of liquid's surface. I mean, liquids is what give us the levels. If you
So you
understand
weren't
that, there is no other magic word.
So
He's
you
gonna
weren't
correct
into
that.
you weren't into any conspiracies. Flat Earth is the first one for you.
Oh no. 9/11, man, and before that, moon landings, and before that, I don't know, aliens.
What, you believed in aliens, or you didn't believe in aliens?
Of course, what do you mean believe in aliens? They exist, aliens. You are an alien to me. I never seen you in my life, man.
Okay.
Unless you have a different definition of alien. What is an alien?
Something extraterrestrial, not from Earth.
Now that's your definition. You know Sting's song "I'm an Alien in New York"?
No.
Well, you should listen to some music.
I do listen to music, right? I just don't listen to Sting.
An alien is a person that is not from around here.
Or it could be
It's not from the hood.
It's not from the hood. Okay.
Now, extraterrestrial, yeah, extra what? Terrestrial, meaning extra terra, yeah, extra land, in other words. Oh, yeah, there's people on other lands. I wouldn't say extra anymore because if we were aware of it, it's not an extra land anymore.
How do you know this? Like, what do you mean people in other lands?
Like Columbus, when he found America, he found aliens. He found extraterrestrial people already on that land. So let's kill these extraterrestrials here. Well, how dare them, bothering me and my colonization.
Yeah.
But well, the Moors did the same, in Europe, and everybody done the same. Conquered. Another piece of land in our map.
When you say pole, George, the pole, what do you mean? Because when you say pole, what people think, right?
Yeah, Polish person.
It's again, you're affirming a sphere when you say that. The North Pole, right?
No. North Pole is the magnetic pole, nothing to do with spheres. The compass, north, south, east, and west are horizontal vectors. It doesn't work on spheres. South is not down and north is not up. It's horizontal.
No, I understand the way you're saying it and meaning it, but I'm just telling you the terminology you use, right? Nautical miles, poles, equators.
Yeah, but
all these things, you're just reaffirming a model. You're bringing, whether you realize it or not, you're bringing a model to the person's head. Yeah.
I understand, but for the lack of a better word, the word pole in magnetic terms, in terms of navigation, is the place as where to the compasses point to. Yeah, that's why we call the magnetic pole, because it's the only one we have. Now, to have a northern star, above that place, there is a discrepancy on it. It's not right above. I think it's 10 degrees, about 5 degrees, something like that. Discrepancy, you need to correct for it. Either using one or the other, because there is discrepancy. But anyway, regardless of that, that is the pole that we're talking about, the magnetic pole, which is a place of reference for the compass.
I understand that, George. I understand that, but I'm just telling you the terminology that you use. It's like you're bringing a globe. You're reaffirming a globe. Whether you realize it or not, maybe not intentionally.
I know, and normally the word pole I don't mention. I mention now. I'm talking about it because you brought it up. Normally, I question which poles you're talking about because if you want to call the magnetic a pole, okay, I can see why you're calling a magnetic a pole. Because there's a pull and a push. It's a pole. It's a center of attraction. Okay, I see how. But we only have one, though. If you want to call that to something, there's only one point with those characteristics, which is in the north. That's what we call the magnetic reading, magnetic north. Again, for a lack of a better word, the word that we call is magnetic pole or magnetic north. In terms of navigation, that is.
I get you, George. I'm just telling you like how it looks, how the whole argument looks. Whereas where you guys had the black swan, right? Now that's a solid argument. Whatever you want to say, we have a oil derrick in the water. It's not moving. We know the distance. That's a solid argument. You kill the R there. There's no question. Nobody can argue that. But this argument is all full of holes, bro. I mean, I'm sorry, man, but it's just the way it is.
I don't understand how can you say that, man. It requires elevation angles from a horizontal plane, which is a level surface that we dwell on top, that we navigate on. Yeah, elevation angles to Polaris. No matter how far away you are, if you can see Polaris, you can still use elevation angles to it. Once you just stop seeing Polaris, and you might be able to turn around and have a different reference point in the sky that you can refer to and continue your navigation over the same plane. Now, if you want to call this north and south, lights in the sky on the same over the same plane, yeah, that's how we navigate horizontally. North, south, east, and west have horizontal positions.
I'm with you, bro. I don't believe for a second we're on a globe, right? Don't get me wrong. I'm just telling
Yeah,
you
I know
the
that.
argument.
I know that.
Yeah.
But unfortunately, the language we're using is English, and these are the words that, you know, even though English is not my first language, and I might be struggling to find words to describe what I mean, but these are the words that are used. For a lack of better word, magnetic north, or magnetic pole. It's referred in terms of navigation. Once you're using a compass, you need to know what is what. For that purpose, that's why that's the name of it. Now, yeah, I might change. I might agree with you tomorrow if you give me a different perspective or a different name to call it. It makes more sense than this. Yeah, I'm willing to change it. But for the time being, for a lack of a better word, that's the only word I have. Maybe I need to check the English dictionary for a better word.
No, you're using the words that are used. I mean, there's nothing wrong with your English, or you're using the words that are used, but each time you say nautical mile, equator, pole, right?
Yeah, but I see. Let me try to explain to you where I come from. Yeah. People laugh. How can you say you are a flat earther? There are mountains and valleys and so on. I'm sure you heard that argument many times.
Yeah, absolutely. Yeah.
I didn't know better back then, but today I can tell you that I know a bit better. I knew a bit more than I knew yesterday. And I know that the words are being misused.
Yeah,
because
like technically,
the word that people are looking for is ground. Yeah. The ground is not flat. Yeah, of course not. The ground is made out of mountains, valleys, the ocean beds, and the ground is what keeping the waters within. Now, the ground cannot be flat. The ground is what is keeping everything in.
Now we're talking, George. Now we're
this
talking
realm that
reality.
we're talking about, the realm that we're talking about, we call it Earth. Not meaning the ground, meaning the realm that we live in. And the surface of the water, it gives us the horizontal plane that we dwell on. And we travel on the top of it. And that is the flat horizontal plane that we're talking about. We're not talking about the seabed and the top of the mountains. No. That is ground, not Earth. It belongs to Earth, but not reduced to that. And I think we all know what we mean, but we say a word that to somebody else will mean something else, depending what the person is listening at.
That's the
Depending
whole
on what
issue.
frequency.
That's the whole issue. Yeah, exactly.
Yeah, that's the issue.
Words have meanings and are
Yeah.
important. Yeah.
And you are telling me that you have something level and this and that and how that level is, and you describe it to me, and I can visualize it one way. But the bowler comes along and he visualizes completely a different picture.
Exactly, but you're using baller terminology. That's my thing. I'm not trying to put you down. I'm just telling you. Like the black swan, bro. There's no issues on that. You can kill the R. It's like dead in the water. Like, but this stars in the sky, it leaves a lot of interpretation, a lot of misunderstanding. And the terminology you use is baller terminology.
I mean, listen. For you to have what is an elevation angle? I'll answer to that question. An elevation angle is an angle above horizontal plane. Now, how many horizontal planes are there in the sphere?
Anyone? How many horizontal planes in a sphere?
Yeah. It's a nonsensical question, isn't it? Because a sphere doesn't have horizontal planes.
I'm with you, bro. I'm with you. I'm not arguing that. Yeah.
So you cannot have you cannot have elevation angles from a sphere. because it requires a horizontal plane, something that the sphere does not have. I mean, it's simple as that. Obviously, if you want to go into in depth in this, because that's the problem. Most of the times when we start talking about the subject, we're already halfway through. I mean, who's bothering with the first details? If you were too late to the conversation, but tough luck to you. But sometimes we are just skipping the details, like there is no importance to it, when the detail is, like they say, the devil is on the details. That's where the Globers, they come promptly to give us already the elevation angle reading for you to do the rest of the equation, where you're going to need a sphere to finish your equation. But the elevation angle, it does require a horizontal flat plane to do so.
Well, let me ask you this, George. Do you think that you know the shape of the realm that we're on?
Well, if it's true that the realm that we live in is 70% of water, and knowing physics, as I know physics, I'm not an expert on physics, but I understand the behavior of liquids, and water is one of them. So yes, I can say that, yeah, we do live on a horizontal level plane. I'm not a fish.
I didn't ask you that. I asked you the shape. Do you think you know the shape of what you're standing on?
No,
on what
not
the realm
shape.
is?
No, shape, of course not. To be flat is not a shape.
Okay, but understand that if you're using this coordinate system, this celestial navigation, you are saying that you know a shape.
No,
at the
it's
very
flat.
least, you're saying that you know a circumference.
No, man, it's
man.
It's the flatness of it, and the circles are for you to find distances to reference points, lights in the sky in this point. Yeah,
Bro, the numbers you're using are based on a sphere.
No, they are not. It gives you the illusion of, because the only thing you can think of is the sphere. The language is the same. It's like we're talking about level, and we are visualizing level to be two different things when it's not. It might still be some kind of, it's not lost in translation, that is not the word, but the realization of the intent of the word, what the word actually means in that context, if you know what I mean.
Yeah, that's my whole point. Yeah.
I'm struggling here, guys. Nobody helps me out. English, well, it's one of my strong, but it's not my main language.
It's not a language issue. You're very clear and understandable. There's no problem.
Well, I don't think so, but sometimes, for you to put the question back to me again, it's because, my message didn't went through because you're still questioning me about it. If you know what I mean.
Yeah, no, your message went through. It's just I'm trying to tell you some, how can I say it? Some terminology that you're using that it just doesn't equate with what you're trying to say. Like, I get what you're trying to say. You need the plane, level, this and that. But then you're using terminology and numbers that are based on a sphere.
No, that's not correct. You're talking about you're talking about 60 nautical miles per degree again.
Yeah.
That is based on a
that
sphere.
That is from a circle, man. Again, it's a circle. You have
on
a straight
circle
line.
based on the
Listen.
equator, which you used, the word, which is cut in half. Yeah, bro. That a baller could make that
It's
argument.
A circle. No, man.
You
can
have to
have a
see that,
circle.
man.
No, you are not seeing it. It's the other way around. I'm past that. Maybe I was at some point thinking the same way as you, but I'm way past that. You cannot see it like that. If you have a piece of paper, doesn't matter how big it is, you can draw any circle of any size on any size on it. Yeah. Now, the size of that whatever circle you're going to draw on this paper, on this plane, yeah, you can call whatever. The distance between the center of this circle to the extreme of this circle, yeah, it's this much. Would you know? Well, this is the extreme of the circle is the sun spot, and the center of the circle is the North Pole. Yeah, or the celestial north, or the northern star, or whatever terminology you're talking of. Because if you're talking about lights of the sky in the sky, you're talking about lights in the sky, not about the magnetics on the floor. You're talking about lights in the sky. So this is when you are describing this circle 360 degrees around the pivot point, in this case the Polaris, and the equator line, which is an arbitrary point. But on that circle 360 degrees, for every degree around that circle, yeah, or going from the extreme of the circle to the center of the circle, is the same 60 nautical miles per degree. Does it make sense?
Yeah, it does make sense. I'm not telling you that it doesn't. I'm just telling you that a baller will tell you that's our system. It comes from the Nautical Almanac. We take a globe, we chop it in half at the equator.
And if you don't know better, you're going to end up agreeing with him. And that's a problem. That's why we need to communicate more. That's why we need to express better what we mean, and sharpen up the argument. Because these guys will bring the same thing tomorrow again, and the day after, next week.
Might even bring it today. Hey, George. Hey,
guys. Right?
Yo. Bring it. Let's hear it. Bring it.
Oh, God, it's dinner time.
They need to hear. Oh, it's dinner time for you, huh?
No, go ahead. Go ahead. It hasn't started yet.
No, not me. Jesse.
You use it today, Jesse. Go on.
Well,
there we go.
Yeah, there we go.
So tell them your objection. Don't tell me. I know mostly what you're gonna say, bro. I just want these guys to hear all the objections that we gotta deal with. That they put this argument in our lap, and they think it's so easy.
Yeah, because you cannot be talking about celestial navigations and sextants and introduce the other light readings in it. Because it doesn't work like that. That's not how it's done. You cannot compare carrots and potatoes. It's wrong.
What are you talking about, Jesse? This is not an argument that we're talking about here.
Yeah, go ahead, Jesse.
Oh, I'm sorry. I didn't know what the topic was exactly.
Celestial navigation.
Oh.
So, George, I just want you to understand my argument, right? I'm not.
I understand.
Downing you guys. I'm not against you guys in any way, shape, or form.
Absolutely. I don't see it like that either.
Well, Nathan sees it like that. He thinks we're bashing him or against him, or I just merely was putting some pitfalls that I knew the ballers were going to come up with, like the distance to the sun.
I see where you're coming from. Yeah, absolutely, man. But this whole thing, I didn't become flat earthers on my own. The same not for you and for anyone else here, or global for that matter. It was influenced by somebody else. So all of this realization of reality, it's a shared information. It's people actually talking about it, and I don't want to say debating, but mainly expressing what they mean and what they and the readings and measurements and so on and experiences, you know. And
yeah, I'm with you, George. Did I swear at you once today?
No, man. But if you do, I mean, it's part
No,
of
but
it.
just answer me. Did I swear? Did you swear at me once, or did I swear at you once today?
Oh no, not at all. No,
Did we
I'm not
raise
talking
our
about
voices
swearing.
to each
No,
other?
not at all. No.
I missed
Do
it
you
out. Go
feel
do it again for me.
disrespected? Do you
I'm
feel
beyond that
disrespected?
anyway. Not at all. But I'm beyond that, Odysee. I'm beyond that.
Yeah, but this is your boy Nathan can't have a conversation like that.
No, first of
That's
all,
the
he's not my
problem.
boy. First of all, he's not my boy, and I'm not him. He's not me. We are different people. Yeah.
Fair enough. Fair enough.
I know where you're coming from. You know, if you tell me to f off or something like that, or you know, I wouldn't take it personally because
Why
we
would I
chat
do that?
before.
Why
We've
would I tell
chatted
you that,
before.
Bob?
Yeah, but we've chatted before. We know better than that.
Yeah.
I guess we know better than that. You know, people
Yeah.
get heated sometimes in the discussion, and that's normal.
If I have an idea or a theory or whatever, I expect people to challenge it or to ask me questions, and I'm not going to get pissed off or think they're crazy or whatever. Even disagree with me, I don't care.
Different people have different views of the same art piece.
Yeah.
Did you see my art piece I posted? It's even related to celestial navigation.
Go on, just go on.
Well, as you very well know, obviously, the distance between an observer and the GP of a star is basically equal to 60 nauticals per mile of zenith angle, right?
Mm-hmm. According to your model, yes.
Well, no, that's what the celestial navigators do, and it works, right?
Mm-hmm. Yeah.
Not from the zenith angle, no, from the what's it called? The co-altitude angle.
I think you mean zenith angle to the star, right?
Well, you have a zenith angle to the star. You have an angle from you to the star.
Okay.
And that angle needs to be deducted from 90 degrees. That is the co-altitude angle.
Okay, so
once that you minus your angle reading by the 90 degrees, reading, that difference you need to multiply by 60 nautical miles to find the distance.
Okay.
I'll be right back, guys. I need to go for a second. I'll be back in a couple of minutes.
Should we wait for him or what?
I gotta take a call, guys.
Perfect.
I think it's important to be specific on which zenith he's talking about, because I think that they refer to the zenith of the GP rather than the observer.
The zenith. How does that work?
Yeah, it doesn't.
I mean, if there's me, and there's my zenith, and there's a star, that's the zenith angle. That's my zenith angle to the star, right?
Well, the observer's zenith doesn't matter what's up there. It's just vertical. Of course, you take your angle of elevation to the star and you subtract that from 90. That gives you your co-altitude angle, which is the angle between your horizontal plane, or between your zenith and the angle to the star. Right?
Well, I'm going to see if I can find a diagram. So in astronomy, it can mean the complement of an altitude, or it can mean the altitude, the same altitude as another aircraft. Okay. And it's got an anagram of colitude. Wikipedia is not very helpful.
Sorry, guys.
That's all right.
Like I said, very busy.
Indeed. Montreal went to take a phone call.
Perhaps somebody was calling and telling him the Earth is a globe.
No, not at all. Just someone who wants to organize a Orthodox Christmas, which is Friday on the 6th. Party, that is.
Hey, George, do you still go to Nathan Oakley's server?
Yeah, cool.
So there was a video that, you remember Protothad?
If I remember Prototype, yes.
Yeah, he was always doing the all the stuff for the celestial navigation, and like he said, he's done it personally.
Still
he's
is.
got the books and all that stuff.
Still is.
Yes, I think he may have gotten banned from Nathan Oakley's now, or at least kicked temporarily.
As until yesterday, no, it wasn't. Unless it was after yesterday. As to yesterday, I've seen him in the chat.
Okay, well, this was last week, so maybe he wasn't, or maybe he's back in. I don't know. But he put out a video. I think actually he got kicked temporarily, so he couldn't discuss it with them on the show. So he put out his own little video, and basically he uses 10th man's own citations against him.
Well, 10th man's citations are from Celestial Navigation Almanacs. Yeah, that's where the information is coming from. It's not coming from me, it's not coming from 10th man. It's coming from Celestial Navigation Almanacs.
Right.
Nothing personal. We're just pointing out the contradictions when it comes to celestial navigation, that it requires an elevation angle, which it requires a horizontal plane to do so, which is the one that we dwell on top. And for some reason, later on, they will use a Haversine formula to convert it into a sphere. Yeah, we understand that.
For some reason?
But we are pointing it out that for you to have this technique done, celestial navigation that is, you will need elevation angles to do so, 90 degrees, to zenith lines, planes. That's the geometry, right angle triangles.
Right, and the purpose of the Haversine formula
that
is
geometry it's not part of a sphere.
So what was the purpose of the
surface? You cannot do this geometry on the surface of a sphere.
So what was the
Doesn't
point
work
of the
like that.
What was the point of the Haversine formula again?
Well, it's to convert something that is straight into something that is not straight, like a sphere.
And why do they use it?
To convert something that is straight, like circling, or what's the word? Squaring a circle.
But why is that necessary? Why is that done?
Because you're begging the question of a sphere. If you're assuming a sphere, you need to convert it to a sphere, even though you measure to be flat. That's why the conversion. If it was whatever it is, it's whatever needs to be measured as. Yeah? If it's not measured to be spherical, but to be flat, why would you need to convert from flat to spherical?
Why indeed, George? Why indeed?
Yeah, why? Look, if it's a sphere and it measures to be a sphere, you don't need to convert. It's a sphere. You already have the measurement.
You're saying the purpose of the Haversine formula is to further the flat Earth deception that, the Earth is flat, but because everybody knows, we have to pretend it's a sphere, so we have to change it to a sphere. That's what you're saying.
Wow, you're catching on.
Okay.
I'm catching up.
Don't you find it convenient, bro, that it's like it looks flat. It measures flat. We fly a plane like it's flat. We shoot radio waves like it's flat. We use
Locally
weaponry
flat.
like it's flat. It's actually just an illusion. It's a ball. Never for a second does it ever cross your mind that it may be something else?
Never, not once.
Question for you, Extremistes. What is it that it looks flat, it measures to be flat, but it's not flat?
I mean, it looks flat because it's really big and it's hard to see.
No. Looks flat. I don't know what it is. I wonder what it is. Looks flat, measures flat, but it's not flat.
I mean, I was answering and you interrupted, but.
Well, you're skipping the measure part.
I was going to get to it. You didn't give me a chance. I was going to say it looks flat because it's too big. As far as measuring flat, I would disagree that it measures flat.
Me too.
I'm going to give you plane survey data. I mean, you want me to show you? You want me to send you a link where you can read what plane survey is, where it literally says we measure the Earth like it's flat? You want me to send you a video where this dude called dozens of surveyors that said that we measure the Earth like it's flat? Like literally, they say that we measure the Earth like it's flat, and then he tells them over the course of 5.7 miles over a lake, you should have almost 22 feet of curvature. Does that sound right? And every one of the professional surveyors say, no, that's way too much.
Do the professional surveys say the Earth is flat, or do they say we measure it like it's flat? Because there's a difference between those two.
Disingenuous when I make a specific point for you just to say something like that when you know that everyone was told it's a ball and kind of just believes it? Isn't it disingenuous when I explain to you that professional surveyors are told that over the course of a 6-mile lake, you should have 22 miles of curvature? 22 feet of curvature, and they all instinctively say, no, there's no way that's right. I do surveys that long. There is not that much curvature. Why would your response be, did they say the Earth is flat? Why would that be your response?
My response is because as a professional surveyor, they should know what the shape of the Earth is. So my question is, if you ask a professional surveyor what the shape of the Earth is, what will their answer be?
Why are you doing it again?
What did I do?
You're doing it again. You're not responding to the point I made that was very specific.
Okay, make your point again.
With chanting. Do you understand that
do it again?
That it's very
disingenuous
to act that way?
Ask your question or make your statement again. I will answer directly with you.
Okay.
You're invoking that there is a shape attached to it.
They are professional surveyors. When they were told that over the course of 6 Mile Lake, there should be 22 feet of curvature, they all, every single one of them say, there's no way that's right. That's way too much. I do surveys that long. There is not 22 feet of curvature. That is incorrect. You need to redo the math.
Okay. That's fine. They say that. Now, my question to you is, I concede your point there with it. I will concede that.
I'm saying, I'm asking you to expand on it. Like, if professional surveyors go out and measure in the real world over those distances and don't see that curvature, and they say that they do it all the time and don't see it, why is that?
I don't know the answer. I don't know. I'm not a surveyor. So I will concede that to you that they say that. That's fine. My question to you is, if you ask these same surveyors, is the earth flat or a sphere, what will their answer be?
They think it's a sphere, which actually strengthens my point that they think it's a sphere, and they think it must be much less curvature rate than that, because in the real world, they professionally survey the earth and don't see that much curvature.
Why, as professional surveyors, if they survey it, don't see the curvature, why do they think it's there if they don't see it?
Because they just assume it's there and assume it must be so big that you wouldn't see it on that small of a scale, even though objectively, according to the mathematical claims of the ball earth, you would.
So
yeah, but not just that. But not just that. They are surveying different levels above sea level. They're ignoring the sea because they already know that the sea is level. So elevation above sea level is what they are surveying.
They literally say that when they measure right above water, they don't see that 22 feet over the 5 Mile Lake.
Hey, what's it?
Are you going to change the subject?
No, this is the exact same subject. I've measured over water numerous times, and I've found that sometimes there is the drop, sometimes there's a negative drop. So
you've done professional surveying over water?
Non-professional surveying over water.
No, you're talking about your little, I put a level up in the sky. I'm talking about people that professionally measure the earth.
Well, to say that because I haven't been paid for it means it's an invalid measurement is just a fallacy.
I paid you for it.
All the surveyors are wrong when they say that amount of curvature isn't there.
That's right. I did get paid for one of those. Yeah, I guess that makes me a professional.
So all those surveyors are wrong when they say that.
It depends on how you interpret what they say.
I interpret it using my brain, where they were point blank asked if they observed 22 feet of curvature over 6 miles, and they say no, never. You must have the math wrong. There is nowhere close to that much curvature over that distance.
Okay, so my next question is, are the surveyors in on the conspiracy, or are they victims of the conspiracy?
No, they just believe it, bro. They just believe
they're just victims of it.
Yeah, they're victims of the same low IQ mentality that it's so big we don't see it, and they just assume that their job would never see it.
So we ought to stay away from that level of intellect in the conversation.
Well, what's funny is you guys can't just be genuine. You can't just be genuine. It's like, how can I talk to you guys about the
Fucking how
intricacies
ironic.
of cosmology and where we come from and where we live when I can't have a genuine, honest conversation with you, period?
Well, you can me. And I just posted some real data. I got pictures of the readout of the instrument and everything, the location, and it's data from 2 different days. In one case, the water laps against the side of the ship below eye level, which would fit a globe, and on the other day, it laps against the side of the ship above eye level, which would match a concave Earth. So this is pretty good evidence that if you shoot over water in on warm, calm days with cool water, you very well could be not measuring any drop, or you could be measuring a negative drop. So the survey.
Are you a surveyor, Jesse?
Well, I've only been paid for one job, actually.
Okay, I have a question for you, if I may.
Wait, real fast so you understand, they don't actually do like 7 miles at a time, which goes to show you don't actually know how they professionally survey.
Well, now you're making an argument for the non-existence of something. You don't know that
Jesse,
nobody's done
hold on
it.
a second. If you had to build a barrage, a water reservoir, you need to build a dam, and a massive wall. Would you calculate the water to be above the level of the wall that is retaining the water, or below the wall? How would you calculate the volume of water, including a bulge in the center above the level of the wall or not?
I don't even understand what you're asking, and you're changing the subject.
I just don't know.
No, I
think
wonder
it's
how do you
weird, right?
measure
Like,
this?
I feel that an honest person, when they go watch a video where someone calls multiple professional surveyors and asks them, do you ever account for the curvature of the earth? And they say no, or they say, well, yeah, you would have to on bigger jobs. And then because they just assume it. And then they're asked, okay, well, I thought that too. But then I went out to the lake by my house, which is 6 miles, and there should be 22 feet of curvature. But I never see that. And then they say, no, there's no way there would be that much. There's definitely not that much curvature over 5.7 miles. I do this all the time. That's definitely way too much. He said, well, that's the Earth curve calculator. That's how much it says there should be. You must have the formula wrong. You can go to the surveying websites and you'll be able to get the formula. That must be wrong. No, that is the official numbers of how much there should be based on the globe. I'd have to look at it. I'm not in my office. I don't have the formula. There's no way that that's right, though, because I know for a fact there are not 22 feet of curvature. There is not 22 feet of curvature over 7 miles, 6 miles.
So he asked an inexperienced planer surveyor a geodetic surveying question, and the guy just wasn't familiar with geodetic surveying because that wasn't his field. But I'm showing you evidence that light can bend over water, and it can go either way. There can be drop, or there can be negative drop.
You have no actual measurements of curvature then?
Oh, I have that too. This just wasn't it.
You can't use surveying to get measurements of curvature.
Why not? Well, okay, something.
According to you,
curves.
You can't. So.
Well, not if you make no control for the atmospheric conditions and your line of sight is near the water, then all bets are off. Okay.
What do you mean control for it?
Well, if the air is well mixed up, like if there's strong turbulent winds, then there's no strong density gradients, and then you can do it.
When there's no density gradients.
No strong density gradients, yeah. When the air is warm over cool water and it's calm, the cool water cools the lower portions of the air and creates a strong density gradient, which curves light downwards drastically.
So when it's cold, then we're good.
Well, it depends on whether the water is colder or the ice is colder, as the case may be.
Yeah, this is the guy who says that my plumb bob might shrink or they depending on the temperature of the air.
Dude, they're sitting here admitting that they can't actually measure curvature.
Well, now, wait a second.
They're going to cherry pick data. And
they
pretend that there's like this magical understanding that it only doesn't work when there's specific conditions, when in reality, it never works. Professional surveyors say they never see it, period. And they control for atmospheric conditions. That's their job.
Not all professional surveyors say that. In fact, probably most don't.
Really? Can you please find an actual plane surveyor that says over 6 miles you're going to see the observable 22 feet of curvature? Can you please go talk to them? Can you call them, talk to them, record it, and drop it for us? Since this dude called dozens of them and not once at it.
Why can't I call a geodetic surveyor?
Oh, so you agree that all the plane surveyors, they never see the curvature?
They may not look.
No, they do. What do you mean they may not look?
Well, anyway, you've diverted and you misquoted me. I did not say that you cannot use
You
surveying
diverted to an entire different branch of surveying.
No,
actually.
I said.
Well, let me defend his diversion, and then.
Now the thing is, planar surveying does not need to consider the curvature of the Earth. Everybody knows that. It's
okay. And
hey,
so,
Montreal's
does geodetic surveying use plane survey data?
That doesn't even make sense as a question.
Oh well, sorry, you're
It's
not.
it's the other way. It's the other way. Planar surveying builds upon the datum established by the geodetic surveying.
Incorrect. Geodetic surveying
the other way
uses
around.
plane survey data. That's how they know the distances in the first place. Thank you for playing.
Funny you mention a 6 mile distance, because see the picture I just dropped?
Yes.
I'm on a pier about, I'd say, roughly 8 feet. My tripod. That red thing is about 5-6 miles. We got verification, so ballers. Ask Bob the Science Guy. We did this live on a show once. Now, I don't know if you guys can see a fish past that. See the fish popping out of the water? I don't know how the hell I got that, but yeah.
To the right of the stick.
Uh-huh. Yep. There's an observation for you right there. That is not possible on your sphere, I would say.
That fish isn't actually there, Essie. It's actually an illusion.
Yeah.
What was
and
the
Jesse
distance and
admits
how?
that you can't even use geodetic surveying because when you look out the distance, everything changes. So basically, what we're going to do is we're going to cherry pick the data.
Don't
throw
straw
all
man
the
me like
data
that.
out until we find
Don't
something we
misquote
think
me,
is pretty
please.
close. That is what you're saying.
No,
I'm accurately denoting what you said.
No, I said when there is a strong density gradient near water's surface, if your line of sight is near the surface of the water, then all bets are off.
Right,
But if
you can just make vague statements about strong or weak density gradient. Strong density gradient. Okay, so what specifically classifies as not a strong density gradient?
homogeneous temperature.
So it has to be exactly the same.
No, just close.
So like I said specifically.
Well, if it's more than 0.12 degrees per meter of gradient, then it reaches the point where the horizon moves infinitely far away until the temperature is different. So the way that you can do surveying to detect or to measure curve is to get up a couple hundred feet above sea level.
Oh, we can't do any geodetic surveying to find the curvature at the surface.
I beg your pardon?
So we can't do any geodetic surveying at the surface.
Not unless you control for your temperature gradient.
So if we do have less than that number you said, then we're going to see the curvature of the Earth for sure.
Yeah, or if you get up above a couple hundred feet.
Well, Jesse, the main surveyor, disagrees with you, and he actually said that even whenever you have the proper atmospheric conditions, sometimes you don't see what you expect to see, and if it doesn't fall within the predetermined window, you just throw it out.
So there's always a margin of error with any measurement, but I measured the angle to a mountain that's 75 miles away from 180 feet elevation. The top of the mountain is a couple miles high, and I measured at all times throughout the year and throughout the day. I used 11 different instruments, and my entire I didn't throw out any outliers. My entire margin of error was plus or minus 100 feet at 75 miles. So sure, there's a margin of error, but it's not nearly big enough to excuse the missing 3,200 feet.
Oh, so you're sitting here telling an entire
How did you
room
establish
of
the height
grown
of the mountain again?
that it always falls within that window. That's what you're actually going to sit here and tell us. when I talk to professional geodetic surveyors and they patently disagree with you.
They disagree that a margin of error of plus or minus 100 feet at 75 miles is...
Yes.
Do you have a citation for that?
Yeah, go watch my debate with the surveyor.
So you don't have a citation you can present.
Dude, they just throw them out. If they just throw data out, how am I going to cite it?
Well, they were trying to get more accuracy than plus or minus 100 feet. I kept all the data because I wanted to know what the total margin of error was, what the total deviation was.
Did you actually look at the density gradient, or you just throw that out so you can come on Discord and just basically make stuff up about it?
I took sightings in all different kinds of weather so that I could find out what...
Did you actually record the density gradient, or
No.
did you just ignore it so you can come on Discord and then make claims about it?
Well, I had no way to measure the density gradient along that 75-mile path.
Oh, so it's an unfalsifiable claim that then gives you a buffer to always be right.
No, it's real-life data. It's
you just
showing...
said you didn't take the data, so your data is inadmissible according to your own standard.
No, but my deviation is real-life data. My
But
plus or
according to
minus...
your own standard, we can't take it seriously unless we know the density gradient.
Well, no, because I took... See, so the density gradient argument is, your guys are cherry-picking. They're saying, aha, I took a shot. There was no drop over this lake. I'm saying that if he took a shot multiple times throughout the year, multiple times throughout the day, he would see this great variation. He would see that sometimes he did measure globe curve. And so that's why I took my shots from the same spot to the same spot throughout a year and throughout all times of the day.
So once again, you skated right past the fact that you didn't actually record the density gradient that you have just previously invoked as a requirement, a literal requirement, but you didn't do it.
No.
No, you did. You said that you have to have a specific density gradient or you can't get the observation. Then you're claiming that you got the observation, but you didn't account for the density gradient. And then you accused me of cherry picking as you proceeded to detail the very definition of cherry picking, which is sometimes it looks like the curve of the earth.
So, no, what I said was that when your line of sight is near the surface of the water, you must account for the density gradient, the temperature gradient. If you get a couple 100 feet up, then you can reliably, consistently measure Earth curve without having to pay any attention to the density, to the temperature.
How many angular degrees is that?
Is what?
How many angular degrees is required to get past that angle of incident that you're claiming?
I don't even understand the question.
Okay, I guess you don't get the argument either.
What's weird to me is you know for a fact that you're cherry picking. Like, you know for a fact.
What do you mean?
You just said sometimes you see the curve. Sometimes it looks like the curve. And so if I go, first of all, one of the major problems is, what geometry of optics are you using?
So first of all, I'm not cherry picking because I'm not cherry picking low elevation shots. It's the low elevation shots that your guys are cherry picking. All of your seeing too far in black swan evidence is all based on tests where the line of sight passes very close to the water. If you
just make sure you do anything but actually address what I said.
Well, you keep straw manning me or whatever here.
What geometry do you use for the optics?
Geometry? You mean you want the focal length and the aperture and all that stuff?
The geometry, the geometry, like you're drawing a line from you to alleged curvature geometry, or are you just going to ignore the geometry? We're just going to make assumptions about the geometry. So can you enlighten me? Because flat earthers do it too. They draw a straight line from the person. They say the curvature should be here. So what kind of geometry are you using? I know the answer. You're using orthographic Euclidean geometry. You're drawing a straight line from the observer, even if you don't physically do it. It's baked in with an assumption of the Earth curve calculator. And then you're saying, okay, the Earth should physically curve at this rate and block me at this location. And we don't actually see like that. Optics don't work like that. Optics don't see in orthographic Euclidean geometry.
So then how do they work?
Oh, yeah. So we actually see visual space, optics see visual space in non-Euclidean geometry, specifically hyperbolic, which would have flat plane shapes distort.
Okay, I posted you what you recognize there.
I'm disengaging. Because I make a very specific coherent point. You do not have an interest in actually figuring out the truth. You want to find observations that agree with your presupposition, and then you want to discount them all because of a predetermined script of why the rest can't be relied upon. And you are doing a textbook cherry-picking fallacy while
Do you know the
also
last-
consistently ignoring what I'm saying. And it's just already giving me a headache, and I just got on this.
And do you know the last time you disengaged with me was when I posted this exact thing and asked you
Oh,
about
there
it?
you go. Gaslight me and chant to the room after you've literally, blatantly skated right past my specific point.
Well, this diagram should help you explain your specific point.
This diagram just furthers my point.
Perfect. Use it to your advantage then.
Why are you drawing orthographic straight lines from someone's eye?
Well, to illustrate that the light, or you want to call it, what do you want to call that thing that I call light? The disturbance starts at the top of the building. It traverses along a thing which we would call a path, because we could place a dinner plate at any point along that path to block that disturbance. The disturbance clearly passes through the red water in the tube, which is a couple inches below the observer's camera. Then somehow that disturbance gets its way back up to the camera lens, because it enters the camera lens, right?
So you're literally going to skate right past what I say. So how is it not disingenuous and disrespectful? Maybe we can start there. How is it that it's not disingenuous that I point out specifically that you're drawing orthographic straight lines from sight? Well, provably, optics don't work that way. Visual space does not work that way. Provably. You're going to just skate past it, then use that same bastardization of optics, and then proceed to tell me the Earth's a ball.
Well, how does hyperbolic vision explain
Oh, you're getting there.
the path of this disturbance starting out 180 feet above me, passing 2 inches below me, and then back up to my eye level?
Whoa, you're saying that the light comes from the building, goes down, and then comes back up.
Well, the building, the top of the building is objectively 180 feet above my eyes, right? And the red water in the tube is objectively a couple inches below my eyes. So, and the light comes from the top of the building, passes through the water a couple inches below eye level, and then comes into my eyes. So, how does hyperbolic vision explain that?
Oh my god, dude. Okay. First question. What angle is the camera? Are you claiming the camera's completely level?
Oh, not completely level, but I got
It's
the
tilted
video.
down. It's tilted
I aimed
down.
it. In the video, I aim it up and down and right and left and all around. Let me get you the video. That doesn't solve the problem.
Oh, so it stays the same no matter what angle you tilt the camera? You want to bet? You want to bet money on it?
Well, I mean, it stays essentially the same. Let me get you the
now
video.
It's essentially the same. What a shocker. Okay, so that was the first lie. Second one. How is it that you're using orthographic Euclidean straight lines of vision when that's not how vision works?
Well, just to illustrate the setup there, the reality is that somehow that light started out above me, objectively passed through a location below me, and then somehow came back up to my eyes.
It came back up to your eyes in a matter of a foot?
No, 90 feet.
You were 90 feet away from the
Yeah, like 95 or about roughly 90 feet behind the water tube level. I had to get it all in focus-ish.
And you didn't have to tilt down to see it.
No, let me get you the video. I tilt
So
up.
have you compared the
and tilt down.
angular size change of the building and the levels relative to distance? You've just done nothing. So you said you've been bringing this up for years, but so did you change the angular size? Did you account for angular size change of the building and the levels relative to your position and your height?
I just took the picture. I set up the water tube level and took the picture.
Oh, so
How
you
do I?
have
Why
just
do
a
I
very
need to account for
in-depth
anything?
observation.
Well, but you still haven't answered how the light gets from above me to below me and then back up to me in a straight line when those 3 points aren't in a straight line.
Hey, does the building change angular size?
Oh, sure.
Does the levels change angular size?
Absolutely.
Okay, what's the ratio based on the distance that you had them, since you left out where the levels were until I specifically asked, and I'm sure you've never even brought that up for 5 years.
Oh, actually, it's the actual GPS coordinates of those three of the observer and the levels have been published on my video for a couple of years.
That's
Let me
weird.
get
Every time you bring it up, you just leave that part out.
Oh, no one. I mean, no, I haven't left that out. Always, people have asked, and I've told them.
Okay, what's the angular size change of those levels relative to distance?
Say that again.
What's the angular size change?
Compared to what?
You.
So, explain. I'm was about 6 feet tall.
Things change angular size in the distance.
Okay, so I mean it's the height divided by the distance, the arctan of the height divided by distance to give you the angular size. I'm not sure what you're asking though.
There you go. So what kind of geometry is that?
Isn't that trigonometry?
Yeah, so we're using orthographic, straight line of vision, Euclidean geometry.
So there, I pasted the video for you that the screenshot was took from. And
Jesse, man, you're not even kind of curious as to what the truth of where we live is? Are you actually curious? Do you want to know what the truth is, or do you have a predetermined outcome?
Oh no, I'm looking for the truth. That's why I'm actually out there doing measurements.
How come
Sounds
every
like
time
you're
I make
defending a
specific
belief
point
system to me.
I mean,
Well, so yeah, I don't know what you call it a belief system, but no one will.
It is a belief.
No one will explain to me how the top of that building appears below that water level.
What do you mean? Witcher just walked you through what you left out, the variables that you weren't accounting for to get your biased perspective that you're basing your narrative on.
Yeah.
No, he didn't. He just said stuff shrinks in the distance, and that's the same thing Dave Weiss says to me.
That's all you heard?
Well, no one tells me. Okay, you help me, Dysel. You help me, Dysel. We agree that the light starts out at 180 feet above the observer, right?
I'm not even looking at your picture or your video. I'm listening to you guys go back and forth, and I'm hearing a lack of honesty and validity behind you.
Great. So you're not even looking at the evidence, and you're calling it dishonest and invalid. Perfect.
I'm not looking
because all you have to do is listen to me critique it and watch you consistently skate past the critique.
Well, I guess it's back up to you. What's it? So do we agree at least that the light starts out at the top of the building?
Dude, you're not gonna just skate past the point, which is that you have to account for angular size change.
Okay.
And the way that you do that is straight line of vision, orthographic view of Euclidean geometry from the optics. But that's not how optics work. So automatically, you're wrong. Automatically.
Okay, easy to say. So let's say I took...
Oh, it's objective, though.
Well, everything you say is objective, my friend.
Pretty much.
Objectively.
I don't think any optometrist would disagree with what Witset's saying.
It's provable. It's provable that we don't see in straight line Euclidean geometry and visual space. It's provable. So your assumption's provably wrong.
So if I took a weightless, super strong string, which of course doesn't exist, but let's just say I did, and I stretched it between my camera and the top of that building, would it pass between? Would it pass below the red water level like the top of the building appears, or would it?
We had a weightless, super strong string that had no slack. Is that your question?
Yeah, exactly.
And you were able to maintain it completely level.
No, not level, just straight from the observer to the building. Remember, the building's 180 feet taller than the observer.
Well, you agree on a flat earth straight is level.
What?
Oh my
Straight
god,
is
dude.
level?
Honestly, Jesse, I think I'm getting dumber. I think I'm getting dumber. You're laughing right now because like you look ridiculous. So on a flat Earth, if I stretch out a perfectly straight line, is that line level? Yes or no?
Only if the two ends are the same height.
It's straight, Jesse. If a line is straight from point A to point B, how are they going to be different heights on a flat Earth?
Well, what if you had a straight ruler and you kind of lifted one end up so it wasn't level?
Oh, so it's not a straight line from point to point.
So if you take a perfectly straight ruler and you lay it on a table, but you put a block under one end so it's at a slant, does that mean it's no longer straight?
That's right. That's right. It's not a straight line from point to point.
Well, what if it's from a
angled
point
up.
on? What if it's a point on the table to a point on the top of the block that it's
Why
sitting
would you
on?
do that?
Well, that doesn't make it unstraight just because it's not level.
Well, if I look at it from the side, is it straight?
According to the standard definition of straight, it would be straight. I don't know what definition you're using for straight. That
Oh my god. Okay. If I stretch a line out across a flat Earth, okay, and it's perfectly strong and has no slack, then it's not going. You're going to have to account for angular size if you're using optics, which is what you're doing. So you're conflating physical, tangible reality with optics, which is my entire point. In reality, if we have physical, tangible straight lines that are parallel to each other, optically, they will appear to converge. This shows that objectively, there is a difference in tangible reality and optical visual space. Right?
I'm still stuck on this straight versus level thing.
I'm just dude, this is such a waste of my time at
Hey
this point,
Jesse,
dude.
what would your observation look like if you had 4 inches less water in your water level?
I don't mind talking with you, but look, do you mind if Witsit and I wrap up?
He doesn't have an answer for that. Hey, Jesse, if you want to wrap up, you'd actually address my point.
Hey, Regis, find the link I posted to the video at 12:09 or 09 past the hour, and I actually raised the camera up about 4 inches, so you can answer your own question there. So Witsit,
I just left.
if I got a 4-foot builder's level, it's perfectly straight, but I have it on the table and I block one end up with a 1-inch block. You say that's not straight anymore because it's not level. If it's not straight, does that make it curved? Or are you saying slanted is exclusive to straight?
No, it's straight at an angle. I said if you do one point to point across the flat Earth, it's going to be level.
What if those 2 points are at different elevations?
Well, that would be dumb. That wouldn't help us determine something right now.
But what's dumb about it?
What is not dumb about it? Can you actually address my point? Can you address my point now for the 50th time?
Well, can I just dismiss it by saying it's dumb like you did mine?
Actually, your point isn't a blatant red herring fallacy when I've made my point 7 times now. And you've not addressed it once because you can't address it. You've never heard anyone say it to you. You think you had somehow a slam dunk, and now your entire world's crumbling because you know that you don't have a rebuttal.
Okay, what's your point?
You don't even know my point.
You talked about a bunch of stuff. I'm not sure what you're referring to. So refresh my memory.
We do not see visual space in orthographic Euclidean straight lines. You are baking that assumption into your observation, which means that's automatically not accurate because that's not how we see.
Okay, but that does not answer my question how something which is below the straight line path between me and the building can block my side of the top of that building, right?
Because the object is closer to you than the building is.
Okay, so if there was a guy on the top of the building with a little laser and he pointed it right at the camera, would that laser beam cut through the top of that red water there? Or would it
According to you
appear?
guys, lasers can't be trusted to be straight. So
No, I'm asking in your paradigm.
no, I'm sorry, we can't use lasers according to you guys because they're never straight. They magically curve around the globe, whatever that rate is.
It's funny how the flat earthers can't get off the globe.
Yeah, because that's what we're destroying. Yeah, reputation of the globe. The Earth's not curving anywhere. What is it?
Belief system.
If the Earth's not curving anywhere, what is it, Jesse?
It seems to be curving everywhere where I measured it.
If the Earth's not curving anywhere, what is it?
It is curving everywhere.
But if it's not curving anywhere, what is it?
Imaginary.
Can't even say it.
Oh,
You're
he
scared
can't
of a
even say it,
four-letter word, dude.
Are you anti-flat Earth, Jesse?
Yes. He's scared of a four-letter word. This was like my 2017 intellectual honesty test. I would just ask people this. They would freak out. They wouldn't answer. I'd say, okay, I have a table. If the surface of my table isn't curving anywhere, what is it?
Kind of reminds me of your boy Jace, dude. I caught him on some questioning yesterday, and he just would refuse to answer and left the chat.
Well, if your table's curving, it's not carrying bees. Or maybe, or if it's not curving, it's not carrying bees.
Floating, dude.
No, but look, you won't tell me what path the light takes. It's a very simple question. You know it starts out above me. You know it passes through below me, and you know it somehow gets back up to me. You won't tell me whether the laser beam would intersect the red water going straight to the camera, and you won't tell me whether a tight, weightless string would be above or below the red water. Why won't you answer these things?
First of all, I asked a question before all that bullshit, and you refused to answer it because it destroys your entire premise, and you don't know an answer, so you're doing anything but answering my point. Okay, so I could play your game and chase you around as if you have some type of intellectual superiority, or as if I should be blessed to have the ability to discuss with you. But I don't feel that way. Actually, I feel the opposite of that. I don't feel that I need to chase you around and play your game. I don't feel the need to convince you. I don't feel the need to convert you. I don't feel the need to play your game because you're being disingenuous, and I destroyed your entire observation by pointing out you have a faulty, infallible assumption at the beginning, which is that we use optics, and optics is in fact viewed through visual space of Euclidean geometry. This is objectively not true, which means any assumption you built upon this is intrinsically fallible. But you don't want to address that. You want to ask me every other question of your script that you've been asking from this observation over and over, these little gotchas you think you have. And they're not gotchas, and I could answer all of them, but I'm not going to. Because you're not addressing my point, and it's disingenuous and dishonest. It's not very respectful, and that would thus be a waste of my time.
Well, how about I answer one of your questions, and you answer one of my questions? You said I failed to answer the question. I don't remember that, but go ahead and ask it again.
Do we view visual space in orthographic, straight line, Euclidean geometry? Yes or no?
I don't know.
Okay. Did you assume that we do?
I don't even know what that means. That's why I don't know. It's because I don't know what that means. I mean, I know how.
Do lines converge?
Dysel,
Like,
you're not looking at the evidence. You're just sandbagging, Dysel.
I'm giving you facts. If you were to look down a set of railroad tracks, do the railroad tracks appear to converge at the end of the road, or do they stay straight and separated as they do at your feet? Like if you're standing on a railroad track and you're looking down it, do those tracks on that railroad track, do they converge to a single point, or do they stay separated all the way down from your long distance observation?
They appear
okay.
They appear to converge, but when you zoom in, then they aren't converged anymore. They're still spaced apart. The problem is, in my observation, which you aren't looking at, when you zoom in, the railroad tracks, instead of unconverging, are crossed over backwards. And
I'm looking at your observation, and if you were to just take 4 inches out of your water level, then everything's fine. You said you raise the camera, but that throws the water level out of sync. If you were to just take the water out of the tube by 4 inches, then everything's fine. So it's all dependent upon where you have that water level.
Think about it. It's the same relationship, lowering the water level 4 inches or raising the camera 4 inches.
No, it's not, because you raise the camera 4 inches and it throws the water level off. They're not at the same height with the camera view.
And do you think they're going to be the same height if I lower the water in the water?
I do.
Oh,
if you
my
keep
friend.
the camera the same, if you keep the camera the same, in the same spot as where they're level, and then you take 4 inches of water out of that tube, yes, 100%, both of them are going to drop, and it's going to...
Are they both going to drop the same amount in the camera, though? Because they're not at the same distance. One is 10 feet farther than the other.
Go look at your video right now on YouTube, okay? And go to the very end, 4 minute, 24 seconds. And tell me that if you took 4 inches out of that tube, it wouldn't just be 4 inches lower if you kept the camera the same, right in the middle of the building.
So are they gonna drop the same because they're further away? He's blatantly hijacking that things drop down optically and saying that it's because of curvature.
No,
Yeah, this is a weird observation.
This is home run that no flat earther can ever address it.
So, do you have a... Regis, did you take trig at all?
Yes, I know trig.
Okay, simple. The observer is 90 feet from the first water tube and 100 feet from the second end of the same tube, okay? You take the arctan of 4 inches over 90 feet and 4 inches over 100 feet, and those will be two different angles. If
Bro,
you
why
were
are you making it so complicated? Just go to the 3 seconds till the end of your video, look at it, and you tell me with a straight face that if you were to take 4 inches out of that water level, that it wouldn't be the solution that no one can figure out from our side.
Are you willing to bet money on this? $100?
What are you claiming would happen?
I'm claiming that if I took out water from the tubes to lower it by 4 inches, that the two water levels would no longer appear the same from the vantage point of the camera because it's looking down on them.
If you zoom out, what happens?
On them? It doesn't look like
if I took 4 inches of water out of that tube, then the water level would be below the camera.
Oh, I see what you're saying. Yeah, maybe like the tiniest little bit, but there's not...
You want to bet money?
I don't know. I want to think about it more. That's for damn sure.
Wait, Jesse, if I zoom out, what happens to the water levels relative to the building?
Dude, that's in the video. Let me find you a time. I
Why don't you
literally
answer the question.
Nothing.
Nothing. It stays exactly the same relative to the building, no matter how far you zoom out or zoom in.
I mean, obviously the size changes, but the relationship doesn't. Let me find you a link to the video, it's in the video. Let me find a.
Hey, when the size changes, does the top go up and down?
Everything shrinks in or away from the center of the camera. But
okay, so things drop down optically due to perspective in the distance.
But the ratio between the red water tube level and the building stays the same.
How do you know
Jesse, the farther you get away from the water level is going to make a big difference when you take the 4 inches out. If you're right up on it, yeah, there's going to be a big difference. The farther you move back, which it looks like you move pretty far back, it's going to make way less of a difference, which is how you get in this effect.
Well, my question remains. You want to bet money on it that raising the camera 4 inches is different than lowering the water 4 inches, the red water?
Are you claiming that it won't look different the further back you move? Because I'll bet that. But I want to look at it more before I put any actual money on it.
No, the distance is part of the geometry and the trigonometry. But
we're back to where I destroy you again.
But you're claiming that raising the camera 4 inches is effectively different than lowering the water 4 inches. I'm telling you that either action causes the two red water levels to appear different in height in the camera because it's the exact same relationship.
Yo, we're back to trigonometry and geometry again? Isn't it funny how you skate past that and the flat earthers have to constantly bring it up for you to even acknowledge as part of your observation? So would you agree that if you have a faulty base assumption about geometry and trigonometry as it pertains to perspective and angular size, then this is going to mess up your entire conclusion?
Nah, it doesn't mess up anything.
Oh. How do you know that? What can you explain to me why it wouldn't mess it up? Can you explain to me what the difference would be using the different geometry and why it wouldn't mess anything up?
Hey, so I answered your question about vision. So do you
No,
mind?
you're literally. This is my question about vision. You're not answering it.
No, you asked me, and I said I didn't know because I didn't know what.
What's the future? You just said you didn't know, and you knew it wouldn't mess anything up. So now you're
Well,
double
you
speaking.
said you didn't know, and then I walked you down the line of reasoning, and you agreed that lines converge at the end of the road. And then you said as soon as you zoom back in, they appear to separate, which I do agree with as well. But if you zoom in and you look further past what you're zoomed in, they still converge. So are you
Right.
going to agree or not?
But this is the problem. In this particular case, the evidence, which you're not looking at, and I wish you would, the train tracks, they're not train tracks, but we can use that as an analogy or a comparison. When I zoomed in, they didn't separate back out. They appeared to cross over. The right track appeared on the left, and the left track appeared on the right, except it was turned sideways because it's a vertical thing. So that which should appear above is appearing below, something that's below it.
All right, so if I take a little like 6-inch ruler, and then I put something that's much taller on this really long flat table, right? And I put it down at the end of the table, and it's taller, but I have the camera down below the 6-inch ruler, right? Is the 6-inch ruler going to be taller than the thing that's taller in the back?
Yeah, depending on how close. But yeah.
What were the dimensions again? So that
Doesn't
how high
matter.
is
You understand the actual concept.
well, no, I didn't understand. What was the height
We
of
have
the
a
observer?
6-inch ruler, and we have something significantly taller than that. An undetermined height and distance, because it's the concept. It doesn't matter. We
Okay,
have a
so
long table, and then we have. Is it possible to have that 6-inch ruler look taller than the much taller object that's further down the table? Yes or no?
Only if the observer is below the top of the 6-inch ruler.
And you're saying that you're above the levels?
I'm above the part that's blocking the top of the building.
Are you above the level or not?
Yes, I'm above the level that's
No, you're
blocking the
not.
top of the building.
That's what the water level's doing. It's keeping
Is the
you
camera
in line with it.
Well, no,
is the camera above it?
You can see in the video that I actually do move the camera above the red water level surface, and you can tell because they go out of they don't appear the same height anymore due to parallax, and the entire building is still below. Let me get a screenshot.
So if it's even when you're behind there, when you have it in the spot that you do with 3 seconds left in your video, why would removing 4 inches of water, why would that make them that out of whack? You're straight on with them. It would just be the water moving down from both sides of the tube. It would be essentially the same, dude.
Do I actually have to go like do this for you? I have to like go set it up on a long table. I actually have to go do it for you.
Actually, I've challenged numerous flat earthers to demonstrate something that's lower than both the observer and the target, blocking the target, and none of them have been willing to do it. I've tested it myself, and
Can we get verification that you're below the levels, please? I mean, like
above, you mean?
Yeah, above.
Well, if you watch the video, you can tell that I move it up and down based on the left-looking red
You move the
water.
height up and down, or you move the angle?
I do it all. I do the height and the
Oh,
angle.
you do it all. You do it all, and when I change the height and I change the angle, is it going to change what I see?
Changing the angle doesn't change the apparent
ratio
vertical
between
relationship.
the two. That's
right.
objectively wrong.
Except
Objectively wrong.
What's that?
That's objectively wrong. The angle of view does change what you see relative to these two objects.
You mean by changing the angle, you could look over something?
Does it change what we see?
It changes the location of something that we see in our field of view.
Okay. So now we need to figure out the geometry then, right? If we're talking about angle of view, changing what we see, we need to figure out that we have the right geometry, correct?
Sure.
Because think about it very simply, okay? Let's step back outside of your little demonstration here, okay? You think we live on a sphere. So let's envision a sphere from the outside. And we have this set up. Now you think those buildings are dropping down below us because they're going away from us on a sphere. Then you draw a straight line from you or your camera over to the buildings. That's what you're doing, right?
Okay.
Now you think that we have a sphere with straight lines from our eyes. In reality, the Earth is actually a plane. You can draw a straight line. And your eyes do not see in perfect straight lines. They actually see in hyperbolic geometry.
So you mean the line of sight is not straight?
That's right. It converges and distorts. And provably so. Provably so. So, you need to look into this. Don't feel bad, though, because it's going to not only destroy this alleged claim, but it's going to destroy all of the Baller's geodetic surveying claims. So, you should look into it. I'm guessing, would you read the paper I send you from a PhD mathematician professor explaining that I'm correct?
Well, since you won't, I don't feel bad at all since you won't tell me what path you think the laser would take. You won't tell me where you think the string would be, and you won't tell me what path you think
You're
light
conflating
takes.
the physical path, tangible reality with optics. We have to play this game because you're acting like I'm scared or something. Jesse, I'm not scared to debate you. I'm not scared to answer every one of your questions. So can you what's up? What's your rebuttal to mine?
If we were on a flat plane, then how do we explain inclination as it rises from the equator to each pole in the same way?
Oh my God. Inclination of what?
The magnetic field, the horizontal line.
Oh, magnetic inclination? Whoa. Well, you'll get there. He left. Okay.
That was a short stay.
Yeah, because he messed up. So, Jesse, I think there's this ounce of honesty in you, right? I've talked to you about how you're anti-photonic, right? That's given me this sliver of hope that I give you the benefit of the doubt, and I believe you when you tell me that you are open to things outside the mainstream consensus. Yeah?
Yeah.
Okay.
If observable reality backs them up, of course.
Okay.
Can you watch this video I just posted?
Well, I've kind of had it playing. This doesn't bother me at all.
Okay, the perspective and object.
I'm looking at this and I'm like, okay.
Okay, good.
How do we see things? Dude, this is all based on how we see things. So I'm like, how do we see things? Glober is claiming that it's physically impossible to see this on a flat Earth. I'm trying to figure out what they build that idea upon. Oh, okay. Well, how we see, because they're making a claim about what we can see. So if they're making a claim purely built upon the foundation of optics, and their optical assumptions are incorrect, I must first visit that. Yeah, well, it changes everything. The railroad's a perfect example, but physical, tangible reality is not the same as visual space and optics, and how that, like, the difference between the two, right, changes with distance. So this is a new thing I need to look at if they're assuming that I'm on a sphere and assuming that I see in straight lines when I'm actually on a straight line and seeing basically spherically.
So you said that the 6-inch ruler could block view of a taller target even if the observer was above 6 inches, right?
No, I don't. Again, what I'm saying is that this is a visual effect. You draw a straight line from the top of the building to the person, and you say that represents little photons or whatever going in a straight line to my eye, and that we see in straight lines. Then you're asking about the path of light. You're asking also, and then you're conflating a physical path of light with optics.
So if your eyes are 6 inches high, or if your eyes are 6¼ inches high, is it possible for a 6-inch high obstruction, under any circumstances, for that 6 inches high obstruction to block your view of the top of something that is taller than the 6 inches?
if I'm above it, and
Yes, if you're a quarter,
my angle
yeah.
of view is perfectly level.
I make no restrictions except that you are a quarter inch above the obstruction, taller than the obstruction. You can have the obstruction, or the target anywhere you want, so long as you're a quarter inch taller than the obstruction, and so is the target.
You're telling me that you don't agree that if I start to tilt the angle down, that it's gonna make the thing in front of me obstruct the thing behind further back faster? If I start to tilt down the camera, the short object in the front is going to block the bigger object further back faster based on the angle of view. Because the foreground is being shortened. The foreground of view is being shortened as you go down.
And the big object, the angular resolution would be shrinking it the further back it is, right?
If I think you're saying actually, what's it that even though you maintain the optical center of the lens at the same height, that by tipping the camera forward, you won't be able to see over something that's shorter than you?
Well, yeah, I'm asking if you agree.
If that's what you're saying, I don't agree.
Okay. So you're saying that we can't change our angle of view and make what's in front of us closer, obstruct what's behind further back faster.
I don't know what you mean by faster, but
if you begin to change your angle of view looking down, the stuff that's in the foreground, you will have shortening, foreshortening. Maybe that's what it's called.
So maybe this will help. Maybe I don't understand what you're seeing. What you're saying doesn't make sense to me. Did you watch the 53-second video with the pink styrofoam and the blue block?
No.
41 after the hour.
Jesse, I'm watching it now. Can you please concede that you may not understand how vision works?
Well, there's always things I may not understand. But so far
it's not understood, Jesse. No, like the mainstream understanding of optics is not understood. Do you agree?
I have no idea. I'm not a optics expert. I'm not a vision expert specifically.
So then you agree we're making kind of a primitive caveman assumption about like how we see when we just draw straight lines like we just came out of a cave.
Well, you made a claim.
This video doesn't help me at all for what I'm saying.
Okay, so but we agree that the camera can always see the target because the obstruction is below the line of sight to the target, right? The top of the target.
I'm saying that in order to claim what can or cannot be seen when you're introducing vast distances, you have to do proper geometry.
So are you saying?
Keep saying. I'll be right back. Okay.
All right.
So, check this. You agree? Okay, let me say this. So basically, Flat Earth's position is they say, basically, the globe wants us to believe that the opposite of everything that we experience is true. You guys don't like that statement. you want to jump in and say, no, look, I'm showing you something right now. Da, 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 da. But this is the actual conversation. This is why flat earthers exist. The globe asks us to believe the opposite of everything that we observe and experience on a very basic level.
Except
very
what I've
basic, prominent observations and experiences. Okay. So that has a substantial burden of proof. It's asking us to think that everything's an illusion. Now, let's jump over here to a planar Earth. Okay. In this scenario that I am just kind of flirting with, bringing to your attention, I'm saying we live on a flat Earth, and our eyes do intrinsically impose illusion. And this illusion is based on the fact that the eyes are balls, little spheres, basically. Our eyes are curved. So we have a limit of vision that curves. As if this place was designed in such a way that you were built with a limit in your eye, as to you can't really see and know everything of where you live. You have an intrinsic governor built on your eyes. And that is what we call visual space. It has a limit. There is a limit of view. Only in fairy tale land can you draw an infinite line forever and say that's how we see. So we have a limit of view, and that limit of view is curved. So this is a death blow to the globe, because if we come back to step one, the globe is asking us to believe the opposite of everything that we experience and observe. It's one giant illusion. That physical reality, in fact, imposes onto our eyes, which are infallible. And it has a substantial burden of proof because of this. And people are coming by and saying, oh, it definitely is. Look at this. And on this list that they show us is a bunch of optical assumptions, optical calculative assumptions. Well, if they're blatantly wrong about how they claim we see while making those claims, and that's all they have when they're asking us to believe the opposite of everything that we experience empirically ever, that is game over if you can't sustain. I mean, you have nothing. And this is not even rolled out yet. I haven't even got to the here's the math. The reason is because I find it very important to drive home conceptual understanding, because the whole scientism spell has basically taught everyone go straight to the math. And so people that aren't philosophically sound and don't actually fully grasp and understand the concept of what they are or not believing in, they are like, look, I made the equation work. Here's the answer. I can put a box around it. I'm smart now. So that was a lie, but that's what it is. And we have a visual space, and the limit of our visual space is curved. I gotta check on my baby.
So, are you saying that if in that last video where I showed the styrofoam blocks, if I had simply rotated the camera forward, it would have caused that farther block to be obscured by the shorter block? Simply due to the direction of the camera?
I got
Yes.
I got a question for Witsit after this too. So let me go next, please.
You have to go check on the baby.
Did someone say yes?
I said he had to go check on his baby. He said he'd be back now.
Oh.
Yeah, but I'm after Jeremy. And then it's Napalm, then Regis, then Essie, and then you, Jesse. That's the lineup.
That sounds about like the right amount of time to go get a bowl of cereal. I'll be back.
He was talking about our limit of vision. I think what limits our vision is whether or not something is either big enough or bright enough to be seen. I don't know there are any lines drawn on how far that would be.
That's right. You have no idea.
Yeah, so, I mean, it's like a basic question. I asked it yesterday. I could ask it again. Like, do you think you can see a billion miles, or do you think you can see something that is a billion miles away?
Well, one thing that would limit our vision, obviously, is atmospheric turbidity. I mean, we know that. That's obvious. That would limit your vision, right?
Turbidity?
Atmospheric turbidity, yes.
Turbulence in the atmosphere?
Particles.
Hmm.
It's like turbidity is normally referred to for water, but there's such a thing as atmospheric turbidity. Jesse, if you're there, will you, Jesse, you there?
He's an amateur getting a bowl of cereal. Like, when you grow up and become a big boy, you get a cup of cereal because you got shit to do. All right?
Yeah, get a bucket of cereal.
You got a fucking bucket of it.
Jethro Bodine Bowl.
Glovers are boring. I bet you he's getting cornflakes.
Grape nuts.
Yeah. Cornflakes are half the price of Frosted Flakes, and all you got to do is add sugar to the cornflakes, and boom. Not true. They're the same price.
Okay, a question for Jesse and a question for Whit.
I couldn't hear Skyline. I know he was trying to get in on the comment, but your mic is not doing well, just so you know.
It's fine. He don't ever say anything good anyways.
Yeah.
Yeah, but it's something about the how far can we see? We can't see billions of miles away, right? But if we could, right, it would be dependent on the size of the object, and the reason is not how bright something is, like how much brightness can you fit in a 1 square inch, right? So it would have to just be a larger object, and that's the bottom line. It would have to be so big, so you can't see billions of miles away. It doesn't make any. You couldn't even make sense of it.
You don't think the brightness matters?
Well, you can only have so much brightness in a certain amount of space, so it would have to be a large object to make it brighter.
Sure, but some things can be brighter than others, right?
Yeah.
Yeah.
But what's the maximum amount of lumens that we've experienced ever? I mean,
I don't know. Yeah, good question.
Yeah.
I could have swore like a week or two ago I heard Jesse in here talking about they had spherical excess measurements. I wanted him to send me a DM of them because I've never seen them. I've been asking the Globers for a long time, and they keep showing me this goofy thing that's definitely not a measurement. Jesse would be the first one.
He wasn't 24/7 tonight when I asked him about, because he was saying this proves spherical Earth, and then I was like, okay, well, I mean, you're seeing further. Yeah, it actually proves concave. Like, hold on, how do you go from sphere to concave?
Yeah, they want to push the concave so that they can then say refraction brings everything back to level. That's why the Earth is flat, because it's actually a sphere.
I just want to ask Whitson about the spherical nature of our vision.
Well, I mean, I can
Busy.
agree with it because I mean, under a certain concept, I can put it into practice. I can stand at the edge of the beach, right? Or in the middle of the ocean, either one, right? On a boat. And whatever direction I'm looking to the left and to the right of it, just from my peripheral vision, it'll seem like it's faded out to the left and to the right, like I'm on a globe. And then I'll say, now let me check this. And I'll turn a little bit. I'll turn like, a foot to the right, and I'll look, and I'm like, man, it's a globe there too. I'll turn in a big circle. While I'm turning in a circle, things seem to fade out on the left and right side, but in the center of my vision, I can see the furthest, and it looks like you're on a ball.
Now you're seeing the same distance to the left and right. What do you mean, see further? You see in a circle. Right? You turn around the whole way. You've just seen in the whole circle if you turn around, right? Is that wrong or? Like when you look straight ahead to the left and the right, you see that's as far as it is directly in front of you. No, given there's no atmospheric conditions. Like if there's no crazy.
Yeah, I don't think though. Like if I were to take I guess a bunch of straight parallel lines and like draw them right to my eye, like the way my eye curves. No, I don't believe that like the left side of my eye sees the exact same distance, as the center of my eye. That would be weird. I feel like it would be a radial, like it would radiate out from a center point, like a curved surface, like my eye. That's like drawing in the light with its convexity to a point. Like how like you have a spectral highlight or a spectral, whatever, a highlight on a curved surface, spectrum.
So you think if I put you in a circle? You're saying you think if I put you on the ocean, clear skies as far as I can see, and I put, I don't know, buoys in a circle all around you, right at the edge of the horizon. You think you wouldn't be able to see the buoys on the left or right when you're looking straight ahead?
No, it'd all just fade out on the left and right. I'd have to turn my head and look at them. And be like, yeah, that's a buoy. And then kind of look and squint and be like, yeah, that's a buoy. Yeah. I'd have to turn my head.
I don't know about that.
I mean,
you got no peripheral vision, or?
Yeah,
I got one eyeball and I would be able to see.
I do, but I can't make out precisely what it is. What I typically do, I could try to train myself to like stop doing it, but like when I see something and I can't make it out, out of the corner of my eye, I hurry up and I look that way. I don't really know what it is until I turn my head and look.
You're looking at. We put lights on top of the buoys. You still can't see them?
I can see light. Yeah.
You see the lights? Yeah. So you're seeing in the same distance all the way around.
I'm seeing something at the same distance or at a distance.
Yeah. Well, it's the same. The circle. We made the circle of buoys all around.
Yeah, but I'm not seeing it with the same amount of clarity. And then, like, what happens when you have a bad clarity or bad, like, you can't resolve an image, right? It seems to like fade out. Right? I don't have the same amount of clarity when I'm looking straight ahead at something that's in my peripheral vision. Yeah. But yeah, I know for a fact that when I stand, like, not always at the beach, it really doesn't always happen at the beach, but definitely when I'm out on a boat, it seems like it's just kind of faded out, and as I turn my head, it looks like you're on a ball. Looks like it's a sphere all around you, like a circle.
Hey, Jeremy, I posted an image in the text. You're asking the question about kind of spherical vision or seeing in a sphere, right?
Yeah, I was going to ask Winston about it, but what's up? What do you got?
If you look at that, just imagine the sphere, the yellow sphere there, being your eyeball, right? And if you look at this,
I can't look in the chat right now. I'm at work. I'm sorry.
oh, okay.
Use your peripherals, Jeremy.
I just wanted to ask. Wait till Winston gets back so I can spring it on him.
Yeah, it makes sense. But yeah, I mean, if I can't imagine, like, why would I be seeing it at the same distance? It's not the same distance either way, right? Like, maybe you can, maybe you can't see it the same distance, but just the way things work, right? It's not at the same distance, right? So why would I be able to see it at the same clarity when something's in a straight line ahead of me, 100 feet ahead? But then I keep it on that same line, not a circle. You had put the buoys in a circle, but if I put it on the same line, the same distance from my straight line, then it's on an angle, making it 102 feet away. And then as you radiate to the right a little more, it's 104 feet, 108 feet. Yeah, so I mean, it would be difficult to kind of, I guess, quantify our maximum vision, but I know my eye is rounded. Yeah. And they say the pupil is there's a cone, which is also round cone.
The Globers make an argument specifically that we wouldn't see the correct positions of stars like we do on a star trail from a camera because of the way the image hits your eyeball. It's curved, and the back and the film is flat. So the Globers do make a specific argument that we don't see the way a camera would see because of that, because of the way we see.
Yeah, I mean, I have an issue with even the argument that I'm making as far as is it my eyes seeing this way or the camera? Because my eyes seem to match what I take a picture of, like even at a very long distance, as far as even seeing things fade out to the left and right because they're at an actual further distance, from you.
What about the moon?
So I think that the idea of chromatic aberration being more prominent on the outer edges of a photograph has to deal with what you're talking about, Jeremy, where your sensor is flat and it's not curved. So as that light's coming through on the outer edges of the lens, it's not fully coming back to give you a clear image on the outsides. Now, if you had a curved photo sensor in the back, I think that would reduce chromatic aberration for most lenses. Do you know what chromatic
the
aberration?
The argument the Globers are making is ridiculous. They're saying we wouldn't see the position of the correct position of the stars throughout the course of the night because the way our retina is. So the camera's not getting the correct position of the stars.
So if we wouldn't see the correct position because of our retina, how do we ever see a correct position? Why would it only be
No, my
relevant
bad.
to stars?
They say we do see the correct position. The camera doesn't. My bad.
I would say it's the same thing. The correct position is never really garnered with 100% accuracy.
That's what I'm saying. They're making this nutcase argument about the star trails, the divergence and convergence of the star trails. They're saying not actually happen. That's not what we observe. It's only because of the way the camera catches it on the flat CCD or whatever. You feel me?
So I mean, you can't see a star trail with your naked eye unless you see.
But you can see I know, but you can see. My bad. But you can see the positions of the stars. Obviously, you won't see a trail. Yeah.
Sure, but you're going to see position. I mean, it's going to be a similar type of situation, not exactly the same, right? Because the human eye, really, we only have decent vision at a very small portion of our field of view. The peripheral is just kind of really fuzzy, and our brain kind of stitches it together more so than we actually resolve. So to be like, all right, if I look at the North Star and you're trying to get the position of a star that's, off to your left or to your right, can't really get a position until you turn and look directly at that, which is going to distort the other positions on the, as you move. So to me, it's.
I don't know. I don't know if you're paying attention during the Star Trail argument week we had. Might have went on for a couple weeks, but they were distinctly making the argument that we would not observe the stars in these positions because of the way our eyes see, but the camera does. So, like, we wouldn't see convergence and divergence in the positions of the stars with our eyeball, even though the camera does, right? When you see star trails, forget the trails. We're talking about just the positions of the stars over time. So obviously you're not going to see a trail.
Actually, I mean, I don't even know how we would confirm that because we don't see trails with our eyes.
So
right,
you're dead to me.
I'm just saying.
So for those who can see in the text chat, I put a picture. I took my phone camera and swung it as I took a picture of the city lights at night, and it actually showed them diverging, even though they're obviously not changing angular position because the city's not, undulating or anything. It's just a city. So
this happens with your eyes.
Hold on, real quick, Jesse.
Yeah.
I heard you like 2 weeks ago. You said you had measurements of spherical excess.
I don't remember. I haven't taken any myself, so I would have just.
Somebody brought up spherical excess, and you're like, "Oh, I got measurements of those." Even though like a week before that, I was telling you there was no measurements of it. So I just thought you like found some or something.
Oh no! Someone asked me if I could cite any, and I was gonna give them some copies of the 1912 Great Surveys or whatever, because they're all listed in those old books.
Yeah, those aren't measurements, though. Those aren't measurements.
Well, the book purports them to be. If you look, it actually shows these are the actual angles that they actually measured with their theodolites, and then they actually, in the book, you can see where they have these charts, and they actually say, here's the values we actually measured, and they add up those three angles for that triangle, and it's slightly greater than 180 degrees.
Can you just show me the page where the actual measurements?
Yeah, hold on.
All right, thanks. Send it to me in DM so I can check it.
Oh, sure thing.
Thank you. I can't look at my phone right now. Thank you.
And it's not like it ever actually matches the exact prediction of the globe. It's just
the problem with those is they're not even measurements because they're going like 3 digits past the arc second. That's not even possible. It's not even possible to measure that. You're basically just guessing after the first. You're guessing at that point.
Yo, Whit, now that you're back, look at what I posted at 2 minutes after the hour. Is this somewhat representative of what you were speaking about regarding
Napalm used some fancy word on us while you were gone. No one knows what it means.
What did I say?
Chromatic aberration. Was that you?
Yeah. Well, anybody that's done photography should know what chromatic aberration is.
What is it?
So if you take a picture, right, with a camera that doesn't have necessarily the best lens, and even some of the best lenses still have chromatic aberration. If you look at, like, say you take a picture of a brick wall and you're looking straight on at the brick wall, you snap your photo, the further you look on the edges of that photograph, the lines between the bricks are going to show like color distortion, like reds and greens, where it's actually like the light is not fully converging back to give you a perfectly
so the bricks that are farther
result.
away from you, the bricks that are farther away from the camera.
Yeah, it's due to the lens, and like I was saying, I think that also has to do with the fact that the photo sensor is flat. You're dealing with a curved lens. You're not really rectifying all the light that's on the outer edges of that lens as it comes back. It's going to be in a different position than it is in most of the other portions of the sensor.
It's basically
my main question. Go ahead.
It's like the speed of blue and the speed of red are different in a lens, which is going to cause them to meet up at points that are not congruent, which causes like like overlapping of color information?
Yes.
Right. They focus at different lengths.
All right. My main question would be, though, for Whitsitt, if he's still here, how does this seeing in spherical geometry, whatever, how does that make things appear above or below the level line or horizontal line in a perspective grid? He might have left. I mean, anyone can feel free to answer that. What's like? Jesse's making an argument that stuff's below the level line, right, Jesse?
Yes.
Is that basically? Yeah. So how does this seeing spherical geometry or whatever? How does that make things appear above or below?
But I mean, your field of view determines what drops above and below the level line. Yeah.
Wait, sorry, what did you say?
Your field of view will determine what's above or below the level line.
No, I mean, due to the way we see, though, I don't know how that would affect things
Well, we
across
have
the level line.
does
Does the perspective grid not hold?
You know, we have a round eye. We have about 120 to 160 degrees field of view left to right. Up and down is about 60-degree field of view. So whenever you have more, I guess, I don't know, more land, more mass, more anything below that line, and you change what's in your field of view, then you change where that level line will eventually drop. So when you're looking, and it's really only possible like when you're looking out into the distance, and you get more sky in your field of view than you do the ground.
Does the perspective grid not hold true? Things that are on one side of the level line, they never cross that line. The horizontal, if you want to call it, level, whatever you want to call it.
Why do they not when you get closer and closer to the edge of your visual space, which is in a circle?
Wait, what? What?
As you get closer to the edge of visual space, it curves down. You have a limit. I'm saying, bro, this is like
Limit
one of
to
the
what?
biggest
We're
tricks
looking
they
at
pulled,
something,
man.
bro. We're looking at something in the distance, straight on.
Okay.
How far in the distance? Like what's in the distance though? A mile or like Jesse will show you 70, 80 miles.
Yeah, I don't know. It doesn't really matter how does seeing in spherical or non-Euclidean geometry or whatever, how does that make things cross the level line? I don't get it. We're not looking out the side of our eye, we're looking straight on, dead on at it.
Oh, cross the level? Oh, what does that mean? You mean like meet it, right? I mean,
well, Jesse's whole argument is that things are below the level line. Right? Things are dropping from a horizontal.
Hijacking the change in optics as physical reality, bro.
I know. I'm asking, how does this change?
Rudimentary.
Yeah, but how does this change make things go on either side of the level line, like, or the horizontal line, if you will?
Well, what we see changes with distance based on the limit of visual space, which is curved. So things become distorted in the distance. Flat plane shapes become distorted.
Bro, Jesse's argument is things are below the horizontal line. Jesse's argument is things are below the horizontal line, right? That's all the Glover's argument.
Right, and then Jeremy's, I guess, past and evidence is that things that are below level will converge to level, and things that are above it will also come down. Things to the left will come to the center to a vanishing point right at horizontal and level.
Yeah, I'm not saying things can't cross that horizontal line. We know they do, but I don't know if it has to do with what. I'm wondering how that's happening because of the way we see, though. And
Jeremy's I may be wrong, but Jeremy's only evidence in the past is that I heard was due to the atmospheric distortion. I'm not 100% sold on that. That's being the only reason. I believe it has to do with your field of view and what you have occupying that space.
I don't think so. If you use different field of view cameras, okay, let's say we're at B-Ball's location in Hawaii, and we're looking at that building. If I use different field of view cameras, I'm still going to see the same amount of the building being cut off by the horizon.
Yeah, that doesn't matter in that space. Well, I mean, it can matter in that space, but it depends on how much, what's at your level line, and then what is taking up below that level line and above it. Like so, that would come into play. Yeah. So as you get
I don't
like
know what's
higher,
it. What?
Yeah.
I don't get it. Let me just hear what's a spherical or non-Euclidean thing. How does that make things go above or below the horizontal line? I'm not trying to argue with you about it. I just because you brought this up before, I wanted to hear it, and you're like, "No, I'm doing a presentation," and now like I need to hear it now.
Okay. I just got back. I heard the end of that, but like I don't know what's not. As things get further away from you, they're going to converge down into the spherical limit of what you see. So something much closer to you is much. Yeah, my baby's. I gotta like take care of it, Leah. But I don't.
Go
It
ahead.
changes with
Go get
distance
your
relative
baby.
to visual space. I'm gonna drop a picture, but I gotta go see why she's crying.
Go ahead, bro. He ran away. No, I'm just kidding. I don't know. I'd have to see it or something. I don't know. Like, does the perspective grid? That perspective grid holds true, right? I mean, things that are above the horizontal line will merge and converge and smush into the horizontal line. Like, what would make the way you see cross that? I don't get it because we can use a camera, we can use our eyeball. Like, I don't know. Maybe we can't use our eyeball. I don't know how far B-ball's observation is, but like I don't know if field of view really matters. What a higher field of view, the higher up it's gonna be? What do you think? The lower it's gonna be? Like this is testable for sure. We could probably test that shit right now. I think it's all atmosphere. It's all the atmosphere doing it.
Yeah,
I don't know. If that perspective, I mean, dude, the perspective grid's got to hold true, right?
Does it? I mean, like I said, not like I said, but like people are asking, like, how far can we actually see? Like, what's our maximum? What is the maximum a human being can see? And then can we get to that maximum? And then what happens when you get to that maximum?
After the maximum, things start merging into that horizontal line, right? They'll keep getting lower.
Right.
If they're above the horizontal line, they'll keep getting lower and lower. And then eventually they'll get so far away you can't see it anymore. No?
Well,
I don't know.
I mean,
That's
maybe
how I
you
thought.
can't.
Like,
Well, maybe you can't make out the difference, right? But you'll see that horizontal line, right? Like where the earth, let's say the ground and the sky meet, right? It'll always be at that horizontal line, right? Until you get right, and then it starts to blur together so you get further and further back from it, or up or
no, it's
whatever. Right?
almost
You get
never
further.
at that. It's almost never at that horizontal line.
No, right, yeah, but it'll continue to drop because as you rise higher or you back away from it, you're putting more of what's down below, I guess, that has more color to it.
You know what you're
into
making me think of? You know what you're making me? You sound just like this guy Brandon now.
Candy,
he's a flat
chocolate,
huh? No, Brandon.
no.
This guy Brandon. He used to run a show, and he did a great thing on this. Does anyone remember that towards the end? The thing Brandon did on perspective with the wall going into the distance. No one remembers that? Come on, guys. Anyways, my bad. What were you saying?
I don't even know who Brandon is, man.
Yeah, I was
Never
just saying
heard of
that you have distinct colors on the ground, right? And the sky is not made of many distinct colors, right? But it drops lower and lower as you get higher because you're putting more of the sky into your field of view than you are the ground. It's not, that's all it is. It's just field of view, and I would expect that line to continue to drop, or whatever you're marking it against, to continue to drop, of course.
I don't know, man.
As you zoom out from something or zoom into something, you put more of the if I zoom into, I guess, the horizon, right? It's pretty even until I get it to be 50-50, right? For where the sky and the ground are 50-50, right? And then you keep zooming out and out and out, you're going to see more of the sky, with less color, less of anything to distinguish. Same thing when you go up.
Oh, you're saying, wait. So you're saying when you go up
or out, same thing. You're changing your field of view when you either one, you're going up or out. They should both drop. Yeah.
If I go down, if I get lower, they're gonna drop too.
I said up or out, but lower. I don't know. I don't think what's it, right?
Whatever we're looking at.
What are we looking at? The horizon? Just water and sky meeting? I don't know. I mean, if I go lower, you won't be able to, whatever's lower, if you're below it, you won't have your maximum, wherever your maximum vision is reached. As you zoom out,
I'm not 100% opposed to this, but I'm telling you right now, I don't like it, and I think it's completely wrong. But I'm not totally opposed to this. I mean, I'm open to anything at this point, pretty much.
Well, like, where do you think the horizon would appear if there was no atmosphere, and you zoomed out? It would always just appear at that level line. The horizon without atmosphere.
I don't know. Here's what I do think. Forget the horizon. I do think if you had a stick that you could see the whole way down, and you had it at your horizontal line, and you kept moving it back and back and back, it would never go above or below it. It'd just be at your horizontal line until you couldn't see it anymore or whatever.
Yeah, like a measuring stick. Yeah, we don't know though, because that ratio of like 1 to 100 is only used like locally. Like nobody knows if it changes and by how much. I mean, everything else seems to have a inverse square law to it. Why not this, right? Like, why not exponentially?
See, my shit could be tested too, but we need to do perspective measurements in a vacuum. Like, these measurements need to be done in a vacuum over a long distance.
So I dropped in the text, like 4 videos for you guys. One's a 3-part thing about visuals. The first one that's in the series, the first one I dropped is like an hour and a half on spherical geometry, visuals, how we see, and then the other 3 are just like a 3-part series, small increments of similar ideas. And the gentleman does a really good job, and he does go into the ideas of philosopher Thomas Reid and his common sense approach to science and how he deals with visuals and the way that we see the world. So, pretty good videos.
Thank you. I like that you put up, because I'm already picturing Kevin Costner looking through the eyepiece and then flipping it around and trying to point out his sword and try to fight the bad guys who are right there in front of him. So I feel like I'm already in this video. Like, I'm feeling it.
What does it say about what we're talking about? Give us the cliff notes. I got time to watch 5 hours worth of whatever.
You can't. You don't have time to look at your phone, you liar.
The cliff notes are you view the world in non-Euclidean ways due to the sphericity of your eyeball and your retina and all that. So
I feel you, but how would that make things go below or above the horizontal line in the perspective grid?
Also, keep in mind, you're taking this picture. The picture you take it with a camera seems to match what you see with your eye.
That's what I was trying to tell these guys during the Star Trail arguments of 2022. That went on for like 2 weeks, dude. At least a week. I don't know. They were saying we wouldn't see the positions of the stars with our with our eyeballs where the camera picks it up because of the CCD's flat or what goes on a flat plane or whatever the fuck. I mean, I'm not saying we do see the same as a camera. I'm just saying like the positions shouldn't be that far off. I don't know.
I mean, what camera actually can fully capture the way that we see visually? It's hard to say, right? Because any way that you're going to be viewing what the camera has produced is typically going to be in a 2D flat type situation. It's not necessarily going to be in an actual.
You got your mind.
3D.
You got your mind in the picture. You got your mind in the picture, and you try to say, "Is this what I saw?"
Mm-hmm.
And you can even look at it at the same time and hold the picture up to what you're looking at, and be like, "Yeah, it does match."
Yeah, as we all know, if you've ever been to some place that is like breathtakingly beautiful, and you take the time to take a bunch of pictures of it, you go home, you develop that film, and then you look at it and you're like, yeah, the pictures don't really do it justice. Like, it just never works out. There's a reason for that. You can't fully capture our world in a way that's going to be as immersive as our own actual eyes.
Well, you could say that, but like, I don't know. I mean, it's also the moment has feelings to it, but maybe you're on something.
Yeah, I mean, think of it this way, right? So if you take what is going to be put into VR goggles and you just look at it on like the flat screen before you're actually putting it really close to your eyes and kind of submerging your eyes in the visuals, it looks almost like a really weird fisheye lens, crazy distortions between two different images, right?
I've never tried to use VR goggles. I have one eyeball, but
yeah, I couldn't.
It could be because the way you see in like kind of not 2D, but like this 2.5D because you get parallax. Maybe you don't. Is that the thing that's missing from the camera, or are you missing like the parallax aspect of it?
Yeah, I mean, you can capture some of that with video, right? But you can't really do it with the television screen. So if you paused a video and you moved around the screen, you wouldn't get the effect that you actually get in real life, right? So you can kind of capture the effect. The reason that we see depth or we perceive depth is because of movement, not only our movement, but the movement of the world around us, right? So as we move, we see things in parallax, we see movement. The reason we know that there is depth is because we have learned over time to understand what the depth is, know that the tree off in the distance, even though visually it looks like it's right in front of me, I know that I can't touch it with my arm. But that's only based off of experience.
Yeah.
I just remember me and you were on this. I just remember me and you were on the same side of the how do we see in 2D or 3D argument.
So that's why those babies are like reaching out for shit in the distance because they literally are like, I can grab that tree. It's right fucking there. What's going on?
100%. Looking at a small child as they start to get more visual acuity, they start to try to grab at the keys that you're dangling above them, and they can't realize why they can't grab it. They're just like, what the fuck? You know, it's right there. Why can't I touch it?
And that's funny.
Eventually they learn, and the way that they learn the best is typically with their feet. That's why you see babies usually grabbing their feet, because that's how they start to learn depth perception, is typically with their feet.
So what did you say we see in 2D?
Yeah. 2D or 2.5 stereoscopic vision.
2.5 with the parallax, right? Yeah.
Right, because you have, camera 1, camera 2, like from Wayne's World, right? So now you see in 2D, I would see in 2.5.
Yeah, that's some bullshit. You know what? I tried to use them remember them blue and red 3D shits from the movie theaters, old school shit? I can't use those.
Yep. You're never going to see a 3D movie in the way that somebody with 2 eyes would see a 3D movie.
Yeah, that's bullshit.
Listen, man, I'm covering one eye right now, Jeremy. Other than it being inconvenient, I don't get the big deal. I think you're okay.
You're not getting. There's a slight amount of parallax that your brain subconsciously puts together when you see something. I'm fine with it. I've had this for like 30 years now. I've had one eye, so I'm used to it. Yeah, it's not. I don't even remember what it's like to see in
I don't want to.
3D.
You don't have to answer. You don't have to answer this, but do you have one eye or just one working eye?
No, I got a glass eye.
Mm-hmm.
BB gun 93.
We used to have a fake glass eye when I was a kid growing up that we would scare people with.
Yeah.
My dad would put it in a box, right, with cotton, and then put like fake blood around it. Like, oh, I got you something, and then just open it. Like, here you go.
Yo, the first time, anyways.
My
So
friend's
what
mom
makes
has a glass eye, and she fell asleep on the couch at Christmas, but her one eye was still open. It was freaking me out.
Yo, how does this spherical way we see or non-Euclidean way we see, how does that make things cross the horizontal line? I still don't get it.
I don't know what you mean by crossing the horizontal line. Can you be more descriptive?
Why would things that you know are at that are level in the distance drop below that horizontal level through a theodolite specifically?
Drop below the horizontal level. I'd have to see exactly what you're talking about.
Bro, Jesse's argument is things are dropping below the horizontal line, and Earth is a sphere. Now, I don't know. I thought Witsit was making some counter to that, like we see in it's because we see in non-Euclidean geometry or something. So I don't get it.
I'm just trying to think of.
Is that not what happened, or I could be mistaken? I'm at work, so.
Yeah, I don't know. I wasn't here for the conversation, but
how is that a?
I hear the point that I hear. So we have the 2D. So we see a plane meeting another plane in the distance. Whether like he was just describing, we know we can't touch it, but it's just all one flat picture that we see. No matter what, we see just like a picture. So we see when we take a picture and. But then when we move our head left to right, it's not not everything is moving at the same distance, right? So it's you're drawing, point A to point B, right, and like a geodetic, right, and then it curves along those lines. So those straight points. So if you connect them all, then it's like a slight curve, which is there's such thing as a curve. It's always a straight line, right? No matter what, one point to another point, but gradually enough, it's a curve. So, that makes sense, right?
Okay, has anyone ever been on a hill? Has anyone ever been on a hill and seen
Been
a
on a
plane?
Bitch.
Sorry, Jeremy. I didn't mean to tell you I've been on a hill.
I can't understand what you're saying. What did you say?
Oh.
Let me turn my volume up. Hold on.
No, we heard you about a hill, but then you didn't say anything. Anybody's been on a hill? That was it.
Have you ever been on a hill and seen, I don't know, pick something, that a plane at the horizon be below your level?
Here's the thing.
Or the moon.
It's not necessarily. It's not necessarily below your level, right? That's relative to what you're talking about. So if you're talking about the horizon in the distance, that's in apparent position, right? It fluctuates, right? So we've got that effect. Then we also have the concept of shit shrinks over distance. So if you're on let's say you're in a tall building that's 100 feet tall and you're looking out over the ocean and there's something in the distance that's also 100 feet tall, but it can appear like it's much lower than you, but it's really actually at your eye level. Your eye level isn't necessarily exactly where the horizon is. As you increase with elevation, your horizon does drop slightly, but it's only dropping the amount that your equivalent elevation would be at the distance in which you're seeing the horizon, if that makes sense. On a perfect day, but then you have to deal with that.
How does this seeing in non-Euclidean geometry make things drop below the horizontal line?
Like I said, you need to clarify things dropping below the horizontal line. Is that something that's at your level that's dropping below the horizon? or you're I'm
The horizon is sometimes below level, below horizontal. It usually is.
it's always going to be below the ground slightly. Yes.
No, the horizon is the ground, where the ground and the sky meet. What do you mean?
Where they appear to meet, right? So it's not a clear, crisp line. There's a bunch of information that kind of blends together at the horizon.
I know, but I'm saying the horizon's below level. There's times where we see the moon, the sun, maybe a plane, all kinds of stuff that we know is not below our horizontal line, but it is apparently when we're looking at it here.
So you're talking about where a sun looks like it's being cut off from the bottom. Is that what you're talking about?
A sunset, sure. A sunset or a moonset, whatever one you want. So a plane, like I said, it could be a plane.
Yeah,
See a plane go off in the horizon.
Is that what you're talking about?
It would need to be something large, like a mountain or the sun or the moon. Everything else would get too small before you could see it drop below level.
Yeah, that's a good point. I would like to see an actual video of a plane being obstructed by the geometric leading edge of the ball.
Let's wait till Jesse gets back, because I could have swore his argument was things are dropping below horizontal, and this we see in spherical. How does this spherical, or how does this non-Euclidean way we see help us?
Help us with what? I mean, it helps us navigate the world around us.
What is it causing? Is it causing our vision to do anything different? Like, what's going on?
Yeah, I mean, that's how perspective is formed due to the shape of the lens in which you see the world. It's how your perspective is how we get perspective, and our perspective that we see as humans with eyes and the shapes that they are and the sizes they are is pretty consistent, right? Most people, for the most part, have similar, if not the exact same shape eyes and size of eyes. So we have this kind of standard there for human vision. But if we take something like a 360 cam or an extreme fisheye lens or anything like that, and you take a picture, what is that? What do we call that? It's just a different type of perspective. And the reason the perspective is different is because you've changed the lens in which you're viewing the world. And we only view the world in the lens of the human eye.
Jeremy, like I think I talked to you. I think I was talking to Zanuck about it, right? So, and I had mentioned, okay, if you just kept on. Well, no, actually, go ahead. Address that first. Maybe you have something to say about it. Sorry. Maybe not. I don't know.
I mean, I don't even know what to say to that. But the perspective. Things follow the perspective grid, right? In the perspective grid, shit does not cross that horizontal line. It merges into it.
So
Yeah,
how much can merge into it?
Hold on.
Good.
That's what we see in reality, right? We see things merge in with it. In reality,
No, I see things crossing it, bro. That should definitely not be crossing it. The moon, the sun, maybe a boat, parts of boats in the distance.
I would say that the boat,
skyscrapers.
right. So some of these are visuals due to refraction, right?
No, I'm saying it's refraction. There's someone else saying it's non-Euclidean eyesight or something.
Yep, that plays a part of it, right? So
how
as the light changes, right, it's going to bring your horizon either forward, like closer to you, or further away, and things that are outside that lens. So if the horizon is brought artificially closer to you due to atmospheric conditions, you're going to have what appears to be kind of like a false horizon in the foreground, and you'll still see things in the background. It's almost like a lens has been created.
Listen to me. Hold on, bro. I'm trying to have patience right now.
I'm speaking pretty slow.
I know. I'm trying to have patience with you guys because I'm down there where there could be something weird happening. But my argument is it's refraction. It's some atmospheric effects.
Mm-hmm.
Right? So it has nothing to do with the way we see with
non-Euclidean geometry?
That plays a part in like how your perspective gets things to appear to disappear from like the bottom up, right? The reason that the ground appears to rise up towards the center of your vision, and the reason the ceiling appears to drop down towards the center. The reason you have that appearance is because you see in a non-Euclidean way.
Things rise up towards the horizontal line, and if they're below, and things lower towards the horizon line if they're above it, yes. And then, but things don't cross it. But then things don't cross it, though. What would make something cross that line?
Nothing ever does cross it.
Yes, it does. It does
Only
cross it.
Optically, right? And the only thing...
The way we see. Sorry.
Right. Like I said, you can have atmospheric conditions that give you a closer kind of false horizon, where you've got a horizon which is appearing way closer than it should be due to refraction, but then you also can still see things in the distance, right? So you've got this kind of false horizon that's coming up and things in the distance. You can see the opposite of that, right? There's a bunch of different atmospheric things that can take place. But then you also have, if there was no atmosphere, just strictly based on your vision, the fact that things converge at the horizon. There's so much information contained at the horizon. That's why it's not a clear, crisp line. It's just constantly packing more and more information into that smaller and smaller and smaller and smaller space.
Right. So like, so then if you could keep on increasing that, right? Like, so we have a very like, I guess, dark and pronounced light right at the horizontal line, right? Like, but as you start to back away even further and further and further, what would we expect? Would we expect that dark line to keep on rising?
Sorry, what dark line to keep rising?
Well, the dark line being the ground that has more color, right? Like more, it's more distinct than the air, right? Than the sky.
No, I mean,
dude, is the non-Euclidean way we see have anything to do with, and if so, how? With things being above or below the horizontal line and put in a perspective grid?
I would say if you're talking about the horizontal line being like the exact center of your vision, of your field of view, that would only depend on atmospheric conditions, in my opinion.
That's what I'm talking about, yes.
But see, something like the sun and the moon during a sunset, if you look close enough, it never actually intersects.
I've seen it. We've seen it with the stars. Yeah.
Correct. It never actually intersects with the horizon.
I've seen times where there's huge gaps. Huge gaps.
Yeah. Oh, yeah.
There's also times where you can't see a gap, though, because, I mean, right, especially during a sunset or moonset.
Yeah, and that can be... I was just going to say, that can be like a storm off in the distance that's so far away, like you can't even resolve it. Like there was times when I remember distinctly when I was in St. Lucia, it looked like there was almost 2 sunrises because I started to see the sun come up, right? And there was a slight gap between the horizon and where the sun started to come up. And then it like disappeared into clouds that I couldn't even see, and then started to rise again in this like false horizon. It was the weirdest thing.
We got to just wait for Witsit to come back, because this somehow helps us, this non-Euclidean way we see.
So Jeremy,
I'm just trying to figure out like how.
When you see like light, right? Like, are you always seeing it straight on? Like it's always coming to you in a straight line? Like I said,
do I think that? No, I don't think that, because there's atmospheric shit happening. So no.
Like
you might get lucky and
what's up? I want to get lucky, guy.
You might get lucky, and one day you do see it where there's no refraction in its actual spot. Maybe, I don't know. George, I'm guessing that's the case because George Hanichuk measured the horizon over level,
So I'm guessing there was some point, if he had just watched it the whole time, there would have been some point in between below and above where it wasn't its actual spot. You know
Well,
what I'm
how
saying?
about like yeah? How about like just locally? Like so, like in my, I got my room at the end of the hallway. The lamp is off to the right. I said this like 2 days ago, right? But the lamp is off to the right side of the room, right? And the doorway's on the left, right? The lamp is on. Then I go down my hallway, and then I make a left at my kitchen. Now I'm all the way in my kitchen, but I'm seeing like that dim glow from that lamp that's like three, all the way down the hallway off to the right. Like, is it just going in a straight line all the way to my eye?
Around the corner?
All the way around the
Or
corner.
down?
I mean, down it's a down the hallway in the room, down, then make a right down into the room. The lamp is sitting in that corner, and but every other light in the house is off. But the kitchen is still very dimly lit. Like I could just make out. There's my Oreos.
Probably
Right
bouncing off
there's my milk
walls and it's probably
in
bouncing off
straight
walls and shit.
in straight lines.
I don't know about all that. Maybe.
Well, yeah. So it seems like so. What does the light like bend and curve all the way to my eye? Like all the way around all these corners, it bends and curves to my eye. Why would we see in straight Euclidean geometry when this light is bending and curving down past 4 different rooms all the way to my eyes, but I can see Oreos?
I mean, it's probably going in a pretty straight line. Dude, it's bouncing off walls and shit, bro.
Mm-hmm.
Huh?
I don't know.
That's why you see the light.
See, this is where lots of times people start to talk about the wave or the particle idea, right? Because you're saying, is light in straight lines, like straight rays? I know they like to be, like, people like to draw it that way, but is that what's actually taking place?
It'd have to be something close. It'd have to be something close to that, right? Because when you reach out for something, it's there. So
I would say if you're drawing a sun, like you draw a sun like you're a little kid, and then when you put like rays coming off of it to hit your landscape, you just draw straight lines coming down or straight lines coming off that circle that you drew, right? That's what we think of rays of light being, but it's probably more like the symbol
There's no
for
such thing.
your
Yeah,
Wi-Fi.
there's no such thing as a ray of light.
Right,
Not like
exactly.
that.
I think light travels more like a better illustration would be like what they use for Wi-Fi signal. That's a better illustration of probably how light propagates from a source.
like a ripple in a pond. If you throw a pebble in a pond, you're saying?
Mm-hmm. Yeah. Because then you have this, just like
that's what the Globers say. There's rays of light coming off of everything in every possible direction. Right? That's what you're talking about? Like just a
No,
sphere
like when you think of the Wi-Fi signal, it is one big. It's like a rainbow, like one big rainbow, and then there's one after it, being like propagating, and then another big wave, all hitting you on a curved path from its radial center, but all at once, like coming at you.
Yep.
Just that picture is.
I would say that's more analogous to what light does than drawing some sort of straight line.
Yeah, but dude, when you go to reach for something, it's there, right? I mean, you reach out a straight line, it's there.
Right, because you're seeing it. You're not seeing like each individual ray, right?
Yeah, I'm just saying, close up, I would think you'd see in straight lines, fairly. It'd have to be pretty accurate, because
but this light is it traveling you in a straight line? Like, even the sunset, like you were describing earlier, right? Like I'm seeing it, right? I'm looking straight at it, right? But then I just keep looking straight, and I move 5 steps to the right, but I'm not looking straight at it, but it's still traveling right to me. Is it still a straight line, or is it bending to me now?
Okay, I don't think the sunset is a straight. Don't try to use that against me now. That was my argument against you guys 5 minutes ago. I
No,
don't think that's
even the sun in the sky, just the sun in the sky in general. I'm saying, is it,
I don't think that
straight
light is making straight lines, but I do think the light in front of us is making somewhat straight lines, straighter than that, obviously.
Yeah, right, but even like again, when you connect a bunch of straight line points, there's that's a curve, right? I mean, how gradual it is.
If you're interested, I dropped some more visuals about sunsets. I mean, I don't necessarily think they're 100% accurate because I think things are, like you say, more curved, but this is drawn kind of orthographically with straight lines. But you'll see how since you're closer to the ground, that's going to give you a horizon and a much closer point, then you're going to use then you will lose visuals with things that are higher in the sky, higher above you than the equivalency of the ground to your eye. But you'd have to look at that visually to see kind of what I'm talking about and read the slides, but it's pretty good representation. Because if you think about it this way, right, when you're looking off, you're standing at the beach and you're looking off at the distance and you're looking at the horizon. The horizon appears to be roughly in the center of your field of view. But you know that in the distance, that furthest line that you can kind of resolve at the horizon, let's say it's at like 3, 4, 5, 6, 7, 8, 9, 10 miles or whatever, before you start to just kind of everything blend and merge. The reason that is where it's at the specific distance is due to your elevation from the ground itself, right? The thing that's rising up to your eye level. Now, if you take something like the sun that's directly above your head midday, let's say it's 10,000 miles above you and it's a very large object. As that thing starts to move, right, across the sky, if it goes 10 miles, it's barely going to move like a freaking degree above you visually. So it could go something, like 3,000 miles before it's starting to look like it's even close to the horizon that is at 3 or 4 miles for the ground. But these two places are meeting at the same instance. So you're going to get kind of that false horizon type idea where visually something larger is going to start to intersect and be occluded by all of this information that's being squished into what we call the horizon.
Yeah, but his main concern is like, so I mean, there's just things to think about. I guess you could wait for like a more precise, like he made the claim, right? So you want his precise answer. I understand that, but there's just things to consider, right? You got your, you know what a specular highlight is, right? So you got your eyeball, like if you know what it is. Somebody takes a picture, right, of you smiling. Well, you got one eye, but you might have red eye, right? Like one where the light just gathered in one place and like flashed on your eyeball, or when you're looking at somebody else, you can see the specular highlight on their eyeball. So so there's a curve right there. We can see that we can see that light is traveling from around the corner to reach our eye, bending and waving all the way to us. So we know the sun has a center and radiates. All light seems to radiate from its center. None of these are these are all curved surfaces, curved paths of light, curved. Everything here is curved. I mean, why are we so dead set on seeing in straight lines when everything else is curved? It's strange. I mean, again, like the Globers are the one who claim parallel light, right? Like, I don't think the flat Earth does.
It's possible to take out specular highlights with like a circular polarizing disk or polarizing light, or using them in combination.
So, so look at the last slide that I posted. If you have the ability to check the chat, it would have been at 48 after the hour.
Differential this.
Yeah, I posted 2 slides. Look at the very last one, and look at the image in the bottom left-hand side. So this is kind of what the Globers try to do when they draw things orthographically, right? They're saying, okay, here's this guy's eyeball in the bottom left-hand side. Let's draw these lines up to the sun that's going across. It's maintaining the same altitude, and then we've got our horizontal there, which is the purple line, and then we've got things that are below our horizontal line that are on the ground, right? And that looks nice and pretty and Euclidean there. So switch over to the image just to the right of it, where it says we interpret as, and it's got the little arrow. That's more representative of how we actually interpret the information visually within our field of view. See how that sun is coming down? The interpretation of it is bringing that sun down, and the interpretation is bringing the floor upwards, or the ground upwards. And that orange section off to the right, it's like, okay, at this distance is where the ground is going to have a horizon, where that orange block starts.
What distance is that? What distance is it that things start to rise? I don't know. At all times, I guess.
It all varies, right? So it's based on your elevation, right? Your height from the ground is going to present the ground and the sky differently to you, and objects that are above or below your line of sight are going to be presented differently depending on how they are in your field of view, or where they
It's
are.
like if you put your eyeball down to a chessboard and look at it diagonally, you kind of like can't see the last squares on the board. You know what I'm saying?
Yeah.
You're putting us all on equal footing there because we all have to do that with one eye closed, Jeremy. That was tricky of you, but yeah. So we're all equal now.
That's how I get you, dude. We see very close to the same because there is optical illusions people can draw with the right shadowing and stuff and the right, kind of, they're called hyper realistic painters. They can draw something, and if you don't move, if they just unblindfolded you and you couldn't move your head at all, you wouldn't be able to tell if this shit was 2D or 3D, if it was a drawing or not, or the real thing. You know what I'm saying? So I mean, the one eye thing's really not that big of a difference. Maybe over long distances. I don't know. I'm waiting for Witches to get back. He's busy with the
I'm
kid,
back.
dude. It's so busy having a
back,
baby.
dude.
What up with this?
What's up? So
It is for women usually. I mean, I don't know. I was pretty hands off.
I just went to the store, so.
Yeah,
Hey, Witsa, can you break it down for Jeremy? Because no matter what I do, it's unsatisfactory for him.
Yeah. Okay, there's a bunch of different stuff here. So, for one, what does stuff do in the distance when we look at it, Jimmy? What happens?
I can't really do this now. I'm about to go on break with coworkers.
Oh,
I'm gonna need like 30 minutes.
Okay. Well, they start to
Run
kind of
away.
optically converge, shrink in size, and they compress in the distance. They can become distorted. We end up reaching like our limit of view. Okay, now in Jesse's example, for one, what is the center of view? Because everything's going to kind of converge towards the center of view, right? So meaning everything above it is going to come down, everything below it's going to come up to the center of view. So that's obviously a very important thing that they will never really talk about. Secondly, in Jesse's example, he has like that water there. It's basically creating an artificial horizon, right? Because now you have an obstruction. You have the sky looking like it's meeting the ground, but instead of the ground, you have these level lines. And he's comparing those level lines. So he's like stamping in a certain closer area, right? As opposed to what's further back. So you're going to see two totally different quote unquote horizons or limits of view. You're going to take that however far away the one is, you're going to take that amount of limit of view and then compare it to a greater limit of view. All right. So you're going to have a difference in what's optically happening to that quote unquote horizon or limit of view, because you have greater distance. It's going to keep going down and again towards center view, which is why in Jesse's video, if you look at about 2 minutes, you'll see the level lines going down, right? To where it's like the building's almost not below the level lines anymore. Well, what was he doing to do that? And what would happen if he had to continue to do it? You can literally see at 2 minutes in his video that the levels go down. So all that to say that the way we see this limit of vision is visual space. The visual space is curved. So that is that's a big deal. Like if you draw half a circle out from you, that's how you see. I don't know how you interpret and receive the information optically at whatever the limit of view is going to be curved. Basically slicing through the curve earlier and saying, why does the curve further away look different? Because it would have to. So I don't know, that was a lot, but there you go. I think the best thing maybe go to I think it's like 2 minutes. And you'll see like the level line, the water level line start to change. Like just ask yourself like what's happening right then. Yeah. And what's he
You also
claiming
have
anyway? I
to,
don't even know like how far away are these levels. He's claiming that the other levels the different height because of the curve of the earth.
yeah, you have to also realize that looking 80 miles away, like how perfectly vertical his instrument has to be is unmanageable for one person. The slightest, what do you call it in the micros of a human hair or whatever, off would totally change that line at how far away he's looking.
I just think it's crazy. I mean, you can watch this video and it changes. But I think Jeremy's question was continually like how does spherical geometry make you or make something drop below horizontal? Yeah. That's his question.
Yeah.
Yeah. Like I don't know why it wouldn't. I guess that's what I'm saying. So, like, for one, we're looking through like an additional lens, and the lensing effect perceived through any optics is again like it's curved, right? So, like
Yeah, but
the
he was
Atmos is
more.
just
He said
adding an
take away.
additional lensing
Yeah,
effect to our curved optics.
yeah, and he was interested. Take away the atmosphere, would it still happen, and why?
Yeah, I think it would. Yeah, because for one, in this particular video, all right, like what's the center of view? The center of view is definitely not the water leading up to the buildings. You can just look at the video. That's way above center of view. So things are going to compress down to a limited visual space in center of view. They're gonna go down towards the center of your view, curving. They're gonna curve more and more as they get to the center, because it's curving. So I don't I know that it's like a brand new concept to people on how to see. So it's like I think that visualizations and math are the way to go. That's why I haven't really said too much. I don't know if what I'm saying makes sense, but so he has like the levels here, right? In that's way closer than the visual limit we're seeing far beyond that. And then the question is why does it look different, or more so it's why is it below horizontal? I guess. Like again, you can go look at his own video, and it starts to go. The buildings start to come up towards those levels. Now, the Earth didn't start breathing in and out. There wasn't some different rate of curvature. He changed something with the camera, which means something based on what the optics are seeing caused that to happen, which makes perfect sense in what I'm saying. Like, how did he establish? Well, how do you establish horizontal between the camera and the first level and the second level? And where's the center of frame? I don't know. I don't see how. Of course, you could go up and down.
Somebody who I think is knowledgeable is I think Gary's pretty knowledgeable on the field of view change, and why it would in a spherical vision things would drop below horizontal. I mean, that's my opinion. I think he's pretty knowledgeable on that.
Gary.
Gary boy, what's his name?
Wabinga? It's only Gary I know.
Wybeng?
Yeah, Wybenga.
Yeah. Focal lengths and field of view optics would drop things below horizontal or below that horizontal line.
Yeah, I guess I'm not understanding why it wouldn't.
Yeah, that's what like I had asked. Well, Jeremy was there before, but like, what do people think would happen? Like things would just keep rising, right, and from the bottom, and then come down from the top, and just create a black straight line across our vision. And that's all we see is just like a straight line. Doesn't seem realistic to me.
Things drop down and shrink in the distance into a visual space that's curved. So, There's all kinds of variables. This is why it's such an amazing trick, bro, because when you hijack something like vision and then like don't tell anyone any of the things you may know about how it works, it's like they're gonna run around with their heads cut off, right? I mean, the slightest angle of view is gonna
Yeah,
change how you
man.
perceive something in curved visual space. So
The thing about this argument, though, is people can mess around with this on their own. Like, everybody has a camera on the back of their phone. So mess around with things in the foreground and the background, distances. You know, like, even as I'm sitting on my back porch, guess what? My knee is not higher than my fence, but I can make the top of my knee look like it's right at the top of the fence. And as I pull my camera back away, I can keep the top of my knee at the top of the fence, even though it's lower. I can
Well, how do but
slightly
Nabo, how
change
do
my elevation. You know, I can do very subtle things that make huge differences the further objects are away from one another and the further they are away from the lens.
look, I have
Like,
a
But if
little
you put like
earplug
a
in my hand and I'm holding it close to my eye, and then I'm moving this cup, this Yeti cup, away from me, and I can make the Yeti cup drop down below the earplug, keeping them
but
level.
what about when you have 1,000 different things at level? How do they sort themselves out? What
What?
decides to, what you have 1,000 different things in a line, all at that level line. How do they sort themselves out? Do they just all just disappear into that one small spot?
I mean, at level would have to be what you're talking about. Everything would have to be not only at the same height within the lens. Left right would play a slight part in that as well, but it would have to be literally directly in the very, very center of that lens. Like, you would have to have a pinpoint laser that could shoot forever and would burn a hole through everything and that it was touching, and still just slight changes within moving forwards, backwards, and kind of slightest little tilts are going to make huge changes over distance. I don't know. Maybe I'm
How
not
much,
explaining.
like how? So yeah, that was a lot, I guess, with the burning and everything. But like you have a bunch of different things that are from in a line of sight, right? You have a whole bunch. Or imagine you could put a whole bunch. It's not just sky. How do they decide? How do these things sort themselves out at that further point? Like what decides? Do they all just shrink into one spot? All these things that are in reality not the size of a dot.
I think I seriously need to like make videos of this stuff. This is crazy to me because, like, to me, it clicks a lot. So I guess I need to.
I would imagine it would drop below that horizontal, and some things would go above or below. But that's what I would imagine would happen. I don't see why that wouldn't happen either. All of those things in that straight line of sight, or things that are coming up, things that are coming up, and things that are from the bottom and going down from the top, they're going to have to sort themselves out too, and then that would lower that level line just with all the information you're trying to put into one spot.
Yeah,
without
proportionate to the distance, right? I mean, like, I can do it on my table. I'm not just trying to do it.
without atmosphere being a large part or playing a large part, but perhaps light not being straight, being or traveling straight in a straight line being part of it also.
Well, there's first of all the assumption that it travels, but there's like the physical phenomena of light and then viewing it, which is funny because we use light to view things so people conflate them. But the physical phenomena that we refer to as light, which we see the illumination of a physical phenomena, is not synonymous with how we see it. They do the same thing with everything. Everything in the globe is this lie. This is why they're going to freak out in 2023 because it's like the same thing with Lorentz contraction, right? It's like they conflate that there's a physical contraction with how you see it. They do this with everything, bro, and then they say the Earth's a ball.
Well, yeah, even like with with atmosphere, without atmosphere, even people in the flat Earth are trying to figure out how these perspective things would change, all assuming that they're traveling to our eyes in a straight line, right? Like every time. Like, is anybody assuming that they're not traveling to our eye in a straight line?
Well, traveling to our eye in a straight line. They think little photons are traveling to our eye in a straight line and that we see that straight line.
Yeah, we see it. Yeah.
But we don't see straight lines. So
right, and even some sort of perfect orthographic view is as if there's like no medium between you and the objects, right? There's nothing that could distort the image due to atmospheric conditions as well.
yeah,
So like
that's
this,
like a whole other lens you laid on top of like your eyes.
right? I was trying to explain that to Jeremy earlier, where like sometimes due to refraction, you can even get kind of like this closer false horizon that wouldn't normally present itself in the place that it's presenting itself. But past that false horizon, like that portion of the lens, you're still seeing objects, and they're being obscured by what's falsely being brought up from below due to the first lens within the atmosphere, because you've got different various lenses. Beerman, who's on here, goes over his ideas with this very well. Sometimes Travis as well. It's almost like you're constantly, especially when you're looking out over distance, you could have multiple various like lens interactions that you're having with the atmosphere.
Yeah, like light does seem, or whatever we call it, right? It does seem to accumulate at a point, right? Like, like I don't subscribe to the idea of a dome, right? But when I see, what are they called? The sun dogs. Yeah, it looks. Yeah, sun is. Yeah, sun is. Is directing itself to a point, right? Because air seems to be traveling, or whatever gases travel from their point in all directions. Everything travels from its source in all directions, apparently. So light does seem to accumulate at a point, not a straight line.
Pretty sure there's a dome of sorts, just so you know.
Maybe not.
Yeah.
Even if it was a flat ceiling, I think it would see it in the same way.
It could be all kinds of things, but yeah, I'm saying I think there's a dome, but
so I think the sun dog
really like necessarily how it's been represented. I think it's like this crazy semi-permeable layered enclosure. Mm-hmm.
Well, there's definitely. Yeah, go ahead. Yeah.
I was just going to say it's kind of a good point that how that sundog is presenting itself to you when you're looking towards the sun and you see the circle around it. That's more likely how light is coming to you in almost like a conical form, right? Like if you could imagine that sundog getting much larger as it's getting closer, as it's coming around you, and getting smaller as it goes away, and the pattern that would trace gives you kind of this conical way that we see visually due to perspective, the way we're seeing that light and that perfect circle around it. Hopefully
everywhere we
yeah, for real, that's actually a great point. Yeah, the sundog that he brought up a great thing. Sundog's a good idea of like how our eyes work. So just put that on a flat plane and then say that stuff you see with light is curving the earth. I mean, it's like
that's what it is. Yeah, I mean that is a big part of it.
Yeah,
every light that we see seems to be curving and converging to a point based on like convexity or concavity, whatever you say that word. Yeah, but they have us, concavity, but they have us believing that all light is parallel.
Yeah, so like when you look at the sundog, imagine you see the two lines on the side of them, right? I'll drop a picture, but like it goes in all directions. It actually goes in all directions, right? Oh, wrong picture. All right, yeah. So that goes in all directions, right? Like that curved view of light. That's also going like straight away from you. It's coming towards you.
Yeah, no, that's a good picture. Yeah. But
just imagine that.
Yeah.
just imagine that larger ring is closer to you, the smaller ring is further away, and just if you put a whole bunch more of those, that kind of perfectly describes the conical way in which we see.
Exactly, dude. Just draw like a tunnel that's getting smaller of circles. Now we're talking about receiving information that people call light, interpreting it to mean something. And that's that's the lens we're seeing it through. And then we're adding a whole nother lens of the Atmos. People wonder why refraction is such a complex idea. Like Andrew Thomas Young admitted to Jared in an email that he doesn't understand refraction. It's because of stuff like that. I mean, of course it's complicated. You're adding a lens on a visual space on top. So artificial lens of visual space on top of your actual visual space. And then you're picking out different pieces within that lens that like additional lensing field inside your field of view. And then you're picking out different points with that layered effect and then saying something's happening on the physical earth. They have a huge playground to play with because no one's mapped out the eye correctly. And I'm not even claiming that I know how to fully map out the eye or anything. I'm saying like it's very obvious that they went in the fundamental wrong direction.
Well, you're never going to be able to fully map it out to where it's always going to present itself perfectly within the real world. Because there's
how could you map it out? Yeah, that's crazy.
There's so many other factors. It's like you can get close, just like a photograph from a digital camera is close to how we're seeing that image. But as we all know, like you look at a picture and you are standing in the place that you took a picture of, the picture never does it justice ever.
Yeah, mapping out the eye first of all, the mainstream would have to, I guess, concede that the Earth is not curving, right? That'd be like a start, like to get all the best scientists on it. But like, you can give me 1,000 eyeballs, I'm not going to be able to map them out. Like, what am I going to do with that?
Well, so you can you could do what Jeremy's talking about, like making observations, very precise observations in a vacuum, and just kind of try to get like some kind of baseline of how the eyes work with like a very specific study. You could go out with that baseline, then you would get a much more clear picture of what happens in the Atmos. But you still wouldn't have definitive answers. But they've done nothing like this, right? Like they have gone out into the world, drawn straight lines to a curved Earth, and just said, look, it never actually matches this because refraction. So it's not even like an intelligent trick. It's just like a wise one. Maybe it was done on
It's a good
accident.
trick. I'm still on the fence on. Listen, people are doing it by accident, but also they put 666 everywhere. Somebody did it on purpose. So.
Yeah, and I don't know how far that goes. I think that there was a systematic exclusion of this alternative view to view. So that's sketchy, right? That's suspect. I think a railroad proves that this one's right and Euclidean's wrong. So,
have you ever thought about it from the converse in regards to things like the 666, right? So it pops up a lot within how they have to put together the deception of the globe, right? So for taking all of the things involved in the globe and the many different facets to the deception, do you ever think it's possible that the only way that they could trick the whole entire world into believing that they're on this ball and all the math that they need involves 666 so much is actually a message from the creator to those who have eyes to see and ears to hear as to the markings of the deception, not the other way around?
Sure, that's a good point.
Yeah, that's a possibility. I think they created the entire language of the numbers that do produce 666 just to create this lie. You could easily have just stuck with the other numbers.
That's also a good point. The globe allegedly predates this numerical system, but then that's a whole rabbit hole. So. Does it? Say it does. And his point
That's
is very good.
that's the part that I'll never be able to. That's the rabbit hole I'll never really be able to understand and dive into. Is the numbers, is the language of numbers, and how could they possibly have done all these calculations knowing that this number would produce this language and this answer using this system? I'll never be able to understand. I know it's there somewhere. I'll never know how to access that.
Well, 2/3 ratio isn't like uncommon with certain like geometrical systems, right? So it's like, yeah, I mean, I don't know. I'm very open to it, but
Just mean
I don't
like
really find it to be just coincidence. So is something else.
I just mean like the number system, like number 1, number 2. I mean, I get we have one finger. I can't even imagine calling it something else other than 1. But they did, and I can't. I will never be able to go down that rabbit hole. So why even bring it up? Yeah, but some of the stuff is just as simple as, which I mean, I felt like it was realized a long time ago, right? Like it's not Earth curving; it's light reaching its limit in a radial way, right? Like it's light bending or whatever. It's not a globe. I feel like that was one of the first obvious things that was realized, right? We see that the sun, from high altitude is like that, like it's dark over there, so it's blackness, and over here it's light, right? And we go high in the sky and look at it, and look, there's a globe, or the sun is just radiating from a center point, right?
Hey,
So
so
like
if
that's kind of basic.
draw you a circle, say you have a lid to a cup, it's a circle, and you hold that circle up to your eyes, what do the edges of the circle look like? Do you think that the edges of the circle look like they're level with the center, or do you think they drop down away from the center of the circle?
I think I'm gonna have to get a cup and put it to my eye. This is ridiculous.
Like a lid. You don't have to do it, but you can also use like a
I'm
coaster,
doing
right?
it.
I have a lid and a coaster here, so
No,
I'll
I'm
just give
doing
you
it.
I'm back.
Too late.
I'm back. How does this seeing in non-Euclidean geometry help us?
Dude, he explained it so well, just in like in the last 20 minutes. I don't think he has the energy to go over it again, honestly.
Damn, bro. I literally missed the whole thing.
Whole thing.
Okay, so we see in an arc of vision, right? We have like a circle that we see. We have limits to our view, and to the side is called our peripheral. That's called our peripheral vision, right? It's a giant circle, and it's actually a circle that goes in all directions. And if you look at the sundog at 18 minutes after the hour, you'll see the circle that actually goes in front of you, it wraps it towards you, it goes away from you, all that. That's how we see in circles. We have a visual limit space. When it comes to Jesse's example specifically, he's showing the buildings allegedly below the levels, like way above center of frame. Everything converges to center of frame. If you have physical obstructions in the way, you introduce a new visual limit to your space, and so you're going to have those circles there. I know I'm just saying a lot, but okay. So for one, note the center of frame is where everything's going to converge to. Secondly, he's basically introducing an artificial horizon of sorts when he puts that level there. And he's saying, look where this is, and then blah, blah, blah. And then you're also viewing all of this spherical visual space, more so just curved visual space, through an additional lensing effect of the Atmos. So you have it's basically you laid another lens over your eye, which also has visual acuity that is curved, right? And so then you're looking in the distance, and then the distance, then you're going to converge more, compress, curved at the edges. And then to say like, oh, look, this should be up level is insane. It's not. You're viewing through a greater distance of curved space. And in his video. You can watch it 2 minutes. You'll see that when he's just messing with the camera, the building starts getting closer and closer to those levels. So if he had kept doing what he was doing, then it would have been up above the levels. So angle of view in curved visual space. I was telling everybody you can do it on your desk, and you can hold a lid or a coaster that's curved like a circle. You can hold it up to your eye. If you hold it pretty close to your eye and you look, it's going to look like to you that the right and left sides of the curved lid of the circular lid is dipping down away from the center. If you could see the other side of the lid, it's going to look like it's going down below the level horizon at the front of the lid. There's how like a circle of view works, how an arc of vision works.
I'm with it. We see in a circle thing. Me and Brandon presented that like a year ago or something. But
and it makes it curved. It makes you look like something's curving.
Yeah, it could make you look like it could make the horizon curve or something. Yeah, but how does it make things drop below horizontal?
Because you're viewing it through curved space. So whatever you see over what you would see over something physically curved is what you're seeing optically. The same thing goes for the horizon. It's a circle, bro. It's a big curved circle. That's how you see it. You can even look up arc of vision too. That's what's so funny. Like arc of vision is kind of like hasn't been entirely hidden.
Yeah, but does the perspective grid not hold true? I still don't. The perspective grid holds true, right?
You mean all the straight lines?
Yeah, with all the straight lines, yeah.
Only to a certain distance. You have a visual limit. Everything's going to like just because you draw a grid that looks like things are converging towards each other, like that doesn't mean that I'm seeing in these straight lines.
Because part of your thing was the atmosphere doesn't, and I'm totally with that. Like that Steva thing, and shit's moving up and down, whatever.
Lens to it, yeah. So it's gonna look like that curved space is closer to you.
I know. I just don't
when you
see
go
how
further in a distance, you have more lensing. It also has to do with how we see, though, bro. Like you have to address how we see and the additional lens of the Atmos, because the additional lens of the Atmos is adding another layer of how we see, which is curved visual space. And you're seeing a different portion of the curve if you go to the levels that are just 90 feet away. Then you go to this other thing that's 100 feet away, and then you go to this other, or you're at a different portion in that visual space. We see everything curved, even when it's straight. It becomes more and more noticeable with distance, closer and closer to the limit of view.
You're saying straight things in the distance become curved because the way we see?
Yeah. Oh, yeah. They curve and distort and compress down into a convergence point. Also, where's the center of view in Jesse's thing, right? Like, Jesse's example is terrible. I just didn't feel like saying all the specifics. I want him to concede that he's wrong about visual geometry.
Oh, I'm just thinking about times where like they take theodolites on a fucking top of a mountain or a plane or something or whatever, and then they like actually like I know the refraction thing is happening, this visual effect in the atmosphere. I think that's what's given us the. I still don't understand
the
how
reciprocal
seeing.
zenith
I'll have to
angles?
watch. What?
Yeah, like that's what you're talking about, right? Like they take the plumb lines on different mountains and they take zenith angles to them. They say that this is dropping down, or leaning away from 90, basically. Is that what you're talking about?
Well, no, that whole reciprocal zenith angle thing is about they see one theodolite lower than from on a horizontal than the other one, and then they say that plumb line's not being parallel.
Same thing. Saying we see lower than
I
horizontal.
think there's just this optical effect happening in the atmosphere. I don't know. I'm not sure about this way we see thing yet, but I don't know that much about it.
We don't see in curved visual space. We have curved eyes.
Yeah, but we can see straight lines though.
Yeah, only like decently accurate relative to distance.
The farther away some things get. Go ahead.
Sorry. I was
just
wondering.
You draw a line on a sphere. And it goes all the way around the sphere. What happens to the line? Say that I start at the same point. I start drawing around the sphere to the right and to the left. What happens to the line?
It meets
curve and converge together on the other side, right?
You're just going to draw a line around a globe?
Yeah, sure, do that.
Like an equator?
Draw a line. Yeah, there you go. And you start from one point, and you go in both directions at the same time. Those lines are going to curve together and converge and meet, right? We see like that, and when we look at straight lines, they look like they're converging because we see like that line drawn on the sphere. Does that make sense?
No, I'd have to see this visually, and I can't even do it right now because I'm at work.
You don't follow what I'm saying at all? Like,
I'm not. No.
You said that the limit of our vision. Could you expand on what you mean by that?
anyone that thinks you can see infinitely, I don't think they consider the table.
Do you have a citation or something I can look at? Because when I looked it up, the only thing I'm getting is either view the limits, which is mathematical formula, or talking about computer programming.
So you think we can see forever?
I think I don't know. I think I would listen to what the experts say.
Oh. What if the experts disagree?
Do they?
Yeah.
Who are the experts? Would you say like Thomas Reed or Andrew Thomas Young? Who would you say the experts are?
See, I don't even know. This is why I was asking if he could further expand on what he was saying, because I don't know the answer to this.
Well, I think this is actually fairly simple to answer. So you've got the concept that you can see forever, right? Well, first of all, that would require absolutely no atmospheric occlusion whatsoever. And you would also require something to be infinitely large, proportional to how far it is away, right? So are those two things possible through a medium? No. So then there must be a limit.
Yeah. And it's even, as to what I'm saying, is simple as well, right? Like you draw a straight line from your eye and you extend it infinitely. That's ridiculous. To pretend you can just draw an infinite line from your eye and therefore that's how far you can see is somehow true or something is insane.
If something like is really, if like there's a really bright light, does that change how far away we can see it?
Maybe, yeah. I mean, you're able to see things further when they're brighter. That's
right,
really
like
specific too.
And when they're bigger as well.
So like when I take my dog out for a walk and we're coming back to the house, if it's daytime, I can see the house, but I can't see the door. But when it's dark, I can see the light above the door, right?
Yeah, it's just because you've got less noise you're seeing through.
The same atmosphere that was there when we walked away during the sunlight.
So think of it this way. You can see something that is emitting light further away than something that is reflecting light, with the exception of maybe like a mirror, I would say would be the only difference. So like a tree is not going to reflect light as far as a flashlight will throw light, if that makes sense.
Yeah, the argument from you seems to be the argument seems to be from you like if there's one variable that matters, then another variable doesn't matter, right? Whereas I think what we're saying is that all those variables matter. So, yeah, when you're in a dark environment, you're going to see light more easily. That's true. That doesn't mean infinitely that you'll see everything.
Yeah, exactly. It's crazy. You guys
I'm still wondering if there's like a citation or something that I could read into, because I don't know much about this. I'm trying to learn here.
Look up Thomas Reed, bro. Go look up
Thomas Reed?
Visual Space.
REED? Or how do you spell
Reed,
it?
yeah. So I put some videos that break down some of his work on his philosophy on visuals based on common sense. I dropped some videos a while ago in the text chat. The first one that I put is about an hour and a half, and then there's 3 parts that are each about 20 minutes. It's this guy's concepts and ideas and the way that he breaks down the video are based on his understanding of Thomas Reed's work. But yeah, you should definitely read Thomas Reed's work.
Okay, that's fair. That's what I was looking for. Thank you.
Mm-hmm.
What chat did you put those in?
They're in the live stream text, I would say.
Yeah, let me see.
Right around 23
minutes. 25 minutes after the hour.
Cheers. I'll have a watch. Thanks.
So we see in a sphere and things appear lower because of the way we see in the spherical nature.
We see in a spherical nature, and we have an additional lens that adds an additional spherical, more so curved, because hyperbolic visual space. So yeah,
I'm with the refraction part. I'm definitely with the refraction
refraction
part.
is not some
No
god
question.
that's been invoked to just explain everything without specificity like the Glovers do.
Jeremy, you're not allowed to have this conversation anymore until you watch the first video that I dropped at 25 minutes after.
All right, will you DM it to me, please?
I second that.
Will you DM it to me, please? Because I'm not.
Yeah, I'll DM all 4 of them to you.
The thing about this subject, though, that I don't get is that, like, I understand that at the more kind of technical levels when you're talking about what actually is the effect of like a specific kind of refraction or whatever. I understand there's debates there, but the idea that there's like you've either got occlusion or you don't, right? So that's an easy dichotomy. The atmosphere or atmos, whatever you want to call it, isn't perfectly clear. We'll know that. Like that's everyone here knows that, right? So therefore, you can't see forever. It's really basic stuff. I'm amazed that we even have to like talk about it.
Oh, I'm not doubting that we can't see forever. I would agree to that. I just don't know how it's making shit appear lower.
Well, according to the
they had
Euclidean
it
straw
right the
man, we
first
can see
time.
forever. So
They had it right the first time. It's an atmosphere.
it is actually, yeah, it's an optical atmosphere. Yeah.
The atmosphere,
Sure.
the way you see.
Yeah, it's an optical atmosphere. Yeah. Azimuthal grid of vision. Azimuthal.
Yeah, it's an atmosphere proven so by things like sundogs. Yeah.
Yeah. I don't know. For me, I think that the mere idea of this is pretty insane to grasp. If you think about if this is the case, dude, look what they did, bro. Like, it's pretty ingenious. Honestly. I mean, I'm not even like attributing intention. I don't know. I think most people just they were just taught this, and when people were first trying to figure out vision, we had some really brilliant minds say, "This is how it actually works. You guys are tripping," and they were just shut out.
But like you said, I don't know. I'll probably never know, right? Like, is it done by accident or is it just done by practicality? Because how else are you going to quantify these things other than just saying, well, let's just say that the light's coming in straight and the ground is curved. As long as everybody knows it's not really curved, but this is the way we can use it, right? But now people think the ground is curved.
So if you get a rectilinear lens, that doesn't spherical nature in it, or
yeah, it does.
Non-Euclidean.
Yeah, it does, dude. You sound like a baller, Jeremy. Man, you gotta come.
I'm just trying to think of what they're gonna say. That's all. I'm trying.
They're gonna say, "Nuh-uh. Show me the math. That isn't true. You're dumb. That's not how trigonometry works."
Valid things that definitely gonna say those, dude.
I'm waiting for Jeremy to drop his name change to Spheremy again.
Spheremy? Yeah.
Yeah, the funny thing about it is, to most of the Globers, if you don't have the math on paper, then what you're experiencing in reality isn't actually what you're experiencing.
Well, that's why when I provide the math, it's going to be like a really sad day for them.
Yeah, the funny thing as well is like when you talk to people who are like really well qualified in maths, they will tell you that yeah, you can sort of manipulate it however you want, and depending on the field they're in. So like this like over reliance on using maths as like a concrete backing for ideas isn't held by people who really understand maths.
Yeah, I actually have the exact same experience when I talk to like actual mathematicians. They openly admit this fact.
All right, so check it. One last thing, maybe not. I'm still thinking about it. If you stand on your head, then it would make things go in the other direction, right? Like if you were to stand on your head and look, things would be going down in your vision, but it would
It would be the other way to you because you're on your head, right? Like this
Yeah,
feels like something we could test.
your
We
ceiling
should
would
check this.
He might
your
have that
ceiling
might
would
be something. He might be onto something there.
well, your ceiling is now going to be the ground, right? So then you're going to have a very low ceiling within your visual field of view, and you're going to have a very high, actually no ground below you in the bottom
Yeah,
portion
but
of
are
your
things going to cross that horizontal line to the other side now?
Bro, I don't think you know what you're talking about when you say that at this point.
I understand. This is what I don't understand, right? So if I take my business card right here, I have a business card. Okay, I'm holding it up to my eye. Like it's pressed on my nose. I'm closing an eye. I take this little earplug and I move the earplug across the business card. The earplug just disappears from the bottom up. The business card is just flat, though. We just see different than physical, tangible reality. We see curved even when it's flat.
I'm not
Just
doing
like
any
in
more of
the
your experiments. I was walking around my living room with a cup held up to my eye earlier and saw nothing.
Did you not see that it looked like it dropped away?
I'm not doing it.
It's kind of hard to tell. I'll say it's not the easiest thing that maybe.
I don't
I mean,
even
is
know
that
what you're
right though? You could stand on your head and the ship wouldn't sink. It would have to appear to go higher, right? We're standing straight up, vertical right now, and things are sinking because of the spherical nature in which we see. All right, things are appearing to sink.
Yeah, sorry.
Yeah, so
you would
if
see
you
the
stand
straight
on your
view.
head, what's up? I'm saying if you stand on your head, wouldn't you see it go the other way?
No, the same thing is going to take place. The exact same thing, just upside down.
Yeah, so things would be higher than the horizontal.
What?
If things are sinking, if things are crossing the horizontal line because of this, then if you stand on your head, I know this sounds silly, but if that's the direction that it's making it go in is down visually according to you, then why when you stand if you're standing on your head wouldn't it go the opposite way?
Would you expect it to do anything different than what it does? Just
No,
upside
I
down?
would expect it to make things appear lower. If you're on your head, that would be higher.
What are you talking, dude?
Bro, things are appearing lower in my vision because of the way we see. Then if I stood on my head, why would it not still be doing the same thing? It'd be going the other way.
You're literally just flipping the image. Everything is doing what it normally does, just upside down.
I don't know. I don't see how this non-Euclidean way we see helps at all. I might be missing something, but I don't get it.
Hey man, I got a business card in my hand. Okay, I'm holding the business card up to my nose. I have a little earplug on top of the business card.
Jeremy, I'll give you $100 if you stay on your head and do this. Whatever he's describing. $100.
When I move the earplug down the business card, what happens, Jeremy?
It's going to disappear from the bottom up.
Why?
I mean, that's just, I don't know. I think that's how it works due to like angular size and shit. Same reason why we can't see the chessboard when you put your eyeball to it. Like the shit that's so close to the ground, the angle of it is just getting too hard to see now.
Okay, now if I just kept on moving the earplug out further and further, but I kept the business card still, meaning that the earplug is going to go way further out than the business card is, right? What's going to happen then? What's it going to look like the earplug's doing?
Yeah, I'll watch one of them videos, see if I can figure it out. If not, I'll come back.
Earplug's going to look like it goes down below the business card, bro.
Have you debated anyone on this or no?
No, I haven't even like really fully brought it out. It's been busy. We're on Discord just in them out, but I've just been like trying to
All
set
right,
up
so
this.
I'm lying. I'm trying what you're saying. So I got two remote controllers in front of my face now with one eye open. So am I seeing? Am I holding them at the same level, right? And then in my left hand with the left TV controller, pushing it further away from the one in the foreground. Is that
If
working?
that's what you want to do.
Whatever. I gotta do it upside down.
I mean, I don't know. I think that the flat surface is really beneficial on this small of a scale. You can see that the whatever's on your little flat surface looks like it's disappearing from the bottom up. Okay, so we need to figure out why. I mean, why does it do that? You can't just say angular size. Jeremy said angular size. Well, angular size, we're back to talking about how the eye see and what geometry to use. So that's my point. That atmosphere doesn't explain these visual, like this visual phenomena.
The angular size is all in line with perspective and shit.
Yeah, this is our version.
You mean if y'all just draw a straight line out from my eye infinitely?
No, I never said we could see infinitely. Absolutely
Okay,
not.
but I mean
I
that's
don't
what
go
we're
with that.
doing hypothetically. Like to do the geometry, we're just drawing a line out from our eye infinitely.
Yes, you draw a straight line out from your eye infinitely at your horizontal.
Okay, now in reality, we can only see so far, right? So at that location that we can no longer see, what is it going to look like? Like you have your flat line, and then you have that area where you can't see past it. What I'm trying to tell you is that area you can't see past it anymore. The line keeps going, right? But now you can't see past it. It all curves down into a central point from all angles. Everything curves down and converges into that point. Does that make sense?
You're saying it's all curving into this point?
Yeah, that's how our eyes see. That's how telescopes see. That's how a camera sees.
Well, you should lead with this one next time. Whatever you said to me just now, lead with that because that made more sense than everything thus far.
Well, how about this? Yeah. So, Jeremy, you're out in the country. Think of a rural state in America. What's like a really rural state?
Like upstate New York.
Is it rural in upstate New York?
Yeah.
Some parts, yeah.
Oh well, we can compare New York then, because I was going to use New York City. So in in upstate New York, you've got loads of land. So let's consider land to be like detail that you can't really see, and it's going to be easier to see like a single house, right? Whereas in the city of New York, you've got houses, skyscrapers, everything everywhere. So there's a lot more stuff competing for the same space. Right? Yep. So the further from your eye you go, the more like New York City it gets. The closer to your eye, the more it's like upstate New York.
Yeah, so like what does all that information do when it's all at that same horizontal, all at that same line? How does it decide what goes higher and what goes lower now? Yeah.
Well, it just gets shoved. It just gets mashed together, doesn't it? That's why it's hard to make it out. Like that's the visual effect that you see is just a mashing together of all these different things.
But when you have a really distinct difference in color, you have something that's like a black mountain against the white sky.
So if we had a line out from our horizontal going straight out into the distance, you're saying it would appear to get lower because of the focal point in our eyeball.
Focal point, yeah, like a specular highlight.
Like everything's going towards this point. Everything's trying, and everything you can see is trying to go towards this point in your eyeball. Yes or no?
Yeah, the light is trying to reach your eyeball, if that's what you're asking.
No, the center of like this one specific point inside your eyeball.
I don't think that's really a functional difference, the center of your eyeball versus the eyeball, because they're both points that the light is trying to reach.
I can't hear you. Are you at the club?
No, I'm just in the pub.
I don't know, but it's making the ship bend somehow. So like it must be trying to get towards like the center of your eye, or I don't know.
I don't think it is bend. I mean, I don't know if I know what Witsit was saying, and I know he used the word bend, but I actually don't think that's really what he meant. He was trying to get you to understand, right? So the way I look at it is to use the New York upstate versus New York City analogy again, right? So let's just say that there's a single pixel of light that's trying to reach your eye, and you've got a piece of information that's much closer, and you've got many pieces of information that are much further away, but they're taking up the same pixel. Well, the eye is just going to resolve the closer one because it's easier to do so, right? Does that make sense?
I don't like this whole. You're losing me on this whole analogy thing.
Is anyone else having trouble with this?
I'm the only one that doesn't get why things are bending down because of this the non-Euclidean way we see.
I didn't say bend.
Well, appearing lower or whatever.
Well, so you're saying then, Jeremy, that a line that I produce right here, an inch from my face, should and will always match a line that's 100 miles away.
I'm saying if you draw one out straight from your face, it's never going to cross that level line, the horizontal line. My bad. If you were to just draw a line straight out from your face, as far as I could see, and there was no refractive effects in the atmosphere somehow, then that wouldn't cross the level line, the horizontal line. I don't think. I mean, I don't know. I could be wrong.
How thick is the line once it's now being projected 100 miles out? Like, how thin does the line have to be in the foreground to determine whether something's dropping above or below it?
I mean, if it is, if you could see it dropping or getting higher or lower, then you'd be able to measure it. Remember, it doesn't even have to be an actual line. You could go coast to coast. Most of the time, there's a dip.
A dip in what?
I think due to an optical effect that's happening due to the atmosphere and shit. So
you go coast to coast, and there's a dip in what?
There's a dip in the other coastline. Usually, not all the time. Sometimes the horizon's higher than the horizontal line. That's got to be an atmospheric effect. No, that can't be the way we see. Like I don't know.
Well, I said the other day. I also said the other day, in regards to the oil rigs, right, on the Black Swan, they are in the Pacific Ocean, the Pacific Ocean, the one with the least amount of waves in the foreground, the calmest ocean of all the oceans. That's where the long distance observations are mostly made. But over the Atlantic Ocean, like coast to coast, like you were saying, right, with the very rough waves and large waves and in the foreground, you can't make the same long distance observations. The difference is one of the, not the only difference, but something that you could put down is the intensity of the water on these different coasts. So, I mean, is it dipping down or is it just more intense on the other side?
You're talking about Atlantic observations from Pacific?
Yeah.
It could be the atmosphere, it could be the amount of turbidity in the air. Who knows?
Right, those are also factors, but just coincidentally, like I was saying, where the the oil rigs, the Black Swan oil rigs are viewed over the Pacific Ocean. It's called the Pacific, it's passive, right. So it's a very calm. It's one of the most, it's the most calm of all the oceans, right? So you can.
Well, that is
so
where B-Ball. That is where B-Ball's doing his observations. Where he gets very little movement, let's say, in the objects, the building that he's looking at all the time.
Yeah.
And that would make sense if you have less choppy waters, if you're throwing a lot of water in the air. I mean, what's that going to do to your visual, to your visual, what do they call it? Optical field? Shit.
Resolution of the image.
What's that going to do for what you're seeing? If there's now a shit ton
Yeah.
more water in the air, turbulent air, you know,
Yeah, turbulent air. Yep.
or water in the air. Even I don't, you know, because when you have waves like that, it's throwing up chop. Have to imagine there's some water, like liquid water, tiny molecules going in the air and shit. We already know
Sure.
solids and liquids float in the air because they're in fucking clouds. So
Yeah, I thought B-Ball was in Florida. He's in California.
he's in Hawaii.
Oh, Hawaii. Oh, yeah, that's right. I'm thinking of some of his pictures, and I thought some of his photos were from Florida. I guess it was.
Like they don't get a big tide. I don't think they get a big tide there, right? Isn't along the equator some of the low? Like, don't they get crazy high tides usually in like Alaska, shit up north or down south? Like, not really.
Listen, they get
That's
tsunamis.
equator.
I'm on the East Coast. I don't get tsunamis. They get They can get wiped out. You know. So I mean, I know it's in the Pacific Ocean, right? But it's I don't know. It's little islands. You can see. I mean, Hawaii should be an easy, place to be a flat earther. You can see your whole. You can go to the top of a hill and see that see one end to the other end. Yeah.
Yes, that's actually an elevator.
What? Yeah, I had a lot of family and friends who, well, a little bit of family, a lot of friends who stayed in Hawaii. They all felt stuck. They all wanted to get the hell out. It's like the same thing every day. Chop fish for a living, I guess. I don't know what people do there, but I don't know. I can't imagine wanting to live there for my life.
I mean, I don't know. I live in the Northeast. I wouldn't mind living somewhere where it's a stable weather pattern.
Yeah, but I also don't want to see the end of my world, like at all times. Be like, yeah, this is my cage. Awesome.
What do you mean? What do you mean?
In Hawaii, you can see all the islands from one vantage point. You can see there's nowhere to go.
There's places out there. You can go to.
No, yeah,
No
you can go
places.
into the ocean at some point. I'm saying you can get to a vantage point where all you see is the ocean surrounding you. Yeah, I don't want to be there.
Oh, I hear what you're saying. Yeah. You feel trapped.
Yeah. Yeah, like my brother went there. A lot of people I know and they stay there for a long while. It's a different kind of. You would probably like it actually because it's a lot of trades, not a lot of cash being used. People would just it's like a communal kind of life a lot of the time.
Yeah. Even trading though is a tough way to go. You got to get rid of that whole idea and concept of I have to get something for this. Like we gotta look at ourselves as like, team humans and work it out.
That's how they are there. I mean, according to all the stories the people I've talked to, I still know a couple. Well, I know that my friends keep in touch with a few people there, but that's how they seem to be. A lot of if you get in with that crowd, yeah. It's not really about what can you do for me. It's just that they'll say, yeah, you can just sleep in my yard, or you can sleep in my house. I got an extra room. And then you say, yeah, oh, that's awesome, man. Is there anything I can do? Yeah, I'll do stuff. I'll grab this for you every morning, and they just kind of work together. Yeah. And they're strangers a lot of the time. Yeah, a lot of times it's strangers, and they kind of like rope you in or bring you in or whatever. Yeah.
As long as we have any kind of monetary system, even if it's barter, you're always going to have the corrupt the corrupt shit going on. You know, if you get rid of money completely, I mean, I'm not saying you get rid of corruptness altogether, but if you can't hoard all the gold or all the goats or all the dollars, then I mean, you know.
That reminds me of the subject. Did you know there's I don't have all the information, I just heard it in passing, but apparently there are golden strands that look man-made, found in Antarctic ice and in different places around the world that seem to be like a strand of man-made gold, very long strand.
No, I
Ever
never
heard
heard
of
of it.
that?
No.
Yeah.
This one guy's argument used to be like, you know where gold comes from? He's trying to make an argument it comes from the center or something. I'm like, I don't know. Humans have made gold out of mercury. Other than that, I don't. You don't know either. I don't know what kind of argument that guy was making. He was weird.
Speaking of, so hey Gary, you there on your mic?
Yeah, I'm here.
So Witsit was making the argument that we see, since Jeremy's here in the room, he's making the argument that we see in not in Euclidean but spherically, right? Like we see spherically, and Jeremy was curious, or maybe wondering what, if or why do we see things drop from the horizontal in the distance, or do we? And is it due to just the atmosphere, or is it the field of view and the way we see? I told him you might have some input on it.
I don't think things drop. No, I think I think what they call drop is, and I could totally be misunderstanding them too. So it's just my opinion. I think when they zoom in, they think things are dropping, because you'll see like if there's a ship that looks like it on the horizon, and then you zoom in, it'll look like it's now lower in the field of view, and you can see the horizon behind it. And I think, I don't know, maybe that's what they consider drop. I don't understand them half the time. So I think if something's at eye level and it's close by you and it moves away, it's going to stay at eye level. That point will stay at eye level.
That's
and
what I think too.
It converges just like
However,
railroad tracks do, right?
I think you were wrong on your first point, though.
Which one was that? I could be wrong on a lot of things. So which one? Which one? Did I lose you guys?
No, I hear you, Jeremy.
Oh. No, I mean, we all have our own opinions, and I listen to everybody and form new ones sometimes. And
check.
Yep.
Yo,
I hear
things. Okay, I agreed with your last point. If you have something at level, it'll stay at horizontal. It'll stay at the horizontal line, right?
Yeah.
All right, but your first point. Was about shit. Why can't I remember now?
He said when you zoom. Well, he did say when they zoom in.
Oh, things aren't dropping. Yeah. So we definitely got, optics over very long distances of shit definitely dropping. Like, we're seeing stuff. They're making, using auto levels at 30 miles, and we're definitely seeing stuff lower. Like,
no, you're just seeing the gap magnified, because the gap with your natural eyes you can't see, just like railroad tracks, right? They look like they're merging, but they're not. But you can't see in between them after a certain point anymore, right? That's where, and then it's usually right where the horizon is, and it's the same thing. But if you look through like one of those auto levels or whatever, it's got the little sights in them or whatever, but it's also it's a zoomed in image because they have magnification. I'm not sure what level they go up to, but so it's just a set already. And so I think what you're just seeing is the crosshairs over the horizon because the gap is magnified. Whereas with your natural eye, if they could back off that zoom on there, that little sight would end up blending in with the horizon again.
I don't know, bro. They're zooming in and seeing you. I mean, with whatever
they see
the auto
gap
light
that you couldn't see with your eyes,
bro. But
that's
when
my
you,
opinion.
But when you zoom in,
I could be
dude,
wrong.
we're seeing like the 17th story of buildings at the horizon. Like, there's no gap.
They're
in
just
between
those. Yeah, those buildings are just way beyond the limit of your vision at the surface. Things just start getting cut off. You got a limit based on your elevation to the surface. So once they move past that horizon, they just keep getting cut off slice by slice. See, they fool us with all the zoomed in images. Oh, how can this big building and half of it's gone? Well, that big building, you can't even hardly see it a lot of times on the horizon. It looks just a little dot. And it's like, and boats. How many times do we see boats that we can you can't see with your natural eye. But they can zoom in on them, right? And then they'll just say, "Oh, that's because it wasn't over the curb," but you couldn't see it. So, according to the people from old, that boat would have been over the curb, right? The zoom is really I think it's confusing everybody on both sides. It takes away from what you naturally see.
Their days of old argument is these things would disappear over the curve without changing in size.
Yeah. They would just say, and back in the Greeks or whatever, they would just think something disappeared bottom first, but they couldn't have any way of telling what it was actually doing. They didn't all have telescopes and P900s, or whatever. So, but now you can sit there. I've got several videos. You can see where they were zoomed in on a boat, and there was distinguishing marks like at the bottom, like a red bottom. And you can see when they back off the zoom, the bottom is the first thing that becomes completely unresolvable, while you can still see the top poking up. And then as they keep backing off the zoom, then it just all dissolves into that vanishing zone. It's just a limit of angles.
I don't know. I've seen way too much stuff appear in a drop in the distance.
But that's only because they're way farther out. They're sliced off. There's just nowhere for that information to be recorded in your eyeballs. They can't. It's I literally call it an
stuff's
optical.
dropping below. Hold on. So stuff's dropping below the horizontal line because there's not enough room. That doesn't fall.
The only reason you even see that gap in the first place is because that has a zoom on it. But the thing is, the buildings in the background, they're way, way, way further than the horizon. And so they're just cut off visually because you just have a limit. That's why a lot of times if you have a camera and you can go up in elevation, the scene completely changes. And that horizon that was close by now is much further out, and you can see much more of the building. Elevation, it's just a limit of angles. And the limit is based on what information you can see at the surface. Just like you go out to the beach and you see the horizon and it just looks like a smooth line, right? But there could be 5-foot waves out there, or even bigger, but it looks like a smooth line to you, right? And of course, you can zoom in on it and you can see waves. You can identify them if they're close by. But it's just like anything else. That the horizon is simply just an optical limit of what you can see at the surface, and so 5-foot waves can be cut off at the horizon. A 6-foot wave, that's another, couple hundred yards beyond that. That it's going to be even more smaller in size, and there's not going to be enough angle over them to see it. Well, that's no different than starting to cut off the bottoms of ships and boats that are past that limit. It's the same thing. It's just portions become too small. The whole thing is shrinking, but portions become too small and can't be resolved as separate from the water line, and it just looks like it's cut off in half.
Yeah, but that wouldn't make things appear below what you're saying wouldn't make things appear below the level line.
No, the only reason you see any kind of a line there is with the zoomed in image. You don't see that with your natural eyes. They're not dropping. They're just, everything is converging to the horizon. The horizon it's obviously it's below your eye level, because if you're standing 6 foot, there's a 6-foot gap out there, but you can't see it. It's too small. That gap shrinks in your vision. And so that you can't see that. And that's the same with the bottom of the ship. There's no different than the 6-foot cut off on the bottom of the ship. And the farther that ship moves out, the smaller that ship gets visually, and more gets cut off of the bottom, because the bottom is nearest the surface. So it's always going to cut off.
Yeah, but that's never going to, you're describing perspective, and that's never going to make things cross the horizontal line. Things don't.
They're not dropping horizontally. They just
there are
aren't.
things below the horizontal line. Yes, there are.
No, they're not. They're not.
Never
beyond,
seen
no,
it.
that.
You've never
Yes,
seen things.
they're beyond the cutoff level. You just simply, there's nowhere for your vision to record that information once it's so far past that horizon line. Things start getting cut off bottom first because of Rayleigh criterion effects. It's compression, Rayleigh criterion. The bottom is always nearest the surface, so that cutoff is always going to happen at the bottom first. The whole thing.
Hold on, real quick. You do realize that the horizon is below level, or below horizontal.
Yeah, I said that.
Times, right? Okay.
Yeah, I said it's always. The horizon's always below.
So we're definitely seeing things. So if we see
your eyes.
So if we see something at the horizon, and there's a giant building being cut off by the horizon, is
No, the
that
building is
part
just
that
way
17th
further. The horizon's
The,
close.
bu-
Remember that.
the building
that
is
17th?
past the horizon, Jeremy. The
Yeah,
horizon
but
is
it's
always below you. You're always standing above the water or whatever. It just appears to rise up. It doesn't. But when something's past it, that's what I've been trying to say. When something's past
Yeah.
the horizon,
Yes.
it's actually in its original position. It's cut off because the horizon that appears to be higher is cutting it off. It's a visual thing.
Yo, we see
Right. And the
the
horizon
horizon.
itself
It's
isn't at
below.
it always appears to slant up because of the angles. It's like you can point at the ground in front of you. Now point off of the ground in the distance, and your arm is coming up towards eye level. The ground is always going to take up the whole bottom half of your vision, and generally it's close by. So once things move beyond that, those things are all getting smaller and smaller too. They're compressing, and like I've have a couple videos where you can literally see there's like a red portion, the bottom of the ship, and you can literally see it getting smaller and smaller where you can't resolve as it's moving through that zone. It gets smaller and smaller until you can't make the difference between that red bottom anymore and the horizon line with your natural eyes. And so it's just compressing, Rayleigh criterion, 2 points of light, which would be like the red portion that's now too small to resolve as separate from the water line. The water line's
What
one
if you,
point, the red portion's another point. You
Hold
get
on,
that
man,
that
bro. You
that
got to You got to
space.
try to be more concise than this, please.
No, that
I'm
angle,
dying
it's
to get
hard
it.
to, it's
I
not
know.
hard to understand when you actually see it.
I know, but
Rayleigh
there's an
criterion is just
objection
2
with all of
points.
this.
When they become the separation between them is too small to resolve them as separate anymore, and they just keep going, and more slices off that bottom.
so
Well, the
like
whole thing
that's
is
6 feet.
shrinking.
That's if you're
We'll
at
take a
6
break.
feet, right? And you try to zoom in on like the 6 feet, right? But then what if you elevate to like say 100 feet to the top of a really tall hill? So then are we always trying to magnify 100 foot from the ground, and then that drop then would be more or appear to be more severe in a longer distance.
Well, the horizon still rises, but you can't see forever. So then you start getting into, depending on the object and the light source and all that, it's just blurring. It's just merging. The sky and the ground, or the sky and this. Go ahead, Jeremy, because I know you're trying to get in.
Thank you. I'm dying to get in, bro. Dying to get in. So we're looking out. The horizon is below horizontal. Building at the horizon. We can see that this, 17th floor is also below the horizon. Like, I don't agree with the statement that things aren't dropping below horizontal visually.
No, that
Optically.
building is not at the horizon. It's past the horizon if it's being obstructed or appear to be obstructed.
Wherever it is, we got the 17th floor below horizontal, right?
Yeah, but the 17th floor is 16 miles further than the horizon.
Okay, that's fine. But this guy's saying shit's not dropping from horizontal. There's no
Well, what he's saying, it's not dropping. You're exactly
It's
right.
just compressing into that vanishing zone.
Dude, stuff is below horizontal. That should be above horizontal.
Oh, Jeremy,
But
what
it's not
convinced you of that?
actually.
Is it only George Hatchnook's thing that you're going off? Like, where are you coming with this? Is it just George?
I'm talking about B-Ball's thing right now.
Okay, I just wonder where you got.
What he's saying is in the crosshair is at one height, and the building in the distance, the crosshair is 8 feet off the ground, and the building in the distance where the crosshair is hitting it from 20 miles away is at 100 feet, and he's saying it's a blow. It's not. The crosshair is an inch away from your eyeball, and that floor of that building is 20 miles. It's
I know,
totally different. You can't compare the two.
So just optically, visually, over long distance, below the crosshair, shit is dropping below horizontal sometimes, right?
No, it's not there. That's the illusion part. It's not actually below those crosshairs.
I'm not saying it's actually anywhere. I'm just saying visually, optically, it's happening.
Okay.
That's all.
I will agree with that. It also will appear sometimes to be above the crosshair, which I
know.
I
With the George
honestly,
thing Gio
people
just brought up, yeah.
Yeah, but people fight me on that. I brought that up way before George. I'm the one who took that picture of George snapshot because everyone was calling me stupid for 2 years.
That was a great snapshot, yeah. Didn't somebody else do it too?
No, yeah, Ruhif did it over the salt flats or something like that, but you can't find his picture. He'll never show you. But I badgered George for years, and I was sitting on my boat in my chair. I can remember like yesterday. He posted it. I took a snapshot. I said, "Got you," because everyone said that my stuff was, or what I was saying was a lie. When I shot the Marriott, and it appeared higher in the crosshairs than what it should have, everybody thought I did something wrong, right? And when I kept asking about it, they said, "No, that's not possible. It's not possible," right? Zanuck for years said I was an idiot for that, and then George showed it. I'll
Well,
be
they're
honest
still
with you,
down.
Dev still says it's not possible, and I disagree with him on that. I saw it for myself. Now I might have had it set up wrong, and George might too, but it's definitely showing the horizon above the crosshair, 100%. What I saw, what George showed, what I took a snapshot of, was definitely the horizon above the crosshair.
Well, it makes me think of
However,
that. Makes me think of that Skunk Bay footage and other footages as well that are time lapse, where you can see like the horizon's literally wavering. You know, it's going up, down, almost like like a wave in the ocean. It's like wavering. So if that's the case optically because of the refraction occurring, then of course, if you had a auto level that was shooting at that, it's going to be going above the crosshairs, below the crosshairs. You know, both of those.
Yeah,
but without the refraction, I was curious. Like Gary was saying that. All right, so when we're on the edge of the beach, there's 6 feet between you and the ground, right? So you're always trying to zoom in on that onto that 6 foot difference, right? That 6 foot gap, right, of where the ground actually is. And as you zoom in, you can see the horizon change, which is just an optical rise. So then when you elevate to 100 feet, now are you seeing this? Now, how does that translate with the? Now you're zooming in on a 100-foot gap.
You said that earlier, and I don't know if someone tried to answer it, but distance and viewer height, of course, matters. But when I said you can't see forever, that's an effect of that. You can't receive the information. When you go up 100 feet and you're seeing 50 miles, you're not receiving all that information. There might be something at 20 miles that's way up, in your eye line or line of sight that is just faded out. It's too small to see.
Bro, are you on an island right now?
I'm definitely on an island.
Your mic's getting a little. We can hear you, but your mic's getting a little crackly or something.
Isn't everybody on an island, if you really think about
it? Some are just bigger than others.
Yeah. And Jeremy, feel free to take this argument, man. I know you're running out. Just use it as But I've been saying for about a year now. Now, I might be using some of the terms wrong, but when that horizon, now think about that, it's double, right? Not only should the water at your feet be going lower than your feet off into the distance, it's not. It's appearing to rise up. So that's double, right? If it's rising up at 8 inches per mile square and it's supposed to be dropping at 8 inches per mile square, you got yourself a little conundrum there. I call that an optical illusion. We call it the horizon. But that's not the actual position of that water. The water is actually 6 feet if you're a 6 foot tall man below your eye line. It's
I've always said the first thing you see when you look out at the beach is an illusion, because we know that the water's not getting higher. We know the water's not almost up to your eyeballs or whatever, so.
Exactly. So it's actually supposed to be below your feet on their model. It's curving in all directions away from your feet if you're standing on water. If you make a platform that's even with the top of the water in all directions, 360 degrees, every millimeter that water is curving down or going below your feet, however you want to put it. But yet optically, it looks like it's rising towards your eye level at any viewer height, basically, until you get to where you can't see far enough to actually see the horizon. What you're seeing is another optical illusion called what do they call it? The horizon dip or whatever. That's not Earth curve. That's an optical phenomena due to altitude. You're seeing the clouds in the sky. I can show you a picture from 24 miles away where the sky is below the building.
That's what I'm saying. This shit is because of fucking optical effects or something happening in the atmosphere, but I don't think it's because of the way your eyeball is.
Well, it's just an illusion. Your brain is being tricked. You're not receiving all the information due to, you can name it whatever you want to name it. But all the information's not, the reflected light or however it works is not getting to the back of your eyeball, and your brain is not able to interpret it right.
even when that information sometimes reaches the back of your eyeball, your brain misinterprets it and creates optical illusions. So why wouldn't you think when information is missing that optical illusions are being made? Hope I'm not yelling.
It's probably because we see in 2D. Yeah, you got to stop yelling at us, bro.
Yeah,
You're
I'm
like
on my truck
screaming.
mic,
No,
so
it's fine.
it amps it or something. Like, I'm definitely not yelling. I'm just in my truck.
No, you're
When
good.
So you understand what I'm saying? Like I said, I've been saying that perspective view, once something goes past the horizon, of course it's going to appear, in its actual position or close to it. And the horizon is higher, appears to be higher. So it's obstructing it. It's blocking that information. Reflected light is not getting back from the bottom of the building, but is from the top because of the angle difference. And way
Question
perspective.
of the day, though, is that because that's how your eyes are seeing it, or is it strictly because of the atmosphere?
I'm saying it's because of the
I
atmosphere.
think it's more than, I think it's everything put together. You ball it up into one, squish it around a little bit, mix it together with a blender, and then your brain goes blah, right? I can see the top of the building because of the reflected light doing this and the angle. But when the sky and the ground's trying to merge, the bottom of the building is missing because of the same reasons, right? The angle, the distance, the viewer height. There's more dense air. I don't disagree with them. The density layer lower to the ground is more dense. I mean, it's a thicker medium. They say that's not what the dense layer means, right? But it is. They're talking about pressure affecting the light, but it's also medium based, right? There's more particles, there's more dust, there's more, whatever. Jeremy, take it over. You know my argument.
Atmospheric turbidity, it's called.
Turbidity. That's the name. I can't spell it.
No, you got to say atmospheric. Atmospheric, because there's a turbidity thing, but it's water. But it's atmospheric turbidity, yeah.
It's turbulence. I mean, come on. You look behind a jet plane, the exhaust turbulence. It's the same thing happening to gases and water vapor and blah, 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 which is the same thing, thanks to, anyway, what was his name? That said toilets flush in different directions, different atmosphere. I'll never forget that guy.
Yeah, first time I went on Jose's. Dude, that was B-ball.
Yeah, no, not B-ball. It's the other guy from Georgia where he said he could see 7 states from the tower I went to in Tennessee. Anyway, what's his name?
When I first went to Jose's, one of them guys was trying to say the toilet thing. I'm like, dude, no way.
It's the one SE always.
I should have known right then not to fuck with them guys.
Yeah, just leave them be, right? They think their toilets are flushing because of the spin of the earth. They walk to one side of the house, right, and the toilet spin one way, and walk to the other side of the house, toilet spin in the opposite way because you must live on the equator. The arguments have gotten ridiculous. I don't think anyone's ever going to figure everything out, but you just have to use a little discernment and say, yeah, I can look over this body of water on one day and I can see the damn building over there or the beach. And then the other day I can't. Like it's not even blurry. It's gone. Like come take a ride on the boat and go 10 miles offshore, right? Everything just merges together and looks like sky at some point due to visibility. Well, that water tower and that bridge is still there and it's above the water. It's not Earth curve. You haven't gone far enough. So why aren't you seeing it? Well, you're looking through a thicker medium. The longer you go, the more of that medium is you're trying to look through. So that even makes it thicker, which they fight against that too, which is ridiculous. Like that doesn't make any sense. Of course, the longer distance it is, the more medium you're looking through. I mean, how can you fight against that? I'll be here all week. Tip your waitresses. I love this conversation like this. I don't know why. This is my this is what I started with.
This was your come up. I remember that in Gems, and then you got all your other shit for me. I remember that,
yeah. Yeah, your memory's bad. Stanley showed me that power line, and visually I said, shit, that looks like a small curve to me, right? Which is what it shows, a really compressed small ball curvature, if that's Earth curve, right? And then told us he could see it with his naked eye, although he took pictures with it through a telescope and blah, blah, blah. And then when I went out and shot it, I saw the same thing. I was like, holy shit, the water does curve, right? Oh, wait a minute. Water doesn't curve. Like, something's got to be going on. You know, water doesn't curve, right? It definitely doesn't curve that much. They're telling me the Earth is really big, so that wouldn't look like that over that big of a Earth. It would actually look flat, or it would look like it's rising up, right? Due to perspective and other things. Instead, we see it curving like it's on a basketball. And some guy named Soundly is saying that's Earth curve, and then 1,000 people are backing him up.
Bro, I should sound like Wikipedia or something.
Yeah, because they push it, man. It's like, how can Neptune be at the top of every Google search when you try and Google something? Who's Neptune again? Can he fix my AC is what I want to know.
Yo, the way I see it, them dudes we were up against at Gem, Zanuck, Robert, like all these guys, Kosho, these guys got to be way better than McToon and Fight the Flat Earth. Them guys been debating like these crazy no-name people no one ever heard of for years now. You know what I mean? It's just people they get off of like Facebook and Twitter who no one ever even heard of them. Kosho and Zanuck.
Anybody that can take a subject that they've never heard of and in 5 minutes become an expert like Kosho does, not dogging him, right? This is actually what he does. That is amazing.
No, I know. He's real time. He's like he'll learn it in like real time. Yeah, it's pretty. I've always said he's one of the top globers, not because he's smart, just because he's, he's good with the arguments, the slick fallacies they try pulling. He's got the Google on the fly. Like, that's huge. If I had Google on the fly, while I was debating these guys, that would make me way better.
I'm convinced he is Google. Why wouldn't he be?
I don't know. I always tell people, I'm like, yo, whoever you're talking to, that could be Kosho. You never know.
Yeah, that machine in your house is, you ask it any question and it tells you the answer. Kosho. Now, you know what I'm saying? I actually think I've heard some things that Kosho's saying lately that's making me think he's questioning, at least on the outer scale of questioning things. I think he just needs that breakthrough moment where he goes out and does his own, okay, I've been taking all these angle measurements to lights in the sky. We know that light does this, or we think that light does that. But what if I could go out on a weekend and take a very easy, well-engineered tool and use it to create a straight line segment over distance enough to tell me if whatever's under it is curving or not, and actually do that test? I don't know why people shy away from that.
That's what we got to do, except not the way you did it. We got to only use level at that one middle point.
Right? Do it 1,000 different ways. I don't care. Just mark down your method and tools used. I'll go do it.
All right, bet.
Yeah. But don't tell me to point two theodolites at each other and measure the angle. That's moronic.
Are you still cool for taking angles to the stars with your theodolite?
Yeah. If anybody asks me,
you told me you were going to survey the stars for me.
That's worse. Straight lines. Take 3 straight lines, 3 different points up in the sky and a baseline, and call it not a triangle.
Yo, Moyak legit. I think this is it is an optical way, obviously, the thing Moyak's got. But it does solve both the people's issues. It solves our issues and their issues. Like, we should do this, dude. I'll fucking start a fundraiser. How much money you need to do this?
To do Moyak's adjust the legs? $1 million.
Come on.
Bro, that's moronic. I don't even think you see how, but it's terrible.
Come on, $1 million.
Yeah,
Larry said he could do it.
Pointing out to you how ridiculous it is.
Bro, Larry GPS said he could do that shit in like 2 weeks, bro.
Damn, how many weeks has it been? I hadn't seen that.
I mean, he didn't do it. Yeah, he said he wants to get funded and shit. He needs a team of guys, all kinds of shit. Money for hotel rooms.
Larry, is that the guy that shot the building foundation over 2,500 feet and got a half-inch or a earth curve in the concrete? That guy?
Yeah, that's probably him. Yep.
Yep. Good luck with that.
That's why you got to be there. We get both of you guys there. All right, you guys can touch tips and hang out and do this measurement. It's got to go down like that in the future, bro. I mean, where we're not getting anywhere with words and definitions and citations.
Where you want to go?
I don't know. Somewhere.
Where do you want to go, man? I don't need Larry. I don't need more yacht. I mean, I'm not trying to sound arrogant. This isn't hard. Like these ways to use these tools to create a straight line segment over distance are well established. You don't have to adjust the legs every time either. Just follow the planar surveying rules of creating a straight line segment over distance to measure what's underneath you. I mean, if what's underneath you is the surface of the earth, I still haven't seen that. I've asked them to bring me to that point. Oh, this point is here. Okay, can we meet there? That 2D place you keep talking about in your
That's how we see.
Yeah. No. They call it a 2D point. Well, can you grab some dirt at a 2D point for me? Can we go there and meet there and touch tips like you want to? No.
Well, you said the straight line, but I don't. Rumpus told me in the surveying world that flat means curved. I'm not even lying, bro.
Because Rumpus is ignorant to the surveying world.
He told me in the surveying world flat means curved.
No. Flat, level, and horizontal means all the same thing, not curving.
Well, and then I asked him, what if there was actually a flat spot? What would they call that? He was like, impossible. There are no flat spots. I'm not joking, bro. You can't make this shit up.
He has to say it. He has to say that. How else would you measure? Yeah, the abyssal planes aren't true. They're still curved, right? I mean, they're not curving. Like, you can't measure the curve of them, but they have to be curved, of course.
So, where are we going? Like, seriously, bro, where are we going?
I'm going home.
I mean, you know what I mean. Where are we going? It's 2023, bro. Where are we going this year? We got to do something, man. I want to send cameras to the moon, all types of shit, dude. How flat are the salt flats? Or how level or whatever? If we could get busy on the salt flats, we need like 50 miles. How many? All right, Rocky, let me ask you this. You should never snap a line. I'm guessing the answer is yes. How far with another guy snap a line per day? Me and you were out on the salt flats. How far do you think we could snap a line? Miles a day. Did I disconnect? Did you guys fall asleep? Yo, mic check. I know you guys can hear me. You give me the
You're hot micing.
No, not hot micing. How many miles of, if we had to snap a line on the ground, you snap a line, a chalk line, how far do you think you could snap a line with another dude in a day?
I don't know. I'd have to think about it. I don't know. I popped lines today, cut anchor bolts. We did 400, 500, 600, 700, 800 feet pop lines in 30 minutes. Is that what you're talking about?
Yeah.
We had a horizontal plane, and we had a chalk line.
No, I was talking about snapping a line. Yeah, chalk line on the ground.
Yeah, we had a chalk line, and we measured 26 feet to start off on either side, and popped the line across 100 feet. And then we went 26 more feet, and then 22, 22, 22. So, because we were having to cut joints in that plane. So
Would you say your
basically
line? Would you say the line you make when you snap a line on the ground is vastly straighter than the line you make optically? No, I'm not talking about up and down. I'm talking about left, right. Auto levels.
I'll tell you the trouble. Because if I would say no, I would say the line that's above the ground, not touching the ground at all points, is straighter, left to right.
Think so?
Yeah, because it gets on the ground and it has friction. So if it gets, you have to you have to lift it, and then every time you do that, it's in a different spot. So it's kind of telling you it's not perfect.
So okay,
But if
you had to.
if it's in the air.
Oh, you're saying hang the line above the air?
Yeah, above the ground where it's not touching the ground, but it's like at those points. I don't know how else to say it.
No, if you were
Okay.
gonna stake out or make a straight line somehow, you could stake it out, use the laser, whatever you want to do. What would be the straightest way to make the straight lines? Not as long as you're not worried about up and down, just left to right.
Ooh. I would do leapfrog. I would put a line from A to B, whichever direction you want to go, and then put a line. If that's all I had, I mean, even using tools left to right is difficult, like the angles.
Shit,
But
the lasers and shit.
Yeah,
Yeah.
the left to right. But if you put a line next to that line halfway, and it's touching equally, you know what I'm saying. You move it out, and then you move it back to where it's touching at the same point you have it halfway down. Then that's extending the straight line segment left and right and up and down.
Yeah, so you think the straightest way to make a line, as long as you're not worried about up and down, just left to right, would be to use two actual pieces of string?
And I
think that's the way.
Way.
What's up?
That's I'm in a bad area. I'm on my street.
You're on an island. I know. I know. He's running away. You see, this is what he does when he runs away, guys.
I am pretty much on an island right here, if you consider all the waterways around me, creeks and rivers. Because I have a creek that runs down my property line, and then I have a river on the other. Yep, on an island.
The straightest way, you have to build this line, the straightest line possible. Just mark it out on the ground, left to right. What would you use?
Am I referencing another straight object?
No, you can just make your straight line, whatever. Just go out there and just make a straight line. Doesn't have to be in line with anything else. Just go ahead, whatever direction you want to go, just left to right. It only has to be straight left to right.
I've never even thought about that. I mean, we make straight lines all the time with strings, just leapfrogging them. But we usually have a reference point that we're measuring off of.
Why don't you use a laser?
A laser to make a straight line straight, not going left or right.
Yeah. I mean, the line must be better using the laser, right? I don't know. Like you're doing it in the air, so you could just put the laser out there, get stakes, make all the stakes hit the laser, and you'd have your straight line, right?
Oh, I see what you're saying. No, I was thinking about something else.
Or even an auto.
No,
We just want to make a straight
laser.
line, left to right. We just want to make a straight line, as long as just not turning left or right. Up or down doesn't matter, just left or right. What would you do?
Yeah, lasers over short distances would be the easiest, and it would be just as accurate as doing it other ways if you did it short distance, like what I'm saying, within the limits.
Yeah, no doubt.
Our cheap auto laser is. I don't have.
Well,
one
why do
in
you
here.
guys use the
I
string
only
then?
have a string. Well, the string is just give us a guide to where we just getting the height with the laser. We're not really creating a straight line of the form with the laser. We're just getting the elevation, making sure it's horizontal. Like the plane, the top is creating a horizontal plane, same height, equal elevation above 1 point.
Wait, what are you doing with the string?
Like we want to build in 100 by 100, and we want it 12 inches off of this benchmark. We're gonna set our laser, our rod on the benchmark, and then measure 12 inches. Put our like that's where we want to hit our tape. Whatever you're using, a transit or a laser, you just move the receiver 12 inches, and then you move it down. That brings your rod up 12 inches above the benchmark. And then you just mark stakes or whatever, put a mark, put a nail, and hang a string. That string less slack or is 12 inches above that benchmark. So if you want it 100 by 100, you do it 100 feet apart, mark the string 100 feet, mark out 100 feet, square it up, and use you can use different to square it up. But it's 12 inches above that benchmark by using a laser.
No doubt.
The laser is easy because you can use it just one person. It has a receiver on the story pole, and it has a unit that sends out the pulse of the laser. Now they color it too, so at nighttime you can see it, but in the daytime you don't. It just hits the reader at a certain position, and that reader is on the story pole. So the bottom of the story pole hits the benchmark, and you just measure off of that.
So if I was to say, make me a straight line, not bending left or right, what would you use? Use stakes, whatever, stake it out.
Yeah, I would use lasers, and I could make it visible with string.
Do you think the laser would be better than actually having the physical line? More accurate, I'm saying.
No, I think you could use the laser to put a physical line, and then you would have something there where you could double check and recalibrate, redo everything. Use anything else that you might want to do if you're trying to be super accurate, and check that physical line.
Multiple methods, yeah.
Because often we'll hang strings. Let's say that's our physical representation of our plane, right? At the height we want it, whatever shape we want it, and then we'll come back the next morning and it'll have more sag in the middle than it did the day before because
It'll settle.
Or whatever. So you'll lose tension in the string or whatever it may be, so it sags more. So we'll go back and check. I always check everything. Like I'll check the corners, but I'll also check the middles. I mean, I often have people, my bosses, basically the people who hire me under contract to go do a job, and they'll pull a string across like 100 feet and go, this grade is off by an inch. And I'm like, did you consider that as sagging in the middle? The last guy that did that to me, he goes, I wanted 7 inches. This is only 6. And I said, he goes, it's 7 in a lot of places, but it's 6 in a lot of other places. So I went out there and checked it with him. I said, show me exactly what you did. And he said, well, we put it on this nail, we pulled it across here and measured, throughout, and it's different measurements everywhere. I said, yeah, it's sagging in the middle. I said, look, I showed him with the laser, put it on where he had his nails at. Both are the same. Went to all the other places, and it was all the same, right?
What was this, the Super or something? One of them dudes with a clean truck and his work boots is all spiffy?
He was the owner. So owners and architects, they don't know shit. Me and the contractor were just, he's on a huge project. The foundation it's a 10,000 square foot house. I poured the foundation, and he just called me. He said, the architect he goes, I got more redos from this architect than I've ever had in my life. And the architect basically is making more money on this job than the contractor is. They make mistakes all the time, dude. We find engineering mistakes. I mean, it's, you know, it is what it is. They're not on site most of the time. They're in an office. They're just kind of piecing their day together, you know, and doing the best they can. And then they might have people working under them that they're giving work to, and then they're just looking over it and stamping it. So they might miss things, right? It's not that they're doing it wrong. They're just missing it. They know how to do the work right. They're brilliant, right? But they make a lot of mistakes. All right, I'll be back later.
So where are we going this year? All right, I'll see you later.
I'm going to the Italian restaurant right now.
I meant this year, like general. You know what I mean?
Many times I'm gonna go to this Italian restaurant this year. I'm going to Florida this weekend. But
All right, later. What's good, guys? How we doing? What else we got? Rumpus deadass told me in the surveying world flat means curved. But then I asked him, what if there are actual flat spots? He goes, it's impossible. There shouldn't be any flat spots on Earth, anywhere ever. So, Gary, were you the one earlier saying the stuff didn't drop? Optically, like visually? I mean, it doesn't always. Sometimes.
What was the question?
Were you the one saying that stuff didn't drop in the distance or, you know, horizontal?
No, they don't drop.
Yeah, but it does. It does.
They just simply things that move through and past the horizon, which is an optical limit at the surface for detail, will just simply not be able to be resolved, and it's going to be bottom first. It's nothing to do with the size of the object itself, even though it is getting smaller with distance. It's got to do with the field of view angles. So if you're close to sea level or whatever, and you're looking out in the ocean, you only have 6 foot above the surface, and that horizon is actually nearby. You can't actually see the surface of the water past that point. Just like on the road, if you're driving down the road, look next time you drive, look to see how far you can actually see the surface of the road up ahead. It's not very far. So then you look at cars that pass you up and watch the space between their bumper and the road. And pretty soon, after a while, you can't see the tires anymore. It's just the same thing. Those angles become too small, and you can't resolve what's in between them, just like railroad tracks going off in the distance. They don't merge, but that space between them gets so small, you can't resolve anything in between there anymore. And they slant up in your vision because of the way the angles from your eyes work. They slant up, and those 2 points always meet near the horizon or at the horizon.
Dude,
and you can go higher, and the railroad track will converge further out, right? Or appear to converge, obviously. If I don't
Bro,
say
shit's appearing to
to.
optically drop in a distance, bro.
No, it's just beyond
what
the
we see.
limits of the surface, and they're way further.
Okay, but
in the
there's an
horizon.
optical effect that can be
It
that
is
looks
optical.
like it's dropping. That's what he's saying.
Yes, it's complete optical.
No,
though.
he's
It's
saying
just a
it doesn't
limit.
happen.
No.
It doesn't
You're
happen.
talking past each other. You're talking past each other.
You just said it.
He's
It
saying
doesn't
it
happen.
doesn't actually happen, but there's an optical effect that makes it look like that, right?
So you agree we see things dropping below horizontal that should be above horizontal?
No, they're not dropping below
All right.
horizontal.
I told you.
It's
What do you
it's
think?
the
What's it?
guys with the zooms that are confusing everybody, because when they got their little sights, that's a zoom lens. They're not like a clear lens. If it was just like a clear lens that wasn't zoomed in, and you had the little crosshairs in there, that crosshair would be right on the horizon.
Okay, so when we zoom in, there's an optical effect.
Yes, because you'll see that space, that like the height of view above the surface, that space when you zoom in spreads apart, right? Just like if you zoom in, everything from the center will spread outward. Everything above your eye level will start to spread upward, and everything down, because you're increasing the focal length, which is decreasing the field of view. So everything else is going outward away from that. And when you back off the zoom, everything compresses back into that zone. It's all optical. It's just a
So
limited
have you
angle.
ever used to decrease the focal length and what was the word?
But when you zoom in, you're increasing the focal length. But when you increase the focal length, you're actually decreasing your field of view. And so now all the pixels for your camera are available for that little tiny field of view, which is what magnifies the image,
Does the
right? You
field
can
of
see more
view
detail that
come
you
into?
couldn't even see with your eyes.
How does the field of view, like field of view being like, I guess if you have a circular lens, right, a round lens, right? I mean, a field of view is just a circle then. So the horizon or the halfway point of that circle equidistant from the center, and that's what Jeremy is saying. It drops below. How does it come into play and affect what's at the center of the circle in the distance?
Well, it doesn't drop below. It's just visually cut off by the angle limits. It's just simply there's nowhere for the information to be recorded at that point anymore at the surface past a certain point. And so then you could just pretend that's like 5-foot waves at the horizon, but they look like a smooth line, right? So now you got a 10-foot wave that's another 2 miles further. You're not going to see that 10-foot wave 2 miles further, because that wave is further. It's even smaller apparent angular size, and your gap, your angle over the waves at the horizon is too narrow. The separation is too narrow for you to resolve those waves in the background from waves in the foreground anymore. So then you get another 15-foot wave that's another 10 miles past. You're never going to see those. It's in that zone where it just is too compressed. There's nowhere to record the information optically at all.
Bro, I've seen too many observations and measurements.
You're looking at zoomed in images.
And before. Okay, I realize they're zoomed in, yes, and optically, visually, it looks like they're dropping below horizontal, things that should be above horizontal.
Nope, because your angles are cutting off the bottom first every time. Your angles are always going to be most narrow at the bottom, because the ground is sloping up, right? That appears to. It's obviously it's not. So it's sloping up. The ground takes up your entire bottom half of your field of view. So once something reaches, let's say there's something that's moving parallel to the water that's equal distance from your height above the water to above your head, then they will appear to converge at that point nice and evenly. But it won't do it for things further. When they move further out, they're just simply being cut off. But if you go up higher, you can see further. The horizon will move out further away. It'll still be at eye level with your natural eyes, and you'll see the bottoms of the things that were further out. It's not that they were too small. You just have a limit based on elevation of what you can see at the surface, and it just cuts off. Like I said,
I've personally seen too many observations to know that this, in fact, does happen visually. Things drop below the horizontal. Visually. I don't know. I wouldn't. Visually, yes, that's what we've been talking about. Visually, things are dropping below horizontal.
They're not dropping. They're just converging into
below horizontal. All right, they're below
just
horizontal.
Converging into your eye level. You're talking about people who are using the auto level that's got a scope on it. That's got it's like a zoom. And so yes, that area decompresses basically is what it does. So what looked like your horizon, now all of a sudden you see more detail at the surface for further past that point that you originally saw. You can see it really good when you're zooming in and out with the thing. It's very easy to see what's going on. It's when you just look through a fixed sight that's already zoomed in, and you can't adjust it at all. It doesn't go back and forth. You can't unzoom or zoom further. And so it spreads that gap that was your eye level equal with the horizon optically. It's not actually equal, but it's like you can't see that space anymore at the horizon.
So do you agree that we see
And
that the way we see is actually curved? I think you should watch the
no,
Jesse video. Oh, well, it has to be because our eyes are curved. To think that
well,
we
it doesn't matter
see in
that
like
your eyes are curved. You're just
straight.
it's the way your eyes see the angles. Like let's say you're standing there, and you point at the ground at a 45-degree angle to the ground, right? It's right there in front of you. It's like your body length, right? Then you want to point to the ground further away, and that ground, now your arm is going up. It's going up towards eye level, and that's where your arm will end up at the horizon, right at eye
Why?
level.
Why
You
is it?
can't
Why
distinguish
does
it
it do that?
because of the angles that you're looking at. So that's what places everything in your field of view where it belongs, because it'll be
So
smaller, and it's placed in its proper place in your field of view because of the angles.
okay, but you're saying we don't have an arc of vision. We don't see in a circle.
I don't think that has anything to do with it. That's my opinion.
Well,
I could be wrong.
you could say that, right? But when you're making claims about perspective effects, you're obviously going to have to understand perspective. You should watch the video from Jesse that started all this that Jeremy is talking about, and then explain it in your terms so we can bridge the gap here. Or you and Jeremy are just going to keep talking past each other.
Well, we're
You
going
can
to
breeze
keep
through
talking
it.
past
I mean, he's
everybody,
just
no
wrong.
matter
I've
what.
seen it.
No matter what you show about your vision,
Jeremy, if you
it
say
doesn't
I've
matter.
seen it
They're
too
not
many
going to
times,
change their
I'm
mind.
gonna jump off a
Oh my
roof or
God, this is
something.
from a baller, okay? He's showing something allegedly dropped down below alleged horizontal. Now, I have definitely...
Jesse is not any kind of a land surveyor. He's just one of these guys who's got his own thing and he's messing around with it. He doesn't know what he's doing.
Well,
I
okay,
know who
but
Jesse is.
to specifically address what we see, right? Like I've already pointed out that actually things converge towards the center of view, and where he's showing these buildings aren't the center of view. As he starts to mess with the angle of the camera and the height of the camera, actually the buildings begin to go up higher and higher towards those levels. So he has a level that's like 10 feet apart, that's however many feet in front of him, and then he has buildings like many, many miles away. And he's saying, look, the buildings are lower than the horizontal level.
Because his
Way close.
horizontal line at his site there is based on the horizon, which is close by. It's not based on those things in the distance. He opened up a little gap, but the thing is farther. Those other things are much further, so they've been decreased in angular size.
That's right. I agree with you. But my point is
They're
that when
not.
we talk about angular size, we have been duped into drawing infinite lines in an orthographic view from our eyes, and that is not how we see. Provably, that's not how we see. Just like we see parallel railroad tracks, but they don't appear to be parallel. That shows us a distinct difference in tangible physical reality of straight parallel lines and how we view them as if to converge in the distance. We cannot just draw lines from our eyes and then do some mathematical trick of an inverse function, tangent function, and then say, oh, wow, there we go. We do see in straight lines.
Well, it's visual geometry is what they imagined as a curve. It's visual geometry. Whoever comes up with how to do the math for that is going to be the winner. And it's like they just denied that it was even a thing.
That's what I'm saying. I'm like literally about to do it.
Yeah, well, good. I hope you do. Because I don't know how to. I'm not a mathematician. I don't know how to do it. But like, let's say you're standing in the middle of railroad tracks, right? Right in front of you, just point your finger on your right hand to the right rail, and the one on the left hand to the left rail, and then just point off in the distance, and your hands are literally going to angle up towards each other until they reach eye level. It's like, and that's how those angles are what place that in your vision to give you the depth and the distance.
If you were to mark each point, Gary, and then if you were to mark each point where your hand is turning, like just by like once, little bit, that's a curve. So are we seeing spherically then? I mean,
no, they're not curves. They're
like
straight lines. It's just that
no,
the
they're
angle
not,
becomes
man.
narrower.
Prove that. You sound like a baller.
You can.
Prove that, bro.
Well, draw a line. Stand in the middle of a track and draw a line to the rails. Do close by and then farther away. Do to each side. Stand in the middle of the thing. They're straight lines, and they're converging towards the center as they move away because that angle changes towards the center, and that's what puts things in your field of view where they belong.
Right.
That's why you don't
My
see the thing
brother,
in the
if they're
distance that looking like
converging,
it's dropped way down or up in the sky. It's putting it where it belongs based on straight line angles. They're
hey,
straight
my brother
lines, but the way
man,
your
my
eye
brother
see the
man,
straight lines converges them.
brother man with the rubber bands. Check this out, man. I got another plan. Okay, they're
The rubber bands work
converging
fine. They're just
towards.
angles.
They're converging towards the center, man. That means they're moving towards the center. If I draw a straight
They're
line and they start
compressing
to,
that your vision.
well,
They're compressing because of the angles becoming more narrow. So they're compressing towards the
they're
center and
compressing
towards
in
eye
a
level
curved
at the same time.
convergence. You see, you keep just saying what I'm trying to be more specific about. Whenever they
Okay, well,
converge, I agree that they converge. I'm saying, why do they look like they converge?
because of the angles. It's very simple. Just draw the lines to the angle. Just draw the lines to all the various things. The angles will show where it goes in your field of view.
The most realistic drawings that exist in the history of man is using hyperbolic visual space.
Well, I don't know much about the hyperbolic
So,
thing. I just heard the term
well, that's
recently, but I haven't looked at it.
my brother. You know what a hyperbola is?
Not really. I just heard the term
It's like a
used
U.
here,
It's like a
hyperbolic.
U, right? Like say you draw like a U. So we
Yes.
use like hyperbola math, hyperbolic math when we talk about the curvature of the Earth because for intents and purposes, it's good enough, right? For the
Well,
distances we observe,
would that be anything like if you draw a square on a paper and then you tilt the paper down, it no longer looks like a square? Is that the
that
same
is
kind of
the
thing?
exact. That's a good point because with non-Euclidean visual space, flat plane shapes will appear distorted. So I'm telling you, they hijacked our
No, they're
eyes,
not.
bro.
No, they're not distorted. They're just compressing. Everything's compressing. Angles get narrower with distance, and it compresses towards the center. If they're moving
Yeah,
parallel
towards the center is a
with your line
conversion.
of
It's
sight,
curving in.
anyhow, maybe we're just not quite seeing or understanding what each other is saying. So,
Well, that's what I'm saying. We actually
I'll let you
probably
guys
agree.
continue. I'll just listen. I'm not in the mood
No,
for
you're good. I'm
arguing right now
listening to
with
you.
anybody.
I like
Yeah,
listening
I'm
to
not in
you.
the mood for debating with anybody right now. So, you guys, I just listen.
I'm not really trying to debate with you. I just want to bridge the gap here.
Yeah, well, like I said, it's just angles. It's simple straight line angles and how they're presented in your field of view. They get narrower with distance, which compresses them towards the center as they move away.
Okay. We have a curved surface that we're receiving information, but somehow we don't see curved.
We don't have a curved surface.
Yeah, our eyes or any optics, anything, a telescope, binoculars, a camera lens, those are just imitating the eyes.
The eyes are just interpreting the angles. It's very simple. You guys are overcomplicating this. It's very simple.
Well, in order for us to accurately do the math, we need to accurately establish a foundation.
You just got to measure the rate of compression with the angles. That's all you got to do. I just don't know how to do it, but that's all you got to do.
Okay, man. To be continued. I'm about to eat.
No, it's just like a railroad track. If you're standing on the ground, it appears to converge not too far ahead of you. If you go up higher, it doesn't. Now it's converging further out. You just got to figure out how those angles, they're all straight lines to your eyes, subtended to your eyes. You just got to figure out how the rate of compression, and then you'll start to figure out the rest of it. And compression is the imaginary curve.
Yeah, but I think part of his point was that like compression, even the compression, like is not uh it can be perceived or quantified as a curved as a curve as well. Like all these things it's really difficult to I guess draw them out or map them out in straight lines when you're coming from more than one different side of it. When you're coming straight on, you're coming from the side of it, you're coming from the top of it. Those angles, you plot them out with little dots on a sheet, and you try to connect them. Yeah, I guess that you can call it straight lines, but gradually, enough of those little dots is called a curve. Yeah, I mean, there's almost no such thing as a curve. It's all just the distance between points and straight lines, and however it blurs out, we call it a curve. So I mean, I guess the semantics of that could be talked about, but when we're talking about the difference between a curve or a straight line. People will describe that compression. They'll describe it as, oh, it'll always be compressing and converging to the center, right? So that sounds like, I guess parallel to the globe theory of gravity at the center, right? So we're saying it's all compressing to a center from the left side, the right side, the top, and the bottom. Okay, yeah. Well, what about from the 30 degree and the 20 degree and of the top, and then from all of those angles and compressing to the center? That seems like a sphere, right? Then it's compressing in a sphere-like manner, right? Not just from the top, not just from the bottom, not just from the left, not just from the right, but from the corners as well, and everything in between. And if you map all those little points out, that's a circle. So we're seeing in a straight line according to a circle. Well, straight angles according to a radial from a center point. Seems like it's tough. And that's just from straight on. Then you go to, then you get another viewer, from the side, and he's doing the same thing, and you draw a circle around that. Right? Everything's compressing to the center, like gravity, right? It's all converging at this center point, rising, appearing to rise, appearing to drop, appearing to move in from the sides. That's another sphere. That's another circle. And then you get viewers at every angle around that, and that's the sphere. So, I mean, are we still seeing in straight line angles or drawing straight lines? And then we're saying things compress in straight lines also. They seem to compress radial from all sides to a center point. So it's tough to say which way we see. Do we see Euclidean straight lines? We use straight lines. So we're seeing in straight lines, but then everything's compressing, like a sphere from a spherical point of view. So we're seeing straight, and then everything's compressing spherically. Then we're moving, changing those angles constantly in real time as I'm walking or running, and everything is still compressing from the sides. I'm seeing in a straight line still, and while things in the background and foreground are moving at different rates, all straight lines to those objects. While light comes in which way? How does light come in? Comes in straight? Yeah. I don't know. It seems to radiate from a sun that's a circle in all directions, right? And then as I see that light coming in, then it's coming into my eye with it, which all spherical objects, convex objects have a specular highlight, right? So now the light's coming to my eye, or my eye is picking up the light, however you want to see it or say it, right? To a cone, right? Then there's a cone interpreting it, and it's all straight lines. It's kind of tough to imagine that it's all straight lines. Yeah. Yeah. And then if I'm at 4th of July and I have all the kids are running around with little light glow in the dark bracelets, and they're swinging them around their heads. I'm seeing a big trail of light, right, in a straight line, but I know they're swinging in a circle over top of their head, but I'm seeing in straight lines still. Well, the fireworks going off, they seem to be radiating from a center point. I'm still seeing in straight lines, but I don't know. It seems tough. Yeah, I mean, I'll say it sometimes. I'll say just measure the Earth with your eyes closed. I think that tells you it's flat. That's it. There's so much optics going on. There's so many different interpretations of optics. If I go to one side of the lake and there's a flagpole on the ground and it's 4 feet high, I'll go to the other side and it's 4 feet high. My eyes closed. I can touch it. They're saying it's a curved surface that they can measure this curved globe because it's a sphere, right? But then they claim that gravity is making everything flat. But then they can see it. Then they can see the curve, the physical curve of that's affected by this gravity. So they're seeing gravity. They claim they don't understand what they're saying. They're saying they're seeing gravity with their eyes, with a telescope. When they zoom in, they can zoom in on gravity. It's ridiculous.
Yeah, I've asked them where we can see space-time bending. They showed me an Einstein ring.
They can just show you their drop from the horizontal. That's them observing gravity. They're implementing like this sphere, like this globe, and saying we can see across it. We can see that it's a globe, but there's gravity on this globe pulling to the center at every point that you are at every altitude.
Who the fuck just muted me? Made a big
Yeah,
mistake.
did it work? I took you off. You good? You can talk now.
No, if that was you that muted me. I mean, Geo muted me for a reason.
Bro, say thank you.
I
I'm
said
gonna
I
mute you
said some
again.
scandalous ass shit last
Say
night.
thank you. Or I'm gonna mute you again.
All right, mute me again.
What do you want to talk about? The injustice.
All right, I'm gonna talk to facilitate a conversation between. Where the fuck's that bitch gone? The one that unmuted me. Never mind, Stone. I was trying to set a conversation between you and him, and I was gonna back off, but that's not gonna happen.
Again, I'm not really interested in having conversations in here.
Yeah, nobody comes on a Discord channel to have conversations.
I told them why I'm here in this particular Discord. It's more of an observation. They seem to get a little triggered by my interactions with them, so I'm on an observer kind of status.
I thought you were gonna say that they get a little bit flustered by your big black dick.
That's probably true too. Again, I'm just going to be as an observer status because I obviously have nothing to offer in the way of evidence to the globe, and I don't want to defend it.
Actually,
and I don't want to explain.
You know what, Stone? This could
those
actually be
concepts
this.
to people that don't understand them.
All right, Stone. I've changed my viewpoint, bro. We can actually have a good conversation, right? The conversation is this, yeah. Like, do you think flat earthers really think the earth is flat?
I believe there's two types, and you can be a combination of completely ignorant and you believe it, somewhat ignorant and you're a grifter of the ignorant, some combination of that.
I agree with that too, yeah. But so if we look at the people that generally facilitate in this room, what percentage of people in this room do you think actually think the earth is flat? And what percentage of people do you think?
Don't know, but I'd also like to add to that I believe it offers obviously a community that you can get into where you can pretty much say whatever it is, whatever crazy thoughts you have, and nobody will really judge you. I think it offers a community that has a disdain for academia, has a distrust of government.
So you know
Very
what?
popular now.
Stone. I'm gonna
And
cut
I
you
think
off,
you
bro.
put all
But
these things together, and that's
the
what you have.
reason why people watch sports, right, is because you can do something together, right, and talk about the sport, right?
Well, yes, again, that offers a community, something people can get behind and support. Yes.
So what's the difference?
One's delusional. It's probably not mentally healthy for you to believe in.
Or what?
Like, say if that team
You,
didn't exist,
it's
if the
not.
Dallas Cowboys was just a
It's actually a lot better to sit around and discuss who the fuck kicks the ball harder.
if you that's your opinion, man. If you think talking about things that aren't in actual reality and they're have already been discovered and already been discussed and
Bro, but here's the thing,
linked
my
for
man. Here's
the
the
past
thing, yeah.
2,000 years.
We know, everybody
You
knows
think
it's been discovered.
talking about reinventing the wheel is fun and whatnot, and acting like we don't really know what's up in the sky and shit. If you think that's fun, hey, more power to you.
I mean, if it's not fun, why do you enjoy coming to these rooms?
I guess you weren't here yesterday. I am here because I find FE entertaining in a psychological way and in a comedical way.
Bro, but it's crazy though. If you really think that the majority of people in this room actually think the earth is flat, that's different, my man.
I'm not even really in this. I'm not even looking who's in this server right now. I don't know who's.
I would say in this room right now, there may be one person that may be unsure.
Imstone, you know what that reminds me of? It's like me thinking, like, I think that, like, hundreds of genders, I think that's stupid. But you know what I would never do? I think it's stupid and it's blatant denial of reality, right? I would never go to a server where people think that is reality and stalk them and try to make fun of them and berate them and say that I find entertainment in their delusion and try to make them feel less than human and stalk them for years.
Why not? What's it?
Because I think that that's just a terrible vibration as a person. Why would you ever find entertainment out of doing that?
Yeah, it's also extremely sociopathic, extremely mentally ill to even engage in that type of thing. It's severe sociopathy.
You have no idea what you're talking about, man. You're literally diagnosing somebody, and you have like no knowledge of psychology.
It's not a diagnosis. Sociopathy is a actual.
Oh my god, you are definitely diagnosing me over the fucking internet. Shut up, Brown. God.
It's not a diagnosis for you personally. It's a comment that to engage in that type of behavior is sociopathy.
But you don't even know the truth about the behavior, though, man. I heard.
Why are you getting so emotional, though, man? Like we're all.
Why am I getting so emotional?
Yeah, you're like emotionally interrupting him. I don't know why. We can't just be chill.
Okay. Again, I'm just here to observe. I'll just observe. I'm just going to go back to a point of observing.
That's kind of my point. I would never go to a server that says there's like, I'm just using a random example like that. There's infinite amount of genders.
The first time.
But listen, why would I go into that server, stay on mute, and just observe them for years at a time, and then follow? Oh, they're gonna go meet up over here. I'm gonna go over there and make fun of them for what they think. To me, that is insane, bro.
Yeah, because part of sociopathy is like a complete lack of empathy and a total disregard for other people. So if other people, let's say they think whatever they think, to have no empathy or understanding for where they may be coming from or what they're going through, and to completely disregard them to the point to where you're going to subjugate them, point your finger, and make some kind of a ridicule position upon, that is definitional definitionally sociopathy.
And then to find like genuine entertainment or value in that seems like a very severe case of that, right? I mean, I guess that would just kind of be evidence of that.
Yeah, well, it starts to blend into psychopathy if you start getting into that component of it, where it gets even more like where it's like premeditated and even to the point of going to violence, which this guy has done. He's tried to pick fights with people and stuff. So yeah, it's pretty severe.
Just seems wild because I mean they say that, right? They say that that's why they keep up with it, but I don't know. I'm undecided if I think that's true or not. But what do you think? I'm sure it's a generalized question. Of course, I'm sure everyone's different.
Whether they're actually getting entertainment out of it, or what do you mean?
Yeah, like whether or not the reason for their obsession is actually that they're like entertained by how stupid it is, or do you think that's like a cover story because they're actually just obsessed with the idea, like many of us are?
Yeah, I think it's a cover. I mean, I'm not saying that some of them might not find entertainment in their own ridicule or some of the dumpster fire stuff that happens on some servers and whatnot, but yeah, I think it's like a part of like a cognitive dissonance where the way that they're dealing with like they have actual interest in this and they probably question the globe on some level and obviously have heard some things that resonate and there may even be like an intuitive resonance that there's something to this, to the shape, to the earth not being a globe and so on. And so that creates an extreme state of cognitive dissonance, perhaps in some cases, to where they now have to rationalize, like they don't want to accept that they actually have interest in it or that they might be questioning the globe because of the social ramifications or all the other factors. So the kind of output of that is to create some kind of a facade that they can then project, try to make it seem like they're just subjugating and trying to just laugh at stupid people or whatever, whereas really it's their own intellect that they have a conflict with.
Yeah, because exactly. Because the reason I know that it's a cover is in a scenario where someone's like, these people are so stupid, but they know that they're like significantly more ignorant about the subject. They have much less of a grasp of it. They can articulate the reason they hold their position much less sufficiently. They know that, right? They're not like oblivious to that. So then to claim that it's just pure entertainment due to stupidity, it literally doesn't follow.
Right. Yeah, definitely. That doesn't fit at all. I think that's what he was just saying is that that we're just ignorant about it or don't know the information. That's just not the case at all.
Yeah. I don't know. I find it weird. That's why, like on the tour, I use the because this is what I know, right? Like in person, people's reaction, like initial reaction, was that right? Like just sounds crazy. They just assume it's wrong and they kind of ridicule. But then what would happen was the people just keep walking by. It's like if I'm walking down the street and I hear someone screaming on a blowhorn or whatever, and I'm like, whatever you call him, and he's just like screaming like everyone's burning in hell and just crazy, like he just seems like off his rocker. Like I just walk by him. You know what I'm saying? I'm like, whoa. Like if someone's on the street, some crackhead walks in the street, starts telling me about how aliens visit him and that they're one beside me, but I can't see it and all this crazy stuff. I'm just gonna be like, all right, man, I'm gonna walk away. I'm not gonna sit down and listen to the crackhead tell the alien story over and over and over for years. I'm not going to just sit down and listen to the guy with the air horn or whatever they're called. It's like the same thing with me. Like some people would sit down and it's because they were genuinely intrigued at some point of what I was saying, although they initially ridiculed it. When put on the spot, they will go back to ridiculing because that's just a cover, right? And so, because it's uncomfortable. And it's like that in here. You can't really sit in the Discord and never be put on the spot. You certainly can't speak and interject or be a part of it without kind of being put on the spot. And so that cover comes back up. Dude, like I know for a fact these people have heard like conversations with very high levels of profundity, very profound conversations in here, and been like, whoa, that's crazy. And they've learned a lot. A lot of flat earthers have come in here and then said things, and then they've learned a lot, and they've been fascinated by the conversations. That's why they're here. They know a lot of flat earthers actually are very intelligent, have very profound thoughts, and have done lots of diligent research to formulate those profound thoughts, and that they learn from them. Now, how would you get to be a part of that and, benefit from being around that while avoiding societal kickback, like being ridiculed or ostracism or whatever? You would come and you would say one of two things, that like, it's your virtuous motivation. Like, you have a virtuous obligation to come and shut down the misinformation, and or it's just entertainment for me. I basically laugh at you guys. That way you have a cover story where you don't have to personally take that ridicule, but you still get to be a part of the conversation.
Right. Yeah, exactly. No, yeah, that was well said. Yeah. It's like a psychological compensation in some cases, because their options are to come and be like, you know what, this is interesting. You guys are talking about interesting stuff, or, I might not agree with this, but I do agree with that. Like, actually being a legit person in the discussion and being willing to respect others and sort of, be engaged. There's that option. But if they're not able to do that for whatever reason, because they don't want to accept that they actually do have that within them, then the kind of the social programming thing with a lot of topics that are, that have certain stigma is to, especially with the shape of the earth and specifically flat earth, even that term flat earth is kind of programmed even along with the globe. Like, oh, we're supposed to laugh at those people, and, oh, they're just stuck in the past. And, that whole component of it seems to have a tremendous amount of ridicule, even more than other things, than other contentious type topics. But so the kind of, instead of being like, yeah, I'm actually interested in this, I'm here, I want to have a conversation or contribute or whatever, or actually engage, then kind of like a default thing is just to basically go with that kind of the societal ridicule, like, oh, I'm just here to point and laugh. So it kind of puts them in that category of the pointing and laughing, but like you said, but they're also here and they're able to listen and ask questions or engage. So it's kind of like a mask, like putting on a mask that they can still be here, but pretend like they're on the side of just subjugating and laughing at all these dumb people, but actually they have curiosity and interest in a lot of the same topics.
Yeah, absolutely. I mean, we talk about incredibly interesting stuff. So sometimes the conversation gets dry and reiterative, in my opinion, right? But anyway, so it's like Imstone didn't do this. He was very aggressive in person, but there was another one, Tim Osmond. You know who that is, right?
Oh, yeah.
Yeah, so he came out, I think that was in Utah, Salt Lake City. He came out, and he started off real aggressive and condescending, and I just kind of popped him around with the arguments for a second, and he was just he got really embarrassed. Where people that were around that weren't even flat earthers were just like, wow, this guy he's making him look stupid, kind of, right? So and then I was just being super chill, bro. I'm like, look, man, I'm cool if you want to hang out. I'm cool if you want to follow us around, right? I'm just trying to talk to new people that haven't heard the conversation. If you would like to walk around with me and Chris and all the other flat earthers here, I don't care. It's cool. But can you just chill? Can you stop following me around like a puppy and being in my face and not letting me talk to other people, please? Because that's actually why we do this, is to talk to new people, right? But I was real chill about it. I'm like, look, man, you're good, bro. You were cool. And so it ripped away that BS cover. And then he just started, and this has happened by a few of them that came out in person. They end up saying look, I actually like you, Austin. And I agree with you on lots of things, which is why I'm just so confused why you think the earth is flat. And I'm not sure that if you even truly believe that, because you're so right about so many other things. And this is what Tim Osmond was saying. Oh, look, I really like you, blah, blah. And I really like the stuff you say about many other subjects and stuff. So that's the truth, right? The truth is that they like us. They know that we have good points. They like to listen to our thoughts or our opinions. And they have to have a cover for that. And when you get in person, that's why I encourage them all to come out in person. Because, dude, it's just a totally different game. It's a totally different world. And So I kind of experienced it firsthand. Like I know that that's kind of what's going on for the most part, right? I think that honestly, and that's a good thing, because if it wasn't like that, then they're actually just terrible people that like literally find enjoyment just trying to like tear people down and gaslight them and stuff. I think that's more of a cover. That's actually more of like a maybe good faith, or like yeah, that's like me applying maximum good faith to it, I think. And I believe that most people are like have a longing to be kind to people, actually.
Yeah. No, I remember when that Tim Osmond, yeah, because I watched that stream. Yeah, I remember that. That was wild because yeah, he like was confronting you, and you kept saying like he wanted to kind of debate with you, like because yeah, he was obviously very like respectful of you and your position and your opinion and all of that. So it's like he wanted to talk to you. He was almost like a fanboy, you know, like a fan, like somebody who meets like, you know, Michael Jackson or something in public, and they're like, oh, I want to ask you questions. So yeah, like he was really kind of fanning on you in that sense. And then I remember, yeah, you were like, you kind of didn't want to get into like a debate with a Globe guy. You know what I mean? Like you were there to wake up new people. So you kept saying like, yo, man, I'm going to go around and talk to new people. Like if you want to kind of come along, that's fine. And he didn't want you to do that. Like I remember he was like keeping you from doing that. He like wanted you to debate him. But it did seem like he had like so much interest and curiosity, and like it seems like confliction, which I mean, I know him, and that is kind of his thing about the topic. And so it was almost like he was trying to like plead with you or something, like, come on, no, it can't be flat, no, the horizon. Like it was almost like he was kind of
yeah, because he was like, he's letting me know how much he agrees with me on certain things. I guess he's like conservatively minded or something like that. But yeah, I was just like, well,
I think he agrees
cool,
about like 9/11 and kind of the NWO stuff. I think he's kind of hip to some of that.
He was saying he thinks Flat Earth is basically a psyop to take away from that stuff.
Yeah, that's kind of been his thing. Yeah, he thinks it's like a Trojan horse that is trying to discredit the entire truth movement kind of thing by linking Flat Earth to it.
So once I started getting aggravated, where I'm just like, I gave him a few real concise arguments to shut him up, and I was clearly getting aggravated with him. Kind of shifted a little bit over, where then he ended up saying like, I think you actually don't even believe the Earth is flat, you know? I think you're too smart. This backhanded compliment of basically saying you're too smart, so you must be a liar, you know? And that's kind of like the new thing they say, I guess. It's also very wild to me, right? So I don't know. So whatever. That's why Brent's just saying, how many do you think actually believe it? Because they can't really say we're stupid if they're honest.
Yeah, that may be another, in some cases, like another expression of a cog dis, like trying to deny that people actually think it, just to kind of make it seem less of a dissonance within their own psyche.
What's it like? Udemy is cool, but I think Geo is very mad at me, so I want Geo to unmute me.
I didn't unmute you.
Yeah, I unmuted you, and I'm not mad at you, man. But you interrupt, you derail. It's just wild, dude. You used to be able to kind of be in VC, but it's just gotten to a point where it's like,
I don't know, bro. Like sometimes my derailing does have points that you don't recognize it. Like
I thought I'd give you one more shot at it, but
I'm just saying, like my point system is 3 steps ahead, so it may seem ridiculous when I start the point.
So you're playing chess,
so
playing checkers. We're playing checkers. You're playing chess.
Yeah, checkers, motherfucker. Chinese checkers.
Geo may not be mad at you, but I am.
You know what, Jeremy? I don't give a fuck about what you said. The way you said it just bring up the fucking tone of the room. So bring it up. Say it. It doesn't matter what you say. Just keep saying it that way.
All right.
Well, Branch, you were originally saying that you don't think people actually think the Earth is a stationary topographical
Honestly,
plane.
Gio, I've asked you a couple of times, right? Like, what would you do if you fucking go up on a spaceship? You're like, no, man. If I go on a spaceship, that means I'm going to another dimension. And bro, I like, you know what? Honestly, Gio, I can't fathom a flat Earth fucking understanding the way that you do. Like, it's just so in my, and I hate to say the bad words, my brother, but like, it's retarded.
Great. So what were you saying, Gio?
You want to discuss flat Earth and shit because it's fun to discuss? That's cool.
So so the word retarded means like, like slowed or delayed in knowledge or capacity to process information. So you're saying thinking the Earth is stationary, that it's not moving exactly as we experience it, and is planar, meaning it extends out and up is up, down is down, and it's a planar surface, which has been the base cosmology for humanity since the big dawn of time.
No, Joe, what I'm saying is
You're
this,
saying
like,
that is retarded?
No, what I'm saying is like discussing flat Earth is fun, right? And a lot of people do it because it's fun, it's funny, and we can have a laugh. But to actually believe the Earth is flat is retarded.
What do you believe?
I believe that.
I mean, I would agree with them. I would say,
honestly, bro,
I would
that's
say
an
if
interesting
he actually
question.
believed what he said, then yeah, that is retarded. But the problem is we don't believe it. It's a logical fact. You have the belief, and that's the retarded part about
Right,
it.
and that's exactly the way it should be, right? Like, if you really believe the Earth is flat, you should think I'm just as retarded as I think you are. So for me saying that you're retarded shouldn't be a fucking bad thing, because you should.
Well, I don't really think it's about retardation necessarily. I think it's more about like indoctrination and belief systems, and like perhaps you've been, or one can be deceived. It doesn't mean you're necessarily mentally incapable.
Yeah, but the problem, Gio, is this. Yeah, is that like the world I believe in.
Yeah,
And the
that's
world
what
you believe in
yeah.
is two different things.
Look, Branch, you believe that everything that we experience is actually an illusion. You believe.
Bro, I believe in God. Isn't that fucking delusional? Who the fuck, what motherfucker believes in God?
We're talking about
Some
the Earth.
fucking nigga. I'm sorry.
Talking about the Earth, my guy.
Some motherfucker up in the fucking sky who's controlling me? What kind of stupid shit is that? Yeah, half the fucking planet believes in it.
More than that, yeah. But so here's the point, Branch, right? You believe that everything that we experience is an illusion.
Dude, honestly,
this is what you believe,
You
Branch.
ain't gonna let you
Whenever
finish.
it looks like the sun is moving in the sky, it's actually stationary relative to us. It just looks like it's moving because we're moving. We just can't tell. And that we're falling backwards away from a sunset, nose diving towards the sun during sunrise. That the sun and the moon look like they're the same size, but it's just another illusion. And actually, the sun's 400 times the diameter. And that during the stellar, the sun and the moon look like they're both up in the sky, but that's just an illusion. And actually, the sun is down below it. And then when we see hundreds of miles away, exactly what we would see on a horizontal plane, that's actually an illusion, and they're completely obstructed by curvature. And when we see the horizon way too far, it's just an illusion. And whenever we do a interferometry measurement to detect the alleged orbit and it doesn't measure the orbit, it's just an illusion because the apparatus contracted but looked like it's the same size. So it looks like the apparatus is the same size, but that's just an illusion is actually a shorter. It's everything about it. So I would have to say that if you have that belief, I find that to be a bit retarded.
There we go. Now we think everyone's retarded. Awesome.
No, it's just a
Everyone's
position. It's the position is antithetical to logic and Occam's razor and empirical evidence.
all right.
My bad. I was talking to the Geo back there. Like, I'm sorry. What's it?
Well, I mean, in a way, Branch, the discussion about the shape of the Earth does come down to the nature of reality, the nature of life, the nature of since we're on Earth.
Oh shit, Geo's trying.
So, I mean, it's actually. I mean,
Geo's trying to.
You were saying
side of me that can talk about real shit.
Well, you were trying to make it sound like it's just something that was again what we were talking about before, like this thing that certain people have, where like, oh, I'm just here to laugh and ridicule. Like, there's nothing. I mean, there are something funny about like a comedian or something like that, but we're discussing the Earth, the nature of life. I mean, all of these components. There's nothing outwardly comedic about that.
I get that, bro. And honestly, like I've talked to you multiple times about fucking I don't know if it's cosmology. Just I've talked to you about spiritual shit, right?
I was just
honestly, bro, all that shit is cool as fuck, right? But I actually think once we're dead, we're dead.
It's just an illusion.
And I think that's a point worth discussing. Like, it sounds ridiculous and it may not be, right? But like atheists and I would say probably about 40% of the world believes that once you're dead, you're dead. Like when you kill a ant and it's dead, so are we. But we're no different times. But then there's this other part of the world that thinks that, you know what, once we're dead, we continue living because we're so special as humans.
Are you sober, Branch?
Do I sound fucking sober, bitch?
I mean, you haven't sounded sober.
No, hold the fuck up, my man. Do I sound fucking sober?
Not really, no.
All right, then why fucking ask?
Well, I'm just wondering, like,
if you know if I'm sober or not, why the fuck ask?
Do you ever sober up?
Motherfucker, listen. If you know if I'm sober or not, why the fuck ask? That's the question I'm proposing.
Do you ever sober up?
No.
All right.
You know what, bro? You're like a little fucking bitch. You gotta get that.
I think Branch has been sober for maybe 2 to 3% of his time on Discord in total. And actually, when he's sober, he's on point. Believe it or not. Like,
no. Seriously.
Remember that time? I see Riggs is in there. Remember that time, Riggs, that Branch was sober and he was just killing it, and Riggs was laughing. Riggs was like, "Branch is my favorite Glober now."
He could be my favorite Glober. He absolutely could be.
Hey, I swear to God, Riggs ain't my favorite Glober. SC Montreal's got you beaten by a little bit, Riggs. Just a little bit.
I've always
you're my second favorite Globe. You're my second favorite.
I've always told Branch he's one of the smartest.
You're my second favorite dumper.
But then he starts getting he comes on when he starts drinking. So for a couple hours he's good, and then it just all goes to hell.
Oh shit! Well, you know what? Well, why do we pace this out then, Jeremy? Why don't I shut the fuck up for a couple of minutes? I think you about some other shit. Now come back in.
I think Branch and M Stone should have a small debate.
Oh,
well, you know what? They're actually in the same city. They should get together.
Get along, bro. Like we didn't used to get along. I don't even know how the fuck we started getting along.
Did you meet up and touch tips?
Yeah, kind of. Like, I think it was the sex.
Hey, Gio, can you actually imagine like being in this room for the majority of a day if you didn't actually like believe in this idea?
I think the Globers would be more sad. Like if Flat Earth was to go away, I think the Globers would be more sad than the Flat Earthers. They love it that much.
Oh fuck yeah, bro! Like think about it. The people that are actually making money off fucking Flat Earth are the Globers. It's not that Flat Earth is making money anymore.
Oh, but yeah, Riggs, I know what you mean.
You guys are literally like, I don't know.
I mean, Gio, have you ever dedicated like an exorbitant amount of time to hang out in a community that you're not a part of?
And I thought it was retarded.
And like, yeah, I thought it was retarded. Like, I'm trying to imagine a scenario where I would even dedicate even more than like a few moments.
Like
and
this shit is
Right,
can't
more
even
than
do
like
it.
30 to 45 seconds would be about it.
Yeah, I'd be like, oh wow, and then I'd
and
just
I started fucking asking Shane, like, is fucking, is that motherfucker paying you to set this shit up for him or not? Because like honestly, like if you look at that room that fucking Shane set up, right? It's almost like it's a money grab for these fucking Globers that are facilitating your dumb fucks.
Well, we can't change the censorship, It just is what it is. Like you guys are always going to have the larger audience.
Money, though. I mean, why do this shit
And
for
by the
free?
way,
If you want to be a dumb fuck, don't do it for free.
can somebody
bro.
mute him so I can get the word out? Look, okay, because of censorship, you guys are always going to have more viewers. And when it comes to money, Flat Earth seems to not care about money as much as the percentage of Globers that want to participate in this space. So, like, it's not why we're here. So it's not going to be the overwhelming result of our. It's not going to be the product of our efforts. Like, who cares about the money? If there is something that is so concrete that we need money, I'm sure every one of the Flat Earthers would get behind it because we would need it at that point. But currently, that's just not the case. Like, Antarctica's pretty locked down. You need to suck off like 200 dicks and be a Freemason to get over there. And to explore the areas, you need to be not just exploring by yourself. You need to be protected. The North Pole is basically entirely military consumed. And like, it's just, what else are we supposed to do other than try to push the limits of real science? And that just takes brain power, testing, time, new ideas. Like, it doesn't really need all the money that you're talking about. And if people are making money, it's because that's what they're motivated by. I mean, we can't stop that. We're here for a different reason.
Some of us are.
Well, I don't know any Flat Earthers making a bunch of money. And if they are, like, I'm not a part of that group. So.
I want to change that.
Well, I think some of the Globe channels seem to be into that.
Like, I could totally fucking.
Some of those guys are, because they're not censored and they're able to make a little bit of money with it.
Yeah, I mean, I covered that in my answer. Like, they're not censored. Okay, they have a much larger audience. They get tagged in like, if you watch like a science video, you might get recommended like a Fight the Flat Earth video, like how stupid are Flat Earthers or something, and then it shows like some clips or something. Like,
right, but
Riggs, it's rigged against us.
Riggs, here's the thing, yeah. Like, if you want to make money off of this shit, it's easy. But like, I think you're on the same boat as me. Who gives a fuck? We just here for entertainment.
We ain't here for the same reasons, Branch. Me and
you. No. I mean, seriously. You know, Jeremy, are you here for entertainment or not?
We ain't here. I'm not here for just entertainment.
Okay, Jeremy,
just entertainment for me.
Jeremy, don't fuck me, bro. I will.
We ain't here for the same reasons.
Questions that I don't know what I was gonna say.
We ain't here for the same reasons, Branch. This ain't just entertainment.
But here's the thing, Jeremy. You started off at the same reasons as I did.
I started off to try to find the truth, and I've always been on that.
Jeremy, you started off doing this shit the same way I was doing it, And then,
bro, we're not the same, Brant.
No, we're not the same. I don't like. What the fuck? Obviously, we're not the fucking same.
I'm just saying we ain't here for the same.
I'm not fucking white, my man. It all
We
comes
didn't
down
get
to
into this.
race,
If you
motherfucker.
guys
I'm
think
a racist motherfucker.
All right.
No, I only said that because Gio sent me a text saying I was being very racist last night.
Right. Well, Branch, I don't know. There's like 5% of you that I enjoy, and then the rest is just kind of like garbage, honestly. So.
Honestly, I think what you're trying to say is like,
and I'm probably one of the more forgiving characters in this group. Like, I'll listen to all kinds of bullshit, but
yeah, well,
like that's my rating.
What you're saying is, Branch, go on mute for a little bit.
I mean, I've heard there's numpty clips of Branch destroying Veach. Like, Branch can do dope when he's on point and sober and shit, but when he's here fucking around, trolling, making a mockery of this whole thing, it just fucking sucks.
Well, he's on that poison. He's got a substance problem.
I mean, like,
There's numpty clips of you destroying Veach. I don't know if you knew that or not.
It's not a substance problem. It's a reality.
Yeah, you have a substance problem, Branch. You've been
it's not, bro.
an alcoholic as long as I've ever known you.
It's not a substance problem.
Yeah, well, why are you so defensive when anybody brings it up then? Like, you've clearly been talked about.
I'll tell you fucking straight
People
up.
in your family, people in your life have clearly talked to you about your substance problem, and you're very defensive and you're triggered by it. You know, it just is what it is, man.
I would actually say I'm totally fine being classed as an alcoholic.
There's also some people that like only come on Discord when they drink.
Yeah.
So.
You literally Branch just quoted, "I don't have an alcohol problem."
No, I
so
mean,
I'm an
but
alcoholic."
you know what though, Gio, when I do drink, bro,
never
I
sober.
drink a lot, motherfucker. I drink for like 3 days straight. That's
what
how
you were saying before about being involved in something that you have such an aversion to or whatever. Like we've joked about that idea of like, let's say there was a community that's okay. So people that think flat Earth, well, they claim, oh, it's ridiculous, it's absurd, it's so wrong, and all that. That would be akin to, let's say, like they think it's so wrong or something that, let's say, a group that said that pigs can fly. And if there was a whole community that pigs can fly, and they had a live stream and they were talking about it every single day, think about what it would take for you to, or for anyone to actually not only like peep your head in the door and listen to these people talking about how pigs have wings. Oh yeah, I saw this pig flying and all this stuff, and what it would take to be that involved in the community where you're there every day for hours and hours talking about how pigs can fly. Or even worse, just like ridiculing and laughing at them. And that's your only goal in life, is just to spend your free time. Of all the places you could be on the internet, you're just at the Pigs Can Fly Discord, just laughing at people for your whole life.
Well, what's that Australian, like, it's like this very Marmite or something like that? Vegemite? It's like some salty... Vegemite.
Yeah.
Okay, Vegemite. Yeah, there's some really big fans of Vegemite, right? Like, can you imagine like joining a group of people who like Vegemite and just roasting them for 12 hours at a time?
For years.
For literally the better part of a decade. Like, if you're on Facebook or if you're joining like a video call of like people who enjoy Vegemite and you're just kind of like just drunk, roasting them, like, I don't know, 6, 7, 12 hours a day for years. And it's like, dude, what are you, like, how does someone have that much time?
You wouldn't do it. You wouldn't do it.
No, I would join maybe for a little while, and I would maybe troll a little bit and say, you guys are stupid, that shit's salty. I bet your shit smell weird or something. And then I'd get kicked out of the group, or I'd leave or something. Like, I don't know how somebody can make like a lifestyle out of like what a lot of these Globers do with this topic. It's really strange.
Yeah, this is like it's like an integral part of their life for a lot of these guys. Like, it's not just like a thing that they tap their head in the door. They're like, from the outside, they are like a flat earther. They're like they're like in the community. They're a part of.
Can you imagine like going to like let's say that you're just a fat guy that likes eating Doritos, and you go to a BJJ studio, and you just like hang out in the entrance, and you're just like eating Doritos and Taco Bell, and you're like sipping your soda, and you're like laughing at all the guys doing BJJ all day, and you do that for years. That's literally like what Branch is doing. It's like, what?
Or I thought of another one. Like, let's say there's a band that you really don't like you just dislike whatever band, but you go to all their shows, and you're hanging out. Yeah, for years. And someone's like, "Oh, dude, you like this band?" You're like, "No, I hate them." They're like, "Oh, really? Why are you here?" "Oh, I've been here for years. I've seen them over 150 times. Yeah, they're my least favorite band in the world."
Exactly. Exactly. I can't. My brain just doesn't even. Yeah. Go ahead. Sorry, Jeremy. Go ahead.
No, it's all right. Yeah, it's just you wouldn't. I think deep down, subconsciously, maybe even they have questions themselves about maybe they're not. Maybe their model's not right. They all say it's a probabilistic thing, so deep down they think they could be wrong.
That's a thought. I really don't think that's the case with like a lot of these guys, though. I think they I mean, as much as they say that I think it's more of something else. I think it's something else. I think I think
it could be entertainment.
Maybe they've been through a trauma, or they got some kind of like actual like condition or brain damage, or so, like not trying to make fun or anything. Like, I think maybe something's actually wrong with them.
It could be just for entertainment, just like Brant said. Like, this is entertaining. We talk about some of the best topics you could possibly be fucking talking about on Earth. So, like, could just be strictly an entertainment thing.
Well, okay. Let me ask you this. So, like, clearly Branch was an alcoholic before he came to Flat Earth, right? So, what caused him to be an alcoholic? Maybe that's his problem. Maybe that's why he's got this like mental distress. It clearly has nothing to do with Flat Earth, right? He's here to avoid his trauma. He's here to avoid his what he's trying to escape. And because the alcohol is clearly not working, right? So, it just, but I just don't have a good excuse for everyone else. Like, it's just a strange phenomenon. I would never, ever in my life, I don't have that much time, and I wouldn't want to spend that much time if I had it, doing what they're doing. Like, imagine living your whole life and saying, "Oh, well, when I'm dead, I'm actually just dead, and I don't live on."
Bro, you know what? The whole fucking alcoholic shit, right? I'm fucking bipolar as fuck, and I'll tell you what. I'll tell you what, motherfucker. Look, alcohol actually lets me not only fucking do shit, but I can fucking be smart.
Okay, well, you won't remember it, and when you're dead, right?
Well, all these other fucking drugs,
so what's the point?
Lithium, fucking what is it, Depakote, all that bullshit, yeah. Right. That dumbs your ass fucking down. You,
right.
Fucking,
when,
you feel
when you're
so stupid.
What is the purpose of your life?
No,
like,
you know
what are you even doing
You know
here?
what? So here's the problem.
What are you doing with your life, man? Like, what are you proud about?
Would I rather be smart as fuck and drink alcohol, or dumb as fuck and take drugs?
Smart compared to what? If you're going to be dead, and like, what's the point of your life?
Compared to a motherfucker,
what are you leaving behind?
The last job I had, I was earning $200,000 a fucking year, motherfucker. That's
okay. And you gauge your life by how much, like what?
No,
did you know
you
gauge your life by a fiat currency? You know, somebody could press a button and that 2,000,
exactly
that 200,000 can be like $200.
That's exactly how I was fucking doing it back in those days. Yeah, I was like, you know what?
You know, the money doesn't have value, right?
It doesn't. But listen, my man.
It doesn't. Like, so then, what are you proud about?
If I take these bipolar drugs and shit, and I be dumb as down, I could fucking work at Walmart. Yeah.
Do you think that morality has something to do with why you're alive?
Which one would you pick? A $200,000 job with alcohol, or a fucking work at Walmart with fucking the drugs?
I'm not even going to answer that question.
Yeah, well, don't fucking ask the question.
Because I asked you a bunch of questions. Like, you rated your lifestyle. You valued your life by a fiat currency. That's just a very sad point of view, right?
What the fuck you want about?
Don't you agree?
Currencies? Like, how the fuck is this some shit that me and you got to talk about?
Fiat. Wait, $200,000? What year? So I know what it's worth.
I don't know. That was it right before the pandemic and shit.
Right before the pandemic. Well, what if you made 200,000? I don't know, 2 years from now, it'd probably be worth like a tenth, right?
Gives a fuck, my man.
Yeah, who gives a fuck?
I didn't
Exactly.
I honestly
It's a
think
fiat currency. There is no intrinsic value. So like,
I'm
what?
sorry, Riggs.
How do you value
hold
life?
the fuck up. Hold the fuck up, Riggs. What the fuck?
How do you value life?
Hold
Branch?
on, Riggs. What the fuck was the point you was trying to make?
This is what I'm trying to elucidate. How do you value
What are you trying to
life?
hallucinate? You're trying to hallucinate?
Oh, this is fucking guys.
Yeah,
Geo.
it's degrading very quickly.
This is what he does.
So you don't value life,
No,
is what
just
you're
mute him
saying.
then and move on.
Yeah, that's what I would do. I did it earlier today. I already did it once today.
Riggs, my man, I'll tell you this, yeah? I'm big balls. You want?
All right, man. Look, if you don't value life, then that makes you actually a dangerous person because there's a lot of other people in this world and in this room who actually care about life, and they don't value it by some job with a fiat currency.
Oh fuck no, bro. But the way that you being brought up in this fucking community is to respect your place.
I don't need
in the
I don't
community,
need
and I'll be
this
honest with
community
you, bro. Honestly,
to know what
if
the
you
value of life is, what I value in life. I don't need this community for that. That's why I asked you. I didn't ask the people around you for your answer. All right. Well, I'll stop engaging with them. I just can never get. You know what? It's like I'm squeezing this sponge, and like just nothing comes out. Like I just don't know what's wrong with this guy.
Riggs, that's why you're the fucking best global.
Branch, you got one of the dopest numpty clips, bro. When you were getting Veach on the covalent bonds, that shit was fire, bro. If you were like that all the time, man, that shit would be dope.
I mean, I could be like that I can be like that always, yeah. But it's like,
then why do you do this then? What we're doing right now?
Because honestly, what is the point of being smarter than everybody else? That gets boring, bro.
Well, I don't know.
I don't know if we're going to go back. Well, I was just going to say one thing. We're talking about these people that hang out in a community that they think is, totally wrong information or whatever. Because I was going to say it back before then too. And it was just on my mind. Because like Riggs, you were saying would I ever do that? Or would we go hang out? Would you go to a band that, concert of a band that you don't like and all that? The reason I wouldn't do that is because for myself, I'm always looking to advance myself in some way. So if I were to go hang out in a community of people that, think something that I know is wrong or think is wrong, that's not going to advance me. So right. That would not be of interest at all. Like I said, I might peek my head in for a minute just to see what they're talking about. But it's the same reason I wouldn't go on a stream right now with a bunch of 10-year-old kids playing a video game, screaming and yelling. That's not going to advance me. So I'm not going to go in there and troll or, spend any time there.
Yeah, I think that's a good assessment.
Joe, why did you have to say that shit so fast?
You wouldn't spend your whole day in some place where you thought the people were retarded and their views were wrong, and it wasn't going to advance you at all. Yeah, there's be no point in hanging out for years on end with these people. Like I said, unless it's just strictly entertainment. I mean, if it's entertainment, then that explains a lot. This is a very entertaining.
I mean,
thing.
Honestly, guys, it may not just be entertainment, but the majority of the reason we come here day-to-day basis is for entertainment. I understand.
Well, I know why. I know why you're here, though.
I get
it's
that.
because no one else will actually put up with you.
Come to the room on a day-to-day basis is for entertainment.
I think subconsciously they might think that there obviously is something to this. What we're saying has validity, and there's definitely something to it. Otherwise, yeah.
I think there's another factor that I think perhaps some guys they want to. Okay, so from the perspective that the Earth isn't a globe and it is actually what our ancient ancestors and humanity since the dawn of time, stationary, planar Earth, and etc. That means that there's something very real happening. Now, right now, it's fairly small. It hasn't sort of gotten out to a lot of people yet in the world and so on. And a lot of people are not even aware of the information. And there's a lot more tests that we have to do and things like that as well. But I think one factor is that some of these guys, like, they want to kind of be hip to what's going on. You know, they want to be around, kind of peep their ear in and kind of hear what's going on, kind of be involved a little bit, you know, just because like they know that it is the cutting edge. They, on some level, they know that there is a paradigm shift occurring. Now, whether they're in conflict about that or whatever it may be, but I think that could be another factor for some, that they actually want to kind of be around just to hear what's happening and what's moving and what's shaking, you know, just to kind of be like on the, like kind of have your finger on the pulse of it kind of thing.
I mean, I would say this though, Gio. When I talk about the 1% of the room that actually really does think the Earth is flat, I'm actually thinking about you, bro.
Could it also be?
I personally think, Gio,
so
you're the only
ludicrous.
one in this room that actually thinks the Earth is flat.
So ridiculous that you want to see who comes in here who actually believes it, and you want to hear how they support it. And
What do you think that
if they honestly believe
well, hold the fuck up. This shit got.
Are you one of those people that think that most of us don't actually believe it?
I didn't mean it.
Can both of you answer that question, or like just one of you? Like M Stone,
Yes,
are you
there's
one of those
quite a few
people?
people that believe it's too stupid? I know a lot of people that think FE is 100% Poe.
Oh no! Let me rephrase if I didn't say it right. Do you think that there's a lot of us that the ones that say that we believe it, they don't actually believe it?
Yes, that was the answer to your question that I just said. What part of it didn't you impart to what you just quote?
Well, it sounded like you were commenting. Maybe not. Go ahead.
Okay, it's so ridiculous. People want to hear the people that believe it so they can see if they actually do believe it. They want to hear them. Because a lot of people think that people that believe FE are all Poes. There's a lot of people that believe there are no real people that believe the Earth is flat. That all of you are Poes. That all of the flat Earth community are full of shit. Poes.
Okay. Well, I understand that. I'm asking you guys, not a lot of people. So I did hear your answer, and that's why I asked it again. You're not answering the question.
And again, I'm here because I know that's not true. But I do know that it is true to an extent. And some of you actually don't believe this.
What's true to what extent? That we don't believe it? A lot of us don't.
How are you having a problem following me? Is there
It's because I'm not drunk.
A problem with your headphones or something? Is there a background noise?
I'm not drunk, so I'm making sense. That's seems to be
drunk,
the case.
So you're making sense. Okay, that has nothing to do with your hearing and your ability to follow a fucking conversation. Are you able to do that?
I asked you in Branch the question, and you're making commentary about all of the people that you've heard about on your side who feel a certain way. I'm like, do you actually feel that we are just making this shit up and we're not really?
This, man, I am here to listen and discern that for myself.
Over and over again.
Over and over again. I've never heard you. I'm not here very often, bro. I don't know what you're talking about.
Roses and clovers.
But you're really active, dude. I mean, you went to the Flat Earth conference. Like you woke up that morning. You woke up that morning, like brushed your teeth and shaved and took a shower, and got dressed and like tied up your shoes, and you're like, I'm going to a Flat Earth conference today. And you drove your car and you parked. Maybe you even paid for parking. You found the directions. You got there. You did the whole thing. You also went to meet Austin in public. So once again,
he's more of a flat earther than I am. I've never done all that.
You dressed up. You went to in person with Austin so you could debate him in person. Like, you're very active. Like, you're getting out there.
That never happened. I'm sure you'd like to think it happened like that, but that's not the way it happened.
You didn't go. Well, you're on video with Austin for hours. Like,
yes, I didn't go there to debate him. He was talking shit to some dude, and I went over there and talked to him. I said, "Hey, dude, this dude does this. This is what he does." Then I walked away, and he goes, "Hey, dude, you won't be on camera. You won't even." So I walked back over there, and
so you just happen to be like in the area, and you're like, "Oh yeah, this guy. This is what he does." or did you
Just
actually
by chance.
did you drive over there and you just seek him out? Is that what you did? Am I making that up?
Just happened to be in the area.
Did you ride the bus? Like how the fuck did you teleport?
Yes, I drove to Deep Ellum where he was broadcasting.
No, but you also
When he
lurked
was-
in the
when
back.
he
You were
was-
lurking in the
and you
background
can
for like
go
an
see
hour.
the video, man. It's
Yeah, you were
nuts.
lurking in the background, like waiting, like kind of stalking. You were lurking there for over at least an hour, watching everything,
Yes,
and then you finally got the courage to go up and confront him.
I finally
you
got the
you made one like kind of crude comment, and then you tried walking away, and then he was like, "Oh, come back" or whatever. And then you kind of pretended to walk away again. It was a whole thing, and then you got into it. You threatened to punch him. You wanted to fight him. All that stuff.
You know so much about this, and
Yeah, where
Yeah, I
are you
watched
from?
the
Are you like
stream
Plano, McKinney, like Louisville? Like where in Dallas DFW are you?
I'm in Richardson.
You're in okay, so you're literally like 10 minutes away. That makes sense.
Does it to you? Well, thank God it does.
Yeah.
It makes sense.
Well,
to
if
you,
I was
bro.
10 minutes away, I'd probably
I'm
come
glad
down
it
and troll
figured out
too.
the Earth,
Honestly.
shape of the fucking Earth, man. I'm glad it made sense.
I'm a reasonable guy. If you're 10 minutes away, dude, I lived in Richardson. I know how far that is down 75. It's really close. It's like down the highway, one exit, you're there.
Great. Good for you.
So that whole purpose was just because you wanted to see if Austin really thinks the Earth is not a globe? That was your whole purpose in it?
I was there for the clown tour, man. I heard there was a clown tour in town.
A clown tour?
Then the other time was
circus.
The conference was a few miles away from me, and they y'all at
yeah, the Anatole Hilton
I
or
saw
something.
a video where they were hassling George, and I think George got kicked out. And I went in the lobby to go meet George, and Karen B started streaming me, and then it just kind of snowballed from there. But
Yeah, she's her own animal.
Didn't you have something with what was the other guy's name? Not guy with Witsit, Nathan Thompson.
Yes, at the conference, Nathan Thompson was
Yeah,
talking
okay,
shit
that
to
I remember
George,
the
and I
video.
knocked
Yeah,
his hat off, and he ran away.
I remember that video. That was the clown tour, Jeremy. That's what Witsit and Nathan called their tour.
Yeah, what they call it, the Clown World Tour or something?
Something like that, yeah.
Yeah. They're kind of asking for it if they're going to call their thing a clown show tour, but yeah.
Then they fell apart in Florida and all the drama, all that stuff.
Yeah, I've never been to any of those events. I thought about going to one of them, and I was like, nah. Like I just there's just some people I don't want to associate with.
I wouldn't have shown up.
So
George
what
actually bought tickets and flew down there, rented a fucking truck and shit.
Wait a minute. You spent money to go to a flat Earth event?
George did.
Oh, I thought you were saying you did.
No, I explicitly said I didn't. I was giving you an example of why I was there.
That's pretty
Because
impressive.
the guy that was there got kicked out immediately after he paid the $300 fucking ticket and got a room for 3 days and a fucking car for 3 days plus his plane.
Ouch. Yeah, that's fucked up. What state are you in, M. Stone?
I'm in Dallas, Texas. I don't know if that's not been established yet, but
Gotcha.
So you were saying before that you think that it's so ludicrous that people think the Earth is stationary, planar surface. So what to you is ludicrous about that? It is what you experience, right?
again, I am not here to try to explain spherical Earth to y'all. It's not my position. There's people with PhDs that have been here to try to explain things to y'all. And I obviously don't have a PhD in physics. So I think you would need an individual education for each and every one of you that honestly believe this shit.
What do you
But
think an
I'm not
explanation is
going to try to
comprised of?
educate you on it.
What do you think an explanation is comprised of?
That wasn't really my question, whether you can explain your belief. I understand. It sounds like you just believe in other people and what they tell you to. You just basically summarize that you believe what other people tell you to believe. That's fine. What I asked you is
I believe in my education.
why do you think it's
I believe
ludicrous
in my
to think the Earth
education.
is?
It's
My
not-
question is, why do you think it's
my
ludicrous?
education wasn't what people told me.
What do you think is ludicrous about the Earth being exactly what you experience it to be? That was my question.
I experienced the Earth to be spherical.
Okay, what is your experience that indicates sphericity to the Earth?
Well, the mountains of pictures we have from the Earth, the gravity. I mean, all the things that rely on the Earth being spherical. GPS, satellites. I mean, how many space agencies are there? How many people do you think would have to be involved in something like that? The fact that you can see the flip side of a moon from the southern hemisphere. The fact that this is even a southern hemisphere at all. I mean, all these things are quite apparent with a spherical Earth.
What do you
To
mean
say
by the
they
flip
aren't
side?
ludicrous, and that's why I'm here.
Is the flip side the same as the dark side? A row?
Yeah, I'm
What do you
I'm not
say,
here.
the moon is
I'm not
flipped?
here to interact. I told you I wasn't going to do that. Y'all got really mad at me last night for doing this. I said I would just observe. You're going to get mad at me for doing that, but
I didn't get mad at you yesterday. I thought we were getting along pretty good. I mean, minus your insults and whatnot, but I thought we did all right.
look, I cannot take you seriously. I can't. If you can't discern the shape of the Earth, I'm sorry. I really can't take you seriously. I'm always going to be smiling. It's going to be difficult for me to have any kind of real conversation with you. I think you're a fucking idiot.
And the true garbage comes out finally.
Well, that's the
Took
problem.
them long enough.
I think you're thinking too much, right? And you're basing things off belief. Those are two big no-nos when it comes to reality, bud.
No, bro, you're the one that's fooled. You have to understand that. You're
This
the
is
one
why
that's
I'm
being
just going
fooled.
to observe.
He's telling you straight. He's telling you straight. He thinks you're an idiot.
Right.
Straight. Like, which part don't you get?
No, I get it.
You will not have a conversation with this dude. Ever. Put it through
Yeah.
your thick skull, bro. Nothing personal, but...
No,
yeah.
I mean, I agree with you. I agree.
I'm not trying to have a conversation. I'm not trying to get you to take on the globe. I'm not trying to explain the horizon to you. I'm not trying to explain gravity to you. I'm not trying to explain orbital mechanics to you. I'm not trying to explain all of the mountains of evidence we have for the globe. There's no reason for me to. There's absolutely no reason for me. There's been better people than me to come in here and explain these things to you.
Every single word you waste on him, he wins. Understand that. Every word you say to him,
See, this is not some battle, you
he is
goofball.
winning. Just understand that. He thinks all of us are idiots, fools. Understand that.
Didn't Snacks call him a wiener yesterday? Or a wiener, something like that?
Yeah.
Well, people have a lot of projections that they're working through, but he's here and he's on the panel. So I don't know. What do you want to talk about then, M Stone? Or do you just want to listen to us? You just want to be a lawyer?
I just said I would observe. Interactions with me don't go so well for y'all. I just
His powers are too strong for us, guys. But I think if we combine our powers together and form Captain Planet, we might be able to achieve beating.
Well, I guess he just wants to listen, so I guess he can just hang out and listen then.
You get a chubby listening? Does it turn you on, M Stone, to hear other men talk?
That's what he said. It's all he wants to do.
I just picture him like spanking it while I'm talking.
He specifically likes the part when balls come up.
Yeah, it could be, huh?
I think it's very short-sighted in a lot of cases when people say that people think the Earth is flat just because they don't understand the globe explanations. Not saying that's not the case for some people, because there are various claims and claimed evidences about a globe Earth, but that's kind of what he was saying, is trying to rationalize, like, oh, you guys only think it just because you don't understand it. But then he said he doesn't even understand it enough to explain. It's kind of a strange polarity.
No, I said there's been people in here with PhDs in the subject explaining it to you.
Well, I've got a master's degree in the subject.
In what subject?
Cosmology.
You got a master's degree in cosmology.
Yep.
And you question whether the Earth is flat.
No, I didn't say I question whether the Earth is flat. I never said those words.
Oh, okay.
I know the Earth is not a spinning globe. That's for sure.
How do you know this?
I thought you said you didn't want to engage. Now you do?
I'm just curious. You don't want me to engage? I can go back.
You got him. You got him. He wants to engage now.
You got me, man. I can go back to mute. It's fine, man.
You are interested. So you're not just here to laugh and point fingers. You want to know. You are interested. You got excited.
Yeah, I told you I'm curious about how you came to these. I fucking told you this 5 or 6 times yesterday. I am curious the mechanism of madness, how you got to this point. Do I need to tell you that again? So yes, I would be interested in what you know, how you know that the Earth isn't a spinning fucking globe. That would be something I would be interested in. For fuck's sakes, man. I don't understand why this is so hard for y'all.
It seems like
How
you're the one.
Conclusion?
Well, it seems like
how are you suggesting that NASA is faking everything? That all of the other space agencies are all in on it too. Tesla's in on it too. It's his private money, but he's working with NASA. They're all working with NASA, right?
We had such good conversations all day. We were having great conversations like all day long up in here.
Yeah, it's my fault. Well, you know who was muted? Branch and M Stone were muted for hours. And
see,
it's my fault. I unmuted them.
I will go back.
I do that too sometimes.
I do apologize. Y'all go back to your ear-night conversation.
Well, you see what I'm saying, though. It's like, on one hand, you're like, I just want to laugh at you and observe it's ridiculous. But then you're like, no, I really want to know why you think this. So the thing I would ask, if you want to have a real conversation, here's what I would say.
I'm interested in the psychology of how you came to this point and the comedy of how you came to this point. There's 2 things I'm interested in: the psychology and the comedy. I told you this several times. You don't want to hear it because you don't want to get laughed. You don't want to hear that I'm laughing at you, I guess. But that's fucking like the 7th or 8th time I've reiterated my point on that.
Oh wow, funny. What is that you just posted? The fallacy
Yeah.
files. Taxonomy of logical fallacies. I'd have to blow that up to see it. It's pretty small.
Yeah, pretty cool chart I found today. Sort of like a taxonomical breakdown of larger and more detailed names for fallacies. It like breaks it into like formal and informal, and then like blue and the red, and then just goes over. I don't know. I don't know how they picked them. There's definitely more fallacies than this out there, but I guess these are like the main categories and subcategories. I think it's cool when you kind of see like the relationships between them kind of drawn out.
Yeah, it's interesting. It'd be cool to see like an explanation on some of these too, though, like what they mean by some of them. But yeah, it's interesting how they're interconnected like this.
Yeah, I recognize a lot of them, especially on the informal side. The formal ones, I'm less familiar with the names. But yeah, maybe we can save that and repost it when someone pretty knowledgeable in this subject comes in.
What up, Fundy? Happy New Year.
Happy New Year, Dicelo. You got a pretty comfortable winter going on, not freezing your butt off like half of us.
No, not as bad as everyone else, but it was definitely raining all day. I had to work in it, so it kind of sucked.
No, dang. Yeah. I've heard it's a lot of rain going on for everyone right now. That cold front was crazy last week, man. My pipes froze and everything. It got like to like -25 here.
Yeah, I've been getting a
Yeah.
ton of rain here. Yeah. I'll take rain.
Yeah, it's quite the winter, huh?
I don't know if you guys noticed this, but I definitely did. But like, it was like 1 or 2 days right before the big cold front was expected to come through, just before Christmas there or whatever, or like during Christmas, and I like in the Colorado skies where I live, and I pay pretty close attention to the skies out here, and I hadn't seen chemtrails like that in like months and months, man. I mean, I've seen some pretty gnarly skies, and I know chemtrails when I see them, but like it's just weird how like right before this like huge storm was expected to come through is like the Colorado skies were just flooded with chemtrails, dude. Like I'd never seen anything like it, dude. It was just like the entire sky from like north to south, east to west was just completely flooded with chemtrails. It was like insane. It's just like it seems like there's like some sort of strategical time placement there with some of these chemtrails. I don't know, but it could just be conspiracy. Who knows? Or just a joke. I don't know.
Dude, I missed Christmas this year because like everyone got sick. Like even like family like all around America. Like did any of you guys notice that? Or just everyone randomly got sick overnight, like on Christmas Eve or the day before? Maybe it's just my circles.
No, I mean it seems to happen every year, doesn't it? It's not just this year; it was last year, and it was the year before that too, right? It seems to happen in like every year. There's like clockwork like illness that goes around. I don't know. I mean, I seem to be pretty good. I haven't really gotten it this year, last year either, so I don't know.
Good for you.
Like I said.
Tell you what, guys, I found some really interesting charts online today. Just started collecting them up.
What you said? What kind of charts you said?
All sorts of different topics, but just charts about my interests, and some ones that I just came across and said, "Ooh, that's interesting." Kind of spamming the text chat.
Hey, D-Mock, you there? M Stone says he's got all sorts of globe proof, dude.
He wants to debate you one-on-one.
He said he's dying to have a conversation.
He said he's got ball math figured out.
And he's got a demonstration in a lab.
Yep, with a ball and water sticking to it. Go ahead, tell him, M Stone.
Here's a thought I was just thinking. How many years do you guys think it's been in our recent time, of course? How many years has it been that more than 80% of the world believed the earth was a globe? I'll say the mainstream world, so maybe not considering like tribal area, peoples and things like that, but like of the, let's say, first and second world, maybe even some of the third world. How many years do you think it's been that more than 80% actually believed it was a globe? 50 years, 100, I know they're going to, they try to say, 2,000 years back to the ancient Greeks, but that's really not the case, even looking at like what schools were teaching in the 1800s. But so, yeah, what do you guys think? How many years that more than 80% actually even believed it was a globe or has believed it's a globe?
513 years.
Do you think it's been that long? Like, you think in 1602, they all were like, oh, yeah, we're spinning on a globe, even though gravity wasn't even theorized yet?
Probably started with the boob tube, I'd say,
think,
in the 60s.
I think if you look back to when the first university came about, I think it all probably started mainstreaming from there.
That's
at the first Jesuit university.
Nah, most people were illiterate, bro, around the globe. Are you kidding me? The only way this thing got out is because of TV, boob tube, movies, globe in your face. There's no way that 80% of the population thought the Earth was a globe before that. No chance.
Oh no, I didn't mean in that. I just meant like when the globe model started being projected onto the public.
Oh yeah, but he said more than 80%. So yeah, in that case, you're right. Yeah, it's all to do with mass media in your face.
Right. Yeah, it's consensus by majority and authority.
Don't forget, most people were illiterate, and the information disseminated through the ages was most of the time through the clergy. Most people couldn't even read the Bible, so whatever the priest told them, that's it. And then you have geniuses, which will remain nameless, that just believe everything they're told and ridicule other people for the mere question of it.
Do you think people like M. Stone are just genuine people that are just being themselves, or do you think that there's a possibility they're part of something bigger, or on the take, meaning being paid to do so?
Nah, people like him just have miserable lives, and they have nothing else better to do. They're probably has no friends, can't go anywhere, probably got booted from all other servers, and that's all he has left to do in life is just be that vile individual. I guess that's how he gets his licks, his kicks, whatever. He has never, absolutely ever had a conversation of any meaning with anybody that I heard of.
Do you think he's this way in his personal life, or is this maybe like an outlet for him to be able to portray this character that he's not in his real life?
I'll almost certainly be able to bet he has an insignificant life, very few friends. Nobody takes him serious. So he finds a way of acting like somebody here, you know? A way of like being like pretending that he's better than you based on education, whatever. That you're dumb, that you believe in something, and that's how he gets his jollies. You know, there's all kinds of strange people around.
Well, part of the reason I thought about that 80% thing is that people who seem to, want to claim that it's like so foundational and so established that the Earth is a globe, and they sort of have that a little bit like M. Stone was having, like that laughing, ridiculing, like, oh, it's just so, absurd to think it's not, and all that. And I was just bringing that up because it's like, well, I mean, how many years have humans even really believed it's a globe, and what did it take to even get them to believe that?
Mass propaganda, TV. That's the main thing. That's what did it, I think. In your face.
Yeah, I mean, I would say it wasn't until the fake moon landings that people really, you know what I mean? Because before that, there were no pictures of it. It was just a thing that was told, so they wouldn't really have any reason. But whereas the picture was like, got them in a sense.
Exactly. In your face. I saw it. I was there. How many people have you heard say, I was there, I saw it? No, you didn't.
Yeah, but did M. Stone...
Yeah.
But did M. Stone tell you about the 72 space agencies, though?
Exactly. Yeah. They're
Oh, there's 72? I thought there was only like 70. All right, I believe the globe now. Yeah.
Yeah. How could they possibly lie to us? Yeah.
Because I mean, I see the globe thing. It's like a propaganda. It is like a media propaganda assault. It's like a psyop. I mean, there is other components to it. It's not only media, but because I mean, their story is that they came along and discovered that it was a globe. That for all these years, humanity, was in the dark, and then they came and blew our minds. But then now they came and blew our minds, and then apparently it's people then think it's so foundational that now they can just laugh and ridicule the people that don't take it on board.
So if there was a contradiction between the 72 agencies, like a disagreement, who would have the authority or the upper hand in making the final decision?
No, but you know what's funny when they say the various agencies? Then you tell them, okay, and then you show them pictures of what they think the globe is, and they're all different. Every single one of them.
Well, there is this, I don't know if you're familiar with it. It's called the United Nations Office for Outer Space Affairs. And they actually have an outer space treaty, believe it or not, that they signed in 1966. Which
for the weapons, right?
Yeah, it says here the Outer Space Treaty, formerly the Treaty on, it doesn't matter what formerly was called because it's really long. The Treaty on Principles Governing the Activities of States in the Exploration and Use of Outer Space, including the Moon and other celestial bodies, is a multilateral treaty that forms the basis of international space law. Negotiated and drafted under the auspices of the United Nations, it was open for signature in the United States, the United Kingdom, and the Soviet Union on 27th January 1967. So 2 years before the moon landing. But I just brought it up because Deisler was saying, like, who would be the authority that would kind of, step in, and this would be it. Your beloved United Nations.
Yeah, like how would they decide? Like, would it be the one that's been around the longest, the one that's been furthest into space, the one that's landed? I mean, like, who would make, like, Who would have the authoritative position from these competing agencies?
Yeah, I guess it'd be the United Nations under this outer space treaty thing. So not that different than the Antarctic Treaty. Because it says right here, I found that when I was reading this, I found it interesting. It's key provisions in the outer space treaty include prohibiting nuclear weapons in space, limiting the use of the moon and all other celestial bodies to peaceful purposes, establishing that space shall be freely explored and used by all nations, and precluding any country from claiming sovereignty over outer space or any celestial body. So that means that if someone, even if a civilian or one of these space agencies flew to some other planet out there in a galaxy far, far away, and an empty planet, and landed on it and said, hey, this is our land, apparently the United Nations from Earth is going to come and say, oh, sorry, you can't claim sovereignty over there. We're going to come get you with our Space Force.
Well, it just seems odd because it's like, on the other hand, you've got certain parties that are a part of the United Nations, like China or something, Russia, United States, and they're over here arresting people for spying or treason. But then up there, it's like they're just handing out information like it's fucking Thanksgiving and shit with each other. And they're working together. They're not like on their own mission. They're working together, it seems as if. But down here they're not. It just seems weird, dude. Like, does
The
anyone else see
United
that?
Nations arrest people for treason? Against whom?
Mm-mm. No, I said the composing parties of the United Nations, like the individual countries that make up the United Nations, can go to war with each other and arrest the opposing citizens for spying or their own citizens for treason. But when it comes to space technology or space missions and just anything to do with space, they're all working together and sharing information. It just seems like an issue.
Already do the same thing on the oceans for centuries.
Yeah, I mean, doesn't that seem odd though? Like what's the word
No.
I'm looking for?
Well, like they're all buddies
Conflict of interest.
Yeah, like
No.
they're all buddies in space and they all get along there, but then down here on Earth we're waging war. They're waging war against each other. That does seem strange.
Right.
Well, as
Threats of
President
war.
Kennedy said, space is hostile to us all. We need to work together. So
But that doesn't seem like a contradiction to you. Like, you could
We
have
do it all
people
the time.
dying. You could have people dying here on Earth, but when it comes to their astronauts sharing technology, they got no problem. It just seems like a conflict of interest.
well, I'm sure they don't share everything. We don't cooperate with the Chinese, for example, because the Chinese space program is done by their military. We don't cooperate with technology with them. That's why you don't have Chinese astronauts on the ISS.
And of course, your space program has nothing to do with the military.
Didn't the Chinese astronauts
No, it
save
doesn't.
like one of our astronauts or something?
Not that I'm aware of. Are you aware of one?
I don't know if I'm getting mixed up with a fucking movie or something, but I could have swore there was like some situation where one of our astronauts was going to get left behind and the fucking Chinese astronauts saved him. Remember something like that? Am I thinking of a movie?
I think you're thinking of a movie. The only time I'm aware of anything like that happened was with Apollo 13, when the Soviet premier ordered all the Soviet armed forces and space program to cooperate in any way with the Americans to rescue the astronauts.
Yeah. I don't know.
Don't you find
It
it
just
funny
seems odd.
throughout the whole Cold War and all the wars in between? That's funny how somehow they cooperated in space and in Antarctica. Isn't that like remarkable?
Yeah, it is, isn't it? It's wonderful.
Yeah. I would use another word, but okay, we'll go with wonderful.
Hey, why should we buy it at this point? Why should we think space and all that is happening the way you say, Bob?
Should we care?
I'm sorry?
why should we care whether or not you believe in space? Space doesn't require your
You're
permission.
here. Listen, you're here to muddy our waters specifically so that others tuning in don't quote unquote fall into the same flat Earth trap as we have. You see, we know it's damage control. So, and nobody's stupid to it at this point. The audience knows now. Everybody's hip, right? So you're pretending to be a glober because the Earth will never be a globe. So, my friend,
It's always been a globe.
What?
It's always been a globe.
What can you propose now? We need a fresh batch of popcorn. How do we continue buying your story, sir? Go ahead.
I don't care if you buy it or not. You can research it yourself, and that's what the facts come up as. Do you see the Artemis mission? You know, that takes out at least 5 different flat Earth arguments, the Artemis mission alone.
Oh, really? How so?
Well, let's see. Let's just kind of go through a couple of them. First, they left the Earth's atmosphere and went into the vacuum of space and then returned to the Earth's atmosphere, going at a speed that didn't cause them a problem in space, but did cause them a problem on reentry. Let's see, when it was at the moon, it fired rockets in space, which changed the trajectory of the spacecraft.
Let me try it this way. Bob, why do you believe it? Let's start there.
Because that's where all the evidence points, and that's where all the measurements are. So it not only fired rockets in space.
Okay, so why do you expect us to believe that?
But it literally fell all the way back to Earth.
Why do you expect us to believe that?
I don't.
Oh, okay, thanks.
I don't. But it literally fell all the way back to Earth, accelerating the entire time, and that was proof positive of gravity. We did see images of the moon and the Earth from Artemis. They were both spherical. You know, there's quite a few little problems that you have there.
So just a couple of videos and a couple of chit chat here and there, and that's good enough for you.
Yep,
No, it's a long history.
Time to go home, boys. Time to go home.
Images.
Yep,
it's a long
over.
history of the same data going back to about 1946.
That's how easy it is to fool somebody.
Actually, it goes back
and they realize that with little effort, yeah, they'll even have guys like you fighting for it. What a job, man.
Well, so you think. But, you know, they first noticed the curve of the Earth. They documented the curve of the Earth very well back into the 20s and 30s. So I don't have any issue with that.
So listen to what they convinced you. They convinced you that a rocket left this place traveling at approximately 21,000 miles an hour. Then on its way to the moon, it slowed down. It's like it came out of one soup bowl, right?
Yeah, it slowed down for
and
a
then
very
it
good
started
reason.
falling into that soup bowl till it reached the. Do you know that at one point it was traveling at 60 miles an hour?
Yep.
People are aware of this, right?
Yep. Telemetry was streamed the whole time.
Right. So this is what you believe. You believe a thing left. It traveled at 21,000 miles an hour. Then it slowed down to 60 miles an hour.
Yep.
Then as it approached the moon, it started to speed up again.
Yep.
Then it did a couple of loop-the-loops.
Yep.
Right? And then it fired for about, what is it, a minute? Just a minute of firing, of thrust.
I think
and
it was
then
like
somehow,
2, but I think it was like 2.5, but we'll go with a minute.
Yeah, 2.5, whatever, of thrust to bring it up to a few thousand miles, I think 1,000 or something miles an hour. And then all of a sudden, it regained speed again to 25,000 miles an hour.
Yep.
Wow.
Absolutely. That's gravity for you.
That's gravity for you, yeah. Amazing, isn't it? Yeah.
Yeah, and easy to understand.
And identical to the simulations, right?
Yeah, it works
Well,
just.
if the simulations were designed to simulate reality, yeah, of course it would be identical.
Listen, as a sociopathic narcissist, psychopath, how do you feel about nobody buying your bullshit? Nobody. The audience, Globers, Flat Earthers alike. No one buys it anymore. How does that make you feel?
Were you talking to me?
Yeah, he was. And another thing, all
then
that
you can
money
address me
spent,
properly without all the other crap in it.
You can tell me your feelings, or you can show me the Earth curve.
I already did that. Thanks.
So all this billions of dollars spent, nobody thought, hey, let's put a camera on there specifically with all the f-stops and all that stuff so we can see stars. Nobody thought that would be important, right? Zero.
Why is it important?
Well, see the clouds, the Magellanic clouds, and why is it important? Really,
Yeah.
Bob?
Why is that important? It was a moon mission. It wasn't an astronomy field trip.
See, as long as they have guys like you making excuses, they're going to get away with it, Bob.
They
Yeah,
have.
could
I
you
showed
not
you
have?
pictures of stars from Apollo 16, and your return for that was, well, this is 2022. How come we don't have more pictures?
What's sad is SE. It doesn't take much, partner. Does not take much.
I know.
I mean, they brought a whole vehicle. You'd think they would have brought some kids to at least look at the stars and the Magellan clouds and all that shit. Yeah.
That had 20 some odd cameras on it, didn't it?
Did we see any stars?
I don't know. Did you?
I don't know. Did we?
Did you look?
Zero stars. Zero.
I don't watch science
Zero. I
fiction.
was looking.
No, I didn't look.
Okay, so if you
Zero.
didn't look,
Not
when
one
you review
single
when
star.
you review the available film, let me know if you see any stars.
Well, I was talking about the Apollo mission when they brought the rover.
Yeah,
We've
got star shots from Apollo 16 in particular. They also had a sextant which monitored the stars on the Apollo command capsule. Were you aware of that?
No, let's see the.
A sextant. Hold on. A sextant made on Earth for Earth navigation. You took the fucker into space?
You know, you got to have a horizontal baseline for the sextant to work, right?
Yeah, they had one built in. The guy that's laughing, they had one built in.
SE's absolutely correct. It was specifically
I know.
it was purpose built for it.
I know your stuff, man.
Yeah,
Did they have star shots on the Apollo 16 mission? They had star shots.
Yes.
From the moon?
No, from the journey to the moon.
Why would you want to shoot stars, and why would you want to take pictures and film of the Earth while on your moon, while you're on the moon? But don't be silly, Jeremy.
Why wouldn't you? Yeah, well, I mean, why wouldn't you? That'd be dope as fuck. For stars from the moon. We're on the moon. You might as well get some pictures or photos or video of stars.
Got some nice pictures of the Earth from the moon.
I mean, the astronauts said, well, at least the first mission, they said that they don't recall seeing any stars from cislunar space.
And others did. And
on
others
different
did.
missions.
So what? And they also have photographs of them from Apollo 16. So what's your point?
How did the first people not see any stars?
They weren't looking at the stars.
Oh my god!
The guys that were doing the sextant sure saw stars, and the guys taking the pictures sure saw stars because we've got the pictures of the stars. So what?
I'm pretty sure on the first mission, they literally said they could not visibly see any stars.
So what?
What do you mean? That's a big deal, dude.
Not a big deal at all.
That's a contradiction in evidence.
Nah, it isn't.
What are you talking about, dude?
Well, the bottom line is
That's no different.
Apollo 16 did photograph the stars. They were there. Whether the guys were looking at them or not, I don't know. Don't care. But we have the photographic evidence of the stars from Apollo 16. So if they were seen on Apollo 16, they were seen on all of them.
You have fun believing that.
Mm-hmm.
Got the images, man.
Whatever
no
helps you
shots
sleep
of the
at night,
stars. No shots of the stars from the moon. We were actually having this argument the other day. Would you be able to see stars if you looked away from the sun? Like, say you have the sun facing you. If you turn around 180 degrees, would you see stars?
Well, I would think that the lunar surface would be pretty bright. I don't know if you would see them or not. Now, if it was the dark side, if it was on the dark side, I'm sure you would, because there wouldn't be the sunlight interfering with it.
Okay, what's the reason we don't see stars during the day on Earth?
Same reason, too bright.
Because the atmosphere, right?
No, it's too bright.
It's too because it has nothing to do with atmosphere getting all lit up,
No,
and it makes it too bright to see the stars.
no, it's just too bright outside. And as the sun goes down, you do see stars at dusk. And you do see stars at twilight, which I might add requires a spherical Earth because twilight is defined as the sun being below the horizon of the Earth.
Yeah, we know.
Well, that's the definition of it. It's definitional.
Oh, you like definitions? Are you cool with level being horizontal?
No,
I don't think so.
two different
How
words.
you been, Bob? Bob, how you been? You good?
Yeah, I've been fine. Got back from vacation,
Good.
had a good time.
Nice.
Did a little
Where'd you
star
go?
watching. Did a little star watching. Got some major upgrades to the observatory done today. We've got the dome. The dome has been purchased and a new camera. So we're going to have some really exciting stuff this summer.
Oh, I can't wait. Can't wait.
It's going to be great.
Yeah. Awesome.
So your enthusiasm for discussing Earth not being a globe is just growing consistently and solidly, it sounds like.
Exponentially.
No, I'm more
breakthroughs
just dealing with
everywhere.
science denial. I'm more interested in the concept of science denial. I don't really care what it's about.
So you're into denying science?
No, I'm into studying those that do.
Ain't no one denying science. What kind of science you got?
You're in the wrong place then, Bob.
What kind of science are we denying exactly? Your pseudoscience bullshit?
No, you deny evidence for one. You don't accept evidence. You like asking questions but never listen to the answers. You don't do any of your own research.
Yeah, but what science?
You don't do very simple tests that could tell you exactly what the shape of the Earth is, but you refuse to do them.
Bob, what science are we denying?
I just told you.
Break us off with something specific. I don't do ambiguity. That was very ambiguous. Let's get specific.
You like to ask questions but don't listen to the answers. You are told how to do simple tests to check the shape of the Earth, but you won't do them. When you are
let's have one of those
information,
things.
you come back the next day and say the same thing.
All right, bet. Let's go over one of the things and we'll see if we're science deniers or not.
All right, good. You want to go over some science?
Yeah, hell yeah.
Great.
Hell yeah, let's do science. Let's go.
All right, go ahead and tell me exactly. Using equipment that is available to you, you would falsify the flat Earth.
Bro, what kind of science are we denying? You said you were science deniers.
That's science there. That's science right there, learning to falsify things. So how would you design an experiment using equipment that you have access to falsify the idea that the Earth is flat?
I'm sorry, do you have science we're denying or no?
That's it right there. That's it right there. That's science.
What science are we denying?
Can you falsify the flat Earth?
Give me something. What's your hypothesis?
I just
you have a hypothesis?
He's got nothing for you, Jeremy.
My hypothesis is that the Earth is flat. How would I falsify
That's not a hypothesis.
How would I test it to see whether or not the Earth was indeed flat, or how would I prove it was not flat?
Well, that's not a hypothesis, so I don't even know what.
Yeah, actually it is.
The Earth is flat. That's your hypothesis? That's a baseless assertion.
Correct, it is, but we're going to play with it for right now.
That's a shape plane. That's not science.
Well, the surface of the Earth is flat. My hypothesis is the surface of the Earth is flat. For example, I would test that by saying, could I see an object 3,000 miles away or more? And I can do that because I can see the moon on the horizon. So could I see an object that is above the surface of the Earth between me and the moon?
You could measure if the Earth is flat. This wouldn't be like a scientific endeavor with a hypothesis. That's not a hypothesis.
Actually, yeah,
Are you Bob the scientist?
You're testing it. Yeah, you're testing your hypothesis. So you would take measurements to see whether or not your hypothesis, the predictions made by your hypothesis were correct.
That's not a hypothesis. You have to have cause and effect when we're doing science, right?
Nope.
Yeah, you do.
No.
You're doing pseudoscience then. Yeah, you're doing pseudoscience. Absolutely. Where's extremistus? Is extremistus in the house? Because according to extremistus,
have you ever done science?
It's every day according to extremistus or Glober friend.
Okay, well, go ahead and tell me what science you've done.
That's for extremists. I don't think I'm doing science. I'm
Correct.
doing
You're
your
probably
guys'
not.
version of
So,
pseudoscience. Yeah, I'm not, because I'm doing your bullshit pseudoscience thing where you don't have a hypothesis, you don't have cause and effect, you got nothing.
You're killing it, Jeremy. Crushing.
well,
Man.
when you can figure out how to falsify the flat Earth, let me know.
I don't, dude. Where's the science we're denying? Do you have any science, Bob, the science guy? Do you have science?
Plenty.
Let's have some that we're denying. I mean, I don't even think you know what it is because you don't think you need cause and effect. So I'm not sure.
Well, let's see. All right, let's do another one. Let's do one of my experiments.
We haven't done one yet. Hold on. Let's not do another one. We haven't done one to begin with.
Yeah, I did, but you didn't. You don't understand it, so we'll go on to the next one. Something that you might be able to understand. So, for example, the rotation of the Earth. Now,
Okay, let's do it.
We notice that the stars are rotating above our heads at 15 degrees per hour. Do you agree with that?
The stars move above our heads, sure. 15 degrees an hour, okay.
Okay, does that... Now, what we need to do is we need to test to see whether or not it's the stars moving, it's the Earth moving, or some combination of both. Do you agree with that?
Sure, that sounds good. What's your hypothesis? It better have cause and effect, or it's not a hypothesis.
Okay, so how would we test to see whether or not it was the sky moving or the Earth moving? How would you design a test for that?
Dude, what is this science? Why do you keep trying to make me come up with science when you said we're denying science? Just give me the science that we're denying.
I don't think you understand it well enough to even come up with a science to evaluate it. So how would we test